Hey, this is Andrew Brown from Exam Pro, and I'm bringing you another AWS certification course, and this one happens to be the hardest at the associate track, which is the Developer Associate. So if you're looking to gain hands-on knowledge building, securing, and deploying web applications to AWS, this is the course for you. And remember, if you really want to pass, make sure you do all the follow-alongs that we provide to you here in your own AWS account. And we definitely welcome any type of feedback you have. So go on any social media and we will find you. If you do pass, definitely tell me on Twitter or LinkedIn. I'd love to hear that people are passing, and good luck on your exam. So I'm sure you have a lot of questions about the Developer Associate. I'm hoping that I can answer some of these before you get started on your journey to make sure that you're making the right choice about gaining the Developer Associate. And the first question we're going to ask is, who is this certification for? And I would say that if you're a web developer and you're looking to add cloud computing skills to your developer toolkit, this is the certification for you. If you want to know how to build web applications while thinking about how to build them cloud first, this allows you to push a lot of your web application complexity into managed services, and then you have easier, more modular web applications. That is another goal, another thing you'll achieve getting the Developer Associate. You're going to learn how to deploy web applications for a variety of different cloud architectures, so serverless, microservices, traditional applications. There's a variety of different ways to deploy to the cloud. And the last thing is that if you are a web developer and you're looking to transition into a cloud engineering role, this is the certification for you. Now, what value does the Developer Associate hold? What's it going to do for you? And I would say first that this certification is the hardest associate certification. So you'll have the Solutions Architect and the SysOps. This one is absolutely brutally hard. And the reason why is that you have to have practical knowledge of AWS to pass this exam. It's very hands-on, but the great advantage to that is that it's going to directly help you get a job as a cloud engineer, because it really is about doing the actual work, okay? And the last thing I want to point out is that it will help you stand out on resumes. It's not likely to increase your salary unless your company really values cloud engineers, but you're definitely going to get more job opportunities. And eventually, this is going to be the de facto of a web developer, having cloud skills. So it's important you get this now, because you're going to get ahead of everybody else. So another question people ask me is how long to study to pass as Developer Associate. And you just heard me say that it is the hardest associate certification. So this is a little bit longer than standard. So if you're a developer, I'm going to say it's going to take 1.5 months of study. I generally say for the SysOps or the Solution Architect Associate 1 to 2 months, but this one is definitely going to be 1.5 months, going definitely into 2 months if you are a developer. If you are a bootcamp grad, you don't know anything about AWS, and you're doing this from scratch, you're looking at least 2 months study, pushing on to 3 months. If you are already a cloud engineer and you're just trying to add the certification to round out your resume, you're looking at 30 hours of study. So if you really sat down and took the time, you could get this out in a week. So, that is the scope that I would say there. And the last thing here is just to figure out how much, how long, and how many questions. So the cost of this certification, just like all the other associates, is $150 USD. It's 130 minutes, so it's you get a lot of ample time there. There's 65 questions in this exam, and to pass, you have to have around 72%. It's not an exact number. That number can float around there. I think one more point is that this certification will be valid for 3 years. So it's definitely, $150 seems like a lot, but it's going to last you for quite a while. So, hopefully that answers your questions, and we'll move on to the exam guide. All right, so we're taking a look here at the exam guide breakdown. The first thing I want you to know is the course code, which is DVA C01. This might be the future, and you're booking your exam, and you might be presented with 2 versions of the exam. This happens when a new version of the exam is out, and there's some overlap between the old one and the new one. So the Solution Architect Associate is SAA C02, that's the new one, and the old one is C01. And they have yet to release a CO2 version of the developer. I can tell you right now that there isn't a huge change between CO1 and CO2. At least at the Solution Architect Associate, all they've really done is rebalanced the domains percentages and revised the questions, but the bulk of the content for course material is the same. So if this is the future and you're looking for CO2, you're going to be totally fine using this course content here. We'll move on to the next part, which is the passing grade is 720 points out of 1,000. I don't know how those points are distributed. It's not that important to know. All you really need to know is that you need to get 72% to pass. And that's not necessarily exactly 72%. AWS can adjust that value based on how many people are passing and failing. So you can go to an exam, get 73% and still fail. So you do have to consider that. There are 65 questions in this exam. That means you can afford to get 18 questions wrong. So you have a great margin of error here for this particular exam. And the duration is 130 minutes. So that means you get 2 minutes per question for this exam. For the Developer Associate, it's very unlikely that you'll run out of time. What you'll end up is with surplus time. At the pro levels, you always run out, like you're always running against the clock. So you have to know your pacing per question. For Developer Associate, that's not the case. And if you have surplus time, you're definitely going to want to go back and review all your questions and utilize 100% of that time. Now what we'll talk about is just the type of questions you'll encounter. So you'll see multiple choice. This is where you choose 1 out of 4. And then you have multiple responses. And this is where you choose 2 or more out of 5. So those are the two type of formats you're going to see on the exam here. And now just getting to the actual breakdown of the exam, it's broken down into domains, and it also has subdomains, and we'll look at that in greater detail when we actually pull up the exam guide. But the first domain is deployment, worth 22%. Deployment is extremely important to know for the Developer Associate, and you're going to end up with around 14 to 15 questions that you'll be presented with. The next domain is security, and so security is becoming super important in all the certifications. So we're seeing that really across the board everywhere, and here it's super important with 26%, and you're going to see between 16 to 17 questions. Then we have development with AWS services, so this is at 30%, so you're going to see between 19 to 20 questions. Then you have refactoring, which is worth 10%. So this is between 6 to 7 questions. And the last domain is monitoring and troubleshooting at 12%. So we have questions between 7 to 8 that you'll see on the exam. So you can see that development with AWS services is the highest percentage. And that makes sense because it's a Developer Associate. You should learn how to develop with AWS services. So in the exam guide, it recommends white papers that you should read. And so if you're not familiar with white papers, what these are PDFs that are published by AWS, which are 100% free for you to download. And they're kind of like AWS documentation, but they have a sales perspective to help you adopt AWS. And when they create the exams, they actually base a lot of information from the contents of these white papers. So it's important for you to read some of these white papers. When you're studying for professionals, it becomes absolutely essential to know these white papers inside and out. At the associate level, not so much. But if there are white papers that you should absolutely read, it's these ones in red. You absolutely need to read those white papers. The ones in black are things I suggest for you to read. And the ones in gray are the ones that I would say it would not matter whatsoever if you read them. So that is my recommendation for white papers. And if you're looking for them, they're free to download. You just got to go to aws.amazon.com/white papers. And I believe that they also have the hyperlinks in the actual exam guide, which you can download from AWS as well. But now that we've gone through that, let's actually open up the white paper. All right, so what I've done here is I've pulled up aws.amazon.com certification, Certified Developer Associate, so we can look at the exam guide, maybe the sample questions, and a little bit more about this portal here, just because there is really great information here for you. Before you go and take an exam, or even study, just make sure if any changes are happening. You can go to here, AWS Certification, go coming soon. I check this all the time. I have to watch it like a hawk. And it tells you when things are changing. So here you can see that the Solution Architect Associate exam has changed. And they have a bunch of information here. You can also take beta exams, I think, at half price off, which is here. Beta exams are offered 50% discount from standard exam pricing. I don't ever bother to sit beta exams. I don't know. I guess you get certified if you're beta. I'm not really sure about that, but it's definitely not something I actually ever do. I always just wait for the official exams. But the reason I want you to check this is just to see, are there any changes coming to the exam that you are interested in, and that might affect, when you want to take that exam, would you whether want to wait for the new one or take the old one, or even in the case here, the big data one has been split into 2 certifications. So is it valuable to still get the big data one if there's data analytics and database? Will the big data make you look dated in terms of your certification? So just peek around there and consider that. But coming back to this page, you can see that we have recommended knowledge and experience. And then on the right-hand side here, we can download the exam guide and download the sample questions. So here I have the exam guide open. I'm just going to zoom in a little bit. And the first thing I want to check is the actual course code. Make sure that's the one that you want to study. It's interesting here because this says CO1, and then over here it says DVA 001. I don't know if that's a mistake or not, but whatever. Then down below, we have the recommended AWS knowledge. And you'll notice this is exactly the same thing from the list here. So they've just copied and pasted it there. And then for exam preparation, they recommend AWS training. So we have developing on AWS, an instructor-led live or virtual 3-day course. I believe that's like $1,000, $2,000 for registration. I don't know anybody that uses this. And really it's for enterprise companies that have a lot of money. So there's a lot of like government programs where if you send someone for training, and the training's at $2,000, the government will reimburse like 75% of it. And that's why you have these really expensive training packages, which make no sense, which you'd think they'd be charged $100. It's just kind of that scheme there. I haven't heard good things about these whatsoever, but if you work for a very large company and they're willing to pay for it, maybe you want to take it. Then you have the AWS digital training on the training platform. These are actually okay. So I would definitely consider checking them out as supplemental content to this course here. Then you have the white paper recommendations, and as we can see, they are all hyperlinked. I could open up this exam guide month over month, and this list will slightly change because they're always revising or updating these white papers. It'll be the same white paper, but the date will change here. Maybe the title will change, and some of the content will be revised. But again, for the developer associate, reading white papers is not a big deal, and you saw the recommendations I made in my list. And I like how they've actually now listed AWS documentation here. They never did before, but when you're going through my exam, all I'm doing is, I've taken the exam and I have a lot of practical experience, but I'm going through the documentation and highly, highly condensing it. If you were to study just reading the AWS documentation alone, you can definitely do it. But you're looking at 3-4 times longer study, and you might be overstudying on stuff that you should not be doing. But you definitely want to check out the AWS documentation. It becomes extremely important at the professional level. At the associate level, it can be a bit of a time sink. Then down into the actual exam content, here you can see they're talking about those multiple choice, multiple response, which we talked about there. Then there's unscored content. This happens sometimes. So sometimes you'll end up having additional questions. So like that will never, ever be scored. And the reason why is that AWS is always testing out new questions. So if you're taking the exam and you get a question that is like so far out there, and you're really stressed out about it, you feel like, you didn't study well enough, just consider maybe it's just a test question and you're not supposed to know the answer. There's always like 2 or 3 in there. So, don't get stressed out about that. Then we have the exam results. They talk about this point system, and there it is. It says 720. And then we'll go down below and we'll actually look at the domains and subdomains. So we see them again: deployment, security, development with AWS services, refactoring, monitoring, and troubleshooting. And then here are our subdomains. So under deployment, we have deploy written code in AWS using existing CI/CD pipelines, processes, and patterns. So that's why in my course, we're going to be talking about code pipeline, code build, code deploy, and code commit. Then deploying applications using Elastic Beanstalk. This is something we heavily cover in this course here, and I give you really good follow along that you 100% need to do. It's really good. Prepare the application deployment package to be deployed to AWS. This is kind of talking about Elastic Beanstalk in terms of preparing them. This could be preparing containers for deployment, or this could be just preparing artifacts that need to be deployed via code deploy. Then you have deploy serverless applications. Here they're talking about SAM, the serverless application model, or using CloudFormation templates. Moving on to security. So make authenticated calls to AWS services. I guess that's just using the CLI or API or SDK. And I guess it also could be AWS Cognito. That could be STS tokens. Implementing encryption using AWS services. That is absolutely 100% going to be KMS. And we're probably looking at both in transit and encryption at rest. So also ACM, Amazon Certification Manager. Implement application authentication authorization. So that is specifically going to be Cognito. I set it up here, but this is definitely Cognito. Knowing about Web Identity Federation, maybe IAM accounts. Then we have development with AWS services. Write code for serverless applications. So step functions, Lambdas, X-Ray, API gateway. Translate functional requirements into application design. I guess that's giving you like functional, it's giving you scenarios, and then you kind of like pick out what technologies you should use. That's not too complicated. Implement application design into application code. So they give you a design and you have to translate that into code. I don't know what kind of questions that would be on the exam. And I've written a lot of exam questions, so that one's a little bit vague for me. Write code that interacts with the AWS services, so API, SDK, CLI. You definitely will see on the exam, like they'll show you CLI commands. So in this course here, I try to expose you to as many CLI commands as possible. And even when we could use the console, I'm making you use the CLI just so you get those CLI commands etched into your brain and also get some experience with SDK. Then you have refactoring, so optimize applications to best use AWS services and features. So that's just making the best choice based on the scenario. Migrate existing application code to run on AWS. I guess it's like just deploying code. It's weird because it says migration. So I'm not really sure what they mean by that. And I've written practice exam questions for all this. So I mean, I definitely know, but sometimes I read this, I don't even know what they're talking about. Monitoring, troubleshooting, write code that can be monitored. So CloudWatch, X-Ray. There are new features in CloudWatch for like CloudWatch Insights. Is it CloudWatch Synthetics? There's like a new one for serverless applications. Maybe CloudTrail. Perform root cause analysis on faults found in testing or production code. So this would be like knowing when a code deploy fails and then it shows you errors, like how do you read it and understand what's going on? What happens when CloudFormation rolls back and you have to investigate and go fix that? Logging things out into CloudWatch. So like if you're using a Lambda and something goes wrong, you know to open up CloudWatch monitoring and root through the logs. So things like that. So that's the general breakdown of this exam guide, and hopefully it gives you a bit of perspective of what is in front of us. So let's get to it. So just before we jump into the certification content, I want to remind you about the AWS Certified Challenge. And this was officially started by FreeCodeCamp. And the idea here is it allows you to get support from other people that are also on the same journey as you, so you don't have to do it alone. And all you have to do is, if you have a Twitter account, and you could do this on LinkedIn as well, tweet a photo of yourself, thumbs up, announcing you've begun the AWS Certified Challenge. Tweet your daily progress of what you learned. Encourage other people that are taking the challenge as well. And when you earn that certification, print it out and pose with it. And as an added bonus, there's also an official Discord group that you can join. I think we're almost 1,000 members there. I sit in it all day long, and I'm pretty good about answering questions in real time. And there's a lot of support there and other resources being shared there. So definitely, if you want to maximize your ability to learn and get that support, join the Discord, and also join the AWS Certified Challenge on Twitter or LinkedIn. Hey, this is Andrew Brown from Exam Pro, and we are looking at Elastic Beanstalk, which you can use to quickly deploy and manage web applications on AWS without worrying about the underlying infrastructure. And this is a platform as a service, which we'll talk about here shortly. So to understand Elastic Beanstalk, we're going to need to know what a platform as a service is, or a PaaS. And that is a platform allowing customers to develop, run, and manage applications without the complexity of building and maintaining the infrastructure typically associated with developing and launching an app. So that's exactly what Elastic Beanstalk does. You upload your code and everything just runs. If you want to think of a similar service to Elastic Beanstalk, I always say think of Elastic Beanstalk as the Heroku for AWS. And the way we abbreviate Elastic Beanstalk is with EB. So yeah, there you go. So the idea is you choose a platform, you upload your code, and it runs with little knowledge of the underlying infrastructure. In Elastic Beanstalk, if you read the documentations on AWS, they'll say it's not recommended for production applications. But what does AWS mean by that? Because I know a lot of startups and sizable companies that run their production workloads on Elastic Beanstalk. So they're talking to enterprise and large companies. You have to understand that AWS is a very large company. And so their clients can be like mega corporations or governments, and they'll think, okay, I'm going to run my my infrastructure on Beanstalk, but it's just not the use case. So just take that with a grain of salt that you can run production applications, but AWS is just warning large companies not to rely on it. So Elastic Beanstalk is powered by CloudFormation templates. So when you spin up an Elastic Beanstalk environment, that's what it's doing. It's just a very fancy CloudFormation template with a really fancy UI. So if you go over to the CloudFormation console, you can actually see what it's provisioned, and you can go try to read through that CloudFormation template. It's very complicated, but it's just interesting to see what it's doing there. And so Elastic Beanstalk can set up things such as Elastic Load Balancer, auto scaling groups, RDS database, and it comes with pre-configured EC2 instances. And this is the big list of it. So you can see you can do Docker, multi-container Docker, you have Go, Java, Ruby, etc. And generally, these pre-configured platforms come with the common technology you need to run certain frameworks. So if you're using Ruby, it's going to be able to run Rails, etc. Then you have monitoring. So it has CloudWatch and SNS integrated into its dashboard, which is really nice. It has in-place and blue-green deployment methodologies. So you don't have to go out and build a complex code pipeline, which you could spend weeks doing, so it already has it for you there. It can rotate out your passwords for RDS, so it keeps things very secure, and it can run Dockerized environments. So if you are employing microservices, you can definitely use Elastic Beanstalk as your gateway to Elastic Container Services, which is what it uses under the hood to run Docker containers. So let's just take a quick look here at the supported languages for Elastic Beanstalk. So we got Go, Node.js, Java, Python, Ruby, PHP, .NET, and Docker. And I said this previously, but I'm going to say it again. These pre-configured platforms generally have the tools that you need, or a lot of the things that you need to run the frameworks as well. So if you're going to do Ruby, you should be comfortable about running Rails. If you're running the Python platform, you can run Django. If it's PHP, Laravel, Tomcat, Spring, Node.js, Express.js. So just keep that in mind. So when you first create a Elastic Beanstalk application, you have to choose an environment, and you're choosing between web versus worker. And so if you need to build a web application, you're going to be choosing a web environment. But if you need to run background jobs, you can choose a worker environment. In a lot of the cases, when you're building web apps, you're going to make two environments. You're going to actually make both of these, one web and one worker, and they're going to be interconnected together. But let's just talk about the components that are involved here so we have a bit of an idea of how they're different. So on the left-hand side, we have our web environment, and this comes in two variants, which we'll talk about in another slide here. But the idea is that you have these EC2 instances. Maybe it's one, maybe it's multiples, and they're running an auto scaling group. And it also creates an Elastic Load Balancer for you, which is optional if you want to save money. You just don't have one there, and that goes out to the internet. So it's a very simple setup here on the left-hand side. But then on the right-hand side, we have our worker environment, and this is again for background jobs. So you'd have your EC2 instances. They would be in an auto-scaling group. You'd also create an SQS queue. So if you didn't have a queue, it would create one for you. And it would also install the SQS daemon on all those EC2 instances so that it can seamlessly communicate with the SQS queue. But it also has this other setup here, which CloudWatch will watch the amount of instances you have, so that if you're under capacity, it will spin up more instances and adjust the auto scaling group there. So that's really nice. So there you go. That's your web and worker environment. So in the prior slide there, I said there were two types of web environments, or two variants. So let's look at them. The first one we have already seen is a load balanced environment. And so the idea with this one is that you have EC2 instances running into an auto scaling group, but that auto scaling group is set to scale. So if you get a lot of traffic coming in, it's going to spin up more instances. And then when the traffic declines, it's going to remove instances. So that means that there could be a variable cost based on traffic. You have an elastic load balancer there, and that's where traffic is coming into, is the ELB. So the other case is you could set up a single instance environment. And so this one is extremely cost effective because you're only running a single server, but you still are using an auto scaling group, because auto scaling groups are great for keeping, not just for scaling to add servers, but just to keep even a single server running. So the desired capacity is always set to 1. There is no elastic load balancer, and that's just to save on costs. But with no ELB, that means that there's going to be a public IP address that is used. So if you have Route 53, it's going to point to that IP address, where in the load balance environment, it's going to be pointing to that load balancer. So there you go. So I was saying earlier that Elastic Beanstalk comes with deployment options built in. And this is definitely going to save you a lot of time, so you don't have to set up your own code pipeline. So let's talk about some of the deployment policies that are available with Elastic Beanstalk. And so what we have is all at once, rolling with additional batch, and immutable. And we're going to be walking through every single one of these. But based on what deployment policy you choose, they're only available for specific web environments. And so you can see for rolling and rolling with additional batch, they're not available in single instance environments. And the reason why is that you need a load balancer in order to do that, because the load balancer is going to attach and detach instances in batches from ELB. What you're going to notice is that there is no mention of in place or blue-green on this list. And the reason why is basically this entire list is in place, but we're going to explain in place and blue-green, the context of it. So that makes a little bit more sense, because even myself, when I first started learning this, I was like, okay, we have this list, but where's in place and blue-green? So hopefully I can clear that up for you. So let's take a look first at all at once deployment. So the first thing we're going to do is we're going to deploy the new app version to all the instances at the same time. Then we're going to take all the instances out of service while the deployment is processing. And then the servers are going to become available again. So this is the fastest, but also the most dangerous deployment method. It's fast because it's doing everything at once. It's dangerous because you're taking those instances out of service, meaning that your services are going to become unavailable. And also you're applying updates to all your instances at the exact same time. So if you have a major failure here, you might have to roll back your changes. But if that rollback fails, you'll have all these instances that are in a broken state, and you'll have to deploy the original version again, and it can get kind of messy. So that is all at once deployment. So now we're going to look at a rolling deploy. It looks really complicated, but we just need a big graphic in order to explain this. So the first thing is we're going to deploy the new app version to a batch of instances at a time. So whereas all at once was all of them, this one is just like, we'll do 2 at a time, right? And so if we have 4 servers, we're going to do 2. So we take in batches those instances out of service. And then once those are good, we're going to reattach them with the updated instances. We're going to move on to the next batch and so forth until we've gone through all the servers. So you can see that mitigates some of the problems with all at once deploy. It's going to be definitely a bit slower, But if we might need to perform additional rolling updates in order to roll back the changes. So a rollback could be still pretty darn complicated there. So there you go. So let's take a look at rolling with additional batch. So the idea here is that when you start to deploy, you're going to spin up new servers. So if you're doing it in batches of 2 or whatever size, instead of taking a batch out of service, we're just going to add new servers, and then we're going to apply our app version there. And once those are good, we're going to then terminate our old instances or another batch. And the idea here is that by doing this, we're never going to reduce our capacity. And this is important for applications where a reduction in capacity could cause availability issues for users. Because we saw with rolling, we will have a reduced capacity for a short period of time. In this case, we'll never have a reduced capacity. But we still have the same issues where if you want to do a rollback, you're going to have to perform an additional rolling update. So rollbacks is still quite painful in this case and slow. So let's take a look at immutable deploys, and this one really is reliant on the auto-scaling group. So over here, what you can see is that we already have an Elastic Load Balancer that points to an EC2 instance that's inside of an auto-scaling group. But what we're going to do is we're going to make a new auto-scaling group with a single EC2 instance in it, or whatever, however many servers we need to replace. And then the next thing we're going to do is we're going to deploy the updated version of our app on the new EC2 instances in that new auto-scaling group. And then what we're going to do is we're going to point that Elastic Load Balancer to the new ASG, and then we're going to delete the old ASG, which is going to terminate all the old instances. So the reason why you'd want to do this is that this is the safest way to deploy critical applications. And when you want to roll back, if we just go over here, the idea is that you don't have to destroy this auto-scaling group immediately. You can wait until this new production auto-scaling group is running smoothly. You could wait days or weeks, however long you want, and then you could destroy this old auto-scaling group. Or if you had to roll back, you could instantly move back to that auto-scaling group because all the infrastructure exists. So rollbacks are really easy. It's super safe, but there's not a lot of downsides to it. I mean, this is the one I would choose to do. So we're going to take a look at deployment methodologies for Elastic Beanstalk, and you're going to notice that down below I have blue-green. So we never covered blue-green as of yet. And so these have all been mutable all the way to all at once have been deployment policies. These are built-in deployment methods into Elastic Beanstalk, but we have blue-green. And we'll explain the difference between in place and blue-green in the next slide here. But let's just compare these methodologies and understand what the trade-offs are, because this is definitely important on the exam. So the first one is all at once, and it has the fastest deploy time because it updates all the servers at the exact same time. So if we have 4 servers, it takes them out of service, applies the updates, and puts them back into service. But when they're out of service, we're going to experience a downtime. And downtime could be a bad thing if your users notice, and that could impact their experience, or if they're doing serious or critical transactions, that could be a problem. So you have to decide whether that is a trade-off you want to take, but most people do not want to use all at once. And also, if you encounter an error, let's say your deploy fails and you have 4 servers, now you have to roll them back manually. And so that's kind of a pain. But also, imagine if you encountered an error during rollback, so the rollback fails, and now you have 4 servers all stuck in a broken state. That could be extremely detrimental to your business, losing hours upon hours of time. So you have to weigh those trade-offs. Now, next we have is rolling. And so rolling mitigates this downtime problem where we have instances that are out of service. So what it does is, so if you have 4 servers like the previous case, it's going to update these in batches. So it's going to take the first 2 and take them out of service, right? And then put them back into service, and then it's going to move on to the next one. But the trade-off, there is still a downside, which is we're going to have a reduced capacity. So if you have to have always 4 servers to run your critical workload or to just handle the current usage, this is not going to be ideal for you. So what you're going to want to do is you're going to want to use rolling with additional batch. So rolling with additional batch is very similar to rolling. So it's going to work in batches, but instead of taking a batch out of service, it's going to add a new batch. And once this one is good and running, it just kills an old one. And so this way you always have at least the minimum amount of servers you need running to meet your capacity needs. But rolling back for these methodologies can be difficult. It's still a manual process, and you could just imagine having to roll each section back could be painful. Imagine that you're rolling this back and then this rollback fails, and now this one's stuck into a state. So you have a weird number of servers messed up here. This can be extremely difficult. So the last one here is immutable. Immutable, the idea is you just replicate your entire environment. So like all at once, if you had 4 servers, it would take them out of service. With immutable, it would just create 4 new servers. And once they're all good, then you could move over to those 4 new servers. And if you had to roll back, you just point back to the old ones because they still exist, because they haven't yet been deleted until you decide to do so. So immutable gives you the best flexibility in terms of the rollback process. It can be more expensive depending on how long you keep those servers around. The provisioning time takes a long time. The actual switch takes very little time because it's very fast to roll back or switch to the new version. But to provision those servers take a while because you're replicating everything at once. And before you can actually start routing traffic to it. Because with rollbacks, you can start with rolling, you can start routing traffic to new instances gradually or immediately. Whereas immutable, you have to wait till all the servers are ready. But I think immutable is extremely safe and a good deployment methodology to use. And then last we have blue green, and blue green is very, very similar to immutable, where it will replicate all the servers. So if you have 4 servers, it's going to make 4 new servers, but also it could spin up other infrastructure like Elastic Load Balancers and stuff like that. But these are super, super similar, and that's why we have another slide to talk about them, to understand when something's in place versus blue-green. But just before we move on here, for Elastic Beanstalk, the blue-green methodology uses a DNS way of doing blue-green. So that means that when you want to move over to these new servers, it Route 53 points to a new load balancer. So there's a new load balancer with new instances on it. And so the change is happening at the DNS level. And the reason why this can be a negative is that DNS changes have to propagate to DNS servers around the world. And the effect that could happen is that you could have this new production server ready, but people are still being pointed to the old one, or it's going nowhere. And so even though the server's not down, some users could experience unavailability just because they're being pointed to the wrong thing. So that is a consideration you have to think about. Though for Elastic Beanstalk, it's not generally that bad, but it does happen. So we do have to consider that as a negative. But now that we know deployment methodologies, let's move on to the comparison between in-place and blue-green. So let's take a look at in-place versus blue-green deployment here. And these terms are confusing because they're not definitive in definition, and the context can change the scope of what they mean. So it's important to learn these not just for Elastic Beanstalk, but for DevOps in general. So we're going to spend a little bit of time here making sure you really know this stuff inside and out. So Elastic Beanstalk by default performs in-place updates, and that's all the deployment policies we've been looking at. They've all been considered in place. But let's change the context to see how that affects the scope, which will change what is considered in place. So the first we're going to look at, which we're already familiar with, is with the Elastic Beanstalk environment. So when that is our scope, that means that all the policies we saw prior, all at once, rolling with additional batch, and immutable, are considered in-place deployment methodologies. So let's say we change the scope to outside of Elastic Beanstalk, and now it's just servers. So we have these servers, but what's really important is that these servers are never replaced. So they always have to be the same servers, the existing servers. So that's our scope. And now the only deployment methodologies that are available to us is all at once or rolling, which are considered in place because they never replace a server. They'll take a server out of service, make changes, and put it back into service. Now, that doesn't mean that rolling with additional batch and immutable would be considered blue-green. They just wouldn't be considered in place for the scope of that scenario. Let's set up another one where the scope is now we have a server that can never be interrupted. So it doesn't mean that that means we can't replace the server with a new server, but that also means we can't take it out of service. So it should never lose traffic. It should always be traffic should always be pointed to it. And so to solve this, we'd use zero downtime deploys. This is where blue-green occurs on the actual server itself, like in a virtual sense, where you have your code base and then you deploy the second version of the code base on the server, and then you facilitate the change, the switch within the server virtually. And you can't do this on Elastic Beanstalk. I used to do this for years with Capistrano, Ruby on Rails, and Unicorn. And this allows for deploys that happen within minutes. So like in 30 seconds or 1 minute, I'd have the latest version updated. It was amazing. But when we have to consider all these cloud components, this kind of agility has been lost, but we get other kind of trade-offs to it. So, that's the stuff that we're looking at. But when we're talking about the exams itself and they're talking about in place, they're going to be talking about generally in the context of Elastic Beanstalk environment. So I just want you to know the differences of this. But for the exam, this is the one you're going to focus on for in place. Okay. Okay, so this is the slide where everything is going to fall into place, and you're going to really understand the difference between in place versus blue-green deployment. So this is going to be in the context of Elastic Beanstalk, and we're first going to look at an immutable deployment methodology. So we know with immutable that what happens is it replicates the auto-scaling group with another EC2 instance, and then it facilitates the transition to the new production servers by switching over to this auto-scaling group and then destroying the old one. Now, this is funny because in our last slide, we just saw that there was a blue-green methodology called ELB blue-green, and this is exactly what it did. So why isn't this considered blue-green? And it's called in place. And that has to do with the boundaries of the environment. And so the environment is defined here as being the Elastic Beanstalk container. And so because the mechanism of our deploys inside the boundaries of this environment, it's considered in place because it's inside of the environment. So now looking at a blue-green deploy, for Elastic Beanstalk, this can only occur at the DNS level. So it's Route 53 that's facilitating it. But notice that it's outside of the environments. It's outside of it. It's going from a blue environment to a green environment. And so that is why it's called blue-green deploy. If it's all within the same environment, it can't be considered blue-green. So, talking about doing a DNS, like having the DNS level facilitate the switch of servers, or having the load balancer, I was saying the load balancer was a lot better because with DNS, we could have an interruption in service, not because the servers aren't ready, but like the DNS servers have to propagate the changes, and so there could be some unavailability for servers. So why would you still use this then if this one is better? And this has to do with where some of your external resources lie. So in the context of Elastic Beanstalk, it really has to do with your database. So if you are using in-place deployment, a lot of them are very destructive. So your database would be inside of the environment. It would be running on an EC2 instance, generally. And, it would get terminated with the environment. And so you'd lose your data. So that would not be good whatsoever. So your database would have to sit outside of your environment, like on RDS. And so, the better place to do it would generally be with a blue-green deploy with your database outside of it. So that is generally the reason why we use blue-green. That doesn't mean you can't use RDS with in place, but generally it's more for blue and green deploy. So hopefully that clears up a lot of stuff, and you can understand and visualize those boundaries to see when something's in place and when something is not considered in place. So So if we want to change the way our Elastic Beanstalk environment works pragmatically, then the way we're going to do it is through configuration files. These configuration files sit in a hidden folder called EB extensions at the root of your project, and they're going to have an extension that says .config on them. So there's going to be a variety of different ones, but that's what Elastic Beanstalk expects. And what we can change to these configuration files is the option settings for our initial environment. We can do things very specific to Linux and Windows. And then we can also set up custom resources. So if we need other AWS services to integrate, that's what we can do there. But the motivation of having this file here is that, let's say we want to hand this project to somebody else, they can just provision all the things they need with the exact configuration they need. So this is something you'll definitely run into if you're working on Elastic Beanstalk. You'll have to do a little bit of configuration. So I said that you could configure some option settings for the Elastic Beanstalk environment, and that's called the environment manifest, which is in a file called the env.yaml, and you're going to store that at the root of your project. So this file is important because when you first create your Elastic Beanstalk environment, it's going to look for this file and set up a bunch of defaults. So this is the way that you're really sharing that configuration with other people, or just saving that configuration for yourself. So what I've done here is I pulled out a little example, and we're just going to look at some of these attributes here. So the first one that we're looking at is the environment name. So that's whatever you want the name to be, and we'll talk about what that plus is in a moment on the end there. Then there you have your solution stack, so that could be Ruby, Python, Java, whatever, but that's going to be what AMI is chosen. Then you have environments links, and this associates to other environments. So we saw that you could have a web environment and a worker environment, and so this is a way to connect them together. And then you have some default configurations for specific AWS services. So here we are setting a load balancer to be cross-zone. And there is a lot more options here, but we don't need to go through all of them. You just have to generally know that you can do this stuff. And let's just talk about that plus there on the end. So that plus is used to add the environment name to the end there. So to give these more unique names. So that's all that thing is for. So there you go. So now we're going to take a look at Linux server configuration. There is one for Windows server configuration, but I think we only need to really learn one here because you can pretty much apply this to both, and that'll be good enough for our studies. So the first thing you could configure is being able to download packages. So here I have Ruby, or we have Memcache. I think the package manager will generally be Yum because that's what AWS uses for both Amazon Linux 1 and Amazon Linux 2. If you can use some kind of other OS, that might change to something else. Then you can set Linux Unix groups, something I don't do very often, but something you can configure. Then you can also configure users and assign them to Linux groups. You can also create files or download files from the internet using a URL. That URL is for public-facing files, so I don't think there's a way to download private files. But for the content, you just specify content and provide what you want. There, I'm providing a YAML file. Then you have commands. These are commands that you want to run before your application has been installed. So Elastic Beanstalk pulls your code base, but this happens before that code is actually in the environment. Then you have services. So maybe you've installed Nginx and you want to ensure that it is running when it starts up, and it continuously runs. So if for whatever reason it shuts down, it will try to make it start up again. And then the last thing are container commands. And so these are commands that are specific to your application. So after your application or your source code has been downloaded to the environment, these are what you want to run on it. It says container commands, which make you think that these are for Docker containers. That's not the case. So just be aware of that. But for Windows, you're going to have similar ones. So you'll have container commands, commands, probably something for packages and files. So it's more or less similar. It's just as long as you conceptually understand the things you can set at the server level. So So Elastic Beanstalk has a CLI which you can install, and that's going to give you more of a Heroku-like experience. And you're going to notice some of these commands are very similar to Heroku commands. So to get the CLI, you need to go to GitHub and just ahead and install it. So it's just as simple as cloning the repo. And I believe this is using Python. And so you just execute that command. If you're on a Mac, this should just work. For other systems, you're going to have to read a little bit more on the GitHub page itself. Which you can see is at the AWS Elastic Beanstalk CLI setup there. But let's just run through some of the commands that are available to us, starting with ebinit. So this configures your project directory in Elastic Beanstalk CLI. This is the first thing you're going to want to run because it's going to set up a bunch of defaults on your computer. And if you don't want to make a project, you can just delete that project afterwards, but you still want to run this. When you want to create an environment, you're going to be doing ebcreate. When you want to check the status of an environment, you're going to do ebstatus. When you want to check the health, you can get health on the particular instances and the overall health of the environments. If you want to get that in real time, or near real time, you can do a refresh and it'll update every 10 seconds. If you need to see a bunch of events that are being outputted by the Elastic Beanstalk environment, you can run that. If you want to see logs from the actual instance yourself, you can run eblogs. If you want to open up the application in your browser, there's ebopen, but it's really not that hard to do. You could just go to your browser. When you're ready to deploy your current version of code, you do ebdeploy. If you want to see what kind of configuration setup you have for that environment, seeing whether it's running Ruby or other options, you can check that as well. And if you want to terminate that instance because you want to save money, you can do ebterminate. So, go ahead and download the CLI and give it a go. So we're going to look at how you can use your own custom image in Elastic Beanstalk. And this is where you can provide your own AMI instead of the standard Elastic Beanstalk AMI of your choice. The reason why you'd want to do this is because it could improve provisioning time. So if you have a lot of software, like packages you need to install to run your software, it takes a long time to pull all those. If you bake it into an AMI, it's just going to speed things up because it's already there. So let's go through the process of how you'd actually get a custom image, because it's not hard, but there's a lot of steps to it. So the first thing you're going to want to do is go to AWS Docs. There's a page called supported platforms, and you get a list of all the type of standard Elastic Beanstalk AMIs. And what you're doing is you're trying to get the platform information there so that you can then use the CLI to use this command called describe platform version. And so by using describe platform version, and you can see over there, it has the platform name in it, it's going to get us back an image ID. And that image ID is the AMI's ID, so that we can then find the AMI and then extend that AMI to do what we want with it. So using that AMI ID, you go to the EC2 marketplace, probably into the community section, and you paste in that AMI. So we would find the AMI we're looking for, and then we would launch a new EC2 server. Once that EC2 server is launched, we could then log into it either using SSL or Sessions Manager. I would suggest Sessions Manager to do so. You would need the correct IAM role attached to it, so just be aware of that. But once you get into that machine, you configure it however you want. So you'd go in and you'd install those packages manually, and then you would go ahead and bake that AMI, and so you'd have your new AMI. So once you have the new AMI, you could go in your configuration, like your files, or you could even do it through the console and set the new AMI ID. And then when you create new environments, that's what it's going to use. So that is the whole process to setting up a custom image. So we need to talk about configuring your RDS database with Elastic Beanstalk, because you actually have two options. You can add a database inside or outside your Elastic Beanstalk environment, and you might not even be aware that you're doing it if you're setting it up. So it's important to know the difference. So let's talk about inside the Elastic Beanstalk environment. So when you go to create an environment through the console, you'll have the option to create a RDS database. And if you are doing that, that means it's going to be within the Elastic Beanstalk environment. Now, the thing is, if you do this, that means whenever this environment is terminated for any reason, it will take out the database with it. So that means that generally this setup is for development environments. That doesn't mean you can't use it for production, because as long as you're using in-place deployment mechanisms, so like let's say use immutable and stuff, that's going to replace the EC2 servers. It's never going to remove the RDS database, but if you, for whatever reason, delete that entire environment, your database is gone with it. Then on the other side, you have outside the Elastic Beanstalk environment. And the way you know you're doing this is you're creating your database first in RDS, and then you configure it with your EC2 instances that are inside your Elastic Beanstalk environment. Now, when the Elastic Beanstalk environment is terminated, the database is going to remain because it wasn't created part of the EB environment. And so these are generally suited for production environments. And with this setup, you generally are using blue-green deployment. You don't have to, but you totally can. And I just want you to know that distinction about inside and outside the environment. Hey, this is Andrew Brown from Exam Pro, and we made it to the end of the Elastic Beanstalk overview, and that means it's time for the cheat sheet. So let's review. Elastic Beanstalk handles the deployment from capacity provisioning, load balancing, auto-scaling to application health monitoring. So it really sets up a lot of infrastructure for you. It's a good time to use EB when you want to run a web app, but you don't want to have to think about the underlying infrastructure. And we just saw this big list of infrastructure above. It costs nothing to use EB, only the resources it provisions. So if it spins up RDS, an ELB, EC2, you're going to be paying for those, but EB itself costs nothing. Recommended for test or development apps, not recommended for production use. Remember, when AWS says this, when they say not for production use, they're talking about super large enterprises who think that they can use Elastic Beanstalk for the production environments. If you're a small to medium business, Elastic Beanstalk is A-OK. You can choose from the following pre-configured platforms. We have Java, .NET, PHP, Node.js, Python, Ruby, Go, and Docker. You can run containers on EB either in single container or multi-container mode. These containers are running on ECS instead of EC2. You can launch either a web environment or a worker environment. Web environments come in two types. We have single instance or load balance. For single instance environments, it launches a single EC2 instance, and it signs it an Elastic IP address to that EC2 instance. For a load balance environment, it's going to launch EC2 instances behind an ELB managed by an auto-scaling group. I didn't mention in the last one, but for the single instance environment, it is in an auto-scaling group as well. It's just set to set to desired capacity of 1. But I don't know that's important for the exam. It's not a big deal. Then you have your worker environments. This creates an SQL queue, installs the SQL daemon on all the EC2 instances, has an auto-scaling scaling policy, which will add or remove instances based on the queue size. Then we have EB has the following deployment policies. So we have all at once. So this takes all the servers out of service, applies changes, puts servers back in service. This is super fast and has downtime. So that is one condition you have to think about. Then you have rolling. It updates servers in batches, reduce capacity based on batch size. Rolling with additional batch adds new servers and batches to replace the old. Never reduces capacity. Then you have immutable, creates the same amount of servers and switches all at once to the new servers, removing old servers. You really, really need to know these deployment policies inside and out. So make sure you know the difference. And if you don't know, go back to the lecture content, look at those diagrams and make sure it clicks. And then we're on to the last page here. So rollback deployment policies require an ELB. So rollback, it should be called rolling. So I meant to write rolling. I'll update this here, but for the video, it's just going to say rollback. So rolling deployment. So rolling with additional batch policies requires an ELB, so it cannot be used with single instance web environments. Just consider that. In-place deployment is when deployment occurs within the environment. All deployment policies are in place. Blue-green is when deployment swaps environments, so outside an environment. When you have external resources such as RDS, which cannot be destroyed, it's suited for blue-green deployment. EB Extensions is a folder which contains all configuration files. With EB, you can provide a custom image, which can improve provisioning times. If you let Elastic Beanstalk create the RDS instance, that means when you delete your environment, it will delete the database. This setup is intended for development and test environments. Really do consider that. And the last thing here is Docker AWS JSON is similar to ECS task definition file and defines multi-container configuration. So yeah, if you looked at task definition, you'll understand it. We don't have to go through the guts of that here, but this is generally what you need to know for the exam, but really know those deployment models, okay? Hey, this is Andrew Brown from Exam Pro, and we are going to start with the Elastic Beanstalk follow along, where we're going to look at how to deploy Elastic Beanstalk a variety of different ways so we know it inside and out. I want to point out first, before we get started here, make sure you are in the correct region. And we always do everything in US East 1 because that's where the most abundance of AWS services are available, and it just makes things a lot easier. So just go up here and make sure you're in US East 1. And be very careful because AWS likes to switch out that region on you sometimes. So if you feel like things aren't going the way that it should be going, just double check your region. So now that we have that out of the way, let's go ahead and make our way over to Cloud9 because we're going to need a developer environment to run and test our application, and then go ahead and take that over and deploy to Elastic Beanstalk. So I'm going to go ahead here to Cloud9. I don't have any region or environments created here, so we'll go ahead and create an environment. I'm going to name this dev env, which is developer environment here. It's saying not to use root account. I'm definitely not logged in as the root account, so I'm not sure why I'm getting that message. But we'll go ahead here, hit next. And what we're going to do is we're going to make sure this is a T2 micro. That's part of the free tier eligibility. We'll scroll down here and we have the choice between Amazon Linux and Ubuntu. Amazon Linux 1 is supposed to be unsupported at some point because they want you to use Amazon Linux 2. So if you're watching this in the future, maybe Amazon Linux 2 will be here. You'll have to use Ubuntu. But if Amazon Linux 1 is here, absolutely use it because it is amazing. We're going to leave the default cost-saving settings here to 30 minutes. So if we don't have any activity or we don't have the browser open here, it will shut down the server, save us money. It looks like it wants to create an IAM role. We'll let it go ahead and do that. We'll go ahead and hit next. And down below, it has some best practices for us and just shows us a confirmation of what we're creating. And this is all great. So just hit create environment. And we'll just have to wait here a little bit, and I'll see you here in a moment. All right, so our Cloud9 environment here is ready. And just before I get started, I like to use the dark theme. So I'm going to just switch it down here to the classic dark theme. And I also like to use Vim. I would recommend just using the default, but Vim is what I use. That rebinds all the keys for super efficiency. So, it's just because I've been doing it for years. But anyway, now that we have our Cloud9 environment, let's actually get an application going here. And since this is very developer focused, I think we should try to use the terminal as much as we can to get as much experience as possible. The first thing I want you to do is I want you to type in npm c9-g. So C9, which is short for Cloud9, this is a Node.js utility that makes it easy to open files directly from the terminal here. So we have this README file. And also just notice that, see where it says environment? This actually maps to this dev evn directory. If I hover over there, you can see it'll autocomplete to that. So I don't know why Cloud9 does that, but that's how they name it. But anyway, I just want to show you how C9 works. So we have a README in here, and if I just wanted to open it up, it actually is, I think, open right there. But if I just typed in ls, and then I typed in C9 README, then it would open up that README file. So that is going to give us a little bit of help along the way. So now that we have C9 installed, let's go set up the actual application itself. And so the first thing we're going to do is we're going to type in mkdir, which makes a new directory. And we want to make that in our environment. So I'm going to use tilde to make sure I'm always at home. I'm going to type environment study sync is the name of the application we are creating today. And you can see up here that it created a folder. Okay. And we'll go ahead and we'll just create some additional files. So I'm just going to cd into that folder to save myself some trouble. And the first thing we need to do is initialize an empty node project. So we'll do npm init-y. Okay. And what that did is created a package.json for us here, which we will adjust momentarily. But we want to run a web app, so we're going to need some kind of web framework. So we're going to go ahead and use Express. Okay. So we'll go ahead and type that in. And what's that going to do? It's going to add it as a dependency there. So now we can use Express. The next thing we want to do is we're going to need some initial files to work with here. So I'm going to type in touch. We're going to type in main.js. We'll probably need index.html. Actually not, instead of main, we'll call it index. I think actually I normally call it index. Then we will have index.html, app.js, and style.css. And so that created all the initial files that we need to work with. And so now we just need to populate those files. So the first thing I want to do is I want to have a way of actually running our application here in Node. So we're going to add a new script up here called start. Okay, and we'll just type in node main.js. Actually, I'm going to call that index there. And the next thing we're going to do is we're going to start populating these files. So if you make your way over to the GitHub and you go to Exam Pro Co, the free AWS Developer Associate, there's a folder in here called StudySync000, and these are the files that we're going to copy on over. So the first is the index.js. So we'll go there and just hit raw, and we'll copy the contents here. And we'll double click on that, and we'll just paste it. Then we will click back here, and we'll go grab the styling. Okay, we'll hit raw. It's not that important for you to know how to program, but I mean, you know, we need to get as comfortable as we can here. So we're not going to really need to learn all this stuff that we're doing. Just copy, paste it through. And we just need, I think, the app.js file. Yep, the JavaScript file here. And we will grab all that data. And so those are the three files we need. And just to give you a very quick tour of what's going on here. We have this index.html file. Oh, I guess we didn't populate that. Okay. Give me 2 seconds here. Sometimes you think you do something and you don't. So anyway, the index.html file loads this style.css file, which is located there. What we're doing is we're using a CDN to pull in Mithril, which is a JavaScript front-end framework. We are going to use app.js to load our JavaScript. Going over to our JavaScript here, we're using the Mithril framework. So it's very simple. We have this app here, and the idea is we're going to have a question, and we have multiple choices, and we can submit the answer somewhere. And then we just have some plain styling in CSS. So now that we have that all going, the next thing we need to do is actually preview this application, because before we can deploy it and package it, we need to make sure that it is working here. So I'm just going to go ahead here and close these tabs. And there's just going to be a couple things that we need to do next. Okay, so what we need to do is we need to get our application running to make sure that it's all in working order before we go ahead and package it. And so we can preview in Cloud9, but Cloud9 by default doesn't open up its ports to the internet. So we have to go ahead and do that. This would be no different than you setting up a web app on an EC2 instance. You'd still have to open up ports. And so generally the ports that Cloud9 allows out to the internet is 8080, 8081, and 8082. So what we'll do, I just want to show you how you normally do this. So you go here and you go to EC2 instances. You go to instances on the left-hand side, and we find the one that's running. That's our Cloud9 environment. And over here, we're going to find security groups. And if we expand that and we check inbound rules, we go here, edit, and we just add 8080, right? And then we restrict it to our IP. This is a development environment. Oops, I got to hit plus there. But we're not going to do it this way, because I want you to get as much pragmatic experience, because this is a developer associate. So we're going to figure out how to do it completely from the terminal. So we're going to do the exact same there. I know this is much faster, but like, trust me, this is going to help you in the long run for studying here. So let's get to it. So what we're going to do here, I'm just going to type clear here so my screen's nice and clean, is we need to figure out what the MAC address is for this EC2 instance. And then we're going to use that MAC address to get the security group IDs. And then from that, we'll use the CLI to update and create our own inbound rule. So whenever you want to get information about an EC2 instance, that is where the metadata service comes into play. And it's very easy to access on a server, whether you're here in your SSH into an EC2 instance or you're here in Cloud9. You just type in curl -s http:// And then it's 169.254, 169.254, latest, and metadata. So here it's showing you that there's a way you can get a lot of data in here. This 169.254, you should know this IP address. It should be etched into your brain because it's definitely a standard here when working with EC2. And as a developer, you need to know it. But we need to find the MAC address. And here we have this thing that says MAC. So we'll go ahead here and type in MAC. And now we have the MAC address. And the next thing is we're going to use this MAC address to find out all the security group IDs for the network interfaces that use that MAC. So what we'll do is we're going to hit up, and we're just going to back out here a bit, and we'll do network. And we'll just piecemeal it, because if you make the whole link, sometimes it's a big pain in the butt, and it's hard to hunt down the problems. So I'm going to just keep on doing this bit by bit. Oh, it just shows the MAC address there. That's even more convenient. And we'll just hit enter. And then we want our security group IDs. And there, so we only have one security group. If there was multiples, we'd like attach the EC2 instance, we'd probably see more, but we only have this single one here. So now that we have this security group ID, what we'll do is we will use the CLI. The CLI, AWS CLI is already installed on this Cloud9 environment because it's Amazon Linux 1, already comes pre-installed. And Cloud9 also loads your credentials from your user account, so we don't have to play with the credentials file here. If you're doing this on your local computer, you absolutely would have to set that up. We'll type in AWS EC2, and we'll type in authorize security groups ingress. And there is a new AWS CLI, and it has autocomplete. So like you could hit tab and it would complete that stuff there for you. But I don't believe I have the latest one installed here, so I have to do things manually. And so we'll place in that security group. We'll say what port we want to open up. So port 8080. We'll have to specify the protocol. It's going to be a TCP. And then we need to supply the CIDR. So that's the IP address that we're going to want to be accessible. So before we hit enter here, we actually need to go get our IP address, because that's what we're going to put in here. So what we'll do is use one of AWS's services, which is called Check IP. So it's a very useful service. Let's go use that now. So I just opened up a new tab here, and I'm just going to type in, check IP, Amazon AWS.com, and this will tell me what my IP address for my local computer is. There's other websites like What's My IP, but let's use the AWS service because they took the time to make it for us. And we'll go back over here, and we will hit enter, and we want /32. That /32 is very, very important because that says only a single IP address. A CIDR block is a range of IP addresses. It's something we definitely cover in this course, and you definitely need to know what networking like CIDR blocks are in the associate. But for the time being, if you don't know what it is, just understand that you need to put your IP address in there and type in /. And what we'll do is we'll go hit enter. And actually, before we do that, no, we'll just hit enter. That's fine. So it didn't show us anything. So, I believe that successfully created it. So we'll go over here and just take a look here to see if it actually made it. And there it is. But let's say that we didn't want to make our way over here and we wanted to do this pragmatically. Let's go confirm the security group through the CLI. So what we're going to do is type in AWS EC2, describe security groups. We're going to put in that group ID. It takes a bunch of them, but we only need one here. And we'll output it that says text. That allows us to, generally it's default JSON, but that's just really hard to read in this case. And then we're going to use filters. So we'll type in filters, name equals IP hyphen permission dot to hyphen port values equal 8080. So what I'm saying here is describe all the security groups to me and filter it out so we only select this security group, display this as text, and then filter it out so that we only see inbound rules that have port 8080. And we'll hit enter here. And we have a invalid command there. So I'm just going to double check here. I might have typed something wrong. Permissions does not look spelt correctly to me. Yeah, it's going to be PER, permissions. And I'm still having a bit of trouble here. IP-permissions to port. Oh, you know what? It's a singular permissions. It's not with an S, I think. There we go. So it's a little bit hard to read, but the idea here is that it's going to say this is our security group that we returned. It's saying that port 8080 has been set, and that's the IP address. Now, if it hadn't been set and we ran this command, it would just show nothing. So the fact that something shows up here means that that the security that inbound rule was created. But of course, in practicality, you'd probably just use the console. So now that we have, and we'll just type clear here to clear this stuff up. So now that we've opened that port, the next thing is actually getting the application running. But before we can even do that, we need to know what the actual IP address of this Cloud9 environment is. And I'm pretty sure if we use our EC2 instance here, we can go here and we can go and check it, and that is its public IP address. I think that would be the same thing, but let's again do it pragmatically. So we'll type in curl -s http ://169.254.169.254 latest metadata. I'm going to hit enter just so I'm not having too much trouble here. You can even see right here, it's public IPv4. So we'll type in public IPv4. And it says 385.910. I'm going to go back here. Yep, so it's the same one there. So that's what we're going to use to access the web application. And let's go ahead and actually start this application up. So to start it up, we just have to make sure we're in that study sync directory here. And we want to start it up on port 8080. So if you're wondering, like, why are we typing port 8080 there? The way this application works, if you open up the index.js, it uses process env port, and it's going to pass that port number to Express. So it knows to start up on that port number. And so what we'll do here is we'll just go and type in npm start. And we'll see if this starts up. And we have a little error here, and that's totally okay. It says failed to parse package.json data. You know what happened? We forgot a comma. This is something I do all the time. So remember we wrote this line in here. We have to just make sure there's a comma on the end of it or it's not valid JSON. And I'm just going to go back down here, hit Control-C, which kills that there. And we'll hit up again. We'll see if we're in better shape. So now it says that it's launched on port 8080. So what we can do now is get that IP address that we have earlier. So it is somewhere in here. Can't seem to see it. So I'm just going to go here and copy this here and make a new tab in terminal and just paste it in. Of course, we could just go to EC2 instance, but why do that when we can try to do it the proper way? And so what we'll need to do is do this and say port 8080. We're not going to open it up here, but I'm just typing it out so that I'm having less trouble here. And we'll just copy that, and we will see if this works. And there's our application. So this application doesn't really do much. You can select something and submit, but it doesn't really submit to anywhere. Maybe we will start hooking this up and do more with it. I call this the Study Sync application. It's supposed to help you study, I guess. But you know, it's just a superficial application. So now that we have our application running and we can preview it from Cloud9 and we have some CLI experience, the next thing is to get a Git repository set up. So that's what we'll do next. Okay, so let's get Git going here, and I'm just going to go ahead and close this bash command. We'll go back here, and we'll just stop the server. I'm doing that by typing Control-C on my keyboard. You can see that it says Control-C. This little icon represents control. And we're going to need a .gitignore file because there's files that we just do not want to include. So up here, when we have node modules, this is how Node works. They just put all the libraries in line, and we do not want that in our Git repo. That's just too much stuff. And so with Git, there's a file called .gitignore. And what we'll do is we'll just make sure we create it here in our study sync directory. So just make sure you're in environment study sync. If you're not sure where you are, just type in environment study sync as such. And then we will just go ahead and touch a .gitignore file. And that should now exist. I just don't see it here on the left-hand side. It might be hiding it, or we might have to hit refresh. Well, I definitely know that it's there. So, because if we do an ls-la, there we can see that hidden file. There's probably a way to turn it on there. I'm just not sure at the current moment. But that's fine, because this is all about learning how to use the terminal and CLI as a developer. So if we want to open up that .gitignore, we're going to use our handy dandy C9 command, .gitignore. And if you don't want to type everything, you just hit tab on your keyboard. That saves a lot of time when you're auto-completing stuff. Works for most things. And what we're going to do is type in node modules. What that's going to do, it's going to ignore this file completely, this folder completely, because we don't need to include that with Git. Now that we have that set up, you may want to set up your git config global username and email. We're not going to worry about it right now, but we'll probably be prompted for it, and it'll just be an annoying message every time we see it. So now that we have our gitignore, let's set up our Git. Let's actually set up this Git repo. So we'll type in git init, and it's initialized an empty repo. It's created a new folder called .git here. So if I just do an ls-la, you can see I have a .git directory now. And we're not going to really get into the details about Git here, but just showing you what's going on. The next thing we want to do is we want to add all the stuff that we've worked on so far to our actual repo. So if we type in git status, it'll show that we have these untracked files, meaning that they aren't going to be committed. So let's add them to be committed. So we have to do git add. We'll do git add period. That will just add them all. So we'll hit enter. We'll type in git status. And so now you see it went from untracked to changes to be committed. And so now we just need to write our git commit message -m initial commit. And they are now committed. And there's that thing I was talking about, that git config username and email. Generally, you want to set these with your name and email. Since I'm just doing this for practice here, I'm not going to do that. And it'll probably keep on popping up. But we've created a Git repository, but it only lives on this Cloud9 environment. And we really want to make sure that this is hosted somewhere in the cloud. You could use GitHub. But for this course, this project, we are going to be using Code Commit so that we get some hands-on experience with that. I think a lot of developers already have a lot of experience with GitHub. Yeah, we'll get to that next here. So I said the next thing we want to do is get this this local repo. That's this folder here. Well, we can't see it on the left-hand side because it's hidden. But we want to get this all the contents of this entire folder and this .git file into a repo, and we're going to use Code Commit. Now, when you use the Elastic Beanstalk CLI, and you're setting up a project for the new time, the first time it will set up a Code Commit project for you. And so I figured that's the way we should go ahead and do it. So we'll just go up here and make a new tab, because the CLI is not pre-installed. So the AWS CLI is pre-installed on this Cloud9 instance, but not the Elastic Beanstalk one. So what we'll do here is we're just going to go ahead and type in Elastic Beanstalk CLI GitHub. And because that's going to have the instructions for us to do this install here. And so I'm just going to scroll down here. And based on your environment, you might have to install additional things. You can see there's a bunch of things. But since we were working with Cloud9, there's not going to be anything that's too difficult here. And all we have to do to install this is to run the git clone command. So let's go ahead and give that a go. So we'll make our way back to our Cloud9 environment. I'm just going to type in clear so we can see what we're doing. And I'm just going to go back one directory because this is going to clone that repo, like download this folder. And I just don't want it having in my study sync here. So I'm just going to go back a directory, which is just cd ... And we're going to type in git clone. And this is already complaining. Too many arguments. Oh, you know what? Because when we copied it, it already typed git clone for us. It was trying to save me some trouble. So I'm going to go back in there, copy it. I wrote it in manually. I'm silly. And we'll hit enter, and that's going to clone it. So that's just going to download it to our local computer. And now to run it, if we go over here, it should be probably this command. Yep, that's the command. So we'll go back here and we'll just hit enter. And what it's going to do is it's going to install a bunch of stuff. This is probably not, this Cloud9 environment is probably not using this version of Python. If we just go over here, new tab, we're not gonna mess with this one. But if I just type in, I think it's like, if we just type in Python hyphen version here. Oops, I didn't want that. Hyphen version maybe. Okay, so it says version 3.610, and this one wants version 3.72. So that's just the state of Amazon Linux 1 right now. And we're just going to have to wait. This is going to take a few minutes, as it says here. I'm just going to go over here. Every time I stop the video, I have to hit a command key and it messes up terminal. But we're just going to wait for this to install. And this, again, takes several minutes. So please be patient. It might be 3-4 minutes. And I'll see you back here in a moment. Okay, so just waiting here a little bit here, coming back to our first tab, we can see that it has completed. So it just took a little bit of time to install Python. And there's one more thing that we need to do, and it's just to add this Elastic Beanstalk to our path. So if we were to type in EB, it shouldn't be able to find it because it just doesn't know where that binary is stored. So we just need to take its recommendation here. We are using bash. You can tell we're using bash. This is bash up here. And we just need to echo that command here. And I'll just hit that. It also seems to suggest this. I don't remember having to do this last time, and I think we can go ahead and do that. I think it's safe to do so. I hope that doesn't mess up this follow along here, but I'm pretty sure that won't. And so now if we type in EB, we have Elastic Beanstalk pop up. So that's really great. What I want you to do is just delete this folder. We don't need it anymore. It's just creating clutter. So just type in ls-la. Make sure you are at this environment directory. If you don't know, just type in cd:/environment, and we'll type in rm-rf, A2S, autocomplete it, hit enter, and we saw that it vanished there. So it's just a bit of house cleaning because we don't need that sticking around. So now that we have the Elastic Beanstalk environment installed, or the CLI, let's see what we can do with it, which it will be actually setting up an application. I'm just gonna close this other tab here, and I'll see you here in a moment. So now that we have the CLI installed, we're ready to initialize a new Elastic Beanstalk project. Now I want to point out that we are currently in tilde environment. That's our home directory. It's very important that we run this command in the study sync directory because it needs to find this .git directory in order for it to upload our code to code commit. So just type in cd /environment study sync and do ls-la. Make sure you see that .git directory there. Before we get going here, I'm just going to open up a couple tabs in AWS, and we're going to go to one that's actually at the CLI here. So we're going to make our way, to Elastic Beanstalk, and then for this one, we're going to make sure that it's on code commit, just so we can see what's happening in the background here. So what I want you to do is I want you to type in EB. We'll give you a full list of commands. We'll probably won't end up using all these commands, but these are the most general ones. And they tell you to use ebinit, ebcreate, and thenebopen. Forebopen, we don't actually have the ability to use this command. This makes it so the application opens up in the URL in the browser, which is very convenient. If you're running Elastic Beanstalk on your local computer, not in Cloud9, that's a great command to use, but here we won't be able to use it. But let's go ahead and do ebinit. The first thing it's going to ask us is the region. We definitely want to default that to US East 1, always US East 1 because it makes things easier. It's going to ask us to select an application. It's going to be study sync. It knows that because it's picking it up from the .git folder there. It's going to ask us if we're using Node.js. We absolutely are, so yes. Do we want to use code commit? We'll say yes. And then enter the repository name. We're going to call this study sync. And then it's going to ask us if, or what we want our default branch to be. We want it to be master. We'll just type in master. We can just hit enter there either. And what it's going to do, it's going to go ahead here and in code commit, it will show us that it created that repo. So here it is. So it's now here in code commit. In Elastic Beanstalk, we're not going to see anything here yet. This is just an old one here, but if I do a refresh, I go back here. Well, you probably won't see this, but I had older terminated instances here, so you might not see anything here as of yet. And then down below, it's going to ask us if we want to set up SSH access. I'm going to say no, we do not need that. And so now we've initialized our project. Notice that it's created a new folder called eb elastic.beanstalk. The period means that it's a hidden folder. We're going to go and open up this config.yaml file. And so these are some of the options we chose when setting up the EBINET. So now that we've initialized our project and we have our code on code commit, we need to configure this application. So we'll move on to, or the Elastic Beanstalk environment. So we'll move on to that next. Okay, so the next thing we need to do is configure this environment. So you generally have to do this for all Elastic Beanstalk projects based on what environment you're using. And configurations show up in the .eb extensions directory, so we'll have to create one ourselves. So I'm just going to type clear here. I'm going to make sure that I'm in the right place, so study sync. And I'm just going to type in mkdir, which is going to make a new folder, .eb extensions. Okay, and so now I have that new folder there. I'm just going to double check it, EB extensions. That is totally correct. And we're going to need to create a couple files in here. So I'm going to do touch, I'm just going to cd into this EB extensions folder. It'll save me some time. I'm going to touch a file called 001envar.config. And I'm going to do another one called node command. And then I'm just going to go back a directory. So if we open up this folder here, we now have envar, and this is where we're going to set some default environment variables. By default, you don't have to specify an environment here. It would just go to the Elastic Beanstalk environment, but we are going to be explicit here. And this is what we want to type. I always type the word environment wrong. ENVIRONMENT. We need a colon on the end there. And so I'm just going to set port 8081, and we're going to say node env production. And it's 4 spaces indent. That's totally fine. I'm just going to leave it alone. And so that is one file configured. Then we will go over to the next one here. I'm just going to double check this one here. Option settings. Yep, that's all good. And so the next thing we need to do is tell Elastic Beanstalk actually how to start up our application, because it has no idea. So we'll do AWS, Elastic Beanstalk, container, and then Node.js. So we're going to give it some Node.js specific configurations here. First, we're going to provide node command. That's going to tell what command it's going to run when it first starts up. We want it to npm start. And then we need to specify the node version. This is going to be 10.18.1. I actually don't have to put the parentheses there. I can use double quotes. I think you use single quotes, but I'm just going to stick to what I wrote earlier because I don't want anything to go wrong in my follow along here. And if you do node-version, you can see that it's using 10.19.0, and it is better to use the latest version, but that doesn't necessarily mean that those like Elastic Beanstalk can run that. I definitely know that 10.19 is not out for Elastic Beanstalk, and 10.18.1 is available, so we'll stick with this one. But yeah, that's the configuration there. So we'll go ahead and we'll just commit it. So git add all, git commit -m, configuration for Elastic Beanstalk. It's very important that we do commit this and then we push it, because if these files aren't there and we try to create an environment, it's just going to error out because it always looks at what's in the repo here. So if I go into here, code commit, EB extensions, we can see we have those files there. So that is the configuration phase over here. I'm just going to close a couple things here, just clean up here a bit. And what we'll do next is we'll actually create a new Elastic Beanstalk environment. All right, so we are ready to create our Elastic Beanstalk environment. And to do that, we need to use the ebcreate command. But we're not just going to write ebcreate, we're going to write ebcreate --single. This --single, this is a command flag. What it's going to do is tell this to create a environment, an EB environment that is running in single instance mode. If you don't provide this flag, it's going to spin up an Elastic Load Balancer. Elastic Load Balancers cost money. Technically, if you're using the free tier, if you made this account and you're still in your first year, you get 1 ELB free running. But we just want to avoid these kind of problems, so let's just not use it. And we're not going to really be doing anything with Elastic Load Balancer anyway through this walkthrough, so do EB single. It's going to prompt us with some options. I'm going to name this Study Sync Prod, even though we're in our environment or developer environment for my AWS account. If you go back up here, mine says Exampro Dev. I'm going to pretend this is a production application, and I'm going to say enter there. We just want that to be the same. We don't want to use spot instances, but that's a great way to save money. And then it says this insufficient IAM privileges, unable to determine if this role exists, assuming that it exists. And it's going to go ahead and spin that up. I don't know if this is going to cause us a problem, but we're going to have to wait here. And this is just going to take a little bit of time to get going here. So I'm just going to wait for this to get started. I'm going to open up another terminal here. And I'm just going to go to Study Sync here. And I'm just going to type in EB status. And this actually shows us the current status of the application. Right now, the health is gray and the status is launching. If we go over here, you can see I was trying to launch some stuff earlier here. Those are terminated instances. This is the new one here, pending. And you can see it's a nice dark gray. And this mirrors exactly what we're looking at over here. So this is going to take about 5 to 10 minutes to launch. And I will see you back here momentarily. Okay, so after waiting a little while here, I go back here and it says that it successfully launched the EC2 instance. So it looks like to me that it's all in good working order. We go over here and we type in EB status. You can see that it says ready and yellow. Yellow is not a great status to have. So if we come back over to the Elastic Beanstalk environment, I can't tell if it's finished yet, but I'm just going to go back here to Study Sync, click into the yellow here. And it's giving us a warning. It's saying, unable to assume the role, AWS Elastic Beanstalk service role. So it's supposed to create that for us, but for whatever reason, it just did not. When I first wrote this follow along, it definitely created that for me. So I'm not sure why it's not creating it, but if we go up to this link here and open it up here, the application clearly is working. So yeah, the yellow command's not that great, but maybe it'll go away on its own. I'm just gonna hit refresh. So I'm just going to wait a little bit here and see if it actually does go away or not. Okay, so our yellow eventually became a red, and it really has to do with this AWS Elastic Beanstalk service role. This is confusing because when you run EB create, it's supposed to create this for you. It's supposed to actually create 2 different IAM roles. If I go over here, I don't see them in here at all. Now, you could go ahead and manually create them. I've tried to do this and I haven't had much success as well, but there is another way for us to create these roles without us having to do a lot of manual labor. And again, you might not have to do this. Those EC2 roles or IAM roles may exist, but in my case, I'm just having a hard time today with Elastic Beanstalk. So to get them created, what I'm going to do is I'm just going to start another Elastic Beanstalk project. So I'll go here, create a new app. I'll just call it test, it doesn't matter. Because if we launch one from here, it will absolutely create us those roles. So I'm just going to go here, go to Web Server Environment. I'm going to leave it as test. I'm going to choose Ruby. I'm going to go down here and launch a sample application that will launch Rails. I'm just going to write test in here. Check for availability. That's all good. Hit create environment. And so what that should do is it should trigger through the console that should go create those IAM roles. So if I refresh here, now you see they exist. AWS Elastic Beanstalk EC2 role, AWS Elastic Beanstalk service role. So I have no idea why those aren't appearing, but now they do. But the trick is I just need to delete this environment now. So I can't stop this as it's running. So we'll have to wait till it goes through the motions of it for this test environment. And then once it's done here, we'll just go ahead and terminate it. Okay, so the environment spun up and now we just have to go ahead and delete it. I know this is really silly, but I mean, that's the only way I can get these roles to be created. But you know, they definitely should be able to make them manually, and this definitely should automatically happen. But I'm going to go back. I just clicked to all applications here. Then we'll go into here on the right hand side. We'll see if we can go ahead and delete it here. So I'll just put test in here. And so what that will do is it should automatically start deleting this environment. So if I go into here, it's terminating it. So that's that. But this environment is just no good. So what we'll do is, I mean, we can terminate it, I suppose. I guess what we'll do is we'll just terminate this environment as well. So I'm just going to go here and type this in here. And I'm just going to wait for this one to delete. And then we'll try EB create again. And hopefully we won't have any issues this time around. Okay, so I did a refresh there and it's terminated. And what I'm going to do is I'm going to go back to Cloud9. And I'm going to try this again. So I'm going to go back to our first tab here. I'm going to just hit up. It's going to ask me for the name. So I'm going to do study sync prod. Hit enter again. We don't want spot here. And it's saying that AWS Elastic Beanstalk EC2 role, it can't find it. That's okay. When I first did this, I had that error and it wasn't an issue. But let's just really make sure that it actually is there. Because as long as it's there, that's all that matters. Okay, so the role is there. So we shouldn't have any problems this time around. But we'll just wait here and see what the result is. I'm just going to go over to Elastic Beanstalk, give it a refresh, click in here, and we'll just wait a few minutes and see how it goes. Okay, great. So this Elastic Beanstalk has gone green. So us creating that temporary application, even though as silly as it is, fixed the issue here. Hopefully you don't have to do that and those roles just exist for you. So if we go over to Cloud9 here, I'm just going to do a clear here. If you do EB status, that's going to show you the status here. So green and ready, which is the same thing that is over here. If we wanted to go view this web application, it shows the CNAME in here. So if I copy this out, we can see we have a link there. If we scroll up here, we can also see that it assigned us an Elastic IP address. So that's another way of accessing the web application here, is that IP address. If we typed in EB logs, this would show us what happened actually on the EC2 instance, if anything was logged out. I might have showed you this prior, but I'm going to just show you quickly here again. And so you can see that the application started up here. I'm not sure what's going on down below here. I don't think that matters, but this is what we really do want to see. We'll hit Q to exit that out there. If we type in EB events, that is going to show us the event history that has happened. So if you go over here in events, that's the same information here. Really great way to debug stuff. And I want to point out that the deployment model we're using is all at once right now. We haven't actually done a deploy yet. We technically have deploy, but we haven't deployed to an existing environment. So I'm just showing you that it's using all at once. And so the next thing we're going to do is switch this over to immutable and see what the difference is there. But we're not going to do it in here. We could just click immutable, hit apply, and then do a deploy. But I want to do everything through the console. So that's what we're going to do next here. So let's get to that. So to switch this over to immutable deploys, again, I said that we could modify this file, but we want to do it pragmatically, and we're going to do that through the configuration files. So what I want you to do is go into eb.extensions here. Oh, it's not letting me type. If that happens to you, you can just close bash and open a new window here. I already have one open. And I'm just going to go into eb extensions. I'm going to make a new file, and I'm going to call this 000 deploy.config. I just want it to be ahead of those other ones. I don't think that order really matters, but it's just what I want to do. Oops, it's not make. We want to do touch. So we'll touch a new file there. And what we're going to do here is we're going to set option settings. And we're going to do AWS Elastic Beanstalk here. And we're going to do command. And what we're going to do is set the deployment policy to be immutable. And then what we're also going to do is set health check success threshold to warning. And then we're going to set ignore health check to true. And we're going to set timeout to 600 here. So I'm just going to read this over very quickly here, make sure I didn't make any mistakes here. Elastic Beanstalk, that's correct. Immutable or deployment policies, immutable, that looks right to me. Health check status threshold, that looks good to me. Ignore health check. So we're going to say over here what we're doing, we're actually checkboxing that off, okay? And we're pretty much setting the same settings that are here, except this is going to be warning. And that should make the deploy really fast. And also, while we're at it, let's just make a superficial change. So when we do deploy, we can actually see if the effects have taken effect here. So I'm just going to go to our actual application here. I'm going to just change this to Study Sync. Version 1. If we were to actually check out this application before we deploy it here, notice that this says Hello World here. So we're changing that to Study Sync version 1. We're going to go back to Bash here. We're going to go back a directory. Just going to type clear. Make sure you're in the environment's Study Sync in here. And we're going to add all the changes. So we modified that file. We added a new configuration file. So I'm going to add them both. Git commit -m immutable deploys. I'm going to push those changes. I'm going to go ahead and deploy that. So we'll just type in EB deploy. And right away, it should start switching over to immutable deploys, because it's going to pull those configuration files, look at them, and then it's going to decide on what to do. So if I think we just wait here a moment, it's actually going to tell us. And we can see that I actually have an error here. So I'm going to go ahead and abort that. So I can just type EB abort. But we can see it contains invalid key option settings. So I probably just made a mistake here. Oops. Yep. We'll try this again, EB deploy. Oh, well, we have to commit those changes. Git push. We'll do EB deploy again. And so what we're looking for is to see if it will actually say that it's doing an immutable deploy. And there it is. It says immutable deployment policy enabled. So we're going to have to wait for that deploy to happen. I'm just going to open a new tab here because I'm going to stop the video here. And immutable deploys are a lot slower than all at once. But the advantage here is that it won't take our server out of service. It's going to create a new server. And then when that new server is good, it's going to switch over to it. So our users will never have an interruption in service. So I'll see you back here shortly. All right, great. So our immutable deploy has completed. It's actually been quite a while since last time I was here because I'm actually recording this the next day. But I can tell you that that immutable deploy didn't take too long. So it definitely takes longer than the all-at-once deploy. All-at-once is extremely fast, where these immutable deploys have to go through health checks and then go through multiple checks before it determines that the new service is good and moves over. So, you know, that was immutable deploy, but what I want you to do is go back to Cloud9, and we are just going to undo those changes there, because the next thing we're going to learn how to do is blue-green deployment, and I don't want these immutable deploys slowing down our development here. So just to get rid of this immutable deploy stuff, all we're going to do is remove that file there. So I want you to type in rm, and we're going to do tilde here, environments, study sync, EB extensions, 000, config deploy, and then we're just going to add those changes. I'm going to make sure that I'm in that study sync directory there, because it looks like I was in the wrong place there. And we will do git add all, git commit -m, revert back to immutable deploys. Okay, git push. And just before we do anything else here, I just want to go back to the environment here and just show you under your configuration that it should have switched to immutable deploys. So here you can see it's immutable and the health checks are disabled. But anyway, now that we have that set up, all I'm going to do here is, now that I've made these changes, I did a push. I'm just going to do a cap deploy, or so not cap deploy, EB deploy. I'm thinking of Capistrano, which is for Ruby on Rails. It's not what we're doing here. And what we'll do is we'll just revert this back to all at once. And this isn't going to take too long. So I'm just going to go back here to my dashboard, and we can see this is updating. And I'll see you here when this is done, and then we'll move on to blue-green deployments, which should be super exciting. All right, so after a short wait there, our mutable deploys are back to all at once deploys, and we can just double check here under the configuration. If we go down here, we should see now it's all at once. So let's move on to blue-green deploy. So blue-green deploy is when you switch environments. So right now we have this environment here, which we can consider our blue environment. And the idea is we're going to spin up an identical environment called our green environment, which will have our latest changes. And once that environment is in good shape, what we'll do is we will swap the URL of the environments. Now, this option isn't available to us right now because there's nothing for it to swap to. But once we have that other environment, that's how we will make that switch over. So in order to do so, we're going to go back to Cloud9. And what we need to do is clone this environment, make a copy of it. And we could go in here, and I think we could go right into here and then click actions and clone the environment. But let's do it through the CLI, because again, this is the developer associate. This is the best way to learn. So we're going to type in EB clone, and then it's going to prompt us for the name. I think clone is okay for our case here, so I'll hit enter. We'll keep the CNAME the same. And what it's going to do is start up a new environment there. So we'll go back to Study Sync, and I'm just going to give it a refresh. And here we can see that this environment is spinning up. So again, we're going to have to wait a little bit here, and I will see you back momentarily. All right, so after a short wait there, because it's using all at once deployment, we have our production clone environment up. I know it doesn't look like it's running here, but if we just go back here a second, and I do a refresh here, we can see now it's green. So don't always trust the AWS console. Always refresh and look around, because sometimes things are ready and you're just waiting around for nothing. So if we take a look here at this clone environment following this this CNAME here, or the DNS, what do they call it? We'll just say URL. This URL here, we can see that it's running, but we want to make sure that we have a new version here. So this is version 1. So let's just make a superficial change, calling it version 2, and then see how we can deploy to this new environment and then facilitate the switch. So what I'm going to do is go back to Cloud9, and I'm going to make my way over to the app, and it's just making some complaints here. So I'm going to close these tabs. And what we want to do is we want to go ahead and open this app.js file. And I'm going to just change this to version 2. All right. And so now that I've changed it to version 2, I'm going to commit this to the repo. So I'm going to go git add. Well, I'll do git status. We should always do that. We can see the file we want to add. Git add all. Git commit. Change to version 2. We will do a git push. Git status. All right, great. So our version 2 is there. So how would we go about deploying to the green environment? Because we have these two environments. So if we ran EB deploy, I think by default it's going to deploy to the original environment. But if we want to specify the environment we want to deploy to, which is the green environment, we just have to provide its name. So that's called study sync prod clone. I'm pretty sure that's the name of it. Yep, study sync prod clone. And so this should now deploy the latest changes to this environment. So we'll go ahead and press that there. And it's going to start up again. We'll just give it a second here. We'll flip back. We will go back to study sync. I'm just going to give it a refresh here because something should be changing. Probably the prod. Yep, so it's updating. So we will let that deploy there. We'll give that a little bit of time. And I will see you back here when that's done. And we'll just double check it's version 2. And if that's all good, we can do the swap. All right, so pushing our changes, our version 2 changes to the clone is done. If we go to this page and refresh, you're going to notice that there hasn't been any change. But it actually has worked. This is just an issue with Chrome, because if you open up another browser and refresh in Firefox, it says version 2 for the same URL. So this is a Chrome caching issue. I spent hours upon hours trying to solve this problem and not realizing it's Chrome. So just be aware that anytime you're doing deployments to anything and you're checking stuff, always just rule out your browser, because sometimes it's not even AWS. So, you know, if we want to get to see the latest version here, I'm going to open up Inspector, make sure you're on network and have disabled cache, do a refresh there, and now it says version 2. This will not work unless you have this open, this checkbox, and then you do the refresh. All right. But yeah, now that we have figured out how to deploy our second version with blue-green deployment, what we can go ahead and do is swap over the environment URL. And so we said that what we could do is go to here to Actions and go to Swap Environment URL. And we could go here and choose our other version and swap here. However, since this is for the Developer Associate, I really do want you to get as much experience with the CLI. I'm going to just keep on saying that. And what we're going to do is go ahead and use Cloud9 and use the actual EB-CLI to do that. So the command here is EB swap, and then we're going to say, if we hit enter now, it would prompt us to ask, you know, the source and the destination, but I just want to be very explicit here, and I'm going to just type in the source. So I want to swap the prod with the clone. So we'll say study sync prod clone. And this will do exactly the same thing as swapping the URL out here, okay? And I'm just going to hit enter. Unrecognized argument here, clone. Let me just make sure that I spelt that name correctly. I'm just going to go over here and check. Study sync prod clone. Study sync prod clone. Oh, sorry. You know what? I have to provide a flag here. It is hyphen destination name. And now we'll hit enter. And this is going to trigger that swap action there. And so we're just going to have to wait a little bit there. And it says it's completed the swap. Wow, that was really fast. So we'll go back here. And if we are to click on prod now, what I want you to notice is this is the clone URL here, right? And we are now in the clone environment. So this used to say clone, but now it says prod. It's taking the original CNAME from the other environment. If we go to the first environment here, this one now has clone. So that's the swap that occurred. So that's how we know that it worked. Now that that swap has occurred, what we want to do is just get rid of our old environment, because we know our new environment is running with no problems here. If we just go to prod like this, it's running version 2, so we're all good. And so what we need to do is go in here and then just terminate this environment. But let's do it from the CLI. So we'll go back here to Cloud9. And what we're going to do is type in EB, terminate, study, sync, prod. And then it's going to just ask us to confirm it. We'll hit enter. And that's going to terminate. Now, we're pretty much done with blue-green deployment here. And with that out of the way, we can actually move on to learning how to deploy a single Docker container next. So what we're going to need to do is rip down everything, because we do not need even this clone anymore. So I'm going to also terminate this one, but I'm going to do it through the console here. And we need to type its environment name. So I'm just going to copy it here, paste that in, make sure that's right. And what we're going to do is we're going to wait for these to shut down here. And when these are both terminated, we'll move on to the next step, which is deploying a single container Docker environment to Elastic Beanstalk. All right, so we are back here. It went through the whole process here and built everything, and it's saying that it's running on port 8080. What we're going to need to do is open a new tab here, because we're going to need to get the IP address of this Docker or this Cloud9 environment. So we go to a terminal here. I'm going to type in curl http://169.254.169.254 latest metadata. We'll hit enter, make sure this works, and then we'll type /public IPv4, and that's the IP address. So what we can do with this is just copy this here and go port 8080, and we will see if this works. Oh, let's just click it too, eh? Open. And there it is. So this is running in a single Docker container. The reason you'd want to Dockerize your environment is because it allows you to ship your configuration with your code base. So you saw before we were restricted to version 10.18 whatever of Node, but now we are only restricted to whatever we provide with it. So a lot more flexibility around that. In order to prepare this for deployment, we aren't going to need this node modules anymore. Because we are using a Docker container, and this is just going to do nothing. So we'll go ahead and remove that. So what I want you to do is just close this tab here. I'm going to do Control-C to stop the Docker container. I'm going to go cd tilde. Oh, we're already in the right place, but this is where we need to be. And we're just going to do rm eb extension 002 and just remove that file. So now that's been removed, we need to make an adjustment to this file here. I'll just hit keep open. This needs to be port 8080 because that's what we were setting in our application. And let's go ahead and commit our changes here. So configure EB for Docker. And so now that our pushes have been changed, what we can do is go ahead and do an EB create -- single so we don't launch a load balancer. We are going to name this one different just so we can identify it. So we're going to say study sync Docker. We'll hit enter. We'll hit no, we don't want spot instances. And we will make our way over to the Cloud9 over here, do a refresh. We'll give it a second here to start up. There it goes. We can see that it's using the Docker platform. We'll do a refresh, and we will just wait until this is done and see if it works. So after a little while there, our environment is now running here. Let's take a look to see if it's working. And there you go. We're running on Docker. It was that easy. The thing with Elastic Beanstalk is that it did all the work for us. We just had the Docker file in here, and when we uploaded it, it did all the work. It built the image for us. But normally what you'd have to do is build the image yourself and then push it to an actual Docker repository. That could be Docker Hub, or in the case of AWS, you can use Elastic Container Registry, ECR. And that's what we're going to do because that's a more complex setup and the more common setup that people will be using because most people outgrow this Docker file, this simple setup here. In order to do that, what we're going to need to do is create a new file called a docker run aws.json file, and we're going to have to build an image and push it to ECR. But before we do that, let's just make a revision to our actual code base here. And we will go to app.js, and we'll call this version 3. And the next thing we will do is we'll go ahead and build our Docker image. So I'm going to type in docker build -t study sync period. So this is going to build a Docker image. And it's going to name it study sync. So we'll just wait here a little bit, and there it is. It's done. That was fast. The next thing we need to do is we need to authenticate to ECR. And this is a very long command, so we'll get to it. It's AWS ECR get login password pipe docker login -- username AWS -- password .stn. We're going to have to provide our account ID here. I don't know what my account ID is for this account. We need to poke around. We should be able to find it somewhere. It's generally under my account settings. I just don't want to show all of my billing information here. So another easier way, we'll just go make our way over to IAM. I feel like that's always a place where we see our account number. We should see it anywhere. We'll just go into even a user here. Here's one. Our account number is everywhere. I just need part of it there. So I'm just going to paste it over here and then extract it out. And then what we need to do is provide it as such. And then we need to type in this URL. So we need dkr.ecr. And then we need the region we're operating in. So US East 1 dot Amazon AWS.com. If you're wondering how I got this whole link, it's in the AWS documentations for ECR. So what this is going to do is log us in and generate us out a token so we can authenticate. So it says there's an unknown flag named user. So I'm just going to double check that there. It's actually supposed to be username. So we'll go ahead here and type this in. And here it says that it's created that credentials helper file. So there you go. So notice that it's created a file here called a hidden file called docker config.json, and that's what's storing the token, which is going to help us to authenticate. So let's take a look at the actual images that are here. And we can see that we have our image that is built here, and we're going to have to get this image ID next. And what we need to do is tag this Docker image. So I'm going to put in that image ID. We need our account ID again here. And it's actually the same link here, so it'd probably be easier if I just copy that out like that. And then we need to specify the name. And so now that it has been tagged, what we can do is do Docker push. And I believe it is the same URL here, so we'll just copy this. And it says here that the repository does not exist with this ID. So maybe what we should do is make our way over to ECR, and just maybe we need to make the repo beforehand. I always forget this, so I guess we'll find out. I thought it would just create it for us. Nope, I guess not. So we'll just type in study sync here. I'll hit create repository. Then we'll make our way back to Cloud9, just hit up. And there we go. It's uploading our Docker image. It's kind of like GitHub. This is an incredibly small Docker image, so it's not taking too long, which is really nice. One advantage of using Node.js over other languages and frameworks. So I'll just wait here a little bit, and I'll see you back in a moment. So our Docker image is now built and pushed to our ECR repo here. So if we go in here, we can see that we have it. And the next thing is to prepare our actual, this next environment here. And instead of working with this one, because it's going to be a lot of work here, we're just going to make a new folder. So once you go cd dot, or just go actually here to cd tilde/environment, we're going to make a new directory, and we're going to call it study sync external. And what I want you to do is make a new file in here. So we'll just cd into this. And we're going to call it dockerrun.aws.json. If you've ever seen a task definition file, it's extremely similar. And in this Developer Associate course, we definitely cover how to deploy with ECS and Fargate. So this will become extremely familiar to you shortly. But what we need to do is open up that file. I made it as a directory. That was an accident. I should have made that a file. So I'm just going to remove that. And instead of doing mkdir, I'm going to type in touch. Okay, and then we can just open up that file there. And what we're going to do is write some JSON. So the first thing we need to do is define the Docker version for EBS here. So Docker run version. Just going to double check, make sure that is correct. Yep, that is right. And we're going to specify version 1. Version 1 is for single containers. When you're doing multi-container, you do version 2. Then we need to specify the image. And that's going to be the URL we were seeing there earlier. I feel like we could grab that from ECR. Yep, it's pretty much the same thing here. I just want this part of it. I don't know if I need to put latest in there. So we'll put that in there. We have to specify the ports. So we'll go ahead here and do that. So it knows what to map to. And in that, we will do this. A little bit of cleanup here. I'm just going to double check to make sure everything is right here. Sometimes it's easy to miss these commas. It looks all correct to me, so we're in good shape. The next thing we need to do is initialize a Git repo here. So we're going to do git init. And we're going to copy over a couple files. So we want to bring over our gitignore EB extensions file and our envar.config file, I think. So we will go ahead and do that. I'm just trying to think of the easiest way to do this. Probably just make the files again. So I'm going to just type touch.gitignore. And then we will do, we'll make a new directory called EB extensions. And then we will touch EB extensions 001.envar config. And I think that's the only two files we need to move over. So we will go to our old one here. And it has some Elastic Beanstalk stuff in here, and then we'll just take all of it. That's totally fine. And we'll go to our new one here and paste that in. And we said we need to set this as well. So we'll go to our old one, copy that, paste that there. And now that we have those files in there, I want you to do is go ahead and do a git status. So we have 3 files, that's great. Git add, git commit -m, docker run. And we need this, we need a git repo because it's going to create a new one when we run EB init here in a moment. So I'll just do git status, make sure that all worked fine. Great, and we will do EB init. So we're going to choose US East 1, so number 1. We are going to create a new application, so press 2. We are going to stick with the name that we are given here, so hit enter. We are definitely using Docker, so we'll hit yes. We want to use code commit, sure, so we'll hit Y. We need to select a repo. We are making a new repo, so press 2. Enter the repo's name. This is going to be called study sync external. Make sure you type it right. We are going to want it to be master branch, so hit enter. We don't need to SSH in, that's okay. And so there we go. So now that that is created, I'm just going to go up, double check and make sure that is the case. So we'll make our way over to code commit. And here we have our external repo, so it's all in good shape. So now that that's all set up, we should be able to create a new environment. So we'll do EB create --single. We will name it pretty much the same. I'm just going to take off the dev part on it. Doesn't matter too much as long as you can remember what you set it to. We'll say no for spot instances. And what we're going to do here is just wait a little bit here. It's nice to see the message, just make sure that it's creating what we want it to create. And this is, yep, a Docker image. So hopefully this works first try. I'm going to make my way back to Docker here. We'll go over here. And while that's going, we can go ahead and terminate this one. We don't need this one anymore. And just to point out, like, look at this. This doesn't contain any of our code. So where is our code? Our code is part of the actual Docker container. That's why we don't see it here, because when we built it, it copied it and put it into the actual container. Whereas in this setup, the Docker file is here, and so we can work with our source code and have it all in one place. So you just have to decide, what workflow works best for you. And, if you can get away with just having a Docker file like that, that's definitely better. And this is creating. I'm just going to go back here and do a refresh. I don't see this new environment yet. Should be called external, right? Study sync external. Oh, here it is. Yeah, because it's a completely new application. That's totally fine. So yeah, I'll see you back here in a moment once this environment is done creating. All right, so our deploy is done, but we have health degraded, and it looks like we have an error here. It turns out Elastic Beanstalk can't authenticate to ECR because we didn't give it permissions to do so. Whereas in Cloud9, we had pulled that the credentials and stored it in here so that we could read from ECR. So what we need to do is update the instance profile of the actual EC2 instance that runs here. So what we'll need to do is make our way over to IAM. So just type in IAM here. We'll open this in a new tab. On the left-hand side, we'll go to roles. We'll go to EC2 role here for Elastic Beanstalk. We're going to attach permissions. We're going to type in Amazon, EC2, read-only container. We'll attach that policy. So this should allow us to gain access to ECR. And then what we'll do is go back to Cloud9, and we'll simply do EB deploy. And so what that will do is it will just deploy again, but now it will also update the IAM role, and it should have permissions this time around. So we'll give it a second here to get started. We'll make our way back over to here. We'll do a refresh. And we can see this is in progress, and I'll see you back here momentarily. And our deploy is done. So I'm just going to close these additional tabs here. I'm just going to open up the new tab here. And we are now seeing version 3. If you don't remember, it could be Chrome caching it, but there you go. So we went through a lot of different variations here with Elastic Beanstalk. And that is a lot of stuff, but it is necessary to go all through these things. So let's just go ahead and clean up what we have. So I'm going to go back all the way to applications. And what we can do is go ahead and just delete these applications. This should terminate all the environments. So we hit delete. And we're going to also delete this application here. We'll say delete. If we click into this, these should be terminating. So our Cloud9 environment, it's not a big issue. It's going to shut down after 30 minutes when we're not in use. For our Elastic containers, we're going to go to code commit. I don't think this is really an issue having these around, so I don't have much motivation to delete them, and we might be using them for the ECS and Fargate tutorials. So we're going to leave these alone, or we're going to leave our code commit code commit and ECR alone. So we'll leave this alone as well. But yeah, that's it for the Elastic Beanstalk walkthrough. Hey, this is Andrew Brown from Exam Pro, and we are looking at Elastic Container Service, which is a fully managed container orchestration service. It's highly secure, reliable, and scalable, a way to run containers. So let's take a look at the components of ECS. And so over here, we have a technical architectural diagram, and we'll just talk about all the components involved. So the first is the cluster itself. So an ECS cluster is just a grouping of EC2 instances. They call them EC2 containers, which is a bit confusing because inside these EC2 instances have containers within them. So they are both running Docker installed on them, so you can launch EC2 or Docker containers. And so another thing that's really important is task definition files. We don't have a representation of any of that in our architectural diagram here, but that's just a JSON file that defines the configuration of up to 10 containers that you're going to want to run. Then you have a task, and that uses a task definition to launch containers. And a task is a container which runs for only the duration of the workload. So the idea is, let's say you have a background job you want to run. As soon as it's done, the task stops or deletes itself. So it's really good for one-off jobs. Then you have a service, and this is exactly like a task, except that it's long running. It's intended for web applications, so Ruby on Rails, Django, Express.js, where you don't intend these things to shut down. And the last thing we want to talk about here is the container agent. It's not represented in the diagram here, but this is a binary that's installed on the EC2 instances. And this just monitors, the tasks as well as it stops and starts them. So let's talk about the options we have to choose when configuring a cluster. So the first thing you're going to do is go ahead and create that cluster. And you're going to have to choose between Fargate or ECS clusters and whether you want it to have some networking components involved. And then once you've done that, you'll have to go through and choose a bunch of options. So you have to choose whether you want it to be spot or on demand. So with ECS, you can save money with spot because if you're running background tasks, maybe it's not a big deal for those to get interrupted. Then you're going to want to choose the EC2 instance type. And then you'll have to choose the number of instances. You'll have to choose the EBS storage volume. And then you can choose whether you want to use Amazon Linux 2 or Amazon Linux 1, which both have Docker installed on them. So there are some of those options right there for you, as you can see. Then you'll have to choose your VPC, or you can create a new VPC. Then you need to assign it an IAM role. Then you have the option to turn on CloudWatch Container Insights. This is going to give you richer metrics about the operations of your containers. And then you can choose a key pair, which is unusual because you don't necessarily need to log into your instances, and AWS generally does not recommend you to SSH into those containers, but you totally can. So that's all the options for ECS, and we'll see this again when we go through the follow along. So let's take a look at that task definition file that we talked about that is used to launch our tasks or services. So what you do is you'd go hit the create new task definition, and this would actually have a wizard to help you get set up. But if you had to write this by hand, this is what the actual file would look like. And in this file, you can define multiple containers within a task, which is actually what we're doing here on the right-hand side. And the Docker images can be provided either by ECR, which is Elastic Container Repository, which we'll talk about in the next slide, or an official Docker repository such as Docker Hub. So here you can see that we are specifying an image, and that image is WordPress. And then another important thing is that you must have at least one essential container. So if this container fails or stops, then all the other containers will be stopped. So this is just to make sure that you have at least one dependent resource there. And if you aren't sure how this file works, it's okay because AWS has that wizard. So when you click that create new task definition button there at the top, they have all the fields that you fill out to create this. But if you wanted to create by hand, you could totally do so. So I want to take a quick look here at Task Container Registry, which stands for ECR. And this is a fully managed Docker container registry that makes it easy for developers to store, manage, and deploy Docker container images. So just to give a representation here, you have a Docker image, and then you can push that to ECR, which is like a repo for Docker images. And then once you have it there, you're going to be able to access it from Elastic Container Service, Fargate, Kubernetes, or even on-premise. So it's just an alternative way of storing a Docker image as opposed to Docker Hub or somewhere else, or hosting your own, and it's highly secure. Hey, this is Andrew Brown from Exam Pro, and welcome to the ECS follow along. In order to do this follow along, you have to do the Elastic Beanstalk one first, because in that follow along, we build out a web application and we turn it into a Docker image, and then we host it on ECR. And we are going to need this ECR Docker image in order to complete this follow along. So please go to that one first and do that follow along, and you definitely should. And once you have that done, come back here and we will proceed forward. So before we can create our ECS cluster, we're going to need to create an IAM role for our EC2 instances. AWS has documentation on this, the Amazon EC instance role. These instructions aren't very clear, but I know what to do, so let's follow along. So the first thing is we're going to want to name it this, ECS instant role. well, you could name it anything you want, but let's just be consistent here because this is what everybody else names it. We'll make our way over to IAM. On the left-hand side, you want to go to roles. We're going to create a new role. We're going to leave that here, choose EC2, go next. And then what I want you to do is type in EC2 container. And we're looking container service role for EC2. It's this one here. I'm going to double check it, just make sure it is what I'm expecting it to be. I usually can tell what this stuff is by looking at the services. Yep, this is the one. We will go next. We'll hit next. We will name that role. We'll create that role. And so now we have this role and we're ready to go create our cluster. So going back to our first tab here, I want you to make it over to ECS. So we'll click on that. On the left-hand side, we will choose cluster. We will create a cluster and we'll be presented with multiple options. It's defaulted to Fargate, which we'll be doing in the Fargate follow along, but right now we're doing ECS. And the way you know if it's ECS is that it's not powered by Fargate and you do not create an empty cluster. So we are going to use Linux. So we'll hit next here. And if we checkbox this here, this would make it Fargate, but that's not what we're doing. I'm going to call this my ECS cluster. We'll leave it as on demand. Spot is a really great way to save money, but I just don't want anything to go wrong in this follow along, so we'll just leave it as on demand. I want you to go look for T2 Micro here because that's part of the free tier, and there I found it. We're going to only have one instance. We want to keep this very inexpensive. Amazon Linux 2 seems fine to me. We do not need to set a key pair. We do not need to set any of the VPC settings here. And we need to make sure our ECS instance role is there, and it automatically selected it. And then we can go ahead and hit create. And what's that going to do? It's going to create an ECS cluster. Then it's going to make sure we have that IAM policy. And now we're just waiting for that CloudFormation stack to complete. So this won't take too long. It's still pending right here. We're just waiting for the auto-scaling group and the internet gateway. I think what I'll do is I'll just pause the video here. Oh, no, it looks like it's almost done. Maybe we'll just give it a second here. Oh, okay, it's proceeding forward. Now we're just waiting for the security group and the auto-scaling group. Okay, great. Now we're just waiting for these last two here, the virtual private gateway and the auto-scaling group. All right, now we're just waiting for the EC2 route. You can see that it sets up a lot of stuff to make this cluster. And that looks like it's done. It's still spinning though. I think this is pending here, the route table subnet association. So we're just waiting for the route tables to set up. And there we go. So let's go ahead and view our cluster. And what we need to do is we want to create a service, but before we can do that, we're going to need to create a task definition to actually launch. So go to task definitions, create a new task definition. We have the option between Fargate and EC2. We obviously want EC2, but that's for ECS. We're going to hit next. I'm going to name this study sync. We need to choose a task role. Optional IAM role that the task can use to make API requests to authorize AWS services. Create one here. We might need one here for using ECR. I'm not sure. I guess we'll find out as we go. We'll go down here and we'll have to specify some memory. In order to do this, we need to know how much memory comes with a T2 micro. That is 500 megabytes, so that's the maximum we can do. And with a T2 micro, you get 1 vCPU. So I'm going to place that in there. Here you can set the CPU units, which I have no idea what to do for that. I don't know if 1 vCPU is 1024, probably is, but I definitely know there is only one vCPU for virtual CPU for T2 micros. So now that we're there, we'll go ahead and add our container. I'm going to name this study sync container. And then we need to specify our image repo. So we'll go over to ECR. I'm going to copy that, paste that there. I think we want the latest. I think we can place the latest in here. And we'll set it to 256 megabytes. It's a Node.js app. It doesn't require a lot of memory. we want to map the ports. So 80 is the port that goes to the internet. So that's what we want. And 8080 is what our container port is. That's what we start up our web application on. And we'll see that you'll see that in the Elastic Beanstalk follow along, that's what we do. We're not going to set up a health check. We do need to set up some environment variables. We don't need to set an entry port or command. These are set in that build image. If we wanted to override them, we could place them in here. Same thing with working directory. But we're going to need to set up the port here, which will be 8080, and then the node environment, which will be production. Then we'll go down here. There's quite a few options here. Not super important. We'll keep on going. And yeah, that should be everything that we need. We'll hit add. I still don't know if we're going to run into an issue because I know that ECR requires authentication, and I don't know if it will pull it without that task role, but I guess we'll find out. We have a lot of interesting options here for service integration. So app mesh, proxy configuration, log router with FireLens. I don't even know what FireLens is. Sounds like a new service to me. We can add volumes, not necessary. I do want to point out one thing. I can't, maybe I can click it here. I just didn't show it to you, but when you set environment variables, you can do value from, and this allows you to provide the ARN of a systems parameter store key, and that allows you to pull in secret parameters. So if you had secrets you wanted to put in there, you could definitely do that. It's just good to know. It might show up on the exam. We'll go ahead and hit create. Unable to create this task definition. It doesn't like something I've done. I'm just looking through it here. Looks okay to me. The only thing I can think of is it's because it doesn't have a task role, but it says optional IAM role. All right, so I tried going ahead and creating this task definition, and I got this error, and it's exactly what I thought it was. We just don't have permissions here. And so I did a bit of Googling, and I believe we are missing this ECS task execution role. So here they have the instructions. So we will go ahead and create that. So luckily we still have IAM open here. I'm going to create a new role. I think we need to choose ECS. So select trusted entity, choose Elastic Container Service. What's interesting is that this would actually have been created for us if we had launched Amazon ECS console first run experience. So the first time you do it, automatically creates it. But like, if I don't have anything to launch, I have to create that definition. It's like a catch-22. One of those things that I wish AWS would improve upon. I'm sure if I complain on Twitter, they will definitely do that. But anyway, we'll just go ahead and manually do it because it's all about figuring stuff on your own here. And they might actually already have a pre-made one here, but we'll just go down here. Select your use case. Choose Elastic Container Service task. Oh, there it is. Okay. We'll hit next. And it should automatically add the policy. I guess not. Attach permissions policy. Sometimes when you select those pre-made ones, it automatically fills it in for you, but I guess not in this case. But that's the one we need. We'll hit next. We'll hit next. Let's name it what it suggests us to name it. Oops, there we go. Now we have our role. We'll scroll up, hit refresh, and there it is. And then we'll go down here. You're given permission to ECS to create and use the ECS. So here it's suggesting that it would have created it on our behalf, but it never did. All right. That's fine. We'll just hit create anyway. All right, I'm back here again. Sorry for all the hard cuts. I'm just having a really hard time with ECS. I made this follow along in my other AWS account. It worked perfectly the first time, and I'm just getting beat up at every single corner. And trust me, I go on Twitter and I literally complain to AWS about these things just because they are really painful. But I just want you to know that even myself as being an AWS expert, I even have hard times getting through these follow along. So, you know, just stick with it if you have any issues. But anyway, I was able to create this task definition, and I have to create a revision here to show you what was going on there. So I'm just going to hit create revision, and it has all the same filled in information. And the only problem I had, we definitely probably had to create this task role. We should have made it anyway. But we needed to click on here, and I had latest on the end of here, which I thought prior, but I guess it doesn't allow you to do it. So just remove latest on the end of here. and then you'll be able to create this task definition. And also in this box here, I wasn't carefully reading it, but it was actually saying that it would have created this for us anyway. So if we left this blank and we removed that latest there and created it, we would have had that role. But anyway, we made it through there. So just go ahead and hit create, and you should be exactly where I am with the task definition. So now that we have our task definition, I'm definitely going to close these things here because we have a lot of tabs open. I'm just going to keep on going here, all the way here. We are ready to launch this task. So we'll go over to clusters. Oops, I clicked EKS. Definitely not doing Kubernetes today. We'll go to clusters here. We'll click on My ECS Cluster, and we have services and tasks. So services continuously run tasks, and as soon as the task is done. Since this is a web application, we definitely want to make it a service. So we'll hit create here. We want it to be EC2 because that's for ECS. We're not making a Fargate type. We'll leave that name alone. That's totally fine. We'll name the service. I'm just going to call it My Service. Very unoriginal. We're going to leave it as a replica. We want one task running here. We'll leave it as rolling update. That seems fine to me. AZ balance spread seem fine to me. I don't play around with these too much. We'll go ahead and hit next. And then it's going to ask us what load balancer we want to use. We don't want one. We want to save money. Obviously, it's recommended to use a load balancer and have things in an auto scaling group. But you know, we just want to be able to launch a service. That's all that we really need to learn here. And we'll scroll down. We have a lot of options. We don't need to read any of this. We'll hit next. Then we have service auto scaling. This would add an auto scaling group. We do not need one, so we'll hit next. And then we will create the service. So this should actually be very fast. So when you launch an EC2 instance, it takes forever, right? Because you have to wait for it to create one. But there's already one running. All it has to do is put that task in there. So we just have to wait a little bit. This will take a little bit of time here the first time around, but I'm pretty sure that when we launch tasks after this initial setup here, it's really, really fast. So we'll just wait here a little bit, and I'll see you back in a moment. And that was actually really fast. I did not even have to stop the video, but I did. So now this is started. We can go check out that My Service. I'm going to click the big blue button down below. And here we can see our task is running, and it's running study sync :1, so version 1. Yep, that version is fine. And we'll click into task because we only actually have one version. And in here, what we can do is we can see the container instance. If we click into that, it's going to give us information such as the public IP address and etc. I think if we click into the task here and we drop down here, I know we just went backwards, but it actually shows us port 80 and 8080. And we just have this convenient link to get to it. There's tons of ways to get this link, and we can see our application is running. So version 3 was the one we had last in Elastic Beanstalk. So that's all it takes to run an ECS task. Now there's obviously a lot of options in ECS. Not important for this follow along, but definitely, read through all the lecture content. If you are doing the DevOps, you definitely need to know all those options. So way longer follow along with ECS for that. But for the developer associate, all we need to know is how to launch that service. Now this cluster costs money because it is an EC2 instance that is constantly running. So I'm going to go ahead and delete it. So we'll just type in delete me. And it takes a little bit of time here. And once that's deleted, we'll be in good shape. I'm not going to wait around for this video to see this delete. It's deleting. I know it will happen. But yeah, once this is done, that means we can move on to the Fargate follow along, which is very similar, except there is no EC2 instance running. So that's super exciting because it's a serverless container. So we'll see you then. Hey, this is Andrew Brown from Exam Pro, and we are looking at Fargate, which is serverless containers. So don't worry about the servers, run the containers, and pay based on the duration and consumption. So Fargate is sometimes branded ECS Fargate or just Fargate by itself, but it is under the ECS console. But the difference is that when you want to launch Fargate, you go ahead and you create an ECS cluster, but you actually make an empty cluster. So there's no provisioned EC2. and then you launch the tasks as Fargate, and you can also launch services there as well. So you no longer have to provision, configure, and scale clusters of EC2 instances to run those containers. You are charged for at least 1 minute, and then after that, it's per second. You pay based on the duration and consumption, which we'll look at a bit more. But to really understand the difference, I just want to give you a visual comparison. So this is ECS, which we saw prior, and you can see that there are EC2 containers. And then for Fargate, it's extremely similar, except there's no containers. So, hopefully that makes that clear. So now we're going to look at how to configure a Fargate task. And the first thing you're going to do is using the task definition wizard in the Fargate console, you're going to have to choose how much memory and CPU you want to utilize entirely for all your tasks. And then what you're going to do is you're going to add containers and then allocate memory and CPU for each based on the requirements of, based on the allocation that you've defined above. So here I have a Ruby and a Python container, and you can see that I've split the memory half and half for both. When you run the task, you can choose what VPC and subnet it will run in. A lot of people think that there are no VPCs or subnets with Fargate because it's serverless containers, but that's not true. So you do have flexibility around that. And you can apply security groups to a task. This is a great way to have a security around your tasks. And this actually could show up as an exam question, knowing that you can apply that. The reason why there's some, this is such an important question is because, would you apply the task to the EC2 container that's running the actual server, or would you apply it to the tasks? And this is going to apply for both ECS and Fargate. It's always at the task level. You can also apply an IAM role to the task. So you can say for every individual task, delegate it different policies. And just to reiterate here, you can apply a security group and an IAM role for both the ECS and Fargate. So that's for both tasks and services. And again, that might show up as an exam question. So I want to do a quick comparison between Fargate and Lambda because they're both serverless compute. And so they seem like they solve the same problem, but there are a few key differences. And so we're just going to quickly walk through those. The first is they both have cold starts. And it can be argued that Fargate's cold starts are slightly shorter. I can't really remember as to why, but in the documentation, I think it says that there. A big different factor is duration. So with a Lambda, the maximum time you can run it is 15 minutes, where the duration with a Fargate task, you can run it as long as you want because you can just make it a service and it runs indefinitely. In terms of memory, Lambda has an upper limit of 3 gigabytes, whereas Fargate has an upper limit of 30 gigabytes. So if you need a lot of memory, go over with Fargate. For containers, you provide your own containers with Fargate, so you definitely have a lot more flexibility in terms of configuration there. For Lambda, setting up containers is extremely limited. You use these standardized containers, and then you build stuff on top of that. So if you really need something highly configurable, you're going to need to go with Fargate. For integration, Lambda just has seamless integration with a lot of serverless services. And it just makes it really easy to chain stuff together. Even recently, like Lambda has output destinations, and it just keeps on getting more and more easier to integrate with stuff. Fargate, you can orchestrate things together. So like with step functions, you can tie things together, but it's just not as seamless as Lambda. So, and you do have to do a lot of configuration to get your cluster set up and the Fargate task set up, but definitely less than doing an ECS cluster without Fargate. And the last thing is pricing. So with Lambda, you're paying per 100 milliseconds, where with Fargate, you're paying at least 1 minute, and then every additional second is how the pricing works there. Obviously, the amount of memory you use and the CPUs also comes into factor there. But just the takeaway that I want you to know is that Lambda is 100 milliseconds, right? And Fargate is 1 minute and every additional second. So hopefully that makes a little bit of sense to you there, and you can kind of have an idea like the use cases for each. Hey, this is Andrew Brown from Exam Pro, and we are looking at the Fargate follow along. If you have yet to do the ECS and Elastic Beanstalk follow along, you have to do those ones first. And the reason why is that this is all dependent on a Docker image that we created in the Elastic Beanstalk follow along. And it's good to do this ECS one first so that you get a difference between ECS and Fargate. So, go ahead and do that. And once you have this Docker image, you can proceed forward here. So for this one, what we're going to do is make our way over to ECS because that's where Fargate is. Sometimes AWS calls it ECS Fargate. Sometimes it's just called Fargate. All right. But anyway, Fargate is ECS. We'll go over to clusters. We're going to create a new cluster and we're going to choose networking only because AWS is going to manage the EC2 instances for us, so we don't have the same kind of options as we would here with the other ones. If you were to go here and choose an empty cluster, that is basically a Fargate cluster. But I'm going to go back here and choose networking only, which is the default. And we're going to name this cluster. I'm going to call it my Fargate cluster. Fargate cluster. We are not going to create a VPC. We're going to use the default one here. We're going to hit create, and it creates it right away because it's serverless. It's super fast. There's no server running as of yet, so that's why it's super fast. We need to create a task definition. We created one before for study sync for ECS, and this time we're going to make one for Fargate, and we're going to name it study sync, and I'm going to put an F on the end. That's just my convention for distinguishing those tasks here. We're going to choose the ECS task execution role. If we had not had this here, I feel like it would make it for us. We have the network mode, which is AWS VPC. I was on AWS support, and I was not aware of this until I talked to the support engineer. And I guess this is the default. And the way it works is that whatever port you set is what mapping you're going to get. And I'll explain that in a moment when we get to adding our container. We're going to choose our task memory size, and we're going to choose our CPU. I noticed that I can't go up here, so there are some restrictions as to what you can do. A quarter of a virtual CPU is well enough for this example. Node.js does not require a lot of memory or CPU power. At least our use case doesn't. We'll go ahead and add a container. We're going to need the ECR image here. I'm going to hit copy. And look here, it says that we can put colon tags. So in the ECS follow along, I had colon latest, which I'm really sure that we can do. But for whatever reason, it wasn't working for me. Maybe I had a spelling mistake. Maybe there was something off there. But it definitely seems like I can go in here and use this one where it has colon latest. But I just don't want to have any problems, so I'm going to leave that out there. We're going to name this container. I'm going to call it my Fargate container. Okay, not really original there. We'll just select 128. It's less than we used in the ECS one, but it's totally fine. And notice we don't have a host mapping. So this is what I was talking about, this AWS VPC thing. So our host port is going to be 8080. We don't have a choice in the matter. That's all we get. We're going to scroll down. We're going to make our way over to the environment variables. I'm going to set one for port, and will be 8080. And then we'll set one on node env production. Now, I guess if we wanted to run this on port 80, I could change this to 80. But the thing is, if you've ever set up a server, anytime you run port 80 on Amazon Linux 2 or whatever, it throws errors. You got to make sure it's sudo. It's a big pain. So we're just not going to do it. But for a production environment, you'd want set 80, or we'd have to find another way around this, like doing a proxy container, which I'll talk about later in this follow along here. We don't need to fill out anything else in here. There's a lot of options here, not even worth discussing. And we're going to hit add. You can see it's only utilizing this amount of the actual container. I'm going to scroll on down here all the way to the bottom. We're going to hit create, and it creates super, super fast. We're going to view that task definition. And we don't really need to do anything here, but we'll make our way over to the clusters. And we have my Fargate cluster, and it should say one service running. It probably is just starting, it's getting going. So we'll click into it here, and we should see a service. Oh, no, we won't, because we just created a task definition. We actually haven't launched the service yet. So we'll hit create. We will choose the F1. We'll choose Fargate. It's 1. We don't have anything else. We have my Fargate cluster. I name this my Fargate service. I ran into an error where I named this my service, which was what we named the ECS one, and then it errored out on me, which was weird because it didn't exist anymore. So you may have to fiddle with the name here. So I'm just changing it just so I avoid that issue. We only want one task to be running. We're going to leave it as rolling deploys, and we'll go next. And then we have to choose the cluster VPC and subnet, which when you think of like serverless containers, you think you would have to choose anything. But we're going to go ahead here and choose VPC. We're going to choose the first subnet. We're going to scroll all the way down. We're not going to choose a load balancer. We just want to save money, not have any complications. But for a production environment, you definitely would want to set a load balancer. We'll go all the way down to the bottom. We're going to hit next. We're not going to use auto scaling group, but for production, I would absolutely do that. There's no additional cost there, so it's easy. And then we'll scroll all the way down to the bottom. We get a nice review, and we'll hit create. And this is super fast, way faster than ECS. Well, actually, I shouldn't say that. ECS is faster because it doesn't have to start up an EC2 instance. So this looks like it's fast, but when you go here, you're going to notice that it's provisioning. So it's actually not running as of yet. So ECS is way, way faster for getting your tasks running. So that is one trade-off you have to consider. Now, while this is getting started, we can see we have this public IP. It's in pending or provisioning. So if we go here, we're not going to get anything. And also, it's not going to work because it's running on port 8080. So we're going to need to expose that port. There is a security group attached to this cluster or this task or service or something. Security groups are around tasks, so we should click into the task. Yeah, there it is. And so we'll click into this. And we will go into inbound rules. We will edit a rule, and we are going to add a new rule, 8080, for everybody in the internet. We'll hit save, and then we'll go back, and we'll check on our service here and see if it's warmed up. And so it's active. We'll click into it. We'll go to tasks. We'll click into the task. We will copy the public IP address. We will paste it in here, and we'll do 8080. And does it work? Nothing as of yet. Oh, it still says pending here. Okay. But we don't have any errors. Let me go back here. Pending. I'm just trying to make sure that it's not stopping and starting. If there was a configuration issue, it would stop and start, but it also would tell us the error somewhere in here. It might be in here or in the logs. But we're not seeing any issues yet, so I think we just have to wait a little while. It's still warming up. So what I'm going to do is just stop the video here, and when it is running, I'm going to come back, or if there's an error, we'll talk about it. Okay, and we're back here. It's moved to activating state, and it says it's running. I was looking up to see what would happen if it was in a pending state. And I could say that the Docker daemon is unresponsive, the Docker image is large, the ECS container agent lost connectivity, the ECS container agent takes a long time to stop the existing task. But we're actually not having any problems. It was just me thinking that there was more of a problem there than there actually was. Because if we go here and copy this IP address and then do 8080, it works. So what if we wanted this not to be 8080 and just port 80, which would be nothing on here on the end? What we would need to do is either we would need to start, like in our environment variables, set it so that it's port 80. And but then we might have to set sudo. It's a big pain to get port 80 running for web apps, and so I just didn't want to go through that hassle. Another thing you could do is you could have you could run multiple containers, and one container could be Nginx, and Nginx could be used as a proxy where you change port 8080 to port 80. So that's something that you could use an Nginx container for, and that would be a great strategy if you really have a bunch of containers, and then you want to then have more flexibility on their mapping. But I just want to show you how that it is hard coded to port 80 there. So I'm going to go back to that task definition. I'm going to go into here, study sync F1. We'll go to the JSON, and you can see here it says 8080. All right, and we didn't set that. That's just what it is hard coded into here. But we're done with this service. So what we'll do is we'll go ahead and delete it. And we will type delete me. We don't have to do this because we never set up any service discovery with it. That would be for like app mesh, which I'm not really familiar with. Maybe that would show up in the AWS Advanced Networking certification. And we will hit delete. And that is Fargate. Now we can go ahead and delete this cluster. It's not going to do anything because it's not running an EC2 instance. It's not costing us money, but let's just delete it because it's a good habit to do so. And there you go. So that should be deleted now. Yeah, it's still showing up. Deleting. Okay. Sometimes you got to do it twice. Anyway, that's the Fargate follow along, and we're all done. Okay, so we're on to the ECS and Fargate cheat sheet. I grouped these ones together because Fargate is under the ECS console, and there's not a lot you need to know about these two. So let's get to it. So Elastic Container Service is a fully managed container orchestration service, highly secure, reliable, scalable, and way to run containers. The components of ECS is as follows: cluster multiple EC2 instances that will house the Docker containers, a task definition file, a JSON file that defines the configuration up to 10 containers that you want to run, task launch containers defined in task definition, tasks do not remain running once workload is complete. Service, ensure tasks remain running. So think of a web app. The last two you 100% need to know. Container agent, binary on each EC2 instance, which monitors, starts, stops tasks. And we'll talk about ECR for a second here. I guess it's part of this cheat sheet as well. And it is a fully managed Docker container registry that makes it easy for developers to store, manage, and deploy Docker container images. So think of it like the Git for Docker containers. And then we'll move on to Fargate, which is the last thing here. So Fargate is a serverless containers. You don't worry about servers, run containers, and pay based on duration and consumption. When you create a Fargate cluster, it's just like making an ECS cluster, except it's empty. There's no servers. So it's really easy to set up. Fargate has cold starts. So if this is an issue, then you want to consider using ECS, which does not have cold starts. The duration is as long as you want, so you can run this forever. This is important to note versus Lambdas, which have a hard limit in terms of how long they can run. Memory can go up to 30 gigabytes, which is pretty great. And the pricing, pay at least 1 minute and every additional second from then on. I didn't mention vCPUs. I don't think it really matters, but there is a limit to how many vCPUs you can set on it, but it's definitely a lot more computing than Lambda will give you. But yeah, there you go. That is ECS Fargate, and I guess ECR as well. Hey, this is Andrew Brown from Exam Pro, and we are looking at AWS X-Ray, which helps developers analyze and debug applications utilizing microservice architecture. And also another way to think of it is X-Ray is a distributed tracing system or a performance monitoring system. So to understand X-Ray, we're going to have to understand what microservices are. So microservices is an architectural or organizational approach to software development where software is composed of small, independent services that communicate over well-defined APIs. So these are services owned by small and self-contained teams. Microservice architecture makes apps easier to scale and faster develop, enabling innovation, accelerating time to market for new features. And to really put this in perspective, if you're using AWS and you're using a host of different services, you might already be using microservice architecture. So the idea is that you have all these isolate services. So you have your storage, you have, instead of using large EC2s to handle all the functionality of your application, you break it up into containers or serverless functions, and then you have your databases, notifications, queuing, and streaming. So in the combination of all these services being utilized together is microservice architecture. But the question is how do we keep track of or debug the communication between all these services? Because if you're using a lot of them, it can get a bit confusing. And that's kind of what X-Ray solves. So what exactly is X-Ray? Well, it is a distributed tracing system. So let's talk about what that means. So distributed tracing, also known as distributed request tracing, is a method used to profile and monitor apps, especially those built using a microservice architecture. Distributed tracing helps pinpoint where failures occur and what causes poor performance. Notice at the end there, where failures occur and what causes poor performance. So that's the major thing that X-Ray is doing. Now, performance monitoring, which is its own thing, is also kind of the scope of X-Ray. So traditionally, we used to have application performance monitors. I mean, we still have them, but they were for traditional architecture where you had a single EC2 and all of your business logic or all the tasks that your application was handled was in one specific application. But let's talk about what performance monitoring is, because X-Ray basically falls under that category. So monitoring and management of performance and availability of software apps, APM, the A is for application, strives to detect and diagnose complex application performance problems to maintain an expected level of service. So you could say that X-Ray is both of these, but I would lean towards saying it's a distributed tracing system. So to try to help you understand X-Ray, let's just talk about some third-party services that are kind of similar, where it's cloud monitoring or application performance monitoring. I do feel that these services are starting to tack on like distributed tracing to their services. So some of these might not really match X-Ray, but I'm sure they will catch up in time. The number one service I can think of is Datadog, which does a lot of stuff. It does APN, log monitoring, and other sorts like that. Then you have New Relic, which was traditionally just application monitoring for large applications, but now it can do considerable more. SignalFX, which is supposed to be like Datadog, but is more in real time. And then you have Lumego, which is, and I don't know if I'm saying it right, but that's how I'm saying it, Lumego. And it is focused on serverless monitoring. So it looks a lot like X-Ray, but it has a huge emphasis on just serverless services. So, hopefully if you go look up those and take a peek around there, it'll give you a better perspective on how X-Ray fits in the market of these monitoring services. So X-Ray is a distributed tracing system, and it collects data about requests that your application serves. It can view, filter collected data to identify issues and avenues for optimization. For any trace request to your application, you can see detailed information not only about the request and response, but also about the calls that your app makes to downstream AWS resources, microservices, databases, HTTP web APIs, and I'm certain that there are more things in there. But just to visualize that, here we can see that we have a trace, and we have DynamoDB, and it goes and it shows you all the steps within the table that it's taking. So, you can get some very detailed information out of this. But let's move on and start breaking up what are the components to X-Ray. Now we're going to take a look at the anatomy of X-Ray. So basically this is the overall landscape of how it works. So the first thing is we have the X-Ray console, and this is where we are going to be able to visualize, monitor, or drill down into our tracing data. That data is going to be coming from the X-Ray API. Now you'd think that you would just directly send your requests to this API, but that's not the case. You send them to the X-Ray daemon, and this is used as a buffer because you're going to be sending a lot of requests. The data is coming from the X-Ray SDK. And so here we have Ruby, Python, and Node. There's a lot more than just the ones there. We'll talk about that later. And then we have the SDK and CLI. And this could as well be sending the segment data to X-Ray daemon, or it could be directly interacting with the X-Ray API. So let's talk about the X-Ray SDK, because this is where all our segment data is coming from, and that is what we're visualizing in the X-Ray console. So the X-Ray SDK provides a way to intercept incoming HTTP requests. So that means request information around that kind of stuff. Then it has something called client handlers, and this is just really the SDKs that are specific per language. So when it says SDK client, we're talking just about like the Ruby client or the Python client or etc. And we're able to set up instrumenting. And we'll talk about that in the next slide, because instrument is kind of a vague term, but it'll make more sense soon enough. And then it also has an HTTP client, so we can use this to instrument calls to internal or external HTTP web services, and also just to deliver our information actually to the X-Ray daemon. So that's another component of it. And I want to point out that the SDK does support instrumenting calls for SQL databases, and for other features. The one that's worth highlighting is SQL databases, because it really lets you drill down to see what's happening with your database calls for that. But anyway, let's move on to what instrumenting is. So I mentioned the term instrumenting or instrument in the last slide, and I figured that was worth exploring more, because even myself, I wasn't sure what the term meant. So instrumenting is the ability to monitor or measure the level of a product's performance, to diagnose errors, and to write trace information. So to me, it just sounds like you're logging information. That's exactly what it is. So to get an idea what it looks like to instrument something in X-Ray is we have this piece of code here, and this is for a Node.js Express.js application. And what we're doing is we're including the X-Ray SDK. And then what we do is we open up a segment. Segments and subsegments are the pieces of information that we want to capture or to send X-Ray, and that is instrumenting. So we have a part where we open, and then we have a part that we close. And everything that is in between there is going to get captured, like the duration of it or additional information, and that's what's going to get passed along. Generally in the code, you don't have to necessarily set the segments. The segments get captured. So usually in your code, you're setting up subsegments. Yeah, just to give you a visualization. So just remember that when you hear instrument, just think of it like logging information and sending it to X-Ray. Let's take a closer look here at the X-Ray daemon. And I said earlier when we were looking at the anatomy that we do not send our segment data directly to the KMS API. What we do is we send it to the daemon, and then the daemon buffers it and then sends it off to the KMS API. So let's look in that more detail. So instead of sending your traces directly to X-Ray, the SDK sends JSON segment documents. So that's what the segments are made of, JSON files, to a daemon processing listening on UDP traffic. So here's our SDKs and other clients. And here it is sending that JSON document to the X-Ray daemon, right? And then the X-Ray daemon buffers segments into a queue and uploads them to X-Ray in batches. So the idea is that it's creating this buffer. And this makes sense because if you are sending if you're sending logging or instrument data, you're going to have a lot of requests. And so you don't want the API to be flooded there. So this acts as a buffer. And then there it is sending the batch information to X-Ray API so that it's not so burdensome. You can install the daemon on Windows, Linux, and Mac, and it's already included on Elastic Beanstalk and Lambda platforms. So I think when you're using it, like when you're using the serverless, like you're setting up a serverless application and you turn on X-Ray, there's already a daemon running there. I don't know where it is, but I know it's working. And it looks like you can also just set one up locally for development. And X-Ray uses trace data from the AWS resources that power your cloud applications to generate a detailed service graph. So that's just to say all this segment data turns into that graph. So, hopefully that makes clear the utility of the X-Ray daemon. Now we're going to cover all the X-Ray concepts. So the first thing that we really need to understand are segments, because that is the core of X-Ray. That's the data that X-Ray receives. And X-Ray can group segments and have common requests, which we call traces. Okay. And then X-Ray processes those traces to generate a graph, and that provides a visual representation for your app. So that's the general idea. But there are a lot of components to it. So let's go through the list really quickly here. So we have segments, we have subsegments, we have service graph, we have traces, we have sampling, we have the tracing header, we have filter expressions, we have groups, we have annotation metadata, and then we have errors, faults, and exceptions, mostly just exceptions. So we're going to walk through every single one of these components, and then we'll really understand how X-Ray works. So let's first look at the service graph, and this is something that's visible when you click into a trace. And so the service graph shows the client, your front-end services, and back-end services. And it might not be very clear looking at this, which is the client, front-end, and back-end. So I'm going to help divide this up so that we can make sense of that. So the first one is the client, and it's just a little person in terms of representation. So nothing super exciting there. But then we still have a bunch of these other services that are running. So then we have your front-end services, and we can divide that here. And what we see running here is like computing and application integration. So that could be SNS, Lambdas, ECS, EC2, SQS, so anything like that. And then the last thing is back-end services. This is generally your databases. So here, all these calls are related to DynamoDB. So, hopefully that makes that all clear there. And the service graph, the whole purpose of having this It's to help you perform, like identify bottlenecks, latency spikes, and other issues. So the idea is that you can click into any of these and drill down and really figure out how to optimize your performance. So let's take a look at segments, which is the most important thing to know about X-Ray. And so if you have a bunch of compute resources that are running your application logic, you're going to want to send data about that to X-Ray, and we call that sending work. So we're sending our work off to specific segments. So here is an actual segment that we could drill down into, and there's a lot of different information here. So we have things like the host information, so that'd be host name, alias, or IP address. I called this this Lambda function. If you can see, the origin says AWS Lambda. I called it in the console. I didn't call it through API Gateway, so it doesn't have any of that data here, so that's why we're not seeing it. And then you'd have request information, so the method, client, address, path, user agent. Again, I didn't use API Gateway, so we're not seeing that information there, but if I had done so, we'd see a lot more information. Then you have the response, so that's the status and content. Here we have a 200, so that means everything's good. The work done, so the start and end times. We have the duration and subsegments. And then the last thing would be issues that occurred. So errors, faults, and exceptions, and we have a dedicated tab there for that. So that's what it looks like to drill down into a segment. So let's take a look at subsegments, which allows us to get more granular timing information or details about downstream calls that your app makes. So these are basically operations within your app that you want to capture. So a subsegment can contain calls to AWS services, external HTTP APIs, or SQL calls within a database, and also things within DynamoDB. And that's actually the example we're going to look at is DynamoDB. So here, what we have is we have an Elastic Beanstalk environment, and there's a put request going to it. And then underneath in that application, it's making calls to DynamoDB. So we can see get item, update item, etc. And so those are the subsegments. Now, you can actually define your own arbitrary subsegments to instrument specific functions or lines of code. And that's what I'm going to show you in the next step. But a lot of these things, if you're using specific AWS services, they might already log these subsegments for you. But, if you need something more specific, you can write your own. So here we have a trace, and within this trace we have a segment, and then there's a subsegment. Can you tell where the custom subsegment is? It's right there. So that's one I defined, and I want to show you how you would do that in code. So here is the actual code example, and the first thing you're going to want to do is include the SDK. So there's the X-Ray SDK core. I'm writing this obviously Node.js, and it's very similar to when we defined a segment earlier on. But in this case, we first have to get the current segment, and then we're going to add a new subsegment. So I call this mining, and then you have some code that runs, and then you close the subsegment. So everything in between the start and end will be captured, and that's going to go to that segment. There, I'm just doing a console log, so it's 0.0 milliseconds, nothing super exciting there. You generally don't define. You don't create segments in code. I mean, in the earlier example, we saw it because that was the Express.js application, but generally the only thing you're defining in code for instrumentation is subsegments. But, this is just an example to show you how to set up subsegments. Let's just take a look here at traces. So here I've drilled into a trace, and the way you can think of a trace is it's a way of grouping all your segments together, and they're all started from a single request. So that first request is triggered, and then the idea is we need to keep track of its path through all these segments and services. So that's why we have a trace ID. And the idea is when that trace ID is generated from the first service that it interacts with, it's going to generate that ID, and that's going to get passed along through all this stuff. And that's what helps build out this that graph down below that tells us all that information. So we're going to talk about trace IDs a bit more, but we're going to first talk more about sampling, because not every trace that happens here is actually recorded. So that confused me a lot when I first started using X-Ray, where I was triggering stuff and I was expecting to see every single thing that I triggered recorded, and that's not the case. So I was saying in the last slide when we were looking at traces that not every single request is actually passed on or captured. And the reason why is when you're using the X-Ray SDK, it uses a sampling algorithm to determine which request will actually get traced. So by default, the SDK is going to record the first request for each second and 5% of every additional requests. So why would we have this? What would be the purpose of sampling? And the reason is to avoid incurring service charges. So when you're first getting started, you want the default sampling rate to be low, just because you're maybe not that familiar with X-Ray and you don't realize how many traces or requests you're sending, and you might not be able to make use of that. So you can actually see the options that are set up for this particular sampling algorithm. And you can actually modify the sampling rule and add additional rules. So if you were over here, you could go hit create sampling rule and set a bunch of options. So you can set it to match up on the service name, the service type, and a bunch of other things. And down below, you can see it says limit to 1 request per second, and then 5 seconds per fixed rate. So the whole purpose of sampling is just to help you save money, because it's going to help you reduce the amount of traces for high volume and unimportant requests. You're just going to find that there could be like a component within your application where, let's say, it does polling. So it's constantly polling like frequently, but you don't need to capture that information because it doesn't provide you any valuable information. So now we're going to take a look at the trace header itself. So all requests are traced up to a configurable minimum, and after reaching that minimum, a percentage of the requests are traced to avoid unnecessary costs. Okay. The sampling decision and the trace ID are added to the HTTP request in tracing headers named X Amazon Trace ID. So we were talking about the trace ID gets set, but this is just what it looks like. So the first X-Ray integrated service that the request hits is when the tracing header gets added. So here, this is what it looks like. It has a root and it has a sampled number there. And then the next thing is if you have a tracer header where it's originating from an actual instrumented application, it could actually have this parent thing here as well. You don't really need to remember this stuff for the exam. I'm just showing it to you. But just understand that the trace header determines whether this will show up in the trace or not. And it's going to be based off that sample number that is assigned to it. So even with sampling, a complex application still generates out a lot of data. So sampling isn't going to remove enough so that it's very easy for you to make sense of stuff. So that's where filter expressions come in. This helps you narrow down to specific paths or users. So here's an example, and this is we're looking at all traces. So there's a list of traces. And in that filter expression, you can put in a thing in there, and that's going to filter out what traces you want to look at. If you're wondering like what the actual syntax for filter expressions is, you just click that question mark there. And there's a lot of information under there. So these are a lot of the attributes that you can use. Here you can see that we are filtering out based off the request URL, but there's a lot of stuff here. And also that you can group these results together. So they have a bunch of predefined groups for you to just make sense of stuff a lot easier. You can see in the graphic there, by default, it is for URL. So let's talk about groups. We just saw group by, but you can also assign a filter expression to a group that you create. And the way it works is you're going to name that group, and it could be just a name, or you can use an ARN. And the advantage of making your own groups is that it's going to generate its own service graph, trace summaries, and CloudWatch metrics. And this is going to save you a lot of time when investigating very common scenarios. So the idea is right beside where the filter expression is, you can drop down and hit create group. And from there, you're going to name that group. And again, you can put an ARN in there, and then you just provide your filter expression. Notice that you can only create up to 25 groups by default, but I guess you can use a service limit to increase beyond that. If you're going beyond 25, you must have a very complex application. But I do want to warn you about these groups because and this is just the nature of it. So when you create a group and you set that filter expression, and let's say down the road, like a week later, you want to adjust that filter expression, it's not going to retroactively apply that to all the previous data. It's only going to apply this regular expression or this filter expression for future data. So that's an issue where the data doesn't exactly represent what you expect it to look like because you have this old expression and new expression. So what you can do is, if it really matters to you that the expression only represents data that is exactly based on that filter expression, you're just going to have to delete the current group and make a new one. Okay. So with X-Ray, you can add annotations and metadata to your segment documents. That's the JSON files that get sent to X-Ray. That is generally the information you're doing there. And you can aggregate this at the trace level, and it can be added to both the segments and a sub-segment. So it's not just limited to top-level segments. And so let's talk about annotations. So this is just a key value pair that is indexed for use with filter expressions, and you can have up to 50 annotations per trace. Now for metadata, you have a key value pair that are not indexed, and the values can be of any type, including objects and lists. So they sound really similar. They're both key pair values. The only difference is that annotation is indexed and metadata is not. So just to better understand the use case, you want to use annotations to record data that you want to use in group traces in the console, or when you're calling the get trace summary. So it's really for group traces. And then you want to use metadata to record data when you want to store in the trace, but you don't need to use it for searching traces. So for annotations, it's for you to help find data, and for metadata, it's just to have additional data there when you need it. And you can view the annotation and metadata in the segment, subsegment details of the X-Ray console. So if you just click into a segment, you'll see annotations and metadata there. So now let's just point out errors, faults, and exceptions. So when an exception occurs while your app is serving instrument requests, the X-Ray SDK records exception details and the stack trace if available. These are the type of errors you could encounter. So we have error, fault, and throttle. Errors are client errors, so they're going to be 400. Fault is server errors, that's going to be 500. Throttle is throttling errors, that's just too many requests. And if you're looking for this data, it's going to show up under the exceptions tab for the segment details. And it will also show up in the actual segment graph there. So when you're in a trace and you see all the segments and their duration, sometimes it will have like a little exclamation, or it'll color it differently so you know there's an error at some part during the path of the trace. Now let's take a look at what services integrate in with X-Ray, and the most important we've highlighted in yellow because these are going to be the most common use cases. So we have Lambda, API Gateway, AppMesh, CloudTrail, CloudWatch, AWS Config, Elastic Beanstalk. I'm not exactly sure how that works, but Elastic Beanstalk seems to want to integrate with everything nowadays. Then you have ELBs, you have SNS, SQS, EC2, Elastic Container Service, Fargate, and I wouldn't be surprised if it also supports Elastic Kubernetes Service. But yeah, that is the run of it, but the ones that are highlighted are the ones you most likely need to know, and probably ECS as well there, even though I didn't highlight it. So for the exam, you're going to need to know what languages does X-Ray support. It supports Go, Java, Node, Python, Ruby, ASP.NET, and PHP. So it's all the culprits here. The only thing it doesn't support is PowerShell, which there's no reason to support that. But yeah, this is generally what AWS would support for most services for languages. So, and it has the whole gambit here. Hey, this is Andrew Brown from Exam Pro, and we've made it to the X-Ray cheat sheet. And this one is a little bit long, but X-Ray is very important to know. So we're going to be very thorough here in our review. So let's get to it. So X-Ray helps developers analyze and debug applications that utilize microservice architecture. Remember that it's really, really keen for microservice architectures. So if you're using Lambdas or you're using containers, X-Ray is really good for that. X-Ray is a distributed tracing system. It is a method used to profile and monitor apps, especially those built using a microservice architecture, to pinpoint where failures occur and what causes poor performance. The X-Ray Daemon is a software application that listens for traffic on UDP port 2000, gathers raw segment data, and relays it to the AWS X-Ray API. Data is generally not sent directly to the X-Ray API and passes through the X-Ray Daemon, which uploads in bulk. And that's just to help create a buffer between from the X-Ray API and the actual data being sent. Will the daemon show up on the actual exam? Probably not, but we should really know all the components of X-Ray. Segments provide the resource's name, details about the request, and details about the work done. Then you have subsegments, which provides more granular timing information and details about downstream calls that your app made to fulfill the original request. Then you have your service graph. That is that flow chart visualization for average response of microservices and to visually pinpoint failure. Then you have traces. This collects all segments generated by a single request so that you can track the path of requests through multiple services. Then you have sampling, which is an algorithm that decides which requests should be traced. By default, X-Ray SDK records the first request each second and 5% of additional requests. So if you have a question on the exam and they're asking like, why don't you see this information? Just think about sampling. Tracing header is the name X Amazon Trace ID and identifies a trace with which passed along downstream services. What's important to remember here is X Amazon Trace ID. You might see a question where they show multiple, like to pick the right one. So remembering that is key. Filter expressions allow you to narrow down specific paths or users. Groups allow you to save filter expressions so you can quickly filter traces. And then on to the second page, we're almost done here. Annotation metadata allows you to capture additional information in key value pairs. So for annotations, they are indexed for use with filter expressions with a limit of 50. Metadata are not indexed. Use metadata to record data you want to store in the trace, but don't need to use for searching traces. So if you need to search for traces, and need that metadata, you're going to be or that additional information, you're going to be using annotations. Errors are 400, faults are 500, throttle is 429, too many requests. You probably want to just know the last one there. X-Ray supports the following languages. I don't feel like they'd ask you a question. Well, they used to, but I think the exam's getting a little bit harder. So they're not just asking you to like choose the language that's not applicable anymore. But X-Ray supports basically all possible language that AWS has on there. As long as they're not telling you, putting Perl in the list, it should be pretty easy to figure that out. X-Ray supports AWS service integrations with the following: Lambda, API Gateway, AppMesh, CloudTrail, CloudWatch, AWS Config, EB, ELB, NSS, SQS, EC2, ECS, and Fargate. So there you go. That is X-Ray, and we are done here. Hey, this is Andrew Brown from Exam Pro, and we are looking at Amazon Certificate Manager, also known as ACM, which is used to provision, manage, and deploy public and private SSL certificates for use within your AWS services. So let's look at ACM a little bit more in detail. It handles the complexity of creating and managing public SSL certificates for your AWS-based websites and applications. It handles two types of certificates. We have public, those are ones that are provided by AWS and they are free. And then you have private. And so these are certificates that you import and they cost $400 per month. You generally just want to use a public certificate. If you ever use Let's Encrypt, those are all public. So if you're comfortable with that, you're comfortable with these ones. Just make sure that when you're creating that certificate, you do not make the wrong choice. I myself have chosen incorrectly. But luckily I reached out to AWS support, and before they charged me, they fixed that issue. But that is a tricky one to get your money back on if you make that mistake. So ACM can handle multiple subdomains and wildcard domains. So you can see that I'm entering Exam Pro as the naked domain, and then I have a wildcard one. That is the setup I always recommend that you use because otherwise you'll just have to create a bunch of certificates later, and that's kind of a pain. And ACM is attached to very specific AWS services or resources. So you can attach it to Elastic Load Balancer, CloudFront API Gateway, and you can apparently use it with Elastic Beanstalk, but I'm imagining that is through the ELB. So those are the three services you need to know that ACM attaches to. So remember that, and there you go. So we're going to look at a couple of ACM examples, and the point of this is to understand SSL termination. So the first one here we have is we're using ACM and we're attaching that certificate to our load balancer, which is application load balancer. And if you see that line, the idea is that this red line represents the traffic that is encrypted. And so once it hits the ALB, the certificate is going to decrypt that traffic, and then everything between the ALB to the EC2 instance is now unencrypted. And that's totally fine because it's within your network, so it's still secure. But for someone to take advantage of that, they'd have to break into your AWS account, and they'd have to be able to intercept that traffic. So it's a very low risk. But the ACM can only really be attached to Elastic Load Balancer, CloudFront, or API Gateway. So it's not easy to protect this traffic here. But the advantage of attaching your certificates at this level here is that you can add as many EC2 instances as you want, and you don't have to configure each one of them to be able to handle a certificate. So that makes it a lot easier to manage certificates. Now, the other case is terminating SSL end-to-end. And this is where the traffic from the start to the finish is encrypted. So even within your network, it's going to be encrypted. And the way you would do that, I don't know how to do with ACM. I don't even think you can do it with ACM because I've only known it being able to attach to resources over here. But I guess you could use Let's Encrypt. And so you'd have to set that up on every single server, and then rotate them out. And that's kind of a bit of a hassle to maintain, but a lot of people are used to doing that. And this is if you need end-to-end encryption. This is going to be dependent on your compliancy. So if you're a large corporation, maybe you have a rule that says you have to encrypt end-to-end. But for 99% of other use cases, this is more ideal, terminating SSL at the load balancer. So there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at Route 53, which is a highly available and scalable domain name service. So whenever you think about Route 53, the easiest way to remember what it does is think of GoDaddy or Namecheap, which are both DNS providers. But the difference is that Route 53 has more synergies with AWS services, so you have a lot more rich functionality that you could do on AWS than you could with one of these other DNS providers. So what can you do with Route 53? You can register and manage domains. You can create various record sets on a domain. You can implement complex traffic flows, such as blue-green deploys or failovers. You can continuously monitor records via health checks and resolve VPCs outside of AWS. So here I have a use case, and this is actually how we use it at ExamPro, is that we have our domain name. You can purchase it, or you can have Route 53 manage the name servers, which allow you to then set your record sets within Route 53. And so here we have a bunch of different record sets for subdomains, and we want those subdomains to point to different resources on AWS. So for our app runs behind Elastic Load Balancer. If we need to work on an AMI image, we could launch a single EC2 instance and point that subdomain there. For our API, if it was powered by API Gateway, we could use that subdomain for that. For our static website hosting, we would probably want to point to CloudFront, so the www points to a CloudFront distribution. And for fun and for learning, we might run a Minecraft server on a very specific IP. Probably would be Elastic IP because we wouldn't want it to change, and that could be Minecraft exampro.co. So there's a basic example, but we're going to jump into all the different complex rules that we can do in Route 53 here. So in the previous use case, we saw a bunch of subdomains which were pointing to AWS resources. Well, how do we create that link so that Route 53 will point to those resources? And that is by creating record sets. So here I just have the form for record sets, so you can see the kind of the types of record sets you can create. But it's very simple. You just fill in your subdomain, or even leave the naked domain, and then you choose the type. And in the case for A, this allows you to point this subdomain to a specific IP address. You just fill it in, and that's all there is to it. Okay. Now I do need to make note of this alias option here, which is a a special option created by AWS. So here in the next slide here, we've set alias to true. And what it allows us to do is directly select specific AWS resources. So we could select CloudFront, Elastic Beanstalk, ELB, S3, VPC, API Gateway. And why would you want to do this over making a traditional type record? Well, the idea here is that this alias has the ability to detect changes of IP addresses, so it continuously keeps pointing that endpoint to the correct resource, okay? So that's normally when, if and whenever you can use alias, always use alias, because it just makes it easier to manage the connections between resources via Route 53 record sets. And the limitations are listed here as follows. So the major advantage of Route 53 is its 7 types of routing policies. And we're going to go through every single one here so we understand the use case for all 7. Before we get into that, a really good way to visualize how to work with these different routing policies is through Traffic Flow. And so Traffic Flow is a visual editor that lets you create sophisticated routing configurations within Route 53. Another advantage of Traffic Flow is that we can version these policy routes. So if you created a complex routing policy and you wanted to change it tomorrow, you could save it as version 1 and have version 2 and roll this one out or roll back to that. And just to play around with Traffic Flow, it does cost $50 per policy record. So this whole thing is one policy record, but they don't charge you until you create it. So if you do want to play around with it, just create a new Traffic Flow and name it, and you'll get to this visual editor. And it's not until you save this, so you can play around with this to get an idea of like all the different routing rules and how you could come up with creative solutions. But now that we've covered Traffic Flow and we know that there are 7 routing rules, let's go deep and look at what we can do. So we're going to look at our first routing policy, which is the simple routing policy, and it's also the default routing policy. So when you create a record set, and here I have one called random, and we're on the A type here. Down below, you're going to see that routing policy box, and it's always by default set to simple. Okay, so what can we do with simple? The idea is that you have one record, which is here, and you can provide either a single IP address or multiple IP addresses. And if it's just a single, that just means that random is going to go to that first IP address every single time. But if you have multiples, it's going to pick one at random. So it's a good way to make like a, if you wanted some kind of random thing, maybe for A to B testing, you could do this. And that is as simple as it is. So there you go. So now we're looking at weighted routing policies. And so what a weighting routing policy lets you do is allows you to split up traffic based on different weights assigned. Okay, so down below we have app.exampro.co, and we would create 2 record sets in Route 53, and they'd be the exact same thing. They both say app.exampro.co, but we'd set them both to weighted, and we give them 2 different weights. So for this one, we would name it stable. So we'd name that one stable, give it 85%, and then we'd make a new record set with the exact same subdomain and set this one to 15% and call it experiment. Okay, and the idea is that whenever traffic any traffic hits app.exampro.co, it's going to look at the 2 weighted values, and 85% is going to go to the stable one, and for the 15%, it's going to go to the experimental one. And a good use case for that is to test a small amount of traffic to minimize impact when you're testing out new experimental features. So that's a very good use case for weighted routing. Now we're going to take a look at latency-based routing. Okay, so latency-based routing allows you to direct traffic based on the lowest network latency possible for your end user based on a region. Okay, so the idea is, let's say people want to hit app.exampro.co and they're coming from Toronto. All right, so coming from Toronto, and the idea is that we've created 2 records which have latency with this subdomain, and one is set to US West, so that's on the West Coast, and then we have one Central Canada, I believe that's located in Montreal. And so the idea is that it's going to look here and say, okay, which one produces the least amount of latency? It doesn't necessarily mean that it has to be the closest one geographically, just whoever has the lowest return in milliseconds is the one that it's going to route traffic to. And so in this case, it's 12 milliseconds, and logically things that are closer by should be faster. And so so it's going to route it to this ALB as opposed to that one. So that's how latency-based routing works. Now we're looking at another routing policy. This one is for failovers. So failover allows you to create an active passive setup in situations where you want a primary site in one location and a secondary data recovery site in another one. Okay. Another thing to note is that Rev53 automatically monitors via health checks from your primary site to determine if that endpoint is healthy. If it determines that it's in a failed state, then all the traffic will be automatically redirected to that secondary location. So here we have down below an example. So we have app.exampro.co, and we have a primary location and a secondary one. All right. And so the idea is that Rev53, it's going to check, and if it determines that this one is unhealthy based on a health check, it's going to then reroute the traffic to our secondary location. So you'd have to create, two routing policies with the exact same domain. You just set which one is the primary and which one is the secondary, and it's that simple. So here we are looking at the geolocation routing policy, and it allows you to direct traffic based on the geographical location of where the request is originating from. So down below, we have a request from the US hitting app.exampro.co, and we have a record set for a geolocation that's set for North America. So since the US is in North America, it's going to go to this record set, all right? And that's as simple as it is. So we're going to look at geo-proximity routing policy, which is probably the most complex routing policy. And it's a bit confusing because it sounds a lot like geolocation, but it's not. And we'll see shortly here. You cannot create this using record sets. You have to use traffic flow because it is a lot more complicated and you need to visually see what you're doing. And so it's going to be crystal clear. And we're just going to go through here and look at what it does. So the idea is that you are choosing a region, so you can choose one of the existing AWS regions, or you can give your own set of coordinates. And the idea is that you're giving it a bias around this location, and it's going to draw boundaries. So the idea is that if we created a geo-proximity routing for these regions, this is what it would look like. But if we were to give this one 25% more bias, you're going to see that here it was a bit smaller, now it's a bit larger, but if we minus it, it's going to reduce it. So this is the idea behind a geo-proximity where you have these boundaries, okay? Now just to look at it in more detail here, the idea is that you can set as many regions or points as you want here. And so here I just have 2 as an example. So I have China chosen over here, and this looks like we have Dublin chose. So just an idea to show you a simple example. Here's a really complicated one. Here I chose every single region just so you have an idea of split. So the idea is you can choose as little or as many as you want. And then you can also give it custom coordinates. So here I chose Hawaii. So I looked up the Hawaii coordinates, plugged it in, and then I turned the bias down to 80% so that it would have exactly around here. And I could have honed it in more. So it just gives you a really clear picture of how geo-proximity works. And it really is boundary based, and you have to use traffic flow for that. So the last routing policy we're going to look at is multi-value. And multi-value is exactly like simple routing policy. The only difference is that it uses a health check. Okay, so the idea is that if it picks one by random, it's going to check if it's healthy. And if it's not, it's just going to pick another one by random. So that is the only difference between multi-value and simple. So there you go. Another really powerful feature of Rev53 is the ability to do health checks, okay? So the idea is that you can go create a health check, and I could say for app.exam.pro.co, it will check on a regular basis to see whether it is healthy or not. And that's a good way to see at the DNS level if something's wrong with your instance or if you want to fail over. So let's get into the details of here. So We can check health every 30 seconds by default, and it can be reduced down to 10 seconds, okay? A health check can initiate a failover if the status is returned unhealthy. A CloudWatch alarm can be created to alert you of a status unhealthy. A health check can monitor other health checks to create a chain of reactions. You can have up to 50 in a single AWS account. And the pricing is pretty affordable. So it's 50 cents. So that's 2 quarters per endpoint on AWS. And there are some additional features, which is $1 per feature, okay? So if you're using Route 53, you might wonder, well, how do I route traffic to my on-premise environment? And that's where Route 53 Resolver comes into play. Formerly known as .2 Resolver, it's a regional service that lets you connect route DNS queries between your VPC and your network. So it is a tool for hybrid environments, on-premise and cloud, and we have some options here if we just want to do inbound and outbound, inbound only, or outbound only. So that's all you really need to know about it, and that's how you do hybrid networking. Okay. So now we're taking a look at Route 53 cheat sheet, and we're going to summarize everything that we have learned about Route 53. So Route 53 is a DNS provider to register and manage domains, create record sets. Think GoDaddy or Namecheap. Okay, there's 7 different types of routing policies, starting with simple routing policy, which allows you to input a single or multiple IP addresses to randomly choose an endpoint at random. Then you have weighted routing, which splits up traffic between different weights assigned, so percentages. Latency-based routing, which is based off of routing traffic to the based on region for the lowest possible latency for users. So it's not necessarily the closest geolocation, but the lowest latency, okay? We have a failover routing, which uses a health check, and you set a primary and a secondary, and it's going to fail over to the secondary if the primary health check fails. You have geolocation, which routes traffic based on the geolocation. So this is based on geolocation would be like North America or Asia. Then you have geo-proximity routing, which can only be done in traffic flow and allows you to set biases so you can set basically like this map of boundaries based on the different ones that you have. You have multi-value answer, which is identical to simple routing. The only difference being that it uses a health check in order to do that. We looked at traffic flow, which is a visual editor for chaining routing policies. You can version those those policy records for easy rollback. We have alias record, which is AWS's smart DNS record, which detects IP changes for AWS resources and adjusts them automatically. Always want to use alias record when you have the opportunity to do so. You have Route 53 Resolver, which is a hybrid solution, so you can connect your on-premise and cloud, so you can network between them. And then you have health checks, which can be created to monitor and automatically fail over to another endpoint. And you can have health checks monitor other health checks to create a chain of reactions for detecting issues for endpoints. Hey, this is Andrew Brown from ExamPro, and we are going to take a look here at AWS Command Line Interface, also known as CLI, which control multiple AWS services from the command line and automate them through scripts. So CLI lets you interact with AWS from anywhere by simply using a command line. So down below here, I have a terminal, and I'm using the AWS CLI, which starts with AWS. So to get this installed on your computer, AWS has a script, a Python script that you can use to install the CLI. But once it's installed, you're going to now have the ability to type AWS within your terminal, followed by a bunch of different commands. And so the things that you can perform from the CLI is you could list buckets, upload data to S3, launch, stop, start, and terminate EC2 instances, update security groups, create subnets. There's an endless amount of things that you can do, all right? And so I just wanted to point out a couple of very important flags. Flags are these things where we have hyphen, and then we have a name here. And this is going to change the behavior of these CLI commands. So we have output, and so the output's what's going to be returned to us. And we have the option between having JSON, table, and plain text. And for profiles, if you are switching between multiple AWS accounts, you can specify the profile, which is going to reference to the credentials file to quickly let you perform CLI actions under different accounts. So there you go. So now we're going to take a look at AWS Software Development Kit, known as SDK, and this allows you to control multiple AWS services using popular programming languages. So to understand what an SDK is, let's go define that. So it is a set of tools and libraries that you can use to create applications for a specific software package. So in the case for the AWS SDK, it is a set of API libraries that that let you integrate AWS services into your applications. Okay, so that fits pretty well into the description of an SDK. And the SDK is available for the following languages. We have C++, Go, Java, JavaScript, .NET, Node.js, PHP, Python, and Ruby. And so I just have an example of a couple of things I wrote in the SDK, and one is in Node.js and one is in Ruby. It's the exact same script. It's for AWS Rekognition for detecting labels, but just to show you how similar it is among different languages. So more or less the syntax is going to be the same. But yeah, that's all you need to do. So in order to use CLI and SDK, we're going to have to do a little bit of work beforehand and enable pragmatic access for the user where we want to be able to use these development tools, okay? And so when you turn on pragmatic access for a user, you're going to then get an access key and a secret, so then you can utilize these services. And so down below, you can see I have an access key and secret generated. Now, once you have these, you're going to want to store them somewhere, and you're going to want to store them in your user's home directory. And you're going to want them within a hidden directory called .aws and in a file called credentials. Okay, so down below here, I have an example of a credentials file, and you'll see that we have default credentials. So if we were to use CLI or SDK, it's going to use those ones by default if we don't specify any. But if we are working with multiple AWS accounts, we're going to end up with multiple credentials. And so you can organize them into something called profiles here. And so I have one here for Enterprise D and Deep Space Nine. So now that we understand pragmatic access, let's move on to learning about CLI. Hey, this is Andrew Brown from ExamPro, and we are going to do the CLI and SDK follow along here. So let's go over to IAM and create ourselves a new user so we can generate some AWS credentials. So now we're going to go ahead and create a new user, and we're going to give them pragmatic access so we can get a key and secret. I'm going to name this user Spock, okay? And we're going to go next here, and we're going to give them developer permissions, which is a power user here, okay? And you can do the same here. So our Cloud9 environment is ready here, okay? And we have a terminal here, and it's connected to an EC2 instance. And the first thing I'm going to do is I just can't stand this white theme, so I'm going to go to Themes down here, go to UI, Themes, and we're going to go to Classic Dark, okay? And that's going to be a lot easier on my eyes here. And so the first thing we want to do is we want to plug in our credentials here so that we can start using the CLI. So the CLI is already pre-installed on this instance here. So if I was to type AWS, we already have access to it. But if we wanted to learn how to install it, let's actually just go through the motions of that, okay? So I just pulled up a couple of docs here just to talk about the installation process of the CLI. We already have the CLI installed, so if I type AWS, it's already here. So it's going to be too hard to uninstall it just to install it to show you here. But I'm just going to kind of walk you through it through these docs here just to get you an idea how you do it. So the CLI requires either Python 2 or Python 3. And so on the Amazon Linux, I believe that it has both. So if I was to type in Py and do version here, okay. Or just Python, sorry, I'm always thinking of shorthands. This has version 3.6.8, okay? And so when you go ahead and install it, you're going to be using pip. So pip is the way that you install things in Python, okay? And so it could be pip or pip3. It depends because there used to be Python 2. And so then when Python 3 came out, they needed a way to distinguish it. So they called it pip3, but Python 2 is no longer supported. So now pip3 is just pip, okay? So, you know, you just got to play around based on your system, okay? But generally it's just pip install AWS CLI, and that's all there is to it. And to get Python installed in your system, it's going to vary, but generally, you know, it's just for Amazon Linux, it is a CentOS Red Hat kind of flavor of Linux. So it's going to use a yum install Python. And just for all those other Unix distributions, it's mostly going to be apt-get, okay? So now that we know how to install the CLI, I'm just going to type clear here, and we are going to set up our credentials. All right, so we're going to go ahead and install our credentials here. They're probably already installed because Cloud9 is very good at setting you up with everything that you need, but we're going to go through the motions of it anyway. And just before we do that, we need to install one thing in Cloud9 here. And so I'm going to install via Node Package Manager C9, which allows us to open files from the terminal into Cloud9 here. And so the first thing I want you to do is I want you to go to your home directory. You do that by typing tilde, which is for home, and /, okay? And so now I want you to do ls-la, okay? And it's going to list everything within this directory. And we are looking for a directory called .aws. Now, if you don't have this one, you just type in mkdir. And you do .aws to create it, okay? But it already exists for us because, again, Cloud9 is very good at setting things up for us. And then in here, we're expecting to see a credentials file, and that should contain our credentials. So typing C9, the program we just installed there, I'm just going to do credentials here, okay? And it's going to open it up above here. And you can already see that it's set as credentials for us, okay? And I'm just going to flip over and just have a comparison here. So we have some credentials, and it is for I don't know who, but we have them. And I'm going to go ahead and add a new one. I'm just going to make a new one down here called Spock, okay? All right. And basically what I'm doing is I'm actually creating a profile here so that I can actually switch between credentials, okay? And I'm just going to copy and paste them in here. All right, and so I'm just going to save that there. And so now I have a second set of credentials within the credentials file there, and it is saved. And I'm just going to go down to my terminal here and do clear. And so now what I'm going to do is I'm going to type in AWS S3LS, and I'm going to do hyphen profile. I'm going to now specify Spock, and that's going to use that set of credentials there. And so now I've done that using Spock's credentials, and we get a list of a bucket stuff, okay? So now if we wanted to copy something down from S3, we're going to do AWS S3 CP, and we are going to go into that bucket there. So it's going to be Exam Pro, Enterprise D. I have this from memory, eh? And we will do data.jpg, okay? And so what that's going to do is it's going to download a file. But before I actually run this here, okay, I'm just going to cd ... and go back to my home directory here, okay? And I'm just going to copy this again here and paste it. And so I should be able to download it. But again, I got to do hyphen profile to specify Spock because I don't want to use the default profile there. Okay, and it complained because I'm missing the G on the end of that there, okay? And it's still complaining. Maybe I have to do S3 // no, that's the command. Oh, you know why? It's because when you use CP, you have to actually specify the output file here. So you need your source and your destination. Okay, so I'm just going to type data.jpg there. Okay, and that's going to download that file. So I mean, I already knew that I had something for AWS there, so I'm just going to go to AWS to show you that there. So if you want to do the same thing as I did, you definitely need to go set up a bucket in S3. Okay. So if I just go over here, we have the Exam Pro 00, Enterprise D, and we have some images there, okay? So that's where I'm grabbing that image from. And I could just move this file into my environment directory so I actually can have access to it there. Okay, so I'm just going to do MB data, and I'm just going to move that one directory up here, okay? All right, and so now we have data over here, okay? And so, you know, that's how you'd go about using the CLI with credentials, okay? Yeah, and we just opened that file there if we wanted to preview it, okay? So now let's move on to the SDK and let's use our credentials to do something pragmatically, okay? So now that we know how to use the CLI and where to store our credentials, let's go actually do something pragmatically with the SDK. And so I had recently contributed to the AWS docs for Rekognition, so I figured we could pull some of that code and have some fun there, okay? So what I want you to do is go to Google and type in AWS docs Rekognition, and we're going to click through here to Amazon Rekognition. We're going to go to the developer's guide with HTML. Apparently they have a new look. Let's give it a go. Okay, there's always something new here. I'm not sure if I like it, but this is the new look to the docs. And we're going to need to find that code there. So I think it is under detecting faces here, and probably under detecting faces in an image. Okay, and so the code that I added was actually the Ruby and the Node.js one. Okay, so we can choose which one we want. I'm going to do the Ruby one because I think that's more fun. And that's my language of choice, okay? And so I'm just going to go ahead and copy this code here, okay? And we're going to go back to our Cloud9 environment. I'm going to create a new file here, and I'm just going to call this detect faces. Ooh, we'll keep underscore there, faces.rb, okay? And I'm just going to double click in here and paste that code in, all right? And what we're going to have to do is we're going to need to supply our credentials here. Generally, you do want to pass them in as environment variables. That's a very safe way to provide them. So we can give that a go. But in order to get this working, we're going to have to create a gem file in here. So I'm just going to create a new file here because we need some dependencies here. And we're just going to type in gem file, okay? And within this gem file, we're going to have to provide the gem Rekognition, okay? So I'm just going to go over here and supply that there. There is a few other lines here that we need to supply, so I'm just going to go off screen and go grab them for you. Okay, so I just went off screen here and grabbed that extra code here. This is pretty boilerplate stuff that you have to include in a gem file, okay? And so what this is going to do, it's going to install the AWS SDK for Ruby, but specifically just for Rekognition. So I do also have open up here the AWS SDK for Ruby and for Node.js, Python, etc. They all have one here. And so it tells you how you can install gems. So if we're dealing with Rekognition here, I'm just going to do a quick search here for Rekognition. Okay, sometimes it's just better to navigate on the left-hand side here. All right, and so I'm just looking for a Rekognition. Okay, and so if we want to learn how to use this thing, usually a lot of times with this, it's going to tell you what gem you're going to need to install. So this is the one we are installing. And then we click through here through client, and then we can get an idea of all the kind of operations we can perform, okay? So when I needed to figure out how to write this, I actually went to the CLI here, and I just kind of read through it and pieced it together and looked at the output to figure that out. Okay, so nothing too complicated there. But anyway, we have all the stuff we need here. So we need to make sure we're in our environment directory here, which is that Spock dev directory. So we're going to type tilde, which goes to our home directory, environment, okay? We're going to do an ls-la and just make sure that we can see that file there in the gem file, okay? And then we can go ahead and do a bundle install. All right, and so what that's going to do is it's going to now install that dependency. So here we can see that installed the AWS SDK core and also Rekognition, okay? And so now we have all our dependencies to run the script here. So the only thing that we need to do here is we need to provide it an input. So here we can provide it a specific bucket and a file. There is a way to provide it locally. We did download this file, but I figured what we'll do is we'll actually provide the bucket here. So we will say, what's the bucket called? Exam Pro 000. And the next thing we need to do is define the key. So it's probably the key here. So I'm going to do enterprise D. Okay, and then we're just going to supply data there. All right, and we can pass these credentials via the environment variables. We could just hard code them and paste them in here, but that's a bit sloppy. So we are going to go through the full motions of providing them through the environment here. And all we have to do that is we're just going to paste in like so, okay? And we're just going to copy that. So that's the first one. And then we're going to do the password here. Oops. Okay. And hopefully this is going to work the first time. And then we'll have to do bundle exec, detect faces. Okay, and then this is how these are going to get passed into there. And assuming that my key and bucket are correct, then hopefully we will get some output back, okay? All right, it's just saying it could not detect faces here. I just have to hit up here. I think I just need to put the word Ruby in front of here. Okay, so my bad. All right, and is it working? So we don't have the correct permissions here. So we are a power user, so maybe we just don't have enough permissions. So I'm just gonna go off screen here and see what permissions we need to be able to do this. So just playing around a little bit here and also reading the documentation for the Ruby SDK, I figured out what the problem was, and it's just that we don't need this / here. So we just take that out there, okay, and just run what we ran last there, okay, and then we're going to get some output back, and then it just shows us that it detected a face. So we have the coordinates of a face, and if we used some additional tool there, we could actually draw over top of the image a bounding box to show where the face is detected. But there's some interesting information. So it detected that the person in the image was male and that they were happy. Okay, so you know, if you think that that is happy, then that's what Rekognition thinks. Okay, and it also detected the face between ages 32 and 48. To be fair, Data is an android, so he has a very unusual skin color. So you know, it's very hard to determine that age. But I would say that this is the acceptable age range of the actor at the time of. So it totally makes sense. Okay. So yeah, and there you go. So that is the pragmatic way of doing it. Now, you don't ever really want to ever store your credentials with on your server, okay? Because you can always use IAM roles and attach them to EC2 instances, and then that will safely provide credentials onto your EC2 instances to have those privileges. But it's important to know how to use the SDK. And whenever you're in development, working on your local machine, or maybe you're in Cloud9 environment, you are going to have to supply those credentials, okay? So there you go. So now that we are done with our AWS CLI and SDK follow along here, So we're on to the AWS CLI and SDK cheat sheet, so let's jump into it. So CLI stands for Command Line Interface, SDK stands for Software Development Kit. The CLI lets you interact with AWS from anywhere by simply using a command line. The SDK is a set of API libraries that let you integrate AWS services into your applications. Pragmatic access must be enabled per user via the IAM console to use CLI or SDK. AWS config command is used to set up your AWS credentials for the CLI. The CLI is installed via a Python script. Credentials get stored in a plain text file whenever possible. Use roles instead of AWS credentials. I do have to put that in there. And the SDK is available for the following programming languages: C++, Go, Java, JavaScript, .NET, Node.js, PHP, Python, and Ruby. Okay, so for the Solution Architect Associate, they're probably not going to ask you questions about the SDK, but for the developer, there definitely are. So just keep that in mind. Hey, this is Andrew Brown from Exam Pro, and we are looking at Key Management Service, which is used for creating and managing encryption keys for a variety of AWS services or within your applications. And the way I like to think of it is that whenever you see a checkbox in AWS to encrypt something, it's very likely using KMS. So KMS makes it easy for you to create, control, and rotate encryption keys used to encrypt your data on AWS. And KMS is a multi-tenant hardware security module, which we're going to talk about in the next slide here. And the main takeaway I want you to remember about KMS is that whenever you are using an AWS service and you have the option to checkbox on encryption, so here we have an example of EBS. You're going to checkbox on and then choose a master key, and that's all you have to do. It's going to vary per service, but that's pretty much the routine. And KMS can be used alongside with CloudTrail to audit access history. So if you have to investigate who used what key, that's how you're going to do it. And AWS integrates with a lot of different AWS services. So here I've highlighted the ones which are most important to remember for the associate exams. So you got EC2, SQS, S3, DynamoDB, Elasticache, RDS, and more, okay? So KMS is a multi-tenant HSM, but what does that mean? So HSM, which stands for Hardware Security Module, is a hardware that is specialized for storing your encryption keys. It's designed to be tamper-proof, and it stores those keys in memory, so they're never written to disk. So imagine the power went out, those keys are gone, and that is actually a security feature. And so here is an example of a piece of HSM. And these are really, really, really expensive. And so this is where KMS comes into play, because it is multi-tenant, meaning that there are multiple customers who are utilizing this same piece of hardware. So you're sharing the costs with a bunch of different AWS customers. And those customers are isolated virtually from each other. So there is software that protects you from other people's data. But if you had one customer who utilized the entire piece of hardware, which we would call dedicated, that would be also considered a single tenant, because there's only one person using that server. And AWS actually has a single tenant HSM, and that is called Cloud HSM. And this is going to give you a lot more control. And the reason why people would use Cloud HSM over KMS is that Cloud HSM is FIPS 140 to level 3, whereas KMS is only FIPS 140 to level 2. But the takeaway from that is just understand that Cloud HSM is more for enterprises that need to meet those regulations, but KMS is a really great service to utilize. So to really understand KMS, we need to understand what a customer master key is, because this is the primary resource that KMS is managing. And to start there, let's talk about what encryption is. So encryption is the process of encoding a message or information in such a way that only authorized parties can access it, and those who are not authorized cannot. Okay, pretty basic. And so that leads us to what are cryptographic keys or data keys. So a data key is just a string of data that is used to lock or unlock cryptographic functions. So a cryptographic function could be authentication, authorization, or encryption. And so that leads us on to what is a master key. So a master key is stored in a secured hardware, so an HSM, and master keys are used to encrypt all other keys on the system. And those other keys are being data keys. And so why would we want to use a key to encrypt another key, which is called envelope encryption? Well, the reason why, and here's a diagram of envelope encryption, is how do you know that the keys, the data keys that you use that unlock the data to your database are secure? And that's where these master keys come into play. So the idea is that they create security around those keys. So to learn a little bit more about customer master keys, a customer master key is the primary resource that AWS KMS is managing. And a customer master key, abbreviated as CMK, is a logical representation of a master key. So you're not directly accessing the master key. It's a logical representation. But with that logical representation, we get to attach a lot of metadata that's going to help us understand things about our master key. So the key ID, when it was created, the creation date, we can give it a description and say what state the key is in. And that CMK is going to also contain key material used to encrypt and decrypt data. And so KMS supports both symmetric and asymmetric CMKs. So if you've never heard of symmetric and asymmetric, I'll give you a couple examples. So a symmetric key is generally a 256-bit key that is used for encryption and decryption. So you have a single key that you're using, and an example of this on AWS would be when you encrypt an S3 bucket, it uses something called AES 256. 256 suggests that it's using 256-bit encryption. AES is the protocol for encryption. And so that is that method. And the other method is asymmetric key. And so this would be where you have an RSA key pair that is used for encryption and decryption or signing and verification, but not both. And the idea here is that you have two keys. So a great example of this is with EC2 key pairs. You have a public key and a private key. Now KMS isn't using, when you're downloading EC2 key pairs, I don't think that they're using KMS, or at least if they are, it's probably managed by AWS and it's transparent to you. But the idea of having these two methods of keys is based on the use case. But from a security perspective, if you have to have two keys, one key to match to another, that is technically more secure. Whereas if you have one key, if that one key is lost, then it is less secure. Okay, so that's customer master keys. Okay, let's do a quick review of some CLI commands we can use with KMS. And these are actually very common. And if you're studying for the Developer Associate, you should absolutely commit these to memory, especially for your day-to-day kind of stuff. But on the exam, you might see these appear. And so it's just good to know them so you can eliminate them from options that just do not exist. So the first one here is the create key command. And as the name implies, it creates a customer managed key. Very straightforward. Then you have your encrypt. So this is going to encrypt plain text into ciphertext. Then you have decrypt. So that's going to decrypt ciphertext that was encrypted by KMS. And then you have re-encrypt. And so re-encrypt can be used in 3 scenarios: for manual rotations of CMKs, when you're changing the CMK that protects the ciphertext, or you're changing the encryption context of a ciphertext. So re-encrypt. And the last one is enable key rotation. And the idea is that, once a year, if you want to rotate out those keys, you can turn this on and it will just happen automatically. The only thing that you have to note is that this only works for symmetric customer master keys. And you cannot perform this operation outside of CMK in a different AWS account. So it's within the existing account. So yeah, there you go. So we are at the end of the KMS section, so on to the KMS cheat sheet. Key Management Service, KMS, creates and manages encryption keys for a variety of AWS services or for your apps. KMS can be used with CloudTrail to audit a key's access history. KMS has the ability to automatically rotate out your keys every year with no need to re-encrypt. Customer master keys are the primary resources in KMS. KMS is a multi-tenant HSM. Multi-tenant means you are sharing the hardware with multiple customers. Hardware Security Modules, HSM, is a specialized hardware for storing your keys and is tamper-proof. KMS is up to FIPS 142 level 2 compliant. If you're looking at, what's the other one called? Cloud HSM, that's level 3 if you need level 3. KMS stores master keys, not data keys. Master keys are used to encrypt data keys, which is called envelope encryption. KMS supports 2 types of keys, symmetric and asymmetric. So symmetric is a single key using 256-bit encryption. So I always like to say, think of S3 buckets, AES 256. Asymmetric uses 2 keys. I always thinking about like key pair, public and private. Important KMS APIs to remember, because you might see them as exam questions. KMS create key, KMS encrypt, decrypt, re-encrypt. Enable key rotation. So there we go. That is the end of KMS cheat sheet. If this was the AWS security certification, this is like a 7-page cheat sheet. So this is very light, but you definitely need to know KMS. It's very important as a developer or in sysops. Hey, this is Andrew Brown from ExamPro, and we are looking at Amazon Cognito, which is a decentralized way of managing authentication. So think sign up, sign in integration for your apps, social identity providers, like connecting with Facebook or Google. So Amazon Cognito actually does multiple different things, and we are going to look at 3 things in specific. We're going to look at Cognito user pools, which is a user directory to authenticate against identity providers. We're going to look at Cognito identity pools, which provides temporary credentials for your users to access AWS services. And we're going to look at Cognito Sync, which syncs users' data and preferences across all devices. So let's get to it. So to fully understand Amazon Cognito, we have to understand the concepts of Web Identity Federation and identity providers. So let's go through these definitions. So for Web Identity Federation, it's to exchange the identity and security information between an identity provider and an application. So now looking at identity provider, it's a trusted provider for your user identity that lets you authenticate to access other services. So an identity provider could be Facebook, Amazon, Google, Twitter, GitHub, LinkedIn. You commonly see this on websites where it allows you to log in with a Twitter or GitHub account. That is an identity provider. So that would be Twitter or GitHub. And they're generally powered by different protocols. So whenever you're doing this with social accounts, it's going to be with OAuth. And so that could be powered by OpenID Connect. That's pretty much the standard now. If there are other identity providers, so if you needed a single sign-on solution, SAML is the most common one. All right. So the first thing we're looking at is Cognito user pools, which is the most common use case for Cognito. And that is just a directory of your users, which is decentralized here. And it's going to handle actions such as sign up, sign in, account recovery. So that would be like resetting a password, account confirmation. That would be like confirming your email after sign up. And it has the ability to connect to identity providers. So it does have its own like email and password form that it can take, but it can also leverage maybe if you want to have Facebook Connect or Amazon Connect and etc., you can do that as well. The way it persists a connection after it's authenticated is it generates a JWT. So that's how you're going to persist that connection. So let's look at more of the options so that we can really bake in the utility here of user pools. So here on the left-hand side, we have a bunch of different settings, and for attributes, we can determine what should be our primary attribute. Should it be our username when they sign up, or should it be email and phone number? And if it is, can they sign up or sign in if the email address hasn't been verified? What are the conditions around that? We can set the restrictions on the password, the length, if it requires special characters. We can see what kind of attributes are required to collect on sign up, if we need their birthday or email or etc. It has the capabilities of turning on MFA. So if you want multi-factor authentication, very easy way to integrate that. If you want to have user campaigns, so if you're used to like sending out campaigns via MailChimp, you can easily integrate Cognito with Pinpoint, which is user campaigns, right? And you also can override a lot of the functionality using Lambda. So anytime like a sign up or sign in or recovery password's triggered, there is a hook so that you can then trigger Lambda to do something with that. So that's just some of the things that you do with Cognito user pools. But the most important thing to remember is just it's a way of decentralizing your authentication. That's for user pools, all right? So now it's time to look at Cognito identity pools. And identity pools provide temporary AWS credentials to access services such as DynamoDB or S3. Identity pools can be thought of as the actual mechanism authorizing access to the AWS resources. So, the idea is you have an identity pool. You're going to say who's allowed to generate those AWS credentials, and then use the SDK to generate those credentials, and then that application can then access those AWS services. So just to really hit that home here, I do have screenshots to give you an idea what that is. So first we're going to choose a provider. So our provider can be authenticated, so we can choose Cognito or even a variety of other ones. Or you can have it unauthenticated. So that is also an option for you. And then after you create that identity pool, they have an easy way for you to use the SDK. So you can just drop down your platform and you have the code and you're ready to go get those credentials. And if you're thinking, did I actually put in my real example or identity pool ID there? It's not. I actually go in and replace all these. So if you're ever wondering and watching these videos and you're seeing these things, I always replace them. We're going to just touch on one more, which is Cognito Sync. And so Sync lets you sync user data and preferences across all devices with one line of code. Cognito uses push notifications to push those updates and synchronize data. And under the hood, it's using simple notification service to push this data to devices. And the data, which is user data and preferences, is key value data, and it's actually stored with the identity pool. So that's what you're pushing back and forth. But the only thing you need to know is what it does. And what it does is it syncs user data and preferences across all devices with one line of code. Hey, this is Andrew Brown from Exam Pro, and we're going to do the Cognito follow along and set up a login screen. So I'm going to go to Cognito. There we go. And we're going to be presented with two options: user pools, identity pools. Identity pools is not what we want. We want user pools so that people can log in and authenticate. Identity pools is when you want to give access to existing resources on AWS. So we'll go to user pools here. I'm going to create a new user pool. I'm going to call it Study Sync, since that's kind of the project we've been working with in this Developer Associate. I'm going to go to Review Defaults. All these defaults are fine. You can see you can set MFA. And all the stuff. You can change any of this if you want. I'm going to create this pool, and now the pool has been created. I'm going to need a app client. I'm going to hit Add App Client. We're going to name this Study Sync. We're going to leave all of this defaulted here. I'm going to go ahead and create this app client. Now the next thing I can do is configure this app client. So we'll go to app client settings. We're going to enable user pools. I'm going to put an example URL here for our callback. This is what would happen after somebody logged in successfully, and this is where they would go if they logged out. We want authorized code grants and implicit grants. Might as well take all of the scopes if possible, because why not? And we will go ahead and save these here. In order to use the host UI, this is like a UI that AWS gives you by default. Of course, you could make your own, which is a lot of work, but to use this host UI, which is what we'll be doing here, we need to set a domain name. I'm going to call it Steady Sync. We'll check for availability. It's available. You might have to change it based on your case. We'll hit save. And then to view our hosted domain or our hosted login screen, we're going to go back to app client settings, go to the bottom here, hit launch UI here. I'm just going to do a hard refresh here because it's giving us some trouble. So let me just go back to the domain here. Yeah, it should be here. It looks like we can also customize it, which is kind of nice. But this should work now. So let me just see here. Maybe just needed some time. There you go. So I was just way too fast. And then we'll go ahead and we'll just sign up. And the goal here is that if we sign up successfully, we should be able to be directed to the that URL that we provided. So I'm going to need a temporary email. I'm going to use 10-minute mail. Minute mail here. We'll go here. And well, it just changed the whole UI. I guess they have a new one. Oh, it's beta. Look at that. I'm an early user. If you never use this platform, it's for getting temporary emails very quickly. And we'll go back here. I will paste this in here. And then I'll make the password testing. 1, 2, 3, exclamation mark, sign up. And now we have a verification code. If I go back here, oh, there it is. There's our code. We'll copy it, confirms it. And it redirected us. So that means that we successfully logged in. If we go over to our users, we should be able to see this user now. If I refresh, are they there? There I am. There's Andrew Brown. So, you know, that's all there is to setting it up. Clearly, there's a lot more work involved, but for the developer associate, that's all you need to be comfortable with. I just want to make sure that you got some hands-on with Cognito. Generally, if you use AWS Amplify, it does a lot of the work for you for setting it up and integrating with your application. Integrating Cognito for your web apps without Amplify is extremely painful, but it's worth it because it's so inexpensive. The only thing that is unfortunate about Cognito user pools is there's a limitation in terms of identity providers. So we have Facebook, Google, Amazon, but we don't have LinkedIn. And apparently you can do Twitter, I think with OpenID Connect. But for me, like, LinkedIn's a deal breaker. And it's not AWS's fault. AWS follows like some kind of security standard. And for whatever reason, LinkedIn does not conform to that. And so that's why it's not on the list here. There is a way to get LinkedIn to work, but it's a lot of effort. And so that's why we see a lot of people using Auth0 because it just does everything, but that one's really expensive. There's a lot of things you can do in here. You know, there's a lot of options, and I recommend that you poke around, but we're done for this case, and I want you to go ahead and delete this pool. Delete this pool, we have to first delete the domain name because we are borrowing that from AWS. And once that's deleted, we can go to General Settings, hit Delete, type in Delete, and there we go, our pool is gone. So that's it. See you later. So we're on to the Amazon Cognito cheat sheet, so let's jump into it. So Cognito is a decentralized managed authentication system. So when you need to easily add authentication to your mobile or desktop apps, think Cognito. So let's talk about user pool. So user pool is the user directory. It allows users to authenticate using OAuth to IPDs such as Facebook, Google, Amazon to connect to your web applications. And Cognito user pool isn't in itself an IPD, all right? So it can be on that list as well. User pools use JWTs to persist authentication. Identity pools provide temporary AWS credentials to access services such as S3 or DynamoDB. Cognito Sync can sync user data and preferences across devices with one line of code powered by SNS. Web Identity Federation, they're not going to ask you these questions, but you need to know what these are. Exchange identity and security information between an identity provider and an application. Identity provider is a trusted provider for your user to authenticate, or sorry, to identify that user So you can use them to authenticate to access other services. Then you have OIDC is a type of identity provider which uses OAuth, and you have SAML, which is a type of identity provider which is used for single sign-on. So there you go. We're done with Cognito. Hey, this is Andrew Brown from ExamPro, and we are looking at Simple Notification Service, also known as SNS, which lets you subscribe and send notifications via text message, email, webhooks, Lambdas, SQS, and mobile notification. All right, so to fully understand SNS, we need to understand the concept of pub/sub. And so pub/sub is a publish-subscribe pattern commonly implemented in messaging systems. So in a pub/sub system, the sender of messages, also known as the publisher here, doesn't send the message directly to the receiver. Instead, they're going to send the messages to an event bus. And the event bus categorizes the messages into groups, and then the receiver of messages, known as the subscriber here, subscribes to these groups. And so whenever a new message appears within their subscription, the messages are immediately delivered to them. So it's not unlike registering for a magazine, all right? So, down below we have that kind of representation. So we have those publishers, and they're publishing to the event bus, which have groups in them, and then that's going to send it off to those subscribers, okay? So it's pushing it all along the way here, okay? So publishers have no knowledge of who their subscribers are. Subscribers do not pull for messages. They're going to get pushed to them. Messages are instead automatically immediately pushed to subscribers, and messages and events are interchangeable terms in pub/sub. So if you see me saying messages and events, it's the same darn thing. So we're now looking at SNS here. So SNS is a highly available, durable, secure, fully managed pub/sub messaging service that enables you to decouple microservices, distributed systems, and serverless applications. So whenever we're talking about decoupling, we're talking about application integration, which is like a family of AWS services that connect one service to another. Another service is also SQS, and SNS is also application integration. So down below, we can see our pub/sub systems. So we have our publishers on the left side and our subscribers on the right side, and our event bus is SNS, okay? So for the publisher, we have a few options here. It's basically anything that can pragmatically use the AWS API. So the SDK and CLI uses the AWS API underneath. And so that's going to be the way publishers are going to publish their messages or events onto an SNS topic. There's also other services on AWS that can trigger or publish to SNS topics. CloudWatch definitely can, because you'd be using those for billing alarms. And then on the right-hand side, you have your subscribers, and we have a bunch of different outputs, which we're going to go through. But here you can see we have Lambda, SQS, email, and HTTPS protocol. So publishers push events to an SNS topic, so that's how they get into the topic. And then subscribers subscribe to the SNS topic to have events pushed to them, okay? And then down below, you can see I have a very boring description of SNS topic, which is it's a logical access point and communication channel. So that makes that makes sense. So let's move on. We're going to take a deeper look here at SNS topics, and topics allow you to group multiple subscriptions together. A topic is able to deliver to multiple protocols at once, so it could be sending out email, text message, HTTPS, all the sorts of protocols we saw earlier. And publishers don't care about the subscriber's protocol, okay? Because it's sending a message event, it's giving the topic and saying, you figure it out, this is the message I want to send out, and it knows what subscribers it has. And so the topic, when it delivers that message, it will automatically format it for the message according to the subscriber's chosen protocol, okay? And the last thing I want you to know is that you can encrypt your topics via KMS, Key Management Service. And, so it's just as easy as turning it on and picking your key. So now we're taking a look at subscriptions. And so subscriptions are something you create on a topic, okay? And so here I have a subscription that is an email subscription, and the endpoint is obviously going to be an email. So I provided my email there. If you want to say hello, send me an email. And it's just as simple as creating that button and filling in those options. Now you have to choose your protocol. And here we have our full list here on the right-hand side. So we'll just go through it. So we have HTTP and HTTPS, and you're going to want to be using these for webhooks. So the idea is that this is usually going to be an API endpoint to your web applications that's going to listen for incoming messages from SNS. Then you can send out emails. Now, there's another service called SES, which specializes in sending out emails. And so SNS is really good for internal email notifications because you don't necessarily have your custom domain name. And also the emails have to be plain text only. And there's some other limitations around that. So they're really, really good for internal notifications, maybe like billing alarms, or maybe someone signed up on your platform, you want to know about it. Then they also have it in email JSON. So let's just going to send you JSON via email. Then you have SQS. So you can send an SNS message to SQS. So that's an option you have there. You can also have SNS trigger Lambda functions. So that's a very useful feature as well. And you can also send text messages that will be using the SMS protocol. And the last one here is platform application endpoints, and that's for mobile push. So like a bunch of different devices, laptops and phones have notification systems in them. And so this will integrate with that. And we're just going to actually talk about that a bit more here in the next slide. So I wanted to talk a bit more about this platform application endpoint, and this is for doing mobile push, okay? So we have a bunch of different mobile devices and even laptops that use notification systems in them. And so here you can see a big list. We have ADM, which is Amazon Device Messaging. We have Apple, Badoo, Firebase, which is Google. And then we have two for Microsoft. So we have Microsoft Push and Windows Push, okay? And so you can, with this protocol, push out to that stuff. And the advantage here, you're gonna, when you push notification messages to these mobile endpoints, it can appear in the mobile app, just like message alerts, badges updates, or even sound alerts. So that's pretty cool. Okay, so I just wanted you to be aware of that. All right, so on to the SNS cheat sheet. So Simple Notification Service, also known as SNS, is a fully managed pub/sub messaging service. SNS is for application integration. It allows decoupled services and apps to communicate with each other. We have a topic, which is a logical access point and communication channel. A topic is able to deliver to multiple protocols. You can encrypt topics via KMS. And then you have your publishers, and they use the ABIS API via the CLI or the SDK to push messages to a topic. Many ABIS services integrate with SNS and act as publishers, okay? So think CloudWatch and other things. Then you have subscriptions, so you can subscribe to topics. When a topic receives a message, it automatically immediately pushes messages to subscribers. All messages published to SNS are stored redundantly across multi-AZ, which isn't something we talked in the core content, but it's good to know. And then we have the following protocols we can use. So we have HTTP and HTTPS. This is great for webhooks into your web application. We have emails, good for internal email notification. Remember, it's only plain text. If you need rich text and custom domains, you're going to be using SES for that. Then you have email JSON, very similar to email, just sending JSON along the way. You can also send your SNS messages into an SQS. You can trigger lambdas. You can send text messages. And then the last one is you have platform application endpoints, which is mobile push, okay? And that's going to be for systems like Apple, Google, Microsoft, Badoo, all right? Hey, this is Andrew Brown from Exam Pro, and we are looking at Simple Queue Service, also known as SQS, which is a fully managed queuing service that enables you to decouple and scale microservices, distributed systems, and serverless applications. So to fully understand SQS, we need to understand what a queuing system is. And so a queuing system is just a type of messaging system which provides asynchronous communication and decouples processes via messages, could also be known as events, from a sender and receiver, but in the case for a streaming system, also known as a producer and consumer. So looking at a queuing system, when you have messages coming in, they're usually being deleted on the way out. So as soon as they're consumed, they're deleted. It's for simple communication. It's not really for real time. And just to interact with the queue and the messages there, both the sender and receiver have to pull to see what to do. So it's not reactive, okay? We got some examples of queuing systems below. We have Sidekick, SQS, RabbitMQ, which is debatable because it could be considered a streaming service. And so now let's look at the streaming side to see how it compares against a queuing system. So a streaming system can react to events from multiple consumers. So like if you have multiple people that want to do something with that event, they can all do something with it because it doesn't get immediately deleted. It lives in the event stream for a long period of time. And the advantage of having a message hang around in that event stream allows you to apply complex operations. So that's the huge difference, is that one is reactive and one is not. One allows you to do multiple things with the messages and retains it in the queue. One deletes it and doesn't really think too hard about what it's doing. Okay, so there's your comparative between queuing and streaming, and we're going to continue on with SQS here, which is a queuing system. So the number one thing I want you to think of when you're thinking of SQS is application integration. It's for connecting isolate applications together, acting as a bridge of communication, and SQS happens to use messagings and queues for that. You can see SQS appears in the AWS console under application integration. So these are all services that do application integration, and SQS is one of them. And as we said, it uses a queue. So a queue is a temporary repository for messages that are waiting to be processed, right? So just think of going to the bank and everyone is waiting in that line. That is the queue. And the way you interact with that queue is through the AWS SDK. So you have to write code that was going to publish messages to the queue. And then when you want to read them, you're going to have to use the AWS SDK to pull messages. And so SQS is pull-based. You have to pull things. It's not push-based, okay? So to make this crystal clear, I have an SQS use case here. And so we have a mobile app and we have a web app, and they want to talk to each other. And so using the AWS SDK, the mobile app sends a message to the queue. And now the web app, what it has to do is it has to use the AWS SDK and pull the queue whenever it wants. So it's up to this app to code in how frequently it will check, but it's going to see if there's anything in the queue. And if there is a message, it's going to pull it down, do something with it, and report back to the queue that it's consumed it, meaning to tell the queue to go ahead and delete that message from the queue, all right? Now this app, or the mobile app on the left-hand side, to know whether it's been consumed, it's going to have to, on its own schedule, periodically check to pull to see if that message is still in the queue. And if it no longer is, that's how it knows. So that is the process of using SQS between two applications. So let's look at some SQS limits, starting with message size. So the message size can be between 1 byte to 256 kilobytes. If you wanted to go beyond that message size, you can use the Amazon SQS Extended Client Library only for Java, it's not for anything else, to extend that message size up to 2 gigabytes in size. And so the way that would work is that the message would be stored in S3 and the library would reference that S3 object, right? So you're not actually pushing 2 gigabytes to SQS, it's just loosely linking to something in an S3 bucket. Message retention. So message retention is how long SQS will hold on to a message before dropping it from the queue. So the message retention by default is 4 days, and you have a message retention that can be adjusted from a minimum of 60 seconds to a maximum of 14 days. SQS is a queuing system, so let's talk about the two different types of queues. We have standard queue, which allows for a nearly unlimited number of transactions per second. When we hear transactions, just think messages, and it guarantees that a message will be delivered at least once. However, the trade-off here is that more than one copy of a message could be potentially delivered, and that would cause things to happen out of order. So if ordering really matters to you, just consider there's that caveat here with standard queues. However, you do get nearly unlimited transactions, so that's the trade-off. It does try to provide its best effort to ensure messages stay generally in the order that they were delivered, but again, there's no guarantee. Now, if you need a guarantee of the ordering of messages, that's where we're going to use FIFO, also known as first in, first out. Well, that's what it stands for, right? And the idea here is that, a message comes into the queue and it leaves the queue. The trade-off here is the number of transactions you can do per second. So we don't have nearly unlimited per second. We have a cap up to 300. So there you go. So how do we prevent another app from reading a message while another one is busy with that message? And the idea behind this is we want to avoid someone doing the same amount of work when it's already being done by somebody else. And that's where visibility timeout comes into play. So visibility timeout is the period of time that that messages are invisible to the SQS queue. So when a reader picks up that message, we set a visibility timeout, which could be between 0 to 12 hours. By default, it's 30 seconds. And so no one else can touch that message. And so what's going to happen is that whoever picked up that message, they're going to work on it, and they're going to report back to the queue that, we finished working with it, and it's going to get deleted from the queue, okay? But what happens if they don't complete it within the visibility timeout frame? What's going to happen is that message is now going to become visible, and anyone can pick up that job, okay? And so there is one consideration you have to think of, and that's when you build out your web apps that you bake in the time so that if the job is going to be if 30 seconds have expired, then you should probably kill that job, because otherwise you might end up with this issue where you have the same messaging being delivered twice, and that could be an issue. Okay, so just a consideration for visibility time. So in SQS, we have two different ways of doing polling. We have short versus long. Polling is the method in which we retrieve messages from the queue, and by default, SQS uses short polling. And short polling returns messages immediately, even if the message queue being polled is empty. So short polling can be a bit wasteful, because if there's nothing to pull, then you're just making calls for no particular reason. But there could be a use case where you need a message right away, so short polling is the use case you want. But the majority of use cases, you should be using long polling, which is bizarre that it's not by default, but that's what it is. So long polling waits until a message arrives in the queue, or the long poll timeout expires, okay? And long polling makes it inexpensive to retrieve messages from the queue as soon as messages are available. Using long polling will reduce the cost because you can reduce the number of empty receives, right? So if there's nothing to pull, then you're wasting your time, right? If you want to enable long polling, you have to do it within the SDK. And so what you're doing is you're setting the receive message request with a wait time. So by doing that, that's how you set long polling. Let's take a look at our simple queue service cheat sheet that's going to help you pass your exam. So first we have SQS is a queuing service using messages with a queue. So think Sidekick or RabbitMQ, if that helps, if you know the services. SQS is used for application integration. It lets you decouple services and apps so that they can talk to each other, okay? To read SQS, you need to pull the queue using the AWS SDK. SQS is not push-based, okay? It's not reactive. SQS supports both standard and first in, first out, FIFO queues. Standard queues allow for unlimited messages per second, does not guarantee the order of delivery, always delivers at least once, and you must protect against duplicate messages being processed. FIFO, first in, first out, maintains the order of messages with a limit of 300, so that's the trade-off there. There are two kinds of polling, short by default and long. Short polling returns messages immediately, even if the message queue is being pulled is empty. Long polling waits until messages arrive in the queue or the long poll time expires. In the majority of cases, long polling is preferred over short polling. Majority, okay? Visibility timeout is the period of the time that messages are invisible to the SQS queue. Messages will be deleted from the queue after a job has been processed before the visibility timeout expires. If the visibility timeout expires, then a job will become visible to the queue again. The default visibility timeout is 30 seconds. Timeout can be between 0 seconds to a maximum of 12 hours. I highlighted that 0 seconds because that is a trick question sometimes on the exams. People don't realize you can do it for 0 seconds. SQS can retain messages from 60 seconds to 14 days by default. It is 4 days, so 14 days is 2 weeks. That's an easy way to remember it. Message sizes can be between 1 byte to 256 kilobytes, and using the extended client library for Java can be extended to 2 gigabytes. So there you go. We're done with SQS. Hey, this is Andrew Brown from Exam Pro, and we are looking at Amazon Kinesis, which is a scalable and durable real-time data streaming service to ingest and analyze data in real time from multiple sources. So again, Amazon Kinesis is AWS's fully managed solution for collecting, processing, and analyzing streaming data in the cloud. So when you need real-time, think Kinesis. So some examples where Kinesis would be of use: stock prices, game data, social media data, geospatial data, clickstream data. And Kinesis has 4 types of streams. We have Kinesis data streams, Kinesis Firehose delivery streams, Kinesis data analytics, and Kinesis video analytics. And we're going to go through all 4 of them now. So we're going to first take a look at Kinesis data streams. And the way it works is you have producers on the left-hand side, which are going to produce data, which is going to send it to the Kinesis data stream. And that data stream is going to then ingest that data. And it has shards, so it's going to take that data and distribute it amongst its shards. And then it has consumers. And so consumers with data streams, you have to manually configure those yourself using some code. But the idea is you have these EC2 instances that are specialized to then consume that data and then send it to something in particular. So we have a consumer that is specialized to sending data to Redshift, then DynamoDB, then S3, and then EMR, okay? So whatever you want the consumer to send it to, it can send it wherever it wants. But the great thing about data streams is that when data enters into the stream, it persists for quite a while. So it will be there for 24 hours by default. You could extend it up to 168 hours. So if you need to do more with that data and you want to run it through multiple consumers, or you want to do something else with it, you can definitely do that with it. The way you pay for Kinesis data streams, it's like spinning up an EC2 instance, except you're spinning up shards, okay? And that's what's going to be the cost there. So as long as the shard is running, you pay X amount of cost for X amount of shards, and that is Kinesis data stream. So onto Kinesis Firehose delivery stream, similar to data streams, but it's a lot simpler. So the way it works is that it also has producers, and those producers send data into Kinesis Firehose. The difference here is that as soon as data is ingested, so like a consumer consumes that data, it immediately disappears from the queue, okay? So data is not being persisted. The other trade-off here is that you can only choose one consumer. So you have a few options. You can choose S3, Redshift, Elasticsearch, or Splunk. Generally, people are going to be outputting to S3. So there's a lot more simplicity here, but there's also limitations around it. The nice thing, though, is you don't have to write any code to consume data. But that's the trade-off, is you don't have any flexibility on how you want to consume the data. It's very limited. Firehose can do some manipulations to the data that is flowing through it. I can transform the data. So if you have something where you want it from JSON, you want to convert it to Parquet, there are limited options for this. But the idea is that you can put it into the right data format so that if it gets inserted into S3, so maybe Athena would be consuming that it's now in Parquet file, which is optimized for Athena. It can also compress the files, so just simply zip them, right? There's different compression methods, and it can also secure them. So there's that advantage. The big advantage is Firehose is very inexpensive because you only pay for what you consume. So only data that's ingested is what you pay for. You kind of think of it like, I don't know, AWS Lambda or Fargate. So the idea is you're not paying for those running shards, okay? And it's just simpler to use. And so if you don't need data retention, it's a very good choice. Okay, on to Kinesis video streams, and as the name implies, it is for ingesting video data. So you have producers, and that's going to be sending either video or audio encoded data, and that could be from security cameras, web cameras, or maybe even a mobile phone. And that data is going to go into Kinesis video streams, and it's going to secure and retain that encoded data so that you can consume it from services that are used for analyzing video and audio data. So you got SageMaker, Rekognition, or maybe you need to use TensorFlow, or you have a custom video processing, or you have something that has like HL-based video playback. So that's all there is to it. It's just so you can analyze and process video streams, applying like ML or video processing services on it. Now we're going to take a look at Kinesis Data Analytics, and the way it works is that it takes an input stream and then it has an output stream, and these can either be Firehose or data streams. And the idea is you're going to be passing information data analytics. And what this service lets you do is it lets you run custom SQL queries so that you can analyze your data in real time. So if you have to do real-time reporting, this is the service you're going to want to use. The only downside is that you have to use 2 streams, so it can get a little bit expensive. But for data analytics, it's really great. So that's all there is to it. So it's time to look at Kinesis cheat sheet. So Amazon Kinesis is the AWS solution for collecting, processing, and analyzing streaming data in the cloud. When you need real time, think Kinesis. There are 4 types of streams. The first being Kinesis data streams, and that's you're paying per shard that's running. So think of an EC2 instance, you're always paying for the time it's running. So Kinesis data streams is just like that. Data can persist within that stream. Data is ordered and every consumer keeps its own position. Consumers have to be manually added, so they have to be coded to consume, which gives you a lot of custom flexibility. Data persists for 24 hours by default, up to 168 hours. Now, looking at Kinesis Firehose, you only pay for the data that is ingested, okay? So think of like, I don't know, Lambdas or Fargate. The idea is that you're not paying for a server that's running all the time. It's just data that's ingested. Data immediately disappears once it's processed. Consumer, you only have the choice from a predefined set of services. So you either get S3, Redshift, Elasticsearch, or Splunk, and they're not custom, so you're stuck with what you got. Kinesis Data Analytics allows you to perform queries in real time. So it needs Kinesis Data Streams or Firehose as the input and the output. So you do have to have 2 additional streams to use the service, which makes it a little bit expensive. Then you have Kinesis Video Analytics, which is for securely ingesting and storing video and audio encoded data to consumers such as SageMaker, Rekognition, or other services to apply machine learning and video processing. To actually send data to the streams, you have to either use KPL, which is the Kinesis Producer Library, which is like a Java library to write to a stream, or you can write data to a stream using the AWS SDK. KPL is more efficient, but you have to choose what you need to do in your situation. So there is the Kinesis cheat sheet. Hey, this is Andrew Brown from Exam Pro, and we are looking at Systems Manager Parameter Store, which is secure hierarchical storage for configuration data management and secrets management. So with Parameter Store, you can store data such as passwords, database strings, license code, and as parameter values, and store configuration data and secure strings in hierarchies and track versions. If that doesn't make sense, it will as we work through this here. And you can encrypt these parameters using KMS. So you can optionally apply encryption, though that doesn't necessarily mean things are encrypted in Parameter Store. So to really understand Parameter Store, let's go ahead and look at what it takes to create a parameter. So the first thing is the name. And this is the way you group parameters together based on a naming convention. So by using the forward slashes, you're creating hierarchies. And this allows you to fetch parameters at different levels. So if I created a bunch of parameters under the /prod, then when I use the API to do exam pro application /prod, it'll give me all those parameters. So it's an interesting way to organize your parameters into groups. And then you get to choose your tier, and we'll talk about that a little bit more shortly here. And then you choose the type. So you can have a string, and that's just a string. You can have a string that is, or string list, which is a comma separated string. You can encrypt your string using KMS, and then you just provide the value. So talking about those tiers, there are 2 tiers. We have standard and advanced. So generally you're using the standard one, and this is scoped based on region. So if you never exceed 10,000 parameters, this parameter store is going to be free. But once you go over 10,000, you're now using advanced parameters. Or if you need to use a parameter that has a value higher than 4 kilobytes, you're going to have to use advanced parameter. And if you want to apply parameter policies, you're going to have to use an advanced parameter. Now, a parameter can be applied the advanced tier can be applied per parameter. So you can mix and match these 2 here. So that is something that's interesting to know. But one thing you do need to know about these advanced parameters is that You can convert a standard parameter to an advanced parameter at any time, but you can't revert an advanced parameter to a standard parameter. So it's a one-way process. And the reason for that is because if you were to revert an advanced parameter, you would end up losing data because you have an advanced parameter that has 8 kilobytes and it just can't go back to 4 kilobytes. It would end up truncating the data. So that is the reason for that. So let's talk about parameter policies, which is a feature of only advanced parameters. So the idea here is it's going to help force you to update or delete your passwords. It's going to do this by using asynchronous periodic scans. So after you create these policies, you don't have to do anything. Parameter store will take care of the rest, and you can apply multiple policies to a single parameter. So now that we have a bit of that, let's look at what policies we have available to us. So there's only 3 at this moment. So the first one is expiration. So the idea with this policy is you say, I want this parameter to expire after this date and time, and then it will just auto delete. The next one is expiration notice, and this one will tell you X days before, or hours or minutes before an expiration is going to happen. So if for whatever reason you need to take action with that stored data, this is going to give you a heads up. The last one is no change notification. So let's say you're supposed to have a parameter that's supposed to be modified manually by a developer. So they're supposed to update it themselves after X amount of days or minutes or hours. This parameter will tell you, hey, nothing has changed, so maybe you should go ahead and investigate. So that is parameter policies. So to understand how the hierarchy works with parameter store, I want to show you using the CLI. So the first thing we want to do is we want to create some parameters. So using the put parameter command, we can just supply the name, and that's going to be how we define our hierarchy here. I'm going to provide some values. We're going to store them as strings. And so when you run each of these commands, it's actually going to tell you what version it is. So if you keep on doing a put on the same thing, that version count is going to go up. And this allows you to access older versions because everything in parameter store is automatically versioned. So we put 3 parameters here on Vulkan. So how would we actually get all the parameters in one go? And that's where we'd use get parameters by path. So here we can just specify planets/Vulkan, and all the parameters underneath will be returned to us. So here they are. So you can see we have all of them there. So that's all it takes to get your parameters, and that's how you generally use this within your application. So we are using the CLI here, so you'd have to translate this over to the SDK, but this is how you would get parameters in your application. Hey, this is Andy Brown from ExamPro, and we are looking at Secrets Manager, which is used to protect secrets needed to access your applications and services. So easily rotate, manage, and retrieve database credentials, API keys, and other secrets through their life cycle. So for Secrets Manager, you're going to generally want to use it to automatically store and rotate database credentials. They say they do API keys and other things like that, but really this is where Secrets Manager shines. So, the databases available to us is RDS, or Redshift, DocumentDB. Then we have other databases, which we'll look at closely here in a second. And then you have key value, which they say is for APIs. So what you do is you go ahead and select the secret type that you want to do. For RDS, Redshift, and DocumentDB, it's very straightforward. For other database and other types of secrets, it's a little bit different. So let's look at those in greater detail here. So selecting for credentials for other database, you can select a specific type of relational engine, but here you're providing the server address, the database name, and the port. So for the other 3 managed ones, you wouldn't do that. You just provide the username and password and select the resource within your AWS account. And then for the other types of secrets, this is just a key value. If you go over to plain text, that doesn't mean you can encrypt a plain text file. It just is another representation of that key and value, so you can just work with a JSON object. But yeah, those are all the types there. Just a few other things to highlight about Secrets Manager, and that is when you go ahead and create any credential, encryption is enforced. So with Parameter Store, it doesn't necessarily have to be encrypted, but with Secrets Manager, it has to be encrypted at rest. And you can just use the default encryption key or use a different CMK if you want to go make one. The pricing is pretty simple, so it's 0.40 cents USD per secret per month. So some people don't like Secrets Manager because it costs that, and you can pretty much use Parameter Store for free. But you have to decide what makes sense for you, and it's half a cent per 10,000 API calls there. And then one thing to note is that if you want to monitor the credentials access in case you need to audit them or just investigate, if you have a CloudTrail created, then it will monitor these secrets for you so you can investigate in the future. Probably a good idea to turn on CloudTrail if you have. So the huge value with Secrets Manager is automatic rotation. So you can set up automatic rotation for any database credentials. So any of the managed services and even the other databases there. There's no automatic rotation for the key value secret type. So it's just the database stuff. So once you go through the wizard for any of those steps, you're going to come to this automatic rotation. So you're going to go ahead and enable it. You're going to choose your rotation interval, which can be up to 365 days, so up to 1 year. So just to show you here, if you expand it, you have 30, 60, 90, and you have custom. If you go to custom, you can set it up to 1 year. And the way Secrets Manager works is that it just creates a Lambda function for you. And so some would argue that if you wanted to use parameter store and just make your own Lambda, you wouldn't need to use Secrets Manager, and that is 100% true. But you have to know how to do that. So decide whether you want to put an extra effort so you don't have to pay for Secrets Manager. But yeah, it will go ahead and do that. And there's one option down below here, and this allows you to select what password you're going to rotate out, because you might not want to rotate out this password. You might want to rotate out a developer's password that's connected to the database. So that's another option for you there. So for the developer associate, it's good to know the CLI command. So let's just look at a couple for Secrets Manager. The first one being AWS Secrets Manager describes secret. And this is going to describe information about a particular secret. The reason you'd want to do this is so that you could find out what version IDs are theirs, because you might want to specify a specific version of a secret. And then you get some access information, such as the last time it was changed or accessed. So that might be one precursor step before you actually try to go get the secret. So the other CLI command we need to know is get secret value, and this actually gets the secret. So you can see you supply the secret ID and then the version stage. And if you don't provide version stage, it would just default to AWS current, which is the current version. But if you use the prior step there, you could use a different version stage there. And so using the CLI command, you can see that we have this secret string, and that is what's storing our credential information. So in this case, it's just a key value credential or secret, and so that's what we're looking at here. So to really help make sense of Secrets Manager, because it's not always clear, how do you access the secrets versus how does the database access it versus how does the app access it. I made an architectural diagram here for you. So, the first thing is that you'd use Secrets Manager, and we'd set up rotation with it. So every 90 days, it's going to rotate out that password that is stored in RDS. So the password is actually in RDS, and then Secrets Manager can store a version of it as well. But what it's doing is the Lambda probably set up with a CloudWatch event, and every 90 days, it's going to say, okay, run this Lambda, swap out that password. So that's how the password gets swapped in RDS, but how does the application access it? Well, you'd have your web app running on EC2, and you'd use the SDK, which is the icon there in the actual EC2 instance here, and you would make an SDK call to Secrets Manager and get the database credentials, and then you would use your web server with that new password and username and form a connection URL, which is just it looks like an HTML URL, but it's used to connect to Postgres databases. Not all relational database types have a connection URL, so you might just have to provide the username and password. But the point is, you are making a connection to RDS. Now, from the developer side, the way they would probably use it, because they're in development, they just want to gain access to the database that's in the cloud. They're going to use the CLI to obtain the database credentials, and we just went through the CLI command, so you have an idea what they would run. And then the way they connect to the database would be using a database manager. So you could use Tables Plus. If you didn't have a database manager, you could just go ahead and use Terminal and connect that way there. So hopefully that makes it very clear in terms of how you can use Secrets Manager for all these use cases. Hey, this is Andrew Brown from Exam Pro, and we are looking at DynamoDB, which is a key value and document NoSQL database which can guarantee consistent reads and writes at any scale. So to really understand DynamoDB, we need to understand what is NoSQL. And I can tell you what it's not. It is neither a relational database and does not use SQL to query the data for results. And the key thing that's different is how the data is stored. So it can be either key value or document. So looking first here at key value store, this is a form of data storage which has a key which references a value and nothing more. Okay, so that is one data structure you can have in DynamoDB. The other one is document storage. So this is a form of data storage which has a nested data structure there. So that is what they call the document. So hopefully that makes a bit of sense. So DynamoDB is a NoSQL key value and document database for internet scale applications, and it has a lot of great features. It's fully managed, multi-region, multi-master, durable database, built-in security, backup and restore, and in-memory caching. So you can see why this is AWS's flagship database that they're always promoting, because it has so much functionality at scale. It can provide eventual consistent reads and strongly consistent reads, which we will talk about in the DynamoDB section here, so don't worry if that doesn't make sense just as of yet. And you can specify the read and write capacity per second. So whatever you need, you just say, I need 100 reads and writes per second, and then you just pay that cost. So there they are. And we'll talk about this in greater detail in the DynamoDB section. And the last thing I want you to know is that the data is stored at least across 3 different regions on SSD storage. So those are really fast drives, which makes your data extremely durable to failure. So there you go. Okay, so I made one really, really big mistake here, which I've corrected here, and it's the fact that all data is stored on SSD storage and is spread across 3 different AZs. The reason I thought it was regions was because when I read the documentation, it said geographical locations. It didn't really say AZs, and so I took the guess and thought it was region. But when I thought about it, and I talked to some other people that know DynamoDB better than me, they pointed out that no, it's going to be data centers, and that makes sense because if you have a feature called global tables and allows you to copy to other regions, it just doesn't make sense. So sorry for that mistake, but it's actually 3 different AZs. It's technically 3 different data centers, but we'll just call it AZs for the sake of simplicity. And yeah, that's that correction there. Let's take a look at what a DynamoDB table looks like and understand all the components that are involved. So the first thing is the table itself, and tables contain rows and columns, but we don't call them rows and columns in DynamoDB. They have different names, so that is the entire table there. So we have items, and that is the name for rows. So there we have a row, which is a single item. And then you have attributes, and that is the name for columns. I don't point it out there, but imagine the entire year column as the attributes. Then you have the keys, and that's the name of these columns. So up here we have IMDb ID, so that's the name of the key. And then you have values, and that is the actual data itself. So there's an example of some data. So hopefully that makes it very clear what the structure is for DynamoDB. So with DynamoDB, it replicates your database across 3 regions onto 3 separate hard drives, and this allows for high availability, so you don't have data loss. But this comes with a trade-off, because when you need to update your data, it's going to have to write updates to all those copies. And it's possible for data to be inconsistent when reading from a copy which is yet to be updated. So the way you work around this is with choosing your read consistency. With DynamoDB, you can choose between 2 options. You can choose eventual consistent reads, which is the default, or strongly consistent reads. So let's talk about eventual consistent reads first. So when copies are being updated, it is possible for you to read and be returned an inconsistent copy. Okay, because you're reading from a database which has yet to be updated. But reads are super fast because you're not waiting for data to become consistent. So you can read it immediately, but there's no guarantee of consistency. Now, the time it takes for everything to become consistent is around a second. So if you're building an application and you can wait up to a second after a read, that's how you would ensure that your data is up to date. Or maybe you have an application where it being consistent isn't a deal breaker, so it doesn't really matter. Now, if consistency is extremely important to you, this is where strongly consistent reads are going to come into play. So this is when copies are being updated and you attempt to read it, but it's not going to return it unless all the copies are consistent. So the trade-off here is you're going to have a guarantee of consistency. It's always going to be consistent, but you're going to have to wait longer for that read to come back to you. So it's going to be a slower read. And all copies will be consistent within a second. So that's a guarantee that AWS gives you. So there you go. That's read consistency. So let's look at DynamoDB partitions. And so what is a partition? It's an allocation of storage for a table backed by a solid state drive and automatically replicated across AZs within an AWS region. And that is AWS's definition. So let's take a look at my definition, because I think that's a bit easier to digest. And that is a partition. A partition is when you slice your table up into smaller chunks of data, a partition. And the purpose of this is to speed up reads for very large tables by logically grouping similar data together. So imagine you have a table, and this table is giant. And so it would be faster if you could partition it. And so the idea is that maybe this data would go to partition A, this data would go to partition B, and this data would go to partition C. And if you're wondering, well, how does it choose which tables and stuff like that? That's what we're going to find out next. So looking at partitions a bit more here, DynamoDB automatically creates those partitions for you as your data grows. And you're going to start off with a single partition. And there's two cases where DynamoDB will create additional partitions for you. That's when you exceed 10 gigabytes of data in a table, or if you exceed the RCUs or WCUs for a single partition. And each partition has a maximum of 3,000 RCUs or 1,000 WCUs. If you're wondering what those acronyms mean, it means read capacity units and write capacity units. So an example of setting up those capacity units would be down here below. So you have a table, and here I'm setting the reads, and then I'm setting the writes. And the way it will work is when you get a new partition, it's going to split the reads and writes across those tables. So if you go over that mark, this is exactly where it would hit that threshold. So it would split. So when you create a table, you have to define a primary key, and this key is going to determine where and how your data will be stored in partitions. And it's important to note that the primary key cannot be changed later, so designing your primary key and making the right choice early on is extremely important because you only get one shot at this. So here is an example of the console where you create your primary key and you'd would define a partition key. So that's going to determine which partition data should be written to. And then you have a sort key, which is optional. And this is how your data should be sorted on a partition. And you're going to notice that there are some date types here. And I have a sort key that's a date, but notice that there isn't a date type in DynamoDB. So in that case, you use a string, so just be aware that there is no date type. And there are two types of primary keys. There's one which is called a simple primary key. That's where you only use a partition. And then you have a composite primary key. That's where you have a partition and a sort key that makes up your primary key. So let's talk about how a primary key with only a partition key chooses which partition it should write data to. And again, if you only have a partition key, that makes it a simple primary key. So the first thing is we need some data, and we want to get it into a particular partition. And so we make our primary key, and all it has is a partition defined. And we want to choose a value that is unique. So ID is a really great value because that's going to be extremely unique. And that is very important when designing simple primary keys. So the way this is going to work is AWS has this thing called the DynamoDB internal hash function. And we don't actually know how this thing works because it's a secret, but it's an algorithm that decides which partition to write data to. And so it needs your data and it needs your primary key to figure that out. So those two things go in there, and then it writes to whatever partition it decides to write to. So, that is how that works for a simple primary key. Now we're going to take a look at how primary key with a partition and a sort key chooses which partition it should write data to. And again, a partition and sort key is known as a composite primary key. So we're going to need some data, and then we're going to have to define our key here. And so you'll notice that we're filling in both the partition key and also the sort key value. And what's important is that the combination of the partition and sort key have to be unique. So in the case of simple primary key, we wanted the partition key to be unique, but it has to be unique in the scope of the two combined. And then we have our internal hash function, which again is a secret. Nobody knows how it works. I've reached out on Twitter, asked DynamoDB. They won't tell me, which is great for security. And so what we're going to do is take our primary key and our data, and it's going to get passed to that internal hash function. This happens when you just write to DynamoDB. You don't have to literally call it. And then it's going to decide to put it in partition C. But this is a little bit different, where the composite or the simple primary key had just put it in a random partition. This one is putting it with data that is similar to it. So here we have an alien that is a Romulan, and it's grouping it together with other Romulans there. And it's also sorting that data from A to Z. So the data is close together so that it's faster to access. So that is the idea behind the composite primary key, and how it figures out what partition to go to. So let's talk about primary key designs. We're going to be talking about simple keys and the composite key. Again, simple keys is only a partition key, and a composite key is made up of both a partition and sort key. So for simple, what's important to remember is that no two items can have the same partition key. So here, let's say the ID is the partition key. You can see that two values are the same. That's not going to work out, but here they are different, so that is great. Then on the composite key side, we care about two items where they can have the same partition key, but the partition and sort key combined must be unique. So here, let's say alien is the partition and name is the sort. They're both the same. That's not going to work out. But here, the partition key is the same, but the sort key is different, and that's all right. So that's going to work out great. So there's two things when designing your primary key that you have to keep in mind. You want them to be distinct. The key should be as unique as possible. And the other thing is you want the keys so that it will evenly distribute data amongst partitions. And that is based on how much things will group together based on your, and this is more so even with the composite key, because when you can group things based on that partition key, you want that to be as unique as possible so that it's more even. You don't want 90% of your records being one thing and then 10% being the other. You want it as even as possible. So there you go. Query and scan are two functions that you're going to be using a lot in DynamoDB, and you really need to get familiar with these two functions. And so what I recommend is opening up the DynamoDB console, because they have under these items this way of exploring data where you can query. So there you can choose whether you want to query or scan. And then based on what you choose, scan has very few options, but with query you have a lot of things you can choose to explore based on the partition sort key. And just look at what you can sort when you drop down here. So by playing around with this, you're going to really understand in a practical way what you can do. But let's jump into learning a little bit more about query and scan. So let's talk about the query function. So this allows you to find items in a table based on the primary key values, and it allows you to query a table or secondary index that has a composite primary key. So going back to the actual console, you can see that you have the choice of a partition and a sort, and we have some filtration options. So anything that you can do there is going to really help you understand what you can do. By default, the reads are using eventual consistency. So if you want the reads to be strongly consistent while querying, you can pass consistent read equals true when you're using it in the SDK or the CLI. And by default, it returns all the attributes for the items, so that's all of the columns. And you can filter those out by using project expressions to only get the columns you want. Definitely something you're going to want to do. And by default, all the data will be returned to you in ascending order. That's A to Z. If you want it in descending order, that's Z to A. You can use scan index forward false to do that. But you can see in the console, you can just click ascending or descending. It's a lot easier there. And I just want to give you an example of a payload. So this is an example where if you're configuring the CLI or SDK, these are the attributes you could pass. So you have here a consistent read. You're saying we want it to be true. Projected expression, we're saying I only want ID, name, created at, and updated. Scan index forward, we want it to be returned in reverse. And we can limit it. So we say I only want 20. And there's a lot of different options, but these are the most important ones for you to know. We're going to take a look at the DynamoDB scan function. So this allows you to scan through all items and returns one or more items through filters, and by default returns all the attributes for items. So if we were to try to do a scan within the DynamoDB console, you can see all we have is the ability to add filters. It's really, really simple. Scans can be performed on tables and secondary indexes. They can return specific attributes, and by using projected expressions, we can then limit it just like query, so just like the other one. Scan operations are sequential. You can speed up a scan through parallel scans using segments and total segments. And this is important because when you do a scan, it's going to return everything. And so, it doesn't matter how many records, it'll just return everything. And so that's why this functionality is so important. But I'm going to tell you right now, you're going to want to avoid using scans when possible. They're much less efficient than running a query because, as I just said, it returns everything. As a table grows, the scans take longer to complete, which makes total sense. And a large table can use all your provision throughput in a single scan. So, avoid scans when possible, but they are there for you to use. So, one thing we have to do when we make a new table is choose its capacity mode, whether it's provisioned or on demand. And we're going to first look at provision throughput capacity. And this is the maximum amount of capacity your application is allowed to read or write per second from a table or index. So here is an example of a table where we've chosen to use provisioned capacity. And down below, we have the option to choose or to fill in our provision capacity. And it's even going to tell us what's going to cost us per month at that setting. So throughput is measured in capacity units. So we have RCUs, which stands for read capacity unit, and WCUs, which stands for write capacity unit. So you'll see those abbreviations all over the place. And one thing that we can do, and you'll notice there's an option for auto scaling. So if we were to turn that on, this allows us to scale our capacity up and down based on utilization. So if we need to go beyond that 5 or 10, we'll just set that, and we can say the minimum and the maximum. And the reason why you'd want to turn on auto scaling is to avoid throttling. So if you were to go beyond the capacity that you're set, and let's say you didn't have auto scaling turned on and you went beyond 5 reads per second, that data is going to get throttled, and that means those requests are going to be dropped. So it's literally data loss. They're not going to make it into your database. So auto scaling gives you a bit more wiggle room, but there are limitations to it. So there you go. That's provision capacity. So let's take a look at on-demand capacity, and this is where you pay per request. So you pay only for what you use. So over here, we have it set to on-demand. You're going to notice that we cannot set the provision capacity, and we cannot set the auto-scaling, because this is all going to happen for you automatically. And on-demand is really good for cases where you have a new table, and you don't know how it's going to turn out. You don't know what you should set your capacity to, so it's just easier to go on-demand. Or you're never going to have predictable traffic. It's going to be all over the place. You don't want it to be throttled and lose traffic. And that auto scaling group, it's just not going to work because it's just too erratic. Or, you just like the idea of paying for only what you use, because DynamoDB can get pretty darn expensive at scale. And the only limitations that are applied to you is whatever's the default on the upper limits for a table. And the upper limit is 40,000 RCUs and 40,000 WCUs. So that's the worst damage someone could do to you. And what I mean by that when I say damage is that there is no hard limit imposed by on-demand. So if you get a lot of traffic and it requires 40,000 RCUs, it's going to spin up to that. So you just have to be careful that you don't have runaway traffic here because that will have you end up with a very large bill. But again, on demand is still a really good feature because it gives you a lot more flexibility. So in DynamoDB, it's important for us to know how to calculate the reads or the writes. So let's start with read capacity units. A read capacity unit represents one strongly consistent read per second or two eventually consistent reads per second for an item up to 4 kilobytes in size. So the whole point is figuring out what to put in this box. And so if we had data that was 4 kilobytes or data or less at 10, this would equal 10 strongly consistent reads or 20 eventually consistent reads. But if this shows up in the exam, they're going to not ask you this stuff. They're going to ask you how to calculate this number here. And that's what we're going to figure out. But remember that we have consistent reads and strong reads. So we have to have two different formulas for calculating this n number here. So let's first look at how to calculate RCUs for strongly consistent reads. And the formula is going to be, we're going to round our data up to the nearest 4. We're going to divide by 4, and then we're going to times by the number of reads. So let's go through 3 examples. The first being 50 reads at 40 kilobytes per item. So we don't need to round it up to 4 because 40 is already divisible by 4. And we're going to divide that by 4, giving us 10 timesing that by 50. That's how many reads we have. And that's going to be the number that goes up in here, 500 RCUs. The next one here is 10 reads at 6 kilobytes per item. So 6 needs to get rounded up to 8. That 8 is divided by 4, which turns into 2. And we're going to take that 2 times it by 10, and that's going to be 20 RCUs. So that 20 is going to go up into that box there. Then the last one here, we have 33 reads at 17 kilobytes per item. And so 17 kilobytes need to be rounded up to 20. 20 is divisible by 4, becomes 4. And then we times 4 by the number of reads, which is 33. And that's going to give us 132 RCUs. So we're going to now look at how to calculate RCUs for eventually consistent reads. And remember that for each RCU, we get 2 eventually consistent reads per second. So the formula is going to vary here, but going to be pretty darn similar. So the first thing is we're going to round the data up to the nearest 4. We're going to divide by 4. We're going to times by the number of reads. Then we're going to divide by the final number by 2. And then we have to round up to the nearest whole number. So looking at the first example, we have 50 reads at 40 kilobytes per item. So 40 is already divisible by 4. So we're going to divide by 4, which gives us 10. And we're going to times by 50, which gives us 500. Then divide by 2, and that's going to give us 250 RCUs. The next example, we have 11 reads at 9 kilobytes per item. So we're going to round up 9 to 12, which is the nearest 4, which gives us, and then we're going to divide that by 4, which gives us 3. 3 times 11, that's the amount of reads, so that's 33. Then we're going to divide by 2, which gives us 16.5, and then we'll have to round that up to the whole number, so that's 17. So we're at 17 RCUs. And then one more example here. So let's say we have 14 reads at 24 kilobytes per item, so 24 is divisible by 4, so that gives us 5. 5 divided by 4, or sorry, 24 divided by 4 is 5, and then 5 times 14 is 70, and then divide that by 2 gives us 35 RCUs. So I know math isn't fun, but it is something you definitely need to learn. So just drill through this stuff until you get it, and there you go. Now let's look at how to calculate writes. So this is for write capacity units. And a write capacity unit represents one item per second for an item up to 1 kilobyte. So if we have a write capacity unit of 10 and we have 1 kilobyte or data of less, that's going to equal 10 writes. So I wonder if you noticed, but this formula is going to be a lot easier than the reads. So how to calculate WCUs? We're going to round our data up to the nearest 1 kilobyte. We're going to times by the number of writes, and that's it. So our first example here, we have 50 writes at 40 kilobytes per item. So that's 50 times 40, which is 2,000 WCUs. Our next example here is 11 writes at 1 kilobyte per item. So that's 1 times 11 equals 11. So super easy. The last one, a little bit tricky here, but we have 18 writes at 500 bytes. So we round up the 500 bytes to 1 kilobyte, times that by 18. We have 18 WCUs. So super, super easy. Just remember that writes, pretty much it's just times by whatever. we're going to take a look at Global Tables, and Global Tables provides a fully managed solution for deploying into multi-region, multi-master database without having to build and maintain your own replication solution. So this is a very powerful tool that DynamoDB has when you want to go global. And in order to use Global Tables, there are three things you must meet. So you need to use KMS CMK. So you need to have a custom master key with KMS. You need to enable streams, and the stream type has to be new and old image, I believe, but something has to be set there. So that would show up here on the right-hand side. So you can see once you have three checkboxes, you are good to go. And then you're able to create global tables. So all you got to do is add the region that you want and choose it, and that's it. So global tables are very easy to utilize. It's just more of that activation process. But just remember what global tables are for. They're for deploying a multi-region, multi-master database without having to build and maintain your own replication solution. DynamoDB has support for transactions. So what is a transaction? This represents a change that will occur to the database if any dependent conditions fail, and then a transaction will roll back as if the database changes never occurred. I think at one point DynamoDB didn't have transactions, and that was one of the reasons why people are like, well, that's why we use RDS databases, relational databases, because they're ACID compliant. But it looks like DynamoDB has bolted on that functionality, so that is great. And if you're wondering what ACID stands for, it is for atomacy, I can't say it, consistency, isolation, and durability. So what I want to do is give you an example of a transaction so you can conceptualize it. And these transactions work really well, like especially when you're thinking about money, where you have to have multiple steps before something goes through before you release money. So the way it works is that if any of these steps fail, then the transaction will immediately fail and roll back the changes. So the first thing is we create a new payee, and then we go ahead and we verify that the email is correct format before sending out the money. But it turns out that it's not, and so what happens is it stops and rolls back. So none of these actions actually occurred. So that is, in a nutshell, transactions. But let's look at it in more detail. So now we're going to look at how DynamoDB transactions work, since we just covered conceptually what transactions are. So DynamoDB offers the ability to perform transactions at no additional costs using two functions they have, which is transact write items and transact get items. You'll notice one says write and one says get, and that's when you want to group together a bunch of write actions or get actions. So those are your limitations there. The transactions allow for all or nothing changes to multiple items both within and across tables. Notice that it says across, so you can do this with multiple tables. DynamoDB will perform two underlying reads or writes for every item in the transaction, one to prepare the transaction, one to commit the transaction. So that is going to consume your RCUs or WCUs. So there is a little bit of extra cost there, but it's negligible. You shouldn't even think about it. These two underlying read and write operations are visible in your Amazon CloudWatch metrics. So if you're wondering if you want to keep track of that stuff, that's where you can check it. You can use condition check with DynamoDB transactions to do preconditional check. If that doesn't make sense, this is another explanation. So it checks that an item exists, or to check the condition of a specific attributes of the item. So it's just a way of doing a check before you run that transaction. So that is the specifics of a DynamoDB transaction. So TTL, which stands for time to live, allows you to have items in your DynamoDB expire after a given amount of time. And so when I say expire, I mean they get deleted. This is great if you want to keep your databases small and manageable, or let's say you're working with temporary but continuous data. Examples could be session data, event logs, or just based on your usage patterns. So the way you're going to enable time to live is in your DynamoDB table. You're going to click on TTL, and then you're going to have to enable it, and you need to provide it a attribute. So here I'm providing expireset, which is a string that has to be in a date-time format, and this is what's going to be used to determine when a record should be deleted. Now, if you've been paying close attention to the DynamoDB section, you know that there is no date-time data structure, and everything are strings, because DynamoDB just doesn't have a date-time data type. So it's important that you use that you format the string in epoch format. Okay, and so if you're not familiar with that, this is just I think this is ISO 8061. And what you'd have to do is convert this into epoch, which looks like this. It's a bunch of numbers. So there, you'd have to programmatically do this, or you'd have to use an online calculator. But the advantage of TTL also is that it will save you money, because the smaller your database is, the less likely you'll have partitions and the more money you will save. So there you go. DynamoDB has a functionality called streams, and when you enable streams on a table, DynamoDB is going to capture every modification to data items so that you can react to those changes. So if an insert, update, or delete occurs, that change will be captured and then sent to a Lambda function. So changes are sent in batches at a time to your custom Lambda. Changes are sent to your custom Lambda in near real time. Each stream record appears exactly once in the stream. For each item that is modified, the stream records records appear in the same sequence as the actual modification. So here's an example. Let's say I update an item. So I'm updating Chief O'Brien. This could be an insert, and it gets inserted in the database. But now we're going to react to that insert and send that data to DynamoDB stream. And that DynamoDB stream is configured to send it to a Lambda. And when it goes to that Lambda, we can do anything we want with that data. So we could have it so that it sends out an email, or it gets sent to Kinesis Firehose, or whatever we want to program. So it's just a way of reacting to inserts, updates, and deletes. So there are a couple of errors I want to review with you on DynamoDB that I think you should know. The first one being throttling exception. So the rate of request exceeds the allowed throughput. This exception might be returned if you perform any of the following operations too rapidly. So create table, update table, delete table. This is likely to happen, I would say, with update table, because it's not frequent that you're creating tables or deleting tables, but it's possible you might send multiple actions to an update table. The other error I want you to know, and this one is extremely common, it's provision throughput exceeded exception. So you exceeded your maximum allowed provision throughput for a table or for one or more global secondary indexes. This error occurs when you've exceeded your throughput. So that's your capacity units, your reads or your writes. And so you're very, very likely to see this error. When an error does occur on DynamoDB, you're going to likely be accessing DynamoDB via the AWS SDK. So you're writing it programmatically in your code. And when an error fails, the SDK has it built in, so it will automatically retry when something failed. It'll try it again. As well, it will implement exponential backoff. If you've never heard of this before, the idea is that I've encountered an error. I'm going to wait 50 milliseconds before I try again. And if that one fails, I'm going to try 100 milliseconds. And if that one fails, I'm going to keep on doubling that time. And here it's going to update it up to a minute before it stops. So this is just a strategy for trying to make sure changes make their way through. So if you're using SDK, that ensures that you're not going to lose data, because it's going to try again. And so I want to point out that these two exceptions are important because they're very likely to show up in your exam. Very, very likely provision throughput exceeded exception. And notice that it says provision throughput. So remember, there's two capacity modes. We have throughput, provision throughput, and on demand. So this error, provision throughput, would never happen for on demand. For on demand, this error could never occur. Maybe it would occur if you exceeded the 40,000 RCU or or the write capacity units or the read capacity units. I don't know. I've never exceeded it, so I couldn't tell you what error shows up. Maybe it's called on-demand exception, but this error is extremely common, so you have to understand what it's for. So in DynamoDB, there is the concept of indexes, and indexes are extremely common with databases. So what is an index? A database index is a copy of a selected columns of data in a database which is used to quickly sort. So it's just when you need to quickly look up information, you're literally cloning a version of your database. And DynamoDB has two types of indexes. We have LSIs, which stands for local secondary index, and these can only be created with the initial table. And then you have GSIs, which are global secondary index. And we're going to get into both of these in extreme detail. But the takeaway I want you to remember from this is that you generally want to use global over local, and this is what's recommended in the AWS documentations. And another deciding factor could be strong consistency. So a local secondary index can provide strong consistency, where a global secondary index cannot provide strong consistency. So now that we have a little bit of idea what indexes are, let's jump into LSIs and GSIs. So let's first take a look at local secondary indexes. So it's considered local in that every partition of an LSI is scoped to a base table partition that has the same partition key value. If you're wondering what base table is, that is the initial table that you're creating an index from. The total size of index items for any one partition key value can't exceed 10 gigabytes. So that is definitely a hard limit with local secondary indexes. It shares the same provision throughput setting for read and write activity with the table that is indexing. So that's the base table. And that makes sense because it's a local table. So of course it's going to share. And then it has a limit of 5 per table. Now let's take a look at actually how we create a local secondary index. So the LSI can only be created with the initial table. So here you can see I'm making a table and I'm adding index at the time of creation. You cannot add, modify, or delete LSIs outside of this initial table step. So you have to really get it right here and now. And if you need one, you literally have to make a new table. It's the only way you can make a new LSI. You'd have to make a new table and move all your data over. So you need to have both a partition and a sort key, and there are some conditions around those partition and sort keys. The partition key must be the same as the base table, and this makes sense because it's a local partition, so it's working off that base table. The second sort key should be different from the base table. Now you could make it the same, but then it defeats the whole purpose of having a secondary index, which is supposed to be optimized to sort in a different manner. So you'd want to choose a different sort key in this case. So, hopefully that makes local secondary indexes more clear. So we'll move on to the next one, which is global secondary index. So global secondary indexes are considered global because their queries on the index can span all of the data in the base table and across all partitions. These indexes have no size restrictions, where we saw with LSIs, there was a 10 gigabyte limit for all items in that index. They can provision their own throughput settings and they consume capacity, but it's just not from the base table. So that's a good thing. And there's a limited 220 per table. I think you might be able to use a service limit increase to increase that. I'm not sure. But even if that's not the case, it's not going to show up in the exam, so do not worry. If you want to create a global secondary index, you can create it while you're creating the table, or you can make one afterwards, and you can modify them and delete them at any time. So it's extremely versatile to create these things. And the partition key can be different from the base table, and you should make it different generally because that would make sense. But I guess if you had not made your local secondary index and you wanted a partition key with a different sort key, then I guess you'd have to make a GSI. But just notice that you can set the partition key to whatever you want. And the sort key is optional, so you don't actually have to have it. You could just have a partition key, so that'd be a simple key. But yeah, that's global secondary indexes. So now let's just pull them up side by side and make sure that we understand the differences clearly. Okay, so let's just reiterate through LSIs versus GSIs so we really know the difference between these two and which one is better in each specific aspect. So starting at the top here, when we're talking about key schemas, local secondary indexes only have composite. Now remember, composite is both a partition and sort key, and then global secondary indexes support both simple and composite. Then for key attributes for LSIs, the partition key must be the same as the base table, because remember, it's local, it has to use the same partition key. For GSIs, the partition and sort key can be any attribute you like. Then for size restrictions, the LSI has to be 10 gigabytes or less for all indexed items. And then for GSIs, it's unlimited. For online index operations, the only time you can create indexes is on table creation. But for GSIs, you can add, modify, delete indexes at any time, and you can make these indexes at the time of creation as well if you want to. For queries and partitions, the LSIs query over a single partition as specified by the partition key value in the query. For GSIs, it queries over entire table or across all partitions. For read consistency, we have strongly or eventual consistency. So you can see LSIs win over GSI in this one case, where GSI is only eventual consistency. For provision throughput consumption, this is shared capacity with the base table. So you're more likely to get throttled here. But for GSIs, it has its own capacity, so it's not going to affect the base table. And then the last one here, which we didn't talk about, but we'll talk about now, is projected attributes. So when you create that table, you say what attributes, so those are the columns that are allowed to be in that index. So for local secondary index, you can request attributes that are not projected into the index, whereas GSI, you can only request attributes that are projected into the index. So over those 2 points, you can see why GSIs are generally more recommended than LSIs. But, it all comes down to your use case, so you'll have to decide for yourself. So here we're going to take a look at DynamoDB Accelerator, also known as DAX, and it is a fully managed in-memory cache for DynamoDB that runs in a cluster. And its response times can be in single-digit milliseconds. So DAX can reduce response times to microseconds. And that's really important for certain types of workloads, which we'll talk about a little bit more in the next slide. So here's an illustration of generally what DAX is. So let's just talk through the points of how this thing works. So you have a DAX cluster which consists of one or more nodes. So I have them called cache here. Each node runs its own instance of the DAX caching software. One of the nodes serves as the primary node for the cluster. Additional nodes, if present, serve as read replicas. Your app can access DAX by specifying the endpoint for the DAX cluster. So there we can see the app and it's accessing via the endpoint. The DAX client software works with the cluster endpoint to perform intelligent load balancing and routing. So it just takes care of stuff. You just use the endpoint and it figures everything out. And incoming requests are evenly distributed across all the nodes in the cluster. So now that we kind of have a little bit of an overview of DAX, let's look at the use cases of when and when not to use DAX. So let's take a look at DAX use cases. And to best understand this, let's say what DAX is good for and what it's not good for. So apps that require the fastest possible response time for reads, that's real-time bidding, social gaming, and trading applications, this is where you're going to want to use DAX. Apps that read a small number of items more frequently than others, apps that are read intensive but are also cost sensitive. Please take note of read intensive. That's what DAX is usually for. Apps that require repeated reads against a large data set. Notice that we said reads again. And now onto the not ideal side, apps that require strongly consistent reads, because DAX is not strongly consistent, it is eventually consistent. Apps that do not require microsecond response time for reads or do not need to offload repeated read activity from underlying tables. Apps that are write intensive or that do not perform much activity. Notice an emphasis on write. That is not what DAX is intensive for, it's for read. Apps that already are using a different caching solution with DynamoDB and are using their own client-side logic for working with that caching solution. So if you run into the cases on the right, what would you do for caching in DynamoDB? And that's where Elasticache would come into place, because you can put Elasticache in front of DynamoDB. So if you're dealing with write-intensive stuff, then you can make advantage of Redis there. And so that would be the case there. So we're on to the DynamoDB cheat sheet, and this one's more special than all the rest, and that's why I prefixed it with Ultimate, because DynamoDB is the most important service you need to know to pass the AWS Certified Developer Associate. It's extremely critical to the certification, and this cheat sheet is very long. Okay, it's the longest one in this course. It's 7 pages long, and it actually started out as only being 5 pages. I had published a preview on Twitter, and Kirk, who is a senior technologist at AWS, specifically for DynamoDB. Notice I made some mistakes and made the offer to review the entire cheat sheet for accuracy. And I sent it over to him, and he turned this 5-page cheat sheet into a 7-page cheat sheet. And I even learned a lot of great things. So, I think we all benefit from Kirk's help here. And so I want to tell you, if you can do me a favor, to go on Twitter. If you have Twitter, I want you to tweet out to him, AWS Certified DynamoDB, and thank him. Thank him for helping us with this ultimate DynamoDB cheat sheet. He did it on his own time. He didn't have to do it, and this was his own effort. So we greatly appreciate it. And, I really hope that it helps you pass the exam. So let's jump into this ultimate DynamoDB cheat sheet. Okay, so let's jump into the ultimate DynamoDB cheat sheet. So DynamoDB is a fully managed NoSQL key value document database. DynamoDB is suited for workloads with any amounts of data that require predictable read and write performance and automatic scaling from small to large and everything in between. DynamoDB scales up and down to support whatever read and write capacity you specify per second in provisioned capacity mode, or you can set it to on-demand mode, and there is little to no capacity planning. DynamoDB can be set to support eventually consistent reads by default and strongly consistent reads on a per-call basis. Eventually consistent reads data is returned immediately, but data can be inconsistent. Copies of data will be generally consistent in 1 second. Now, talking about strongly consistent reads, we'll always read from the leader partition since it always has to have an up-to-date copy. Data will never be inconsistent, but latency may be higher. Copies of data will be consistent with a guarantee of 1 second. DynamoDB stores 3 copies of data on SSD drives across 3 AZs in a region. I think before I had said across 3 regions, but this was my misinterpretation of the documentation. And I don't even know if it's really 3 AZs, more so managed data centers by AWS, but it's easy to understand them as AZs, so that's what we're going to call them. DynamoDB's most common data types are B, binary, N, number, S, string. I think there's a few other ones there, and some of them share the word, start with B, so it gets a bit confusing, but these are the 3 that I want you to know. Tables consist of items, which we call rows, and items consist of attributes, which we call columns. A partition is when DynamoDB slices your table up into smaller chunks of data. This speeds up read for very large tables. DynamoDB automatically creates partitions for these scenarios. So every 10 gigabytes of data, when you exceed RCUs of 3,000 or WCUs of 1,000 limits for a single partition. In the last scenario, when DynamoDB sees a pattern of a hot partition, it will split that partition in an attempt to fix the issue. So that is page 1. We're going to go to page 2. So we're on to page 2 of the ultimate DynamoDB cheat sheet. So DynamoDB will try to evenly split the RCUs and WCUs across partitions. Primary keys define where and how your data will be stored in partitions. So primary keys come in 2 types. We have simple primary keys using only a partition key, and composite primary key using both a partition and sort key. Partition key is also known as hash, and sort key is also known as range. I mentioned this before, but the reason they used to be called hash and range, I don't know, but the point is they changed them, and when you're using the CLI or the SDK, they still call them hash and range, so it's important to know both of them there. When creating a simple primary key, the partition key value must be unique. When creating a composite primary key, the combined partition and sort key must be unique. When using sort key records on the partition are logically grouped together in ascending order. DynamoDB Global Tables provide a fully managed solution for deploying multi-region, multi-master databases. DynamoDB supports transactions via the transact write items and transact get items API calls. I don't know if I mentioned it there, but the point of these transaction calls is that they let you go across multiple tables. Oh, I write it right here. So transactions let you query multiple tables at once in an all or nothing approach. So all API calls must succeed. DynamoDB streams allow you to set up a Lambda function triggered every time data is modified in a table to react to changes. And I love DynamoDB streams. I use it all the time for a lot of projects. I don't feel like we need to know too much on the developer about it, but there's definitely a lot we could write about it. And streams do not consume RCUs. So that is the nice thing about it. They're not going to use your read count up. So that is page 2. We're moving on to page 3. So we're on to page 3 of the Ultimate DynamoDB cheat sheet. So DynamoDB has two types of indexes. We first have LSIs, which is local secondary index. And then we'll talk about GSIs. So LSIs support strongly or eventually consistent reads. They can only be created with the initial table. They cannot be modified and cannot be deleted unless you're also deleting the table. That's the only case where you'd be able to delete it. They only use composite keys. They have to be 10 gigabytes or less per partition. The shared capacity units with they have to share the capacity units with the base table. You must share a partition key with the base table, so that's very important as well. Moving on to GSI, so global secondary index, they cannot provide strong consistency. The only way you can get strong consistency is with LSIs, okay? Very important to remember that point. So only eventual consistent reads can create, modify, or delete at any time. That's extremely convenient. Simple and composite keys is what you can use here. Can have whatever attributes. So the partition key can be whatever it wants, and the sort key can be whatever it wants. There's no size restrictions per partition. It has its own capacity settings. So there you go. That is, I think we're page 3. On to page 4. So we're on to page 4 of the Ultimate DynamoDB cheat sheet. So we'll talk about scans and we'll talk about queries. The first thing I want you to tell about scans is your table should be designed in such a way that your workload primary access patterns do not use scans. Overall, scans should be needed sparingly in frequent reports. So generally, you do not want to be using scans. Scan through all items in a table and then return one or more items through filters. By default, returns all attributes for every item. You can use project expression to limit the attributes that you want to use. Scans are sequential. You can speed up a scan through parallel scans using segments and total segments. Scans can be slow, especially with very large tables, and can easily consume your provisioned throughput. Scans are one of the most expensive ways to access data in DynamoDB, and we'll move on to queries next. So it's about finding items based on the primary key values. Tables must have a composite key in order to be able to query. By default, queries are eventually consistent, but if you want to use strongly consistent reads, you can use this attribute strongly consistent reads, set it to true, and now you're doing strong. By default, returns all attributes for each item found by query. So just like scans, you can use project expression to filter stuff out. By default is sorted ascending, and you can use scan index forward false to reverse the order in descending. I don't know if that option is available in scan, but just know that scan index forward is used to flip the order. So there you go. So we're on to the 5th page out of 7 for the Ultimate DynamoDB cheat sheet. So DynamoDB has two capacity modes, provision and on-demand. We're talking about provision first. So you can switch between these modes once every 24 hours. Provision throughput capacity is the maximum amount of capacity your application is allowed to read or write per second from a table or index. So provision is suited for predictable or steady state workloads. It's very important to understand the concepts of RCUs and WCUs, especially for provision throughput, because you definitely set these values here. So RCUs is a read capacity unit, WCUs is write capacity unit. And with provision throughput, you can set auto scaling. And so it's recommended you enable auto scaling with provision capacity mode. In this mode, you set a floor and a ceiling for the capacity you wish the table to support. DynamoDB will automatically add and remove capacity to between these values on behalf and throttle calls that go above the ceiling for too long. And if you go beyond your provision capacity, you'll get an exception, provision throughput exceeded exception. For the exam, you 100% want to know this. It will absolutely show up on the exam. And this is what happens when throttling occurs. And if you're not familiar with throttling, it's when requests are blocked due to read or write frequencies higher than the set threshold. So an example for exceeding the set provision capacity, we've got partition splitting, table index capacity mismatch. So that is provision throughput. We're going to move on to on-demand, and on to the next page we go. So we're on to the 6th page of the Ultimate DynamoDB cheat sheet, talking about on-demand capacity. And this is pay per request, so you only pay for what you use. On-demand is suited for new or unpredictable workloads. The throughput is only limited by the default upper limit of the tables. That's 40K RCUs and 40K WCs, WCUs, that's extremely high value. And throttling can occur if you exceed double your previous peak capacity, so the high watermark within 30 minutes. Had no idea of this. If you previously peaked to a maximum of 30,000 ops per second, you could not peak immediately at 90,000 ops per second, but you could at 60,000 ops per second. So that is definitely something I did not know, and I'm really glad Kirk put that in there because I had something way more simpler before. Since there is no hard limit on on-demand, it could be very expensive based on emerging scenarios, so just be careful with on-demand there. But you definitely have the flexibility where you don't have to think about setting your capacity, so that's really nice. Now let's talk about calculating reads and writes. This is definitely more important for provisioned throughput, not for on-demand capacity, but we'll go through it now. So for calculating reads for RCUs, a read capacity unit represents 1 strongly consistent reads per second or 2 eventually consistent reads per second for an item up to 4 kilobytes in size. And how you're going to calculate RCUs for strong is the following. Round up data to the nearest 4, divide data by 4, times by numbers of reads, and then we'll move on to how to calculate for RCUs for eventual. So round data up to the nearest 4, divide by 4, times by the number of reads, and divide final number by 2, and I think you got to round it up, and then round up the nearest whole number. If you really can't remember that stuff, here are the examples, and I'm hoping you're printing out this cheat sheet on the day of your exam so that you can look through these and make sure you know these for sure. And so that's page 6, and we're on to the last page, page 7. So we're on to the last page of the ultimate DynamoDB cheat sheet. So let's finish strong here. We're going to do some calculating of writes. So our write capacity unit represents 1 write per second for an item up to 1 kilobyte. How to calculate writes? What we're going to do is round data up to the nearest 1 times by the number of writes. We'll talk about, I have the example there. We'll just show you there at the end though. So we'll talk about DynamoDB Accelerator, also known as DAX. It's a fully managed in-memory write-through cache for DynamoDB that runs in a cluster. So reads are eventually consistent. Incoming requests are evenly distributed across all of the nodes in the cluster. DAX can reduce read response times to microseconds. And let's talk about where it's ideal and where it's not. And this is definitely debatable, but I got this from the doc. So, you can't argue with me, but I know some people might consider otherwise. And if it's for the exam, they generally follow whatever on the docs until they've been changed. So DAX is ideal for the fastest response times possible. Apps that read a small number of items more frequently. Apps that are read intensive. So that's the one I'm highlighting there. And then DAX is not ideal for apps that require strongly consistent reads, apps that do not require microsecond reads response times, apps that are write intensive or that do not perform much read activity. And if you don't need DAX, consider using Elastic Cache. That's not a hard rule, but that's a good rule for the exam. If you get a toss up between DAX and Elastic Cache, and it doesn't need microseconds, then consider using Elastic Cache there. Or if it's more write intensive. And just to show you there, these are the examples. You definitely want to print out this cheat sheet and have it on exam day. I hope this ultimate DynamoDB cheat sheet really makes the difference for your exam. So it looks like I lied, and there's actually 8 pages to this DynamoDB cheat sheet. I almost forgot to include DynamoDB API commands, which you'd use via the CLI, which is really important because these could show up on the exam. So let's go through them. The first being getItem. This returns a set of attributes for the items with the given primary key. If no matching item, then it does not return any data, and there will be no item element in the response. Then you have putItem, creates a new item or replaces an old item with a new item. If an item has the same primary key as the new item already exists in the specified table, the new item completely replaces the existing item. Then you have updateItem, edit an existing item's attributes, or adds a new item to the table if it does not already exist. Then you have batch get item. This returns the attributes of one or more items from one or more tables. You identify requested items by primary key. A single operation can retrieve up to 16 megabytes of data, which can contain as many as 100 items. Then you have batch write item, puts or deletes multiple items in one or more tables, can write up to 16 megabytes of data, which can compromise as many as 25 put or delete requests. Individual items to be written can be as large as 400 kilobytes. Then you have create table. Just as the name implies, it adds a new table to your account. Table names must be unique within each region. So you could have the same database name, or same table name, but in two different regions. Then you have update table, so modifies the provision throughput settings, global secondary indexes, or DynamoDB stream settings for a given table. Delete table, and this is very obvious, it just deletes a table with all of its items. Then you have transact get items, a synchronous operation that atomically retrieves multiple items from one or more tables, but not from indexes, in a single account and region. Can contain up to 25 objects. The aggregate size of the items in the transaction cannot exceed 4 megabytes. Then we have transact write items, a synchronous write operation that groups up to 25 action requests. These actions can target items in different tables, but not in different AWS accounts or regions, and no two action can target the same items. And we're really running out of space here, but we have query, finds item based on primary key values. You can create table or secondary index that has a composite primary key. And the last is scan, returns one or more items and item attributes by accessing every item in a table or secondary index. So there you go. That's the real end to the DynamoDB cheat sheet. Super long section, but definitely worth it and super critical to passing the Developer Associate exam. Hey, this is Andrew Brown from Exam Pro, and welcome to the DynamoDB follow along. And what we're going to do is we're going to create a table, load it up with data, write some records, delete some records, get some records in batch, and just really understand how DynamoDB works. What I'll need you to do is get DynamoDB open up here in a tab. So I just type in DynamoDB, click that there, and you will make it to the DynamoDB page. Make sure you're in US East 1. AWS loves to put you in Ohio or somewhere else. And just to be consistent, let's always do US East 1 for these follow-alongs. You're going to need a Cloud9 environment set up here. I showed you this in Elastic Beanstalk follow-along. I show you this in a variety of different ones here. So if you're not sure how to do it, go check those out or give it a go and try to spin up yourself an environment. And I have the DynamoDB documentation open up here so we can poke through this as we're working through these commands. And we're also going to need a couple files from the GitHub repo here, the free AWS Developer Associate. So I have a file here that helps transform data, and then the actual data we plan on importing. And we're going to be working with Starship data from Star Trek. So I have a list of starships, and we can see that this is the data we have, and that's what we're going to be importing. So let's make our way over to DynamoDB. And let's take a look at what it takes to create a table. We're not going to create our table through here. We're going to use the CLI. But let's just talk through what's on the page here. So the first thing you do is you name your table. So I'd call mine starships. And then you set your primary key. We have the option of setting a partition key and a sort key. AWS used to call this a hash and a range. And this will show up in the code because they're still named that way. So if we're looking at our data, what we'd have to do is decide what would make a good partition and sort key. And in this case, the good partition key is going to be ship class because it's a grouping of things. You can see you have cross field, cross field, cross field. And then as long as you have a unique value with both the sort and partition, it's okay. And for the sort, we're using a registry number that identifies the ship, and those are all unique. So this will definitely be a unique value. Generally, you want your sort key to be a date, but it all depends on your data. And in this case, we don't have a date value, so it's going to be ship class as our primary, or our partition, sorry, and our registry as our sort key. So what we do here is we type in the name. I would call it ship class. For some reason, DynamoDB likes to name things camel case, or at least all the documentation out there. So let's just follow suit there. But you could name them lowercase if you wanted to. And this would be registry. And over here we have some data types, string, binary, number. DynamoDB does not have a date time format. We would normally use string in that case, and there might be a few other ones outside of here, but these are the only ones you need to know. S stands for string, B is for binary, N is for number, and these are both going to be string values. You have some default values here. No secondary indexes, provision capacity 5 reads and 5 writes. It has autoscaling turned on, and encryption at rest is default encryption type. So if we just checkbox that off, we can see those values here, 5 and 5, provisioned, autoscaling is turned on, and this is defaulted. If you wanted to create a local secondary index, the only time you can create it is at this particular time. So you'd have to go ahead here and add those. And for local tables, you always want to have the same. You always want to have the same partition key, and then you'd have a different sort key. And you have to specify them both. We don't have another value here, but I put a name, and now I can checkbox on secondary, local secondary index. We're not going to create any secondary indexes. They're not that important to know, other than like how they work, but we don't really need to go through the motions of actually using them. But this is what we're going to do, but we're going to use the CLI to do this. So making our way back to Cloud9, I'm going to create a new folder here called MK, or we'll type in mkdir to make that folder. And I'm going to type in DynamoDB. DynamoDB, we'll call it Playground. And any files we're working with, we'll place them in there. And I already named that wrong, so I can go ahead here and just rename that file. Okay. And I'm just going to go ahead and make a new file in here, and I'm just going to call it like Scratchpad, because this is where we're going to write out all our CLI commands and then paste them in there just so that it's a bit easier to work with. I'm just going to clear that there. Yeah, and so let's get to it. So what we're going to do is create our table using the CLI. So what we do is type in AWS DynamoDB. And I think if we list it out, it'll tell us a bunch of information. So I think we can type in help maybe. And so this is a great way of getting a lot of information about DynamoDB. But we're just going to use the docs for this. So let's look up create table. And in here you can see the values that we can specify. I'm not sure which ones are required, but I generally know what we need to enter. The first thing is going to be attribute definitions. And so the attribute definitions, if we just go to that section, an array of attributes that describe the key schema for the table indexes. So what it's asking for is to specify the attributes for that we're going to use in the actual key schema. So the partition key and the sort key. And we decided that we are going to use the ship class and the registry. So if you just look at the syntax here, this is the format that we have to type it in. So we'll make our way back. I'm just going to copy this to save myself a lot of trouble. So I'm really terrible at writing these things out. And I'm going to type in create table and then put a backslash. That lets us do multi-line, and we'll do attribute definitions. I'm going to do 2 spaces there, and we'll go back here. I'm just going to copy this format. And so that is our first one, and it's going to be, I said, ship class. And it's going to be S for type string. I'm not sure if it tells us the types around here. I'm not seeing it, but we see there's S, N, and B. So back here, remember we have string binary number. That's what they're represented in the CLI and the API, S, N, and B. So we want them to both be string, but that's our first one. So we'll go back here, and we will need a second one. And we said that would be registry. And that's going to be string type as well. The next thing we're going to need is the key schema. And this specifies the attributes that make up the primary key for the table. And down below, you can see that we need an attribute name and a key type. And they might have an example here. Yes, they do. So here it is. And we will make our way back to here, and we will type in key schema. And I'll just paste that in there. And it's going to be the same thing. I know it's a bit redundant, but that's just how it is. And the ship class is going to be the hash. And the registry is going to be the range. Remember I said earlier that DynamoDB used to call them hash and range, and they still appear in the code? This is what I'm talking about. You can see here it says hash is the partition key, range is the sort key. On the exam for the developer associate, you might actually see a bit of CLI stuff here, and then you might need to understand what is what. So just be aware of that. And the next thing, what we might need to specify is the provision throughput. This might have a default, but we'll take a look here. I'll just scroll up here so I can find the name here. Provision throughput represents the provision throughput for the specified table. This is probably a required field. I'm not seeing anything that says required, but I almost feel that it is. And we're going to just set that default for that to 5 and 5. So I'm just going to copy that there, make our way back over here. And we'll just put 2 spaces there for backslash. And then we're going to set the read and write capacity. We're just going to set it as 5 and 5. So we'll do 5 and 5. And one more thing I want to do is set the region. Always, always, always when you're using the CLI, set the region if you can, just because AWS might default it to Ohio, and then you're just going to be scratching your head looking for stuff. So I think this is our create command. I'm just going to type create DynamoDB table. Nice documentation for ourselves. And let's see if this works. So we'll just copy that, paste that on in, hit enter. It did not work. Let's see here. Let me just double check here. Backslash, 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 backslash. Looks all good to me. Maybe I didn't copy it in right. We'll just try this one more time. I'm going to type clear here. Paste that in. Hit enter. Okay, just give me a second to figure this out. Oh my goodness, it is the most obvious thing. I didn't specify the table name. If we don't specify the table name, this thing is not going to get created. So I guess we just skipped right on over that. I'm just going to go down here, and we just provided a string. So I'm just going to copy this here. We'll go back up here. I'm going to call this Starships. And we'll have a backslash there. I'm going to save that. And we will copy this, paste that in, hit enter. And we're getting output. That is good. So this means that it definitely has created. And look down below where it says table status. It says creating, but it creates these pretty darn quick. If we make our way over to DynamoDB, I'm just going to go back to the service here and go to tables on the left-hand side, and it's active. So it's already been created. Super, super fast. Here we can see our ship class, our registry. But we don't have any data in here, so until we have data, it's going to be a little bit hard to do anything. So I think that's what we'll do next. But just before we do, I just want to show you the describe command. So let's say that it was taking a while for our DynamoDB table to create. I don't know why, but let's just say it was really slow. And we wanted to check on the status of it. So we wanted to see that it was active. We could do is type in, and we'll do it up here so we have a reference to it. Describe table. We do AWS DynamoDB, describe table, table name, Starships. I don't know if there's really any other output than that. A lot of CLI commands have this describe. So when you use the CLI long enough, you just start guessing as to what it is. I didn't even have to look it up to know what it was. We'll go here. We'll just see if there's any other options. No, it's just table name. So we just have table name here. And I'm going to go back to the Cloud9 here. And if I just take that and paste that in there, we're getting pretty much the same output as before. And you can see now that it's active. And a lot of times I like to change the output here, and I might do table. This one would probably be good as a table. So I think that's a little bit easier. You see table status over here. It's a little bit easier to read it that way. We could also do text. For this one, it'd probably be a bit messy. So that's not very readable. So for this case, I'd use table. By default, it's JSON. So there you go. So what we'll do next is we'll move on to getting our data into our table. And we're going to have to prepare it because right now it's as a CSV file. We'll move it over to JSON, but we'll do that next. So what we're going to do is we're going to make a new folder in our DynamoDB playground because we're going to generate out a bunch of batch files. Because we're going to need to batch import our data. So I'm going to go here on the left-hand side and make a new folder, and we're going to call that batches. And we are going to need this data here. So both the CSV file and the CSV JSON.rb. Probably the easiest way to get it in there is just to click the raw button here, copy that, and we will make a new file in here, which we'll call CSV2JSON.rb. If you're wondering why this file is written in Ruby, it's because that's my favorite language to use, so why not? And you don't need to know Ruby too much. I'll walk you through this file here in a moment, just so you understand what's going on here. We'll go back, and the next thing we'll need to do is grab that CSV file here. So I'm going to go there, get the raw data, copy all of that, and we will right-click, new file, starfleet.csv. And we'll double click that. Okay. Close tab here. It's because I did this project earlier, so it had a cached version. It was a bit confused. And so I pasted it in there just to make sure that name is correct. So let's take a look. Let's take a look at this file here. Let's talk about why we have to convert this to JSON and why it has to be in terms of batches. And the easiest way to understand is actually to first look at the command that we're going to be using, which is the batch write item. So the batch write item operation puts or deletes multiple items in one or more tables. A single call to a batch write item can write up to 16 megabytes of data, which can be comprised of 25 put or delete requests. So we have some limitations here, and individual items written can be as large as 400 kilobytes. So the thing is that we have records here. If we go back, because we have a nice visual here in GitHub, but you can see that we have, oh boy, 310 records. So that's more than 25. So we have to break this up into batches of 25. And we also have to provide it in the JSON format that it's expecting. I'm not aware of being able to import CSV. I'm going to check here. Nope, there's no way to import CSV. And the format that it's expecting, it looks like this here. So here it says request items JSON. It expects you to put the table name here and then have this structure request put item and then the values. So that's what we need to do. We need to transform our data into that format. And that's why I wrote this little script here to do this. So we'll quickly just walk through it. So what it does is it pulls in the CSV file and it reads the CSV file using the CSV file Ruby library. And this we may or may not need. When I originally created the CSV file, it was in Excel and it was encoding the file not in UTF-8, but this other format. But we just copied and pasted it from here, so maybe we don't need this line anymore. So we'll see. This says include the headers, so it will detect these headers here, name, registry, etc. And then it will map it into a JSON file here. So when we do line, we can then specify that them like this. But the idea is what we want to do is iterate through this file. So it's going to go line by line. It's going to start at 25. And immediately as it starts at 25, it's going to reset it back to 1, and it's going to push on a new batch of files. So it's going to start with a Starships file. That's the name of the file. And then it's going to then format the information into this put request. And it's going to do that. So it's going to create us a bunch of batches. Then it's going to iterate through those batches of data and create a bunch of batch files for us. So hopefully that makes sense, but it's better to see it in action than to talk about it. So what I want you to do is go down below here to your bash, type clear, and we want to make our way into this folder here. So type in db dynamodb. I'm hitting tab to autocomplete it. That saves a lot of time. Hit enter. And we want to run this Ruby file. So type in Ruby CSV to JSON.rb. And if everything is named correctly in here, Starfleet CSV, it looks correct to me. This should work. And there we go. There's our batch file. So we just transformed our data. Let's take a look at one of them. And that's the format we're expecting, right? If we look back here, that looks like the same format to me. This one's a bit more compact. But that's how we transform our data. And each of these contain 25 records. So now to import this, we're going to go back here and we need to write our import command. So that import command is going to look like AWS, DynamoDB. We'll say this, we're using the batch write item. So DynamoDB batch write item. And we'll make our way over here and see what we need to specify. They should have an example here. Ooh, examples. And so we just specify the file. So it's as simple as that. So I'm just going to copy that there. In fact, we could just copy this whole line here, save us any trouble if we made any spelling mistakes. And this file is in batches, so we'll type in batches, batch -000. And I'm just going to paste this a bunch of times. And we'll go through here and we'll just change this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And what we'll do is we'll just copy all of these and paste them in. And there they go. And then number 12, we might just have to hit enter there. And so it says unprocessed items. So if there was anything in there, that means that it didn't process those. This could happen if we had maybe too many items, or if we were being throttled, or not throttled, but we hit our read capacity, or sorry, our write capacity. But we didn't. It executed these perfectly. So if we go back to DynamoDB here and give this a refresh, we can now see our records. So there they all are. Look at that. How great is that? So now that we know how to batch write, I guess the next thing is let's look at how we can actually get this data programmatically through the CLI. So to get items, what we'll do is go back to the CLI here, just click back, click up here, and we should have get. So there's a batch get item, which we'll look at in a moment, but we'll look at get item first. So in get item, you specify the table name, you specify the key. We have some additional things here, but we're going to keep it really, really simple. And we're just going to do a simple get. We'll look at the examples here. And yeah, that's as simple as it gets. So I'm going to copy this over here. We're going to make our way back to Cloud9. Just type here get item. And so we have DynamoDB get item table name. Our table name is Starship, so we'll just copy that here. And this is such a short line, I'm just going to have it one line here. And then we need a key file. So I'm just going to make a new file here. So we'll go here and make a new file. I'm going to call it key.json. And the format is pretty darn simple. So you just specify the actual key. So this is the schema key that we need to provide here to get the record. So I'll go here and its actual values. So we have it is registry is one, and the other one is ship class. And what we'll do is we'll look through our data here and just find a record. I'm going to choose maybe, let's see here if there's any ships that I like. How about the Okinawa? That sounds cool. So we'll grab the Okinawa. We'll try to get this record here. So we'll grab it as Excelsior class here. We'll go back and we will paste that in there. And then we need the registry number, which we'll paste in here as well. So now we have our key, and we'll go back to our Scratchpad here. And this, yep, that should work. So I'm just going to copy that, paste that in there. And there's our record. So it returns all the fields by default. I think you could limit the fields that you want returned, probably with projection expression. Just going to take a look at that quickly here. A string that identifies one or more attributes to retrieve from the table. These can include scalar, etc. And if nothing is specified, then it will return everything. So just remember projection expression. That's what it's used for. And if we want to look at this in a different format, let's look at it a table. Sometimes it looks nicer when it's in another format. Nope, that looks terrible. We'll look at it as text. That's a little bit better. So, just consider you can play around with those values there. But that is for the get item. And next we'll look at how to get things in batch. So we'll go back to our documentation here and click back to DynamoDB. And let's look at how we would get multiple items. And so we have batch get item, request items. So it's not key, it's something else here. And if we go to an example, you can see it's as simple as this. So I'm going to just copy this here, this command. We're going to make our way back here. And we're going to do batch get item. I'm going to paste that in there. We're going to make it a single line. That makes it a little bit nicer. And we're going to create this request items file that it's suggesting here. We'll make a new file there, paste that in. And what we're going to do, I think it's very similar to this, except you can do multiples of it. So we'll go over here and take a look. So here you provide the table name, so we don't have to provide the table here, and then you provide the keys. So it's pretty darn similar. We'll look at the actual, so you don't provide the table name. So we'll look at the actual example here, because this might be a little bit more pared down here. No, it's the same. And you even provide the projection expression here if you want to filter out the fields that you want, but I want all the fields. I'm greedy like that. So I'm just going to paste this in below here. Oops, actually, we'll go here, paste it in there. And we're just going to grab this one to save us some time, because we'll just get the same record. And I'm going to paste that in as one of the keys. And I really don't like 4 spaces, but I'm not going to play around with this, so I'm just going to tab that in here. I'm just hitting tab to do that. I really hate 4 spaces. It's just too much. It's excessive. And I only want 2 records here, so I'll take out this one here. We don't need to project any expressions. We just want everything. And we will go get a second ship. So I will go back here to the data. We will look for another cool ship. Something that sounds cool. USS Reliant sounds pretty darn cool. And so I'll grab the class, which is the Miranda. So we'll do class down here. And I'll have to replace these, of course. And we also need the registry number. Paste that in there. And so, and we also need the name of the ship, which is, or the table, sorry, which is called Starships. And so that should do it. So let's make our way back to our Scratchpad here. And I'm going to copy, whoops, that's not it. I'm going to copy this down below. And we'll paste that in there. And that should give us the record. So it gave us back 2 records with all their information. Well, let's take a look what this looks like as a table. Terrible. Can't even read it. So let's look at this as as text. Yeah, that's a bit better. So again, just play around with that stuff. So that is batch get item. So now the next thing I want to do is show you how to write items to the database, but we don't have any new records. So I'm just going to go ahead and delete one, and then we're going to re-add that back to the database now. So let's take a look at delete. So I think it's called delete item. And we'll make our way over to the CLI here. We'll scroll to the top, go to DynamoDB, and we'll look for delete. There is delete item. And we have delete item, table name, key. We'll just go look at the example here. Yep, and it's as simple as that. So it looks just like get item, but it's delete item. So we'll go here. And I'm just going to go to the top here and look for Starships. Scroll that back down there, table name. And we can just use the same key that we already have, which is just going to delete this record here. And what we'll do, before we do that, let's just make sure the data exists. So this is NCC 139 Excelsior. So if we go here, I wonder if we can quickly find it here. I'm just going to copy the name. I'm going to just do Command F here and see if it shows up. Not seeing it. I'm just going to cheat here. I want to show you querying later, but I'm going to just show it to you now. And we'll just go grab that name here. So we'll type in the ship name Excelsior, or ship class there. I'm going to hit start search. And also we will go get the registry number. Paste that in there, hit start. And so there's the record. So this is the record we want to go delete. We'll go back here and we will go to our Scratchpad, grab this here, and that should delete that record there. We'll hit enter. We didn't get any output back, but that doesn't mean it didn't work. That means it did work. And we will go ahead and hit start, and now that record is gone. So that record is 100% gone, and we want to bring it on back. So that's what we're going to do next. So in order to bring back that item, we're going to need to do a put. And so we'll make our way over back to the documentation here, go to the top, search for put. There it is. And we have a put item, we specify the table, then we need to specify the actual item, and we have a bunch of other options. But we'll go down to examples here. And you can see that we have AWS DynamoDB put item, table name, and the actual item itself. And then we also have return consume capacity. I don't know if we need that. Let's just take a look and read about it. Determines the level of detail about provision throughput consumption that is returned. So this is just going to give us additional information about actual consume capacity. I think that's a good idea. We could check out what kind of capacity is being used up. So we'll go back to the top here, go to examples, but this is obviously optional. And we're going to copy this command here and we'll paste this here. And then I'm just going to make this a single line to make our lives a little bit easier. This one's a little bit long, but it's not that bad. And we will make a new file called item. And we need to grab the name of the table again, Starships. And we need to fill out that item file. So we will open that up. And we will take a look at what that would look like. So that's an example of the file. So let's grab this example here. And what we'll do is we need to go get this record again. So we deleted what was the name of the file. We'll go back to the key here. It's Excelsior type Okinawa, I assume. It's this record here. So I'm just going to grab this data here. Grab the whole row. And we will go back to the item file here. Paste it on down here. And then we just need to name all these. We'll grab the names from here. Just going to do a refresh. So we have ship class. Then we have registry. Whoops. Then we have description. Not really doing it in any particular order. And then we have name. The order doesn't matter as long as you get all the information in. And so this is the name of the ship. This is the registry number. This is the ship class. And then this is the description. We will save that. And so that should be what we need to get this to work. So I'm going to copy this file here. We're going to paste it in on there. And we have an error, hyphen, item, expecting a comma delimiter. So maybe we made a minor mistake in our item file here. Yeah, we don't have a comma on the end here. And we'll go back, hit up, hit enter. And there you go. And it told us how many capacity units it consumed, which was 1 write capacity unit. So, I mean, that could be good if you need to do something pragmatic and make sure you're not over consuming. But let's go see if that record now exists in the table. So we'll just do a query here. We'll go back to here. Actually, we could just use a get item to do that. That'd be probably smarter. So I'm just going to copy this here, paste that in. Yep, so the record is back. So now that we know how to put an item, let's talk about how we would actually go ahead and update an item next. So let's see how we can update an item in DynamoDB. So I'm going to type in update item. Of course, I think you could just edit from here, right? But that's not what we're going to do. We're going to use the CLI, of course. And we'll make our way over to the, we'll fix this file first here, refresh. Click back into there. We'll go back to the CLI here, go all the way to the top, DynamoDB, and we'll look for put item. And so put item here, we'll scroll down. We have put item, table name, you provide the item, and then we have a bunch of other values. I'm certain that this one is not a simple one. If we go to the example here, no, it's not that bad. It's just, oh, sorry. we're not creating an item. We're going to update an item. I'm sorry. We've already done put item. We want to update an item. And so we have update item, table name, key, and then we have a bunch of other stuff. Let's go look at the example. And here you can see it's a lot more complicated. I don't know why it's such a pain, but this is what it is. So I'm going to grab that on here, and we will paste our example here. And this is big. Rename this to Starships. We'll leave this as key. Yeah, we'll update the existing file we have, and we'll talk about these values here. So the first one is update expression. So we'll take a look at here, update expression. An expression that defines one or more attributes to be updated. The action can be performed on them and the values for them. So that is what we're actually going to update. And if we look down below, it should give us examples on how we can write these expressions. Not a lot of information here. But I know what we need to do here. So we'll go here, and we can see that we have this set value here. The next one is the expression attributes names. One or more substitution tokens for attribute names in an expression. The following are some use cases. And so it could be when there's reserved words or placeholder or special characters. So this is just like a remapping of characters. This doesn't make sense. Don't worry, it will once we work through this example. One or more values that can be substituted in an expression. Okay, so, you know, I don't feel like it's the best explanation, but it makes sense when we go through it. So What we'll do is we're going to need a expressions attributes names file, expressions attributes value file, and we already have this file here. So I'm just going to copy these names here, make our way back to Cloud9, and I'm going to make this new file in our playground. So that's one, and then we'll go back here and we will grab the other one. And that's two. And so for names, what it suggests is this. And then for this one here, we have the values. So the way this works is it allows you to remap values. So if we just go back to this example here, notice that in the names, or sorry, the values is the values that we want to update. So here we're saying this number should now be 2015. This string should now be louder than ever. And then we have this :y and :t. And this :y and :t is just like a representation of that actual character. Then in the update expression, what it's doing, it's reassigning it, saying, so make :y into $y. And then if we look at our expression names, $y equals year and $at equals album attribute. If it seems like a lot of roundabout, it does feel that way, but it's allow you to get flexibility so you don't run into issues like with reserved words or special characters. And we could pare this down, but let's actually try to do this in full with the example that they have here. So making our way back here, the first thing I'm going to do is go back to our scratch pad. I'm going to just change this set value. We only need, let's only change the description and make our lives a little bit easier here. I'm going to call this :d, and we'll save that there. And the next thing we'll do is go back to our expressions, and I'm going to call this #d. That's going to be description. Whoops, can't see what I'm doing. Description. And then we will just take out the second one here. We'll make our way over to values. I'm going to change this to :d. This is going to be a string. I'm going to get rid of the second value. And what we're going to do is just shorten the item. So we'll go back to item. And so this is the string here. And I'm just going to change it here. So it says ship commanded by Admiral James Layden on which Benjamin Sisko served. I'm just going to take off the end here. Or maybe I'll just serve as XO. That means the same thing as first officer. Okay, and what we'll do is we'll go back to our scratch pad and we will copy all the stuff. It also has this return values thing, so let's take a look at that before we move on. Use return values if you want to get the item attributes as they appear before or after they are updated. So none is if returns values if not specified. All old, so return all the attributes of the item, return only the updated attributes, return all the new attributes of the items, and etc. And this kind of stuff is kind of important when we get into DynamoDB streams because you can do the old or the new. In this case, I guess we're doing all, and all seems fine to me. It's just an example. That's all we're doing here. And what we'll do is we'll just copy this here. Fingers crossed this works first time. And we got data back, and it says as XO. So that looks great to me. And what we'll do is we'll just make sure that it has been changed. We'll use our get item up here. And it has been updated. So there you go. That is update item. So now that we've learned how to get, put, delete, let's look at the scan and query options next. So let's first look at scan because scan is a lot easier to understand. And there's a lot less going on there. So if we go over here, we can see we have a query and a scan option. Now, if you created a table without a sort key, you'd only be able to scan. But we'll go to scan here and we'll look at what options we have. So the way scan works is that it returns all the records and then you can apply filters after it's returned those records and then filter out what you want. So if you have a very large table, thousands upon thousands of records, that's not very efficient. So generally you always want to use query when you can, but if you don't have a need to have a sort key, then you could have a table that just has scan. But anyway, if we scan and we hit start, it returns everything. And if we want to filter stuff out, we could choose anything we want here. I could say ship class. We'll say Luna. We'll hit start search. And we have some other options here, like begin with, contains with, all these kind of options here that we can use to filter. But just understand that even though we filtered this out, it's already returned all 100 records, and then it filters them out and returns it. So we're using up a lot of capacity when we're doing that. But let's look at how we can do this via the CLI. So we'll go back to the top here, and we will look for scan. And I feel like scan would have a lot of options. Oh yeah, it has tons of options. Tons of options. We can segment stuff. We can do page size, all sorts of things. But let's go down and look at the example here. And this is the example that we are given. It looks a lot similar to the put item one here. And we're just going to do something simple. So we'll do starships. And I'm thinking for this, what we'll do is we will filter out the description for something. So I'm going to go back here to the front here. Let's say we want to get this record or something that starts with science. Maybe something more common would be nice. Maybe destroyed. So we'll look for all the records that start with destroyed, with the description. So I'll go back here, and what I'm going to do is I'm going to think about this for a second. For the scan, I don't need to project anything. These are records that we get back. Remember, projection is if we just want to cherry pick what we want. For the filter expression, we're just going to do a begins with. So I'm going to do begins with. And for this, it's going to be description. I'm just going to do :D here. And then down below, we need to specify our names. Actually, we don't need any names because we are not remapping anything. Remember, we did that before. We did this remapping. It's just extremely verbose. We don't need to do that. And I'm just going to do curlies here. And I'm going to do quotations, :D, colon, curlies, and we're going to make it a string. And then I just want it to return destroyed. So I just want you to notice that we didn't have to extract this out as a JSON file. We can write them in line like this, and it makes things a lot easier for us. But you're probably wondering what this begins with thing is. So let's go take a look back at scan and specifically look at these filtered expressions. So if we just hit enter there, if we click onto this tab here, I think it'll give us more information about it. So down below, it shows you can do equals, these symbols, and then we have begins with. This maps all with this kind of stuff here. But so begins with, in order to use it, we have to write that, and then A, and then substitute whatever the thing is. And that's what we've done. We've said we want the column description replaced with :D, and :D is going to be destroyed. So anything that begins with destroyed. So let's give this a go and see if it works. We'll hit enter. I'm expecting property enclosed with double quotation. So I've clearly made a mistake here. It's a little bit hard to see. It's because I'm using doubles on the outside. I'm going to use singles on the outside. We're just having a conflicts of quotations. And there we go. We got a lot of records back. This is a little bit of a mess to look at. I'm going to go and try output. I don't know why. I'm going to try table. No, no good. You'd think they'd make that actually look like a table. We'll go to text. That's a little bit easier to see. And we can see we're getting all the records back that are destroyed. So that is for scan. Now let's take a look at how to use query. Okay, so we'll take a look here now at query. So if we make our way over to the our actual table here where we can visualize it, we'll go over to query. And with query, you have to specify the partition. I think a sort key is optional. Let's take a look. So if I just wanted Luna, I'm just going to click off the filter here. That's going to give us that. And then if we want to narrow it down further, I can grab the registry here and we'll hit equals. But the difference here is that it's only returning these records. It's not returning all 1,000 or 100 records. And then you can apply filters after the fact. So I could even filter this further and just say a description. And if the string begins with the. It's obviously going to do that. And then you have projected columns here. We'll hit start. Can only be used when querying with an index name. Okay, I don't know. But anyway, the point is that that you need to know is that you have a partition key, and you can optionally add that, or sorry, you have to add that, and then you have an optional sort key, and these are your options, and then you can again filter further, and you could even specify these if you want again, but that'd be a bit silly to do. But let's learn how to do a query using the CLI. So we'll go down here, type the word query, and we will make our way over to the documentation and type in query. And query probably has a lot of options. Holy smokes, look at all those options. We're not going to go all through all of them. I'm going to go down to the examples, and this is the example that it gives us. So we have DynamoDB query, table name, projection, expression, and then we have this one called key condition expression. This one is different. And also this expression attributes value. We had that before. But if we go here and just take a look at this, what this does. The condition that specifies the key values for items being retrieved by query action. So what this is saying is you're pretty much just providing these values here. So this part right here, see this? That's what we're doing with that attribute there. So we'll just go grab our example here, save ourselves some trouble, make our way back here, and we're going to specify starships. And in this case, we need to, we're not going to project any values, but I'm just going to cut that out because I should show you that at least once, how to do that. And for this, we're going to do ship class, and it's just going to equal :C. And I'm just going to do this inline because I just want to make this super easy for us. We'll do curlies. Single quotations. We learned our lesson last time. We should make these singles on the outside. And we'll do doubles, :C, curlies, doubles, S for string, and let's filter out for galaxy. I know that's a type of starship in Star Trek. So if we do this, we copy that there, hit enter, we get some values. So there you go. That's all the galaxy ones. We can go up, output, and do text here, make our lives a bit easier. It's a bit easier to read. Let's say we just wanted to get the registry number. Paste that in there. And I'm just going to change this to output text. Oops, did not like that. Need a backslash on the end there. Holy smokes. Output, it's output. Oh, it doesn't like the projection expression that I put in there. I'm pretty certain that we can do that. Yeah, go to the example here. This one has one in it. Oh, you know what? Because I named it all caps. It has to be the name of what the actual field is. You can't just put all caps. My mistake. Try this again. Maybe I should go a little bit slower here. So I'm just going to, sometimes when you have these issues with this, a smart thing to do is just make it a single line. Those backslashes can be tricky sometimes. There we go. So I don't know, I had some kind of error in here, syntax. Maybe I didn't have a backslash there. I didn't have a trailing space after it. It was messing up. But that's always a trick that you can use to fix your queries. And I'm just going to hit enter there and just clean this up a little bit. Not that we need to do anything else here, but let's just make sure that it works this way. I'm going to try this one more time. There you go. So yeah, that is the query. Maybe we just take a look here and look at if there's any other important fields that we glazed over. Scan index forward is a great way of flipping things the other way. So if you did scan index forward, we'll just play around with some of these settings. Why not? So look at the order that it's in right now. So the D is first. If I put that in there and I say false, I think it's all caps for this. Hit enter. False. I should really just read it, but I'm pretty sure. Nah, I have to read it. I was pretty sure that it's just like false or true. I need an example. I can't tell. Oh, sorry. It's just scan forward index or no scan forward index. You don't actually provide it a value. So if I paste that in there, I think that's all we have to do. Yeah, so there it's in the opposite order. And so if you want it to be the default there, you could do it the other way. Right? Let's look at if there's any other values of interest here. We looked at projection there. No, I'd say that's pretty good. So now we are all done here for this. And I think we'll just take a look at the Transact CLI stuff next here. We're not going to do them because they're a little bit more work to set up, but it's good to know how they work. So let's just take a quick look here at transactional API calls for DynamoDB. We have the get and the write. We're not going to set these up. It's a lot of work to do so. It's just good to conceptually know what you can do here and just to see how it's specified. So transact get items, synchronous operations that automatically retrieves multiple items from one or more tables. That's the key thing, one or more tables. And the idea is that if any of these things happen, then the entire transaction will roll back. This is really good when you have sensitive information that that could be committed that relies on multiple things. Same with gets and writes. But if we go to examples down below here, we can see that it's AWS DynamoDB transact get items, and then you provide the items that you want. So in here, it looks like it's actually the same table, and it's saying that we want both of these records. And if there is a failure on one or the other when grabbing this information, it's going to roll back. So it has to get all the information or none of it. Let's go take a look at the writes. This is very similar. This is when you have a write condition, and there is a lot of stuff going on here. You probably want to read through all this. It's probably a good idea. A condition in one or more expression is not met. An ongoing operation of the process updating at the same time. This one's a very important one where you have two updating at the same time. There is insufficient provision capacity. An item size becomes too large. The size of items exceeds 4 megabytes. There is a user error. We're going to go up here at the top, look at the example. And again, it's very similar, and you could specify different tables here. So this is really good for cross-table writes. But you can see there's a lot of information here. So just be aware of transact write items and get items, and just consider that everything must be successful in order for them for it to do the gets or the writes, and it's cross-table. So we are almost done, but we only need to learn one more CLI command, and this is to clean up the entire project, and that is the delete table command. So we're going to go ahead and delete our table. Now we could just go in here and hit delete table, but that's not fun. Let's use the CLI. So we're going to go delete table, and we'll look at the example. I think it's just as simple as that. Yep, it's that simple. If you delete through here, it would ask you to, like, maybe you might want to back it up. We do not want to back this table up. We want it gone. And I'm going to type in Starships here, and we'll hit enter there. And now you can see that it is deleting. If we want to get an update, we can go over here and see that it is deleting. Might already be gone. Oh, it's already gone. And if it was taking time to delete, we could use the describe command to give it a look here. And we can see that nothing is being returned because there is no longer a table. So there you go. That is the DynamoDB run through. If you have more time on your own, you might want to try to set up a DynamoDB stream. Those are kind of interesting to see. I'm just going to type in Starships again here. You don't have to do any of this. I'm just going through it just so I can show you DynamoDB streams here. Ship class, registry. So DynamoDB streams, once this table creates, we'll give it a second. If you want to set those up, it's under triggers. You create a trigger, you'd create a existing function. And the idea here is whenever new records come into the database, it will call that Lambda function. And then from that Lambda function, you can then send it to wherever you want. Generally, you'd send it to Kinesis Firehose or some Kinesis service. but that's just a way to react to data in here. But yeah, this is outside the scope of the developer associate. It's kind of a stretch goal if you want a little personal project to do. But our table is deleted. I'm just going to go delete it here, and you can see that it says create a backup before deleting. We're not going to do that. But yeah, that's DynamoDB there. So there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at Elastic Compute Cloud EC2, which is a cloud computing service. So choose your OS, storage, memory, network throughput, and then launch an SSH into your server within minutes. All right, so we're on to the introduction to EC2. And so EC2 is a highly configurable server. It's a resizable compute capacity. It takes minutes to launch new instances, and anything and everything on AWS uses EC2 instance underneath. So whether it's RDS or ECS or Simple System Manager, I highly believe that at AWS, they're all using EC2, okay? And so we said they're highly configurable. So what are some of the options we have here? Well, we get to choose an Amazon machine image, which is going to have our OS. So whether you want Red Hat, Ubuntu, Windows, Amazon Linux, or SUSE, then you choose your instance type. And so this is going to tell you like how much memory you want versus CPU. And here you can see that you can have very large instances. So here is one server that costs $5 a month, and here you have one that's $1,000 a month, and this one has 36 CPUs and 60 gigabytes of memory with 10 gigabyte performance. Okay, then you would add your storage, so you could add EBS or EFS, and we have different volume types we can attach, and then you can configure your instance so you can secure it and get your key pairs. You can have user data, IAM roles, and placement groups, which we're all going to talk about starting now. Right, so we're going to look at instance types and what their usage would be. So generally when you launch an EC2 instance, it's almost always going to be in the T2 or the T3 family. And yes, we have all these little acronyms which represent different types of instance types. So we have these more broad categories, and then we have subcategories or families of instances that are specialized, okay? So starting with general purpose, it's a balance of compute and compute memory and networking resources. They're very good for web servers and code repositories. So you're gonna be very familiar with this level here. Then you have compute optimized instances. So these are ideal for compute bound applications that benefit from high performance processors. And as the name suggests, since this is compute, it's going to have more computing power, okay? So scientific modeling, dedicated gaming servers, and ad server engines. And notice they all start with C, so that makes it a little bit easy to remember. Then you have memory optimized, and as the name implies, it's going to have more memory on these servers. So fast performance for workloads that process large data sets in memory. So use cases in memory caches, in memory databases, real-time big data analytics. Then you have accelerated optimized instances. These are utilizing hardware accelerators or coprocessors. They're going to be good for machine learning, computational finance, seismic analysis, speech recognition. Really cool future tech, uses a lot of accelerated optimized instances. And then you have storage optimized. So this is for high sequential reads and write access to very large data sets on local storage. So use cases might be a NoSQL database, in-memory or transactional databases, or data warehousing. So how important is it to know all these families? It's not so important at the associate track. At the professional track, you will need to know them. So all you need to know are these general categories and just kind of remember which fits into where and just their general purposes. All right. So in each family of EC2 instance types, so here we have the T2, we're going to have different sizes. And so we can see small, medium, large, X large. And I just wanted to point out that generally the way the sizing works is you're going to always get double of whatever the previous one was. Generally, I say generally because it does vary. But the price is almost always double, okay? So from small to medium, you can see the RAM has doubled, the CPU has doubled, but for medium large, it isn't exactly doubled, but for here, the CPU has doubled, okay? But the price definitely has doubled almost nearly. So it's almost always twice in size. So general rule is if you're wondering when you should upgrade, if you need 2 of something, then you're better off just going to the next version up, okay? We're going to look at the concept called instance profile, and this is how your EC2 instances get permissions, okay? So instead of embedding your AWS credentials, your access key and secret in your code, so your instance has permissions to access certain services, you can attach a role to an instance via an instance profile, okay? So the concept here is you have an EC2 instance, and you have an instance profile, and that's just a container for a role, and then you have the role that actually has the permissions, all right? And so I do need to point out that whenever you have the chance to not embed AWS credentials, you should never embed them, okay? That's like a hard rule with AWS. And anytime you see an exam question on that, definitely always remember that. The way you set an instance profile to an EC2 instance, if you're using the wizard, you're going to see the IAM role here. And so you're going to create one and then attach it. But there's one thing that people don't see is they don't see that instance profile because it's kind of like this invisible step. So if you're using the console, it's actually going to create it for you. If you were doing this pragmatically through CloudFormation, you'd actually have to create that instance profile. So sometimes people don't realize that this thing exists, okay? We're going to take a look here at placement groups. So placement groups let you choose the logical placement of your instances to optimize for communication, performance, or durability. And placement groups are absolutely free and they're optional. You do not have to launch your EC2 instance within a placement group, but you do get some benefits based on your use case. So let's first look at clustered. So clustered packs instances close together inside an AZ. And they're good for low latency network performance for tightly coupled node-to-node communication. So when you want servers to be really close together, so communication is super fast. And they're well suited for high performance computing, HPC applications, but clusters cannot be multi-AZ, all right? Then you have partitions. And so partitions spread instances across logical partitions. Each partition does not share the underlying hardware. So they're actually running on individual racks here for each partition. They're well suited for large distributed and replicated workloads such as Hadoop, Cassandra, and Kafka, because these technologies use partitions, and now we have physical partitions. So that makes total sense there. Then you have spread. And so spread is when each instance is placed on a different rack. And so when you have critical instances that should be kept separate from each other, this is the case where you'd use this, and you can spread a max of 7 instances, and spreads can be multi-AZ, okay? Whereas clusters are not allowed to go multi-AZ. So there you go. So user data is a script which will automatically run when launching an EC2 instance. And this is really useful when you want to install packages or apply updates or anything you like before the launch of an instance. And so when you're going through the EC2 wizard, there's this advanced details step where you can provide your bash script here to do whatever you like. So here I have it installing Apache, and then it starts that server. If you were logging into an EC2 instance and you didn't really know whether a user data script was performed on that instance on launch, you could actually use the this URL at 169.24, 169.24. If you were to curl that within that EC2 instance with user data, it would actually return whatever script was run. So that's just good to know. But yeah, user data scripts are very useful, and I think you will be using one soon enough. So metadata is additional information about your EC2 instance, which you can get at runtime, okay? So if you were to SSH into your EC2 instance and run this curl command with latest metadata on the end, you're gonna get all this information here. And so the idea is that you could get information such as the current public IP address or the AMID that was used to launch these two instances, or maybe the instance type. And so the idea here is that by being able to do this pragmatically, you could use a bash script. You could do something with user data and metadata to perform all sorts of advanced AWS staging operations. So yeah, metadata is quite useful and great for debugging. So yeah. Time to look at the EC2 cheat sheet here, so let's jump into it. So Elastic Compute Cloud EC2 is a cloud computing service. So you configure your EC2 by choosing your OS, storage, memory, and network throughput, and other options as well. Then you launch an SSH into your server within minutes. EC2 comes in a variety of instance types specialized for different roles. So we have general purpose, that's for balance of compute, memory, and network resources. You have compute optimized, as the name implies. You're going to get more computing power here, so ideal for compute-bound applications that benefit from high-performance processors. Then you have memory optimized, so that's fast performance for workloads that process large data sets in memory. Then you have accelerated optimized, that's hardware accelerators or co-processors. Then you have storage optimized, that's high sequential read and write access to very large data sets on local storage. Then you have the concept of instance sizes. And so instance sizes generally double in price and key attributes. So if you're ever wondering when it's time to upgrade, just think when you need double of what you need, that's time to upgrade. Then you have placement groups, and they let you choose the logical placement of your instances to optimize communication performance, durability, and placement groups are free. It's not so important to remember the types because I don't think it'll come up in the Solution Architect Associate. And then we have user data. So a script that will be automatically run when launching the EC2 instance. For metadata, metadata is about the current instance. So you could access this metadata via a local endpoint when SSHing into an EC2 instance. So you have this curl command here with metadata. And metadata could be the instance type, current IP address, etc., etc. And then the last thing is instance profiles. This is a container for an IAM role that you can use to pass role information to an EC2 instance when the instance starts. All right, so there you go. That's the EC2 cheat sheet. Hey, this is Andrew Brown from ExamPro, and we are looking at Virtual Private Cloud, known as VPC. And this service allows you to provision logically isolated sections of your AWS cloud where you can launch AWS resources in a virtual network that you define. So here we are looking at an architectural diagram of a VPC with multiple networking resources or components within it. And I just want to emphasize how important it is to learn VPC and all its components inside and out, because it's for every single AWS certification, with the exception of the Cloud Practitioner. So we definitely need to master all these things. So the easiest way to remember what a VPC is for is think of it as your own personal data center. It gives you complete control over your virtual networking environment. All right, so the idea is that we have internet, it flows into an internet gateway, it goes to a router, the router goes to a route table, the route table passes through a NACL, and the NACL sends the traffic to the public and private subnets, and your resources could be contained within a security group, all within a VPC. So there's a lot of moving parts, and these are not even all the components, and there's definitely a bunch of different configurations we can look at. So looking at the core components, these are the ones that we're going to learn in depth, and there are a few more than these, but these are the most important ones. So we're going to learn what an internet gateway is, we're going to learn what a virtual private gateway is, route tables, NACLs, security groups, public and private subnets, NAT gateway and instances, customer gateway, VPC endpoints, and VPC peering. So this section is very overwhelming, but you know, once you get it down, it's pretty easy going forward. So we just need to master all these things and commit them to memory. So now that we kind of have an idea what's the purpose of a VPC, let's look at some of its key features, limitations, and some other little things we want to talk about. So here on the right hand side, this is the form to create a VPC, and it's literally 4 fields. It's that simple. You name it, you give it an address. You can also give it an additional IPv6 address. You can't be, or it's either this and this. And you can set its tendencies to default or dedicated. Dedicated meaning that it's running on dedicated hardware. If you're an enterprise, you might care about that. This is what the IPv6 CIDR block would look like because you don't enter it in. Amazon generates one for you. So VPCs are region specific. They do not span regions. You can create up to 5 VPCs per region. Every region comes with a default VPC. You can have 200 subnets per VPC. That's a lot of subnets. You can create, as we said here, an CIDR block. You actually have to create one. It's a requirement. And in addition to, you can provide an IPv6 CIDR block. It's good to know that when you create a VPC, it doesn't cost you anything. That goes the same for route tables, NACLs, internet gateways, security groups, subnets, and VPC peering. However, there are resources within a VPC that are going to cost you money, such as NAT gateways, VPC endpoints, VPN gateways, customer gateways. But most of the time, you'll be working with the ones that don't cost any money, so that there shouldn't be too much of a concern of getting overbilled. One thing I do want to point out is that when you do create a VPC, it doesn't have DNS host names turned on by default. If you're wondering what that option is for, what it does is when you launch EC2 instances, and so here down below I have an EC2 instance, and it will get a public IP, but it will only get a public DNS, which looks like a domain name, like an address, and that's literally what it is. But if this isn't turned on, that EC2 instance won't get one. So if you're wondering, why isn't that there? It's probably because your host names are disabled, and they are disabled by default. You just got to turn them on. So we were saying earlier that you get a default VPC for every single region, and the idea behind that is so that you can immediately launch EC2 instances without having to really think about all the networking stuff you have to set up. But for AWS certification, we do need to know what is going on, and it's not just a default VPC. It comes with other things and with specific configurations, and we definitely need to know that for the exams. So the first thing is it creates a VPC of CIDR block size 16. We're going to also get default subnets with it. So for every single AZ in that region, we're going to get a subnet per AZ, and they're going to be CIDR block size 20. It's going to create an internet gateway and connect it to your default VPC. So that means that our EC2 instances can reach the internet. It's going to come with a default security group and associated with your default VPC. So if you launch an EC2 instance, it will automatically or default to this security group unless you override it. It will also come with, by default, a NACL and associate that with your VPC. It'll also default DHCP options. One thing that it's implied is that it comes with a main route table. Okay, so when you create a VPC, it automatically comes with a main route table. So I would assume that comes by default as well. So there are all the defaults for you. So I just wanted to touch on this 0.0.0/0 here, which is also known as default. And what it is it represents all possible IP addresses, okay? And so, when you're doing AWS networking, you're going to be using this to get the IGW to have a route, like routing traffic to the IGW to the internet. When you're using a security group, when you set it for your inbound rules, you're going to set 0.0.0/0 to allow any traffic from the internet to access your public resources. So anytime you see this, just think of it as giving access from anywhere or the internet, okay? We're looking at VPC peering, which allows you to connect one VPC to another over a direct network route using private IP addresses. So the idea is we have VPC A and VPC B, and we want to treat it so like they behave like they're on the same network, and that's what VPC peering connection allows us to do. So it's very simple to create a peering connection. We just give it a name. We say what we want as the requester, so that could be VPC A, and then we want as the acceptor, which could be VPC B, and we can say whether it's in my account or another account or this region or another region. So you can see that it allows VPCs from same or different regions to talk to each other. There is some limitations around the configuration. So, when you're peering, you're using star configuration. So you'd have one central VPC, and then you might have 4 around it. And so for each one, you're going to have a peering connection. There's no transitive peering. So what does that mean? Well, the idea is like, let's say VPC C wants to talk to VPC B. The traffic's not going to flow through A. You actually would have to create another direct connection from C to B. So it's only to the nearest neighbor where that communication is going to happen. And you can't have overlapping CIDR blocks. So if these had the same CIDR block, if this was 172.31 and this was 172.31, we're going to have a conflict and they're not going to be able to talk to each other. So that is the VPC peering in a nutshell. All right, so we're taking a look here at route tables. So route tables are used to determine where network traffic is directed, okay? And so each subnet in your VPC must be associated with a route table, and a subnet can only be associated with one route table at a time, but you can associate multiple subnets with the same route table. All right, so now down below I have just like the most common example of where you're using route tables, and that's just allowing your EC2 instances to gain access to the internet. So you would have a public subnet where that EC2 instance resides, and that's going to be associated with a route table, and that route table is going to have routes in here. And here you can see we have a route which has the internet gateway attached that allows access to the internet, okay? So there you go. That's all there is to route table. Taking a look at Internet Gateway. An Internet Gateway allows your VPC access to the internet, and IGW does two things. It provides a target in your VPC route tables for internet routable traffic, and it can also perform network address translation, NAT, which we'll get into in another section, for instances that have been assigned a public IPv4 address, okay? So down below here I have a representation of how IGW works. So the idea is that we have internet over here, and to access the internet, we need an internet gateway. But to route traffic from our EC2 instances or anything, they're going to have to pass through a route table to get to our router. And so we need to create a new route in our route table for the IGW. So IGW-ID identifies that resource, and then we're going to give it 0.0.0.0 as the destination. All right, so that's all there is to it. So we talked about how we could use NAT gateways or NAT instances to gain access to the internet for our EC2 instances that live in a private subnet. But let's say you wanted to SSH into that EC2 instance. Well, it's in a private subnet, so it doesn't have a public IP address. So what you need is you need an intermediate EC2 instance that you're going to SSH into, and then you're going to jump from that box to this one, okay? And that's why Bastions are also known as jump boxes. And this EC2 instance for the Bastion is hardened, so it should be very, very secure because this is going to be your point of entry into your private EC2 instances. And some people might always ask, well, if a NAT instance, like NAT gateways, we can't obviously turn into Bastions, but a NAT instance is just an EC2 instance. Couldn't you have it double as a Bastion? And the possibility of it is possible, but generally with the way you configure NATs and also from a security perspective, you'd never ever want to do that. You'd always want to have a different EC2 instance as your Bastion. Now, there is a service called Sessions Manager, and it replaces the need for Bastions so that you don't have to launch your own EC2 instances. So generally that's recommended in AWS, but you know, Bastions are still being commonly used throughout a lot of companies because it needs to meet whatever their requirements are, and they're just comfortable with them. So there you go. So we're going to take a look at Direct Connect, and Direct Connect is an AWS solution for establishing dedicated network connections from on-premise locations to AWS. It's extremely fast, and so depending on what configuration you get, if it's in the lower bandwidth, we're looking between 50 megabytes to 500 megabytes, or the higher bandwidth is 1 gigabytes to 10 gigabytes. So the transfer rate to your on-premise environment, the network to AWS, is considerably fast. And this can be really important if you are an enterprise and you want to keep the same level of performance that you're used to. So yeah, the takeaway here with Direct Connect is that it helps reduce network costs, increase bandwidth throughput. It provides a more consistent network experience than a typical internet-based connection, okay? So that's all you need to do. Hey, this is Andrew Brown from ExamPro, and we are looking at auto-scaling groups. So auto-scaling groups lets you set scaling rules which will automatically launch additional EC2 instances or shut down instances to meet the current demand. So here's our introduction to auto-scaling groups. So auto-scaling groups, abbreviated to ASG, contains a collection of EC2 instances that are treated as a group for the purpose of automatic scaling and management. And automatic scaling can occur via capacity settings, health check replacements, or scaling policies, which is going to be a huge topic for us here. So the simplest way to use auto-scaling groups is just to work with the capacity settings with nothing else set. And so we have desired capacity, min, and max. Okay, so let's talk through these three settings. So for min is how many EC2 instances should at least be running. Okay, max is the number of EC2 instances allowed to be running. And desired capacity is how many EC2 instances you ideally want to run. So when min is set to 1, and let's say you had a new auto-scaling group and you launched it and there was nothing running, it would spin up 1. And if that server died for whatever reason, because when it was unhealthy or it just crashed for whatever reason, it's always going to spin up at least 1. And then you have that upper cap where it can never go beyond 2 because auto-scaling groups could trigger more instances. And this is like a safety net to make sure that, you just don't have lots and lots of servers running. And desired capacity is what you ideally want to run. So ASG will try to get it to be that value. But there's no guarantee that it will always be that value. So that's capacity setting. So another way that auto-scaling can occur with an auto-scaling group is through health checks. And down here, we actually have two types. We have EC2 and ELB. So we're going to look at EC2 first. So the idea here is that when this is set, it's going to check the EC2 instance to see if it's healthy. And that's dependent on these two checks that's always performed on EC2 instances. And so if any of them fail, it's going to be considered unhealthy, and the auto-scaling group is going to kill that EC2 instance. And if you have your minimum capacity set to 1, it's going to then spin up a new EC2 instance. So that's the EC2 type. Now let's go look at the ELB type. So for the ELB type, the health check is performed based on an ELB health check. And the ELB can perform a health check by pinging an endpoint on that server. It could be HTTP or HTTPS, and it expects a response. And you can say, I want a 200 back at this specific endpoint. So here, that's actually what we do. So if you have a web app, you might make a HTML page called health check, and it should return 200. And if it is, then it's considered healthy. If that fails, then the auto-scaling group will kill that EC2 instance. And again, if your minimum is set to 1, it's going to spin up a healthy new EC2 instance. The final and most important way scaling gets triggered within an auto-scaling group is scaling policies. And there's 3 different types of scaling policies. And we'll start with target tracking scaling policy. And what that does is it maintains a specific metric at a target value. What does that mean? Well, down here, we can choose a metric type, and so we'd say average CPU utilization. And if it were to exceed our target value, and we'd set our target value to 75% here, then we could tell it to add another server, okay? Whenever we're adding stuff, that means we're scaling out. Whenever we are removing instances, removing servers, then we're scaling in, okay? The second type of scaling policy is simple scaling policy. And this scales when an alarm is breached. So we create whatever alarm we want, and we would choose it here, and we can tell it to scale out by adding instances or scale in by removing instances. Now, this scaling policy is no longer recommended because it's a legacy policy, and now we have a new policy that is similar but more robust to replace this one. You could still use it, but it's not recommended, and it's still in the console. But let's look at the one that replaces it, called scaling policies with steps. So same concept, you scale based on when an alarm is breached, but it can escalate based on the alarm's value, which changes over time. So before, where you just had a single value, here we could say, well, if we have this this alarm and the value is between 1 and 2, then add 1 instance. And then when it goes between 2 and 3, then add another instance. Or when it exceeds 3 to beyond, then add another instance. So you can, it helps you grow based on that alarm as it changes, okay? So earlier I was showing you that you can do health checks based on ELBs, but I wanted to show you actually how you would associate that ELB to an auto-scaling group. And so we have classic load balancers, and then we have application load balancer and network load balancer. So there is a bit of variation based on the load balancer, how you would connect it, but it's pretty straightforward. So in the auto scaling group settings, we have these two fields, classic load balancers and target groups. And for classic load balancers, we just select the load balancer and now it's associated. So it's as simple as that. It's very straightforward. But with the new way is that there's a target group that's in between the auto scaling group and the load balancer. So you're associating the target group. And so that's all there is to it. So that's how you associate. So to give you the big picture on what happens when you get a burst of traffic and auto-scaling occurs, I just wanted to walk through this architectural diagram with you. So let's say we have a web server and we have one EC2 instance running, okay? And all of a sudden we get a burst of traffic, and that traffic comes into Route 53. Route 53 points to our application load balancer. Application load balancer has a listener that sends the traffic to the target group, and we have this EC2 instance which is associated with that target group. And we have so much traffic that it causes our CPU utilization to go over 75%. And once it goes over 75%, because we had a target scaling policy attached that said anything above 75%, spin up a new EC2 instance, that's what the auto scaling group does. And so the way it does it is it uses a launch configuration, which is attached to the auto scaling group, and it launches a new EC2 instance. So that's just to give you the like a full visibility on the entire pipeline of how that actually would work. So when you have an auto scaling group and it launches an EC2 instance, how does it know what configuration to use to launch that new EC2 instance? And that is what a launch configuration is. So when you have an auto scaling group, you actually set what a launch configuration you want to use. And a launch configuration looks a lot like when you launch a new EC2 instance. So you go through and you'd set all of these options, but instead of launching an instance at the end, it's actually just saving the configuration. Hence, it's called a launch configuration. A couple of limitations around launch configurations that you need to know is that a launch configuration cannot be edited once it's been created. So if you need to update or replace that launch configuration, you need to either make a new one, or they have this convenient button to clone the existing configuration and make some tweaks to it. There is something also known as a launch template, and they are launch configurations but with versioning. And so it's AWS's new version of launch configuration. And you know, generally when there's something new, I might recommend that you use it. But it seems so far that like most of the community still uses launch configuration. So the benefit of versioning isn't a huge, doesn't have a lot of value there. So you know, I'm not pushing you to use launch templates, but I just want you to know the difference, because it is a bit confusing because you look at it and it looks like pretty much the same thing, and it just has versioning. In here, and we can review the auto scaling group cheat sheet. So an ASG is a collection of EC2 instances grouped for scaling and management. Scaling out is when you add servers. Scaling is when you remove servers. Scaling up is when you increase the size of an instance. So like you'd update the launch configuration with a larger size. The size of an ASG is based on the min, max, and desired capacity. Target scaling policy scales based on when a target value of a metric is breached. So example, average CPU utilization exceeds 75%. Simple scaling policy triggers a scaling when an alarm is breached. Scaling policy with steps is the new version of simple scaling policy and allows you to create steps based on escalation alarm values. Desired capacity is how many EC2 instances you want to ideally run. An ASG will always launch instances to meet the minimum capacity. Health checks determine the current state of an instance in an ASG. Health checks can be run against either an ELB or an EC2 instance. When an auto scaling group launches a new instance, you use a launch configuration which holds the configuration values of that new instance. For example, maybe the AMI, instance type, or role. Launch configurations cannot be edited and must be cloned or a new one created. Launch configurations must be manually updated by editing the auto scaling group settings. So there you go. And that's everything with auto scaling. We're looking at VPC endpoints, and they are used to privately connect your VPC to other AWS services and VPC endpoint services. So I have a use case here to make it crystal clear. So imagine you have an EC2 instance and you want to get something from your S3 bucket. So what you normally do is you use the AWS SDK and you would make that call, and it would go out of your internet gateway to the internet back into the AWS network to get that file or object out of S3. So wouldn't it be more convenient if we could just keep the traffic within the AWS network? And that is the purpose of a VPC endpoint. It helps you keep traffic within the AWS network. And the idea is now, because it does not leave the AWS network, we do not require a public IP address to communicate with these services. It eliminates the need for internet gateway. So let's say we didn't need this internet gateway. The only reason we were using it was to get to S3. We can now eliminate that and keep everything private. So, there you go. There are two types of VPC endpoints, interface endpoints and gateway endpoints, and we're going to get into that next. So we're going to look at the first type of VPC endpoint, and that is interface endpoints. And they're called interface endpoints because they actually provision an elastic network interface, an actual network interface card with a private IP address. And they serve as an entry point for traffic going to a supported service. And if you read a bit more about interface endpoints, they are powered by AWS Private Link. There's not much to say here. That's just what it is. So access services hosted on AWS easily, securely by keeping your network traffic within your AWS network. This has always confused me, this branding of AWS Private Link. But you might as well just think of interface endpoints and AWS Private Link to being the same thing. Again, it does cost something because it is spinning up an ENI. And so, it's 0.01 cents per hour. And so over a month's time, if you had it on for the entire time, it's going to cost you around $7.50. And the interface endpoint supports a variety of AWS services, not everything, but here's a good list of them for you. So the second type of VCP endpoint is a gateway endpoint. And a gateway endpoint, it has a target for a specific route in your route table used for traffic destined for a supported AWS service. And this endpoint is 100% free because you're just adding something to your route table. And you're going to be utilizing it mostly for Amazon S3 and DynamoDB. So you saw that first use case where I showed you that we were getting the EC2 instance to talk to S3. That was using a gateway endpoint. So there you go. Here we are at the VPC endpoint cheat sheet, and this is going to be a quick one, so let's get to it. VPC endpoints help keep traffic between AWS services within the AWS network. There are two kinds of VPC endpoints, interface endpoints and gateway endpoints. Interface endpoints cost money, whereas gateway endpoints are free. Interface endpoints uses Elastic Network Interface, an ENI, with a private IP address, this is all powered by Private Link. Gateway endpoints is a target for a specific route in your route table. And interface endpoints support many AWS services, whereas gateway endpoints only support DynamoDB and S3. Hey, it's Andrew Brown from ExamPro, and we are looking at Elastic Load Balancers, also abbreviated to ELB, which distributes incoming application traffic across multiple targets such as EC2 instances, containers, IP addresses, or Lambda functions. So let's learn a little bit what a load balancer is. So a load balancer can be physical hardware or virtual software that accepts incoming traffic and then distributes that traffic to multiple targets. They can balance the load via different rules. These rules vary based on the type of load balancers. So for Elastic Load Balancer, we actually have 3 load balancers to choose from, and we're going to go into depth for each one, but we'll just list them out here. So we have Application Load Balancer, Network Load Balancer, and Classic Load Balancer. So to understand the flow of traffic for ELBs, we need to understand the 3 components involved. And we have listeners, rules, and target groups. And these things are going to vary based on our load balancers, which we're going to find out very shortly here. But let's quickly just summarize what these things are and then see them in context with some visualization. So the first one are listeners, and they listen for incoming traffic, and they evaluate it against a specific port, whether that's port 80 or 443. Then you have rules, and rules can decide what to do with traffic. And so that's pretty straightforward. Then you have target groups, and target groups is a way of collecting all the EC2 instances you want to route traffic to in logical groups. So let's go take a look first at Application Load Balancer and Network Load Balancer. So here on the right-hand side, I have traffic coming in through Route 53 that points to our load balancer. And once it goes to our load balancer, it goes to the listener, and it's going to check what port it's running on. So if it's on port 80, I have a simple rule here, which is going to redirect it to port 443. So it's going to go to this listener, and this listener has a rule attached to it, and it's going to forward it to target 1. And that target 1 contains all the EC2 instances, okay? And down below here, we can just see where the listeners are. So I have listener 80 and 443, and this is for application load balancer. You can see I also can attach a SSL certificate here. But if you look over at rules, and these rules are not going to appear for network load balancer, but they are going to appear for ALB. And so I have some more complex rules. If you're using ALB, it simply just forwards it to a target. You don't get more rich options, which we'll show you those richer options in a future slide. But let's talk about classic load balancer. So classic load balancer is much simpler. And so you have traffic coming in, it goes to CLB, you have your listeners, they listen on those ports, and you have registered targets. So there isn't target groups, you just have loose EC2 instances that are associated with the classic load balancer. Let's take a deeper look at all three load balancers, starting with application load balancer. So application load balancer, also known as ALB, is designed to balance HTTP and HTTPS traffic. It operates at layer 7 of the OSI model, which makes a lot of sense because layer 7 is application. ALB has a feature called request routing, which allows you to add routing rules to your listeners based on the HTTP protocol. So we saw previously when we were looking at rules, it was only for ALB. That is, this is that request routing rules. You can attach a web application firewall to ALB, and that makes sense because they're both application specific. And if you want to think of the use case for application load balancer, well, it's great for web applications. Now let's take a look at network load balancer, which is designed to balance TCP and UDP traffic. It operates at the layer 4 of the OSI model, which is the transport layer, and it can handle millions of requests per second while still maintaining extremely low latency. It can perform cross-zone load balancing, which we'll talk about later, and it's great for, multiplayer video games or when network performance is the most critical thing to your application. Let's take a look at classic load balancers. So it was AWS's first load balancer, so it is a legacy load balancer. It can balance HTTP or TCP traffic, but not at the same time. It can use layer 7 specific features such as sticky sessions. It can also use strict layer 4 for balancing purely TCP applications. So that's what I'm talking about, where it can do one or the other. It can perform cross-zone load balancing, which we will talk about later. And I put this one in here because it is kind of an exam question. I don't know if it still appears, but it will respond with a 504 error in case of timeout if the underlying application is not responding. And an application could be not responding would be example as the web server or maybe the database itself. So classic load balancer is not recommended for use anymore, but it's still around. You can utilize it, but it's recommended to use NLB or ALB when possible. So let's look at the concept of sticky sessions. So sticky sessions is an advanced load balancing method that allows you to bind a user session to a specific EC2 instance. And this is useful when you have specific information that's only stored locally on a single instance. And so you need to keep on sending that person to the same instance. So over here, I have the diagram that shows how this works. So on step 1, we route traffic to the first EC2 instance, and it sets a cookie. And so the next time that person comes through, we check to see if that cookie exists, and we're going to send it to that same EC2 instance. Now, this feature only works for classic load balancer and application load balancer. It's not available for NLB. And if you need to set it for application load balancer, it has to be set on the target group and not individual EC2 instances. So here's a scenario you might have to worry about. So let's say you have a user that's requesting something from your web application, and you need to know what their IP address is. So the request goes through, and then on the EC2 instance, you look for it, but it turns out that it's not actually their IP address. It's the IP address of the load balancer. So how do we actually see the user's IP address? Well, that's through the X-forwarded-for header, which is a standardized header when dealing with load balancers. So the X-forwarded-for header is a command method for identifying the originating IP address of a connecting or a client connecting to a web server through HTTP proxy or a load balancer. So you would just make sure that in your web application that you are using that header, and then you just have to read it within your web application to get that user's IP address. So we're taking a look at health checks for Elastic Load Balancer, and the purpose behind health checks is to help you route traffic away from unhealthy instances to healthy instances. And how do we determine if a instance is unhealthy? Well, it's through all these options, which for ALB and LB is set on the target group, or for Classic Load Balancer is directly set on the load balancer itself. So the idea is we are going to ping the server at a specific URL with a specific protocol and expect a specific response back. And if that happens more than once over a specific interval that we specify, then we're going to mark it as unhealthy, and the load balancer is not going to send any more traffic to it. It's going to set it as out of service, okay? So that's how it works. One thing that you really need to know is that ELB does not terminate on healthy instances. It's just going to redirect traffic to healthy instances. So that's all you need to know. So here we're taking a look at cross-zone load balancing, which is a feature that's only available for Classic and Network Load Balancer. And we're going to look at it when it's enabled and then when it's disabled and see what the difference is. So when it's enabled, requests are distributed evenly across the instances in all the enabled availability zones. So here we have a bunch of EC2 instances in 2 different AZs, and you can see the traffic is even across all of them, okay? Now, when it's disabled, requests are distributed evenly across the instances in only its availability zone. So here we can see in AZA, it's evenly distributed within this AZ, and then the same thing over here. And then down below, if you want to know how to enable cross-zone load balancing, it's under the description tab, and you'd edit the attributes, and then you just checkbox on cross-zone load balancing. Now we're looking at an application load balancer specific feature called request routing, which allows you to apply rules to incoming requests and then forward or redirect that traffic. And we can check on a few different conditions here. So we have 6 in total. So we have the header, host header, source IP, path, HTTP header method, or query string. And then you can see we have some then options. We can forward, redirect, return to fixed response, or authenticate. So let's just look at a use case down here where we actually have 1, 2, 3, 4, 5 different examples. And so one thing you could do is you could use this to route traffic based on subdomain. So if you wanted subdomain app to go to target prod and QA to go to the target QA, you could do that. You could either do it also on the path. So you could have /prod and /QA, and that would route to the respected target groups. You could do it as a query string. You could use it by looking at an HTTP header, or you could say all the get methods go to prod. I don't know why you'd want to do this, but you could. And then all the post methods would go to QA. So that is request routing in a nutshell. So we made it to the end of the Elastic Load Balancer section and on to the cheat sheet. So there are 3 Elastic Load Balancers: Network, Application, and Classic Load Balancer. An Elastic Load Balancer must have at least 2 availability zones for it to work. Elastic Load Balancers cannot go cross-region. You must create one per region. ALBs have listeners, rules, and target groups to route traffic. NLBs have listeners and target groups to route traffic. And CLBs use listeners, and EC2 instances are directly registered as targets to the CLB. For Application Load Balancer, it uses HTTPS or without the S traffic, and then as the name implies, it's good for web applications. Network Load Balancer is for TCP UDP and is good for high network throughput, so think maybe like multiplayer video games. Classic Load Balancer is legacy, and it's recommended to use ALB or NLB when you can. Then you have the X-forwarded-for, and the idea here is to get the original IP of the incoming traffic passing through the ELB. You can attach Web Application Firewall to ALB because, Web Application Firewall has an application in the name and NLB and CLB do not. You can attach an Amazon Certification Manager SSL certificate, so that's an ACM, to any of the ELBs to get SSL. For ALB, you have advanced request routing rules where you can route based on subdomain, header, path, and other HTTP information. And then you have sticky sessions, which can be enabled for CLB or ALB. And the idea is that it helps the session remember which EC2 instance based on cookie. Andrew Brown from Exam Pro. We are looking at security groups, and they help protect our EC2 instances by acting as a virtual firewall, controlling the inbound and outbound traffic. As I just said, security groups acts as a virtual firewall at the instance level. So you would have an EC2 instance, and you would attach to it security groups. And so here is an EC2 instance, and we've attached a security group to it. So what does it look like on the inside for a security group? Well, each security group contains a set of rules that filter traffic coming into, so that's inbound, and outbound to that EC2 instance. So here we have two tabs, inbound and outbound, and we can set, and these are rules, right? And we can set these rules with a particular protocol and a port range, and also who's allowed to have access. So in this case, I want to be able to SSH into this EC2 instance, which uses the TCP protocol, and the standard port for SSH is 22. And I'm going to allow only my IP. So anytime you see /32, that always means my IP, all right? So that's all you have to do to add inbound and outbound rules. There are no deny rules, so all traffic is blocked by default unless a rule specifically allows it. And multiple instances across multiple subnets can belong to a security group. So here I have 3 different EC2 instances, and they're all in different subnets. And security groups do not care about subnets. You just assign an EC2 instance to a security group, and just in this case, and they're all in the same one. And now they can all talk to each other, okay? I have 3 security group scenarios, and they all pretty much do the same thing, but the configuration is different to give you a good idea of variation on how you can achieve things. And so the idea is we have a web application running on EC2 instance, and it is connecting to an RDS database to get its information, running in a private subnet. Okay, and so in the first case, what we're doing is we have an inbound rule on the SG database saying allowing anything from 5432, which is the Postgres port number for this specific IP address. And so it allows this EC2 instance to connect to that RDS database. And so the takeaway here is you can specify the source to be an IP range or a specific IP. And so it's very specific. It's /32, and that's a nice way of saying exactly one IP address. Now, in the second scenario, it looks very similar, and the only difference is instead of providing an IP address as the source, we can provide another security group. So now anything within the security group is allowed to gain access for inbound traffic on 5432, okay? Now, in our last use case down below, we have inbound traffic on port 80 and inbound traffic on port 22 for the SG public group. And then we have the EC2 instance and the RDS database within its own security group. So the idea is that that EC2 instance is allowed to talk to that RDS database, and that EC2 instance is not exposing the RDS database well, it wouldn't because it's in a private subnet, so it doesn't have a public IP address. But the point is that this EC2 instance now is able to get traffic from the internet, and it's also able to accept someone from like for an SSH access, okay? And so the big takeaway here is that you can see that an instance can belong to multiple security groups, and rules are permissive. So when we have 2 security groups, if this one allows, then this is going to take precedence over SG Stack, which just doesn't have anything, because it denies by default everything, but anything that allows is going to override that, okay? So you can nest multiple security groups onto one EC2 instance, so just keep that stuff in mind. There are few security group limits I want you to know about, and so we'll look at the first. You can have up to 10,000 security groups in a single region, and it's defaulted to 2,500. If you want to go beyond that 2,500, you need to make a service limit increase request to AWS support. You can have 60 inbound rules and 60 outbound rules per security group, and you can have 16 security groups per ENI, and that's defaulted to 5. Now, if you think about like how many security groups can you have on an instance, well, it's depending on how many ENIs are actually attached to that security group. So if you have 2 ENIs that it's attached to a security group, then by default you'll have 10. Or if you have the upper limit here, 16, you'll be able to have 32 security groups on a single instance. Okay, so those are the limits I thought were worth telling you about. So we're going to take a look at our security groups cheat sheet. So we're ready for exam time. So security groups act as a firewall at the instance level. Unless allowed specifically, all inbound traffic is blocked by default. All outbound traffic from the instance is allowed by default. You can specify for the source to be either an IP range, a single IP address, or another security group. Security groups are stateful. If traffic is allowed inbound, it is also allowed outbound. Okay, so that's what stateful means. Any changes to your security group will take effect immediately. EC2 instances can belong to multiple security groups. Security groups can contain multiple EC2 instances. You cannot block a specific IP address with security groups. For this, we need to use NACLs, right? So again, it's allow by default. Everything's deny, and you're only allowing things, okay? You can have up to 10,000 security groups per region. Default is 2,500. You can have 60 inbound and 60 outbound rules per security group, and you can have 16 security groups associated to that ENI. Default is 5, and I can see that I added an extra 0 there, so don't worry. When you print out your security groups cheat sheet, it will be all correct, okay? Hey, this is Andrew Brown from ExamPro, and we are looking at Network Access Control Lists, also known as NACLs. It is an optional layer of security that acts as a firewall for controlling traffic in and out of subnet. So NACLs act as a virtual firewall at the subnet level, and when you create a VPC, you automatically get a NACL by default. Just like security groups, NACLs have both inbound and outbound rules. The difference here is that you're going to have the ability to allow or deny traffic in either way, okay? So for security groups, you can only allow, whereas NACLs, you have deny. Now, when you create these rules here, it's pretty much the same as security groups, with the exception that we have this thing called rule number. And rule number is going to determine the order of evaluation for these rules. And the way it evaluates is going to be from the lowest to the highest. The highest rule number could be 32,766. And AWS recommends that when you come up with these rule numbers, you use increments of 10 or 100, so you have some flexibility to create rules in between if you need be. Again, subnets are at the subnet level, so in order for them to apply, you need to associate subnets to NACLs, and subnets can only belong to a single NACL, okay? So where you have security groups, you can have instances that belong to multiple ones. For NACLs, it's just a singular case, okay? All right, so we're just going to look at a use case for NACLs here, and it's going to be really around this deny ability. So let's say there is a malicious actor trying to gain access to our instances, and we know the IP address. Well, we can add that as a rule to our NACL and deny that IP address. And let's say we know that we never need to SSH into these instances, and we just want an additional guarantee in case someone misconfigures a security group that SSH access is denied. So we'll just deny on port 22, and now we have those two cases covered. So there you go. All right, so we're on to the NACL cheat sheet. So Network Access Control List is commonly known as NACL. VPCs are automatically given a default NACL, which allows all outbound and inbound traffic. Each subnet within a VPC must be associated with a NACL. Subnets can only be associated with one NACL at a time. Associating a subnet with a new NACL will remove the previous association. If a NACL is not explicitly associated with a subnet, the subnet will automatically be associated with the default NACL. NACLs have both inbound and outbound rules, just like a security group. The rules can either be allow or deny traffic. Unlike a security group, which can only you can only apply allow rules, NACLs are stateless. This means that NACLs do not care about the rules that you set. So if you want to deny outbound, that doesn't necessarily mean it's going to deny inbound automatically. You have to set it individually for both sides, and that's why it's considered stateless. When you create a NACL, it will deny all traffic by default. NACLs contain a numbered list of rules that get evaluated in order from lowest to highest. If you needed to block a single IP address, you could via NACL, where a security group cannot, because it only has deny rules, and it'd be very difficult to block a single IP with a security group. So there you go. That's your NACL cheat sheet. Hey, this is Andrew Brown from Exam Pro, and we are starting the VPC follow along, and this is a very long section because we need to learn about all the kind of networking components that we can create. So we're going to learn how to create our own VPC, subnets, route tables, internet gateways, security groups, NAT gateways, NACLs. We're going to touch it all, okay? So it's very core to learning about AWS, and it's just great to get it out of the way. So let's jump into it. So let's start off by creating our own VPC. So on the left-hand side, I want you to click on your VPC. And right away, you're going to see that we already have a default VPC within this region of North Virginia. Okay, your region might be different from mine. It does kind of matter what region you use, because different regions have different amounts of available AZs. So I'm going to really strongly suggest that you switch to North Virginia to make this this section a little bit smoother for you. But just notice that the default VPC uses an IPv4 CIDR block range of 172.31.0.0/16. Okay, and so if I was to change regions, no matter what region, we'll go to US West Oregon. We're going to find that we already have a default VPC here as well, and it's going to have the same CIDR block range, okay? So just be aware that AWS does give you a default VPC so that you can start launching resources immediately without having to worry about all this networking. And there's no faux pas with using the default VPC. It's totally acceptable to do so, but we definitely need to know how to do this ourselves. So we're going to create our own VPC, okay? And so I'm a big fan of Star Trek, and so I'm going to name it after the planet of Bajor, which is a very well-known planet in the Star Trek universe. And I'm going to have to provide my own CIDR block. It cannot be one that already exists, so I can't use that 172 range that AWS was using. So I'm going to do 10.0.0.0/16. And there is a bit of a rhyme and rhythm to choosing these. This one is a very commonly chosen one. And so, I mean, you might be looking at this going, okay, well, what is this whole thing with the IP address /416? And we will definitely explain that in a separate video here. But just to give you a quick rundown, you're choosing your IP address that you want to have here. And this is the actual range. And this is saying how many IP addresses you want to allocate, okay? So yeah, we'll cover that more later on. And so now we have the option to set IPv6 CIDR or a CIDR block here. And so just to keep it simple, I'm going to turn it off. But you know, obviously IPv6 is supported on AWS, and it is the future of you know, our IP protocol. So it's definitely something you might want to turn on, okay, and just be prepared for the future there. Then we have this tenancy option, and this is just going to give us a dedicated host for our VPC. This is an expensive option, so we're going to leave it to default and go proceed and create our VPC. And so there it has been created, and it was very fast. It was just instantaneous there. And so we're going to click through to that link there, and now we can see we have our VPC named Bajor. And I want you to notice that we have our IPv4 CIDR range. There is no IPv6 set. And by default, it's going to give us a route table and a NACL, okay? And so we are going to overwrite the route table because we're going to want to learn how to do that by ourselves. NACLs is not so important, so we might just gloss over that. But yeah, so there you are. Now there's just one more thing we have to do because if you look down below here, we don't have DNS resolution or DNS host names is disabled by default. And so if we launch an EC2 instance, it's not going to get a DNS DNS host name, and that's just like a URL so you can access that EC2 instance. We definitely want to turn that on. So I'm going to drop this down to actions, and we're going to set host names here to enabled. Okay. And so now we will get that, and that will not cause us pain later down the road. So now that we've created our VPC, we want to actually make sure the internet can reach it. And so we're going to next learn about internet gateways. So we have our VPC, but it has no way to reach the internet. And so we're going to need an internet gateway. Okay, so on the left-hand side, I want you to go to internet gateway. And we are going to go ahead and create a new one, okay? And I'm just going to call it IG for Internet Gateway. Bajor, some people do IGW. We can do IGW, it doesn't hurt. And so our Internet Gateway has been created. And so we'll just click through to that one. And so you're going to see that it's in a detached state. So internet gateways can only be attached to a very specific VPC. It's a one-to-one relationship. So for every VPC, you're going to have an internet gateway. And so you can see it's attached and there is no VPC ID. So I'm going to drop this down and attach the VPC. And then select Bajor there and attach it. And there you go. Now it's attached and we can see the ID is associated. So we have an internet gateway, but that still doesn't mean that things within our network can reach the internet, because we have to add a route to our route table, okay? So just closing this tab here, you can see that there already is a route table associated with our VPC, because it did create us a default route table. So I'm just going to click through to that one here to show you, okay? And you can see that it's our main route table because it's set to main, but I want you to learn how to create route tables. So we're going to make one from scratch here, okay? So we'll just hit create route table here. And we're just going to name it our main route table, or our internet route table. I don't know, it doesn't matter. Okay, maybe we'll just say RT to shorten that there. And we will drop down and choose Bajor, and then we will go ahead and create that route table, okay? And so we'll just hit close. And we will click off here so we can see all of our route tables. And so here we have our main one here for Bajor, and then this is the one we created, okay? So if we click into this route table here, you can see by default it has the full scope of our local network here. And so I want to show you how to change this one to our main. So we're just going to click on this one here and switch it over to main. So set it as main route table. So the main route table is whenever, it's just what is going to be used by default. All right. And so we'll just go ahead and delete the default one here now because we no longer need it. All right. And we will go select our new one here and edit our routes. And we're going to add one for the internet gateway here. So I'm going to just drop down here, or sorry, I'm just going to write in 0.0.0.0/0, which means let's take anything from anywhere there. And then we're going to drop down, select internet gateway, select Bajor, and hit save routes. Okay, and we'll hit close. And so now we have a internet gateway, and we have a way for our subnets to reach the internet. So there you go. So now that we have a route to the internet, it's time to create some subnets so we have some way of actually launching our EC2 instances somewhere, okay? So on the left-hand side, I want you to go to subnets, and right away you're gonna start to see some subnets here. These are the default ones created with you with your default VPC. And you can see that there's exactly 6 of them. So there's exactly one for every availability zone within each region. So the North Virginia has 6 AZs, so you're going to have 6 public subnets, okay? The reason we know these are public subnets, if we were to click on one here and check the auto assign, it is set to yes. So if this is set to yes, that means any EC2 instance launched in the subnet is going to get a public IP address. Hence, it's going to be considered a public subnet, okay? So if we were to switch over to Canada Central, because I just want to make a point here that if you are in another region, it's going to have a different amount of availability zones. Canada only has 2, which is a bit sad. We would love to have a third one there, but you're going to see that we have exactly 1 subnet for every availability zone. So we're going to switch back to North Virginia here. and we are going to proceed to create our own subnet. So we're going to want to create at least 3 subnets if we can. Because the reason why is a lot of companies, especially enterprise companies, have to run it in at least 3 availability zones for high availability. Because if one goes out and you only have another one, but what happens if 2 goes out? So there's that rule of always have at least 2 additionals. Okay, so we're going to create 3 public subnets and one private subnet. We're not going to create 3 private subnets just because I don't want to be making subnets here all day, but we'll just get to it here. So we're going to create our first subnet. I'm going to name this Bajor public, okay, A. All right, and we're going to select our VPC, and we're going to just choose the US East 1A. And we're going to give it a CIDR block of 10.0.0.0/24. Now notice this CIDR range is smaller than the one up here. I know the number is larger, but from the perspective of how many IP addresses it allocates, there's actually a fewer here. So you are taking a slice of the pie from the larger range here. So just be aware, you can't set this as 16. It's always going to be less, and by less I mean a higher number than 16. Okay, so we'll go ahead and create our first public subnet here, and we'll just hit close. And this is not by default public because by default the auto assign is going to be set to no. So we're just going to go up here and modify this and set it so that it does auto assign to IPv4, and now it is considered a public subnet. So we're going to go ahead and do that for our B and C here. So it's going to be the same thing, Bajor public B. Okay, choose that. We'll do B. We'll do 10.0.1.024. Okay, and we're going to go create that. Hit close, and we're going to then auto assign that there. All right. And the next thing we're going to do is create our next subnet here. So Bajor, how boring, eh? Bajor public C. And we will do that. And we'll go to C here. And it's going to be 10.0.2.0/24. Okay, we'll create that one. Okay, we'll hit close. And we will make sure, did I set that one? Yes, I did. Did I set that one? Not as of yet. And so we will modify that there. Okay. And we will create another subnet here, and this is going to be a Bajor private A, okay? And we are going to set that to A here, and we're going to set this to 10.0.3.024, okay? And so this is going to be our private subnet, all right? So we've created all of our subnets. So the next thing we need to do is associate them with a route table. Actually, we don't have to because by default, it's going to use the main. All right, so they're already automatically associated there. But for our private one, we're not going to be wanting to really use the main route table there. We probably would want to create our own route table for our private subnets there. So I'm just going to create a new one here, and we're going to just call it private RT. Okay, we're going to drop that down, choose Bajor here, and we're going to hit close. Okay, and the idea is that we don't need the subnet to reach the internet, so it doesn't really make sense to be there. And then we could set other things later on. Okay, so what I want you to do is just change the association here. So we're going to just edit the route table association, and we're just going to change that to be our private one. Okay, and so now our route tables are set up. So we will move on to the next step. So our subnets are ready, and now we are able to launch some EC2 instances so we can play around and learn some of these other networking components. So what I want you to do is go to the top here and type in EC2, and we're going to go to the EC2 console, and we're going to go to instances on the left-hand side, and we're going to launch ourselves a couple instances. So we're going to launch our first instance, which is going to be for our public subnet here. So we're going to choose T2 Micro. We're going to go next. And we are going to choose the Bajor VPC that we created. We're going to launch this in the public subnet here, public A. Okay, and we're going to need a new IAM role. So I'm just going to right click here and create a new IAM role because we're going to want to give it access to both SSM for Sessions Manager and also so we have access to S3. Okay, so just choosing EC2 there, I'm going to type in SSM. Okay, SSM, There it is at the top. Then we'll type in S3. We're going to give it full access. We're going to go next. We're going to go to next, and we're going to just type in my Bajor EC2. Okay. And we're going to hit create role. Okay, so now we have the role that we need for our EC2 instance. We're just going to refresh that here and then drop down and choose my Bajor EC2. Okay, and we are going to want to provide it a script here to run. So I already have a script pre-prepared that I will provide to you, and this is the public userdata.sh. All this is going to do, and if you want to just take a peek here at what it does, I guess I don't have it already open here, but we will just quickly open this up here. All it's going to do is it's going to install an Apache server, and we're just going to have a static website page here served up. Okay, and so we're going to go ahead and go to storage. Nothing needs to be changed here. We're going to add, we don't need to add any tags. We're going to go security group, and we're going to create a new security group. I'm going to call it my Bajor EC2 SG. Okay, and we're going to make sure that we have access to HTTP. Because this is a website, we're going to have port 80 open. We're going to restrict it down to just us, and we could also do that for SSH, so we might as well do that there as well. Okay, we're going to go ahead and review and launch this EC2 instance, and I already have a key pair that is created. You'll just have to go ahead and create one if you don't have one there, and we'll just go ahead and launch that instance there. Okay, great. So now we have this EC2 instance here, which is going to be for our public subnet. Okay, and we'll go ahead and launch another instance. So we'll go to Amazon Linux 2 here, choose T2 Micro, and then this time we're going to choose our private subnet. Okay, and I do want to point out that when you have this auto assign here, see how it's by default disabled because it's inheriting whatever the parent subnet has, whereas when we set it the first one, you might have not noticed, but it was set to enable. Okay, and we are going to also give it the same role there, my Bajor EC2, and then this time around we're going to give it the other script here. So I have a private script here. I'm just going to open it up and show it to you. Okay, and so what this script does is, well, it doesn't actually need to install Apache, so we'll just remove that. I guess it's just old. But anyway, what it's going to do is it's going to reset the password on the EC2 user to Kai Wynn. Okay, that's a character from Star Trek Deep Space Nine. And we're also going to enable password authentication so we can SSH into this using a password. And so that's all the script does here. Okay, and so we are going to go ahead and choose that file there and choose that. And we will move on to storage. Storage is totally fine. We're not going to add tags. Security groups, we're going to actually create a new security group here. It's not necessarily necessary, but I'm going to do it anyway. So I'm going to say my private EC2 SG. Maybe put Bajor in there so we just keep these all grouped together, know what they're for. It's only going to need SSH. We're not going to have any access to the internet there, so like there's no website or anything running on here. And so we'll go ahead and review and launch, and then we're going to go launch that instance and choose our key pair. Okay, great. So now we're just going to wait for these two instances to spin up here, and then we will play around with security groups and NACLs. So I just had a quick coconut water, and now I'm back here, and our instances are running. They don't usually take that long to get started here. And so we probably should have named these to make it a little bit easier. So we need to determine which is our public and private. And you can see right away, this one has a public DNS hostname, and also it has its IP address. Okay, so this is how we know this is the public one. So I'm just going to say Bajor public. Okay. And this one here is definitely the private one, all right? So we will say a Bajor private, okay? So, yeah, and just to iterate over here, if we were to look here, you can see we have the DNS and the public IP address, and then for the private, there's nothing set, okay? So let's go see if our website is working here. So I'm just going to copy the public IP address, or we can take the DNS one, it doesn't matter. And we will paste this in a new tab. And here we have our working website. So our public IP address is definitely working. Now, if we were to check our private one, there is nothing there. So there's nothing for us to copy. We can't even copy this private one and paste it in here. So there's no way of accessing that website that is running on the private one there, and it doesn't really make a whole lot of sense to run your website in the private subnet there. So just to make a very clear example of that. Now that we have these two instances, I guess it's a good opportunity to learn about security groups. Okay, so we had created a security group, and the reason why we were able to access this instance publicly was that in our security group we had an inbound rule on port 80. So port 80 is what websites run on, and when we're accessing through the web browser there, and we are allowing my IP here. So that's why I was allowed to access it. So I just want to illustrate to you what happens if I change my IP. So at the top here, I have a VPN. It's a service you can buy. A lot of people use it so that they can watch Netflix in other regions. I use it for this purpose, not to watch Netflix somewhere else. So don't get that in your mind there. But I'm just going to turn it on, and I'm going to change my IP. So I think this is Brazil. And so I'm going to have an IP from Brazil here shortly once it connects. And so now if I were to go and access this here, it shouldn't work. Okay, so I'm just going to close that tab here, and it should just hang. Okay, so it's hanging because I'm not using that IP. So that's how security groups work. Okay, and so I'm just going to turn that off, and I think I should have the same one, and it should resolve instantly there. So great. So just showing you how the security groups work for inbound rules. Okay, for outbound rules, that's traffic going out to the internet. It's almost always open like this, 0.0.0.0, right? Because you just want to be able to download stuff or etc. So that is pretty normal business. Okay. So now that we can see that, maybe we would like to show off how NACLs work compared to security groups. So security groups, as you can see, if we were just to open this one up here, okay, security groups by default only can allow things. So everything is denied, and then you're always opening things up. So you're adding allow rules only. You can't add an explicit deny rule. So where NACLs are very useful is that you can use it to block very specific IP addresses, okay, or IP ranges, if you will. And you cannot do that for a security group, because how would you go about doing that? So if I wanted to block access just to my IP address, I guess I could only allow every other IP address in the world except for mine, but you can see how that would do undue burden. So let's see if we can set our NACL to just block our IP address here, okay? So security groups are associated with the actual EC2 instances. So the question is that how do we figure out the NACLs? And NACLs are associated with the subnets. Okay, so in order to block our IP address for this EC2 instance, we have to determine what subnet it runs in. And so it runs in our Bajor public A, right? And so now we got to find the NACL that's associated with it. So going up here to subnets, I'm going to go to public A, and I'm going to see what NACLs are associated with it. And so it is this NACL here, and we have some rules that we can change. So let's actually try just blocking my IP address here, and we will go just grab it from here, okay? All right, and just to note, if you look here, see how it says /32? That's a CIDR block range of exactly one IP address. That's how you specify a single IP address with /32. But I'm going to go here and just edit the NACL here, and we are going to, this is not the best way to do it, so I'm just going to open it here, okay? And because I didn't get some edit options there, I don't know why. And so we'll just go up to inbound rules here. I'm going to add a new rule, and it goes from lowest to highest for these rules. So I'm just going to add a new rule here, and I'm going to put in rule 10. Okay, and I'm going to block it here on this CIDR range, and I'm going to do it for port 80. Okay, so this, and we're going to have an explicit deny. Okay, so this should not allow me to access that EC2 instance any longer. Okay, so we're going to go back to our instances here. We're going to grab that IP address there and paste it in there and see if I still have access. And I do not. Okay, so that NACL is now blocking it. So that's how you block individual IP addresses there. And I'm just going to go back and now edit the rule here. And so we're just going to remove this rule and hit save. And then we're going to go back here and hit refresh. Okay. And I should now have access, and I do. So there you go. So that is security groups and NACL. So I guess the next thing we can move on to is how do we actually get access to the private subnet, okay, and the ways around that. We have our private EC2 instance, and we don't have an IP address, so there's no direct way to gain access to it. So we can't just easily SSH into it. So this is where we're going to need a bastion, okay? And so we're going to go ahead and go set one up here. So what I want you to do is I want you to launch a new instance here. And I'm just going to open a new tab just in case I want this old tab here. And I'm just going to hit launch instance here. Okay, and so I'm going to go to the marketplace here. I'm going to just type in Bastion. And so we have some options here. There is this free one, Bastion host SSH, but I'm going to be using Guacamole, and there is an associated cost here with it. They do have a trial version, so you can get away with not paying anything for it. So I'm just going to proceed and select Guacamole. And anytime you're using something from the marketplace, they generally will have the instructions in here. So if you do view additional details here, we're going to get some extra information. And then we would just scroll down here to usage information, such as usage instructions. And we're going to see there is more information. I'm just going to open up this tab here because I've done this a few times, so I remember where all this stuff is. Okay, and we're just going to hit continue here. Okay, and we're going to start setting up this instance. So we're going to need a small. So this one doesn't allow you to go into micros. Okay, so there is an associated cost there. We're going to configure this instance. We're going to want it in the same VPC as our private. Okay, when we have to launch this in a public subnet. So just make sure that you select the public one here. Okay. And we're going to need to create a new IAM role. And this is part of Guacamole's instructions here because you need to give it some access so that it can auto-discover instances, okay? And so down here, they have the instructions here, and they're just going to tell you to make an IAM role. We could launch a CloudFormation template to make this, but I would rather just make it by hand here. So we're going to grab this policy here, okay? And we are going to make a new tab and make our way over to IAM. Okay, and once we're in IAM here, we're going to have to make this policy. So I'm going to make this policy. Okay, unless I already have it. Just to see if it's already in here. No. Okay, good. And I'm going to go to JSON, paste that in there, review the policy. I'm going to name it. They have a suggestion here what to name it. Guac AWS. That seems fine to me. Okay, and here you can see it's going to give us permissions to CloudWatch and STS. So we'll go ahead and create that policy. It says it already exists. So I already have it. So just go ahead and create that policy. And I'm just going to skip the step for myself. Okay. And we're just going to hit cancel there. So I'm just going to type guac. I don't know why it's not showing up. It says it already exists. Okay, I'll just type that in again. So yeah, there it is. So I already have that policy. Okay. So I couldn't hit that last step, but you'll be able to get through that no problem. And then once you have it, you're going to have to create a new role. So we're going to create a role here, and it's going to be for EC2. We're going to go next. And we're going to want, I believe, EC2 full access. Is that the right? Oh, read-only access. Okay. So we're going to want to give this EC2 read-only access. And we're also going to want to give it that new guac role. So I'm going to type AWS here. Oh, it's giving me a hard time here. We'll just copy and paste the whole name in here. There it is. And so those are the two policies you need to have attached. And then we're just going to name this something here. So I'm going to just call it my guac bastion, okay, role here. And we're going to create that role. Okay, and so that role has now been created. We're going to go back here, refresh the IAM roles, and we're going to see if it exists. And there it is, my guac bastion role. I might spell bastion wrong there, but I don't think that really matters. And then we will go to storage. There's nothing to do here. We'll skip tags. We'll go to security groups. And here you can see it comes with some default configurations. So we're going to leave those alone. And then we're going to launch this EC2 instance. Okay. So now we're launching that. It's taking a bit of time here, but this is going to launch. And as soon as this is done, we're going to come back here and start using this bastion to get into our private instance. So our bastion here is now ready and provisioned. So let's go ahead and just type in bastion so we don't lose that later on. We can go grab either the DNS or public IP. I'll just grab the DNS one here. And we're going to get this connection not private warning. That's fine because we're definitely not using SSL here. So just hit advance and then just click to proceed here. Okay, and then it might ask you to allow. We're going to definitely say allow for that because that's more of the advanced functionality of Guacamole there, which we might touch in at the end of this here. We're going to need the username and password. So it has a default. So we have guacadmin here, okay? And then the password is going to be the name of the instance ID. All right, and this is all in the instructions here. I'm just speeding you through it. And then we're going to hit login here. And so now it has auto-discovered the instances which are in the VPC that is launched. And so here we have Bajor Private. So let's go ahead and try to connect to it. Okay. So as soon as I click, it's going to make this shell here. And so we'll go attempt and log in now. So our user is EC2 user. And I believe our password is KAIWINN, Kaiwin. And we are in our instance. So there you go. That's how we gain access to our private instance here. Just before we start doing some other things within this private EC2, I just want to touch on some of the functionality of Bastion here. Guacamole, and so why you might actually want to use a Bastion. So it does, it is a hardened instance. It does allow you to authenticate via multiple methods. So you can enable multi-factor authentication to use this. It also has the ability to do screen recording, so you can really be sure what people are up to. Okay, and then it just has built-in audit logs and et cetera, et cetera. So there's definitely some good reasons to use a Bastion, but we can also use Sessions Manager, which does a lot of this for us, with the exception of screen recording within the within AWS. But anyway, so now that we're in our instance, let's go play around here and see what we can do. So now that we are in this private EC2 instance, I just want to show you that it doesn't have any internet access. So if I was to ping something like Google, right? Okay, and I'm trying to get information here. Do you see how it's hanging and we're not getting a ping back? That's because there is no route to the internet. And so the way we're going to get a route to the internet is by creating a NAT instance or a NAT gateway. Generally, you want to use a NAT gateway. There are cases to use NAT instances. So if you were trying to save money, you can definitely save money by having to manage a NAT instance by yourself. But we're going to learn how to do a NAT gateway because that's the way AWS wants you to go. And so back in our console here, we are in EC2 instances where we're going to have to switch over to a VPC, okay? Because that's where the NAT gateway is. So on the left-hand side, we can scroll down and we are looking under VPC. We have NAT gateways, and so we're going to launch ourselves a NAT gateway. NAT gateways do cost money, so they're not terribly expensive, but you know, at the end of this, we'll tear it down, okay? And so the idea is that we need to launch this NAT gateway in a public VPC. Public subnet. And so we're going to have to look here. I'm going to launch it in the Bajor public A. It doesn't matter which one, just has to be in one of the public ones. And we can also create an elastic IP here. I don't know if it actually is required, assigned EPI to network. I don't know if it really matters. But we'll try to go ahead and create this here without an EIP. No, it's required. So we'll just hit create elastic IP there. And that's just a static IP address. So it's never changing, okay? And so now that we have that and it's associated with our NAT gateway, we'll go ahead and create that. And it looks like it's been created. So once your NAT gateway is created, the next thing you're gonna have to do is edit your route table. So there actually is a way for that VPC to, that private instance to access the internet, okay? So let's go ahead and edit that route table. And so we created a private route table specifically for our private EC2. And so here we're going to edit the routes, okay? And we're going to add a route for that private to that NAT gateway, okay? So we're just going to type in 0.0.0.0/0, and we are then just going to go ahead. Yep, and then we're going to go ahead and choose our NAT gateway. And we're going to select that there, and we're going to save that route. Okay, so now our NAT gateway is configured, and so there should be a way for our instance to get to the internet. So let's go back and do a ping. And back over here in our private EC2 instance, we're just going to go ahead and ping Google here. Okay, and we're going to see if we get some pings back, and we do. So there you go. That's all we had to do to access the internet. All right. So why would our private EC2 instance need to reach the internet? So we wouldn't want inbound traffic, but we definitely want outbound because we would probably want to update packages on our EC2 instance. So if we did a sudo yum update, okay, we wouldn't be able to do this without a outbound connection, all right? So it's a way of like getting access to the internet only for the things that we need for outbound connections, okay? All right, so we had a fun time playing around with our private EC2 instance there. And so we're pretty much wrapped up here for stuff. I mean, there's other things here, but you know, at the associate level, there's not much reason to get into all these other things here. But I do want to show you one more thing for VPCs, which are VPC flow logs. Okay, and so I want you to go over to your VPC here. Okay, and then I just want you to go up and I want you to create a flow log. So flow logs will track all the traffic that is going through your VPC. Okay, and so it's just nice to know how to create that. So we can have it to accept, reject, or all. I'm going to set it to all, and it can either be delivered to CloudWatch Logs or S3. CloudWatch is a very good destination for that. In order to deliver that, we're going to need a destination log group. I don't have one. So in order to send this to a log group, we're going to have to go to CloudWatch. Okay. We'll just open this up in a new tab here. Okay. And then once we're here in CloudWatch, we're going to create ourselves a new CloudWatch log. All right. And we're just going to say actions create log group, and we'll just call this Bajor VPC flow log or VPC logs or flow logs. Okay. And we will hit create there. And now if we go back to here and hit refresh, we may have that destination now available to us. There it is. Okay. We might need an IAM role associated with this to have permissions to publish to CloudWatch logs. So we're definitely going to need permissions for that. Okay. And I'll just pop back here with those credentials here in 2 seconds. So I just wanted to collect a little bit of flow log data so I could show it off to you to see what it looks like. And so, you know, under our VPC, we can see that we have flow logs enabled. So now we're done the VPC section. Let's clean up whatever we created here so we're not incurring any costs. So we're going to make our way over to EC2 instances, and you can easily filter out the instances which are in that that VPC here by going to VPC ID here and then just selecting the VPC. So these are the 3 instances that are running, and I'm just going to terminate them all because, you know, we don't want to spend up our free credits or incur costs because of that bastion there. So we'll just hit terminate there, and those things are going to now shut down. We also have that VPC endpoint still running. Just double check to make sure your NAT gateway isn't still there. So under the back in the VPC section here, just make sure that you had. So and there we have our gateway endpoint there for S3. So we'll just go ahead and delete that. I don't believe it costs us any money, but it doesn't hurt to get that out of the way there. Hey, this is Andrew Brown from ExamPro, and we are looking at Identity Access Management, IAM, which manages access of AWS users and resources. So now it's time to look at IAM core components, and we have these things called IAM identities, and those are going to be users, groups, and roles. So let's go through those. So a user is an end user who can log into the console or interact with AWS resources pragmatically. Then you have groups, and that is when you take a bunch of users and you put them into a logical grouping so they have shared permissions. That could be administrators, developers, auditors, whatever you want to call that. Then you have roles, and roles have policies associated with them. That's what holds the permissions. And then you can take a role and assign it to users or groups. And then down below you have policies, and this is a JSON document which defines the rules in which permissions are allowed. And so those are the core components, but we'll get more in detail to all these things next. So now that we know what the core components are, let's talk about how we can mix and match them. Starting at the top here, we have a bunch of users in a user group. And if we want to en masse apply permissions, all we have to do is create a role with the policies attached to that role. And then once we attach that role to that group, all these users have that same permission. Great for administrators, auditors, or developers. And this is generally the way you want to use IAM when assigning roles to users. You can also assign a role directly to a user. And then there's also a way of assigning a policy, which is called inline policy, directly to a user. Okay, so why would you do this? Well, maybe you have exactly one action you want to attach to this user and you want to do it for a temporary amount of time. You don't want to have to create a managed role because it's never going to be used for anybody else. There are use cases for that, but generally you always want to stick with the top level here. A role can have multiple policies attached to it, okay? And also a role can be attached to certain AWS resources, all right? Now there are cases where resources actually have inline policies directly attached to them, but there are cases where you have roles attached to or somehow associated to resources, all right? But generally this is the mix and match of it. If you were taking the AWS security certification, then this stuff in detail really matters, but for the associate and the pro level, you just need to conceptually know what you can and cannot do, all right? So in IAM, you have different types of policies, the first being managed policies. These are ones that are created by AWS out of convenience for you for the most common permissions you may need. So over here we'd have Amazon EC2 full access. You can tell that it's a managed policy because it says it's managed by AWS, and an even further indicator is this orange box, okay? Then you have customer managed policies. These are policies created by you, the customer. They are editable, whereas in the managed policies, they are read-only. They're marked as customer managed. You don't have that orange box. And then last are inline policies. So inline policies, you don't manage them because they're one and done. They're intended to be attached directly to a user or directly to a resource, and they're not managed, so you can't apply them to more than one identity or resource. Okay, so those are your three types of policy. So it's now time to actually look at a policy here. And so we're just going to walk through all the sections so we can fully understand how these things are created. And the first thing is the version, and the version is the policy language version. If this changes, then that means all the rules here could change. So this doesn't change very often. You can see the last time was 2012. So it's going to be years until they change it. And if they did make changes, it probably would be minor, okay? Then you have the statement, and so the statement is just a container for the other policy elements. So you can have a single one here. So here I have an array, so we have multiples. But if you didn't want to have multiples, you just get rid of the square brackets there, and you could have a single policy element there. Now going into the actual policy element, the first thing we have is SID, and this is optional. It's just a way of labeling your statements. So SID probably stands for statement identifier. And again, it's optional. Then you have the effect. The effect can be either allow or deny, and that's going to set the conditions or the access for the rest of the policy. The next thing is we have the action. So actions can be individualized, right? So here we have IAM and we have an individual one, or we can use asterisk to select everything under S3. And these are the actual actions the policy will allow or deny. And so you can see we have a deny policy, and we're denying access all to S3 for a very specific user here, which gets us into the principal. Now the principal is kind of a conditional field as well. And what you can do is you can specify an account, a user, a role, or federated user to which you would like to allow or deny access. So here we're really saying, hey, Barkley, you're not allowed to use S3, okay? Then you have the resource. That's the actual thing that is we're allowing or denying access to. So in this case, it's a very specific S3 bucket. And the last thing is condition. And so condition is going to vary based on the resource. But here we have one and it does something, but I'm just showing you that there is a condition in here. So there you go. That is the makeup of a policy. If you can master these things, it's going to make your life a whole lot easier. But, just learn what you need to learn, right? So you can also set up password policies for your users. So you can set like the minimum password length or the rules to what makes up a good password. You can also rotate out passwords. So that is an option you have as well. So it will expire after X days, and then the user then must reset that password. So just be aware that you have the ability to do a password policy. Let's take a look at access keys, because this is one of the ways you can interact with AWS pragmatically, either through the AWS CLI or the SDK. So when you create a user and you say it's allowed to have pragmatic access, it's going to then create an access key for you, which is an ID and a secret access key. One thing to note is that users can only have up to 2 access keys within their account. So down below, you can see that we have 1. As soon as we add a second one, that gray button for create access key will vanish. And if we want more, we would either have to remove keys, okay? But just be aware that that's what access keys are, and you can make them inactive, and you're only allowed to have 2. Quickly talk about MFA. So MFA can be turned on per user, but there is a caveat to it where the user has to be the one that turns it on, because when you turn it on, you have to connect it to a device, and your administrator is not going to have the device, so it's on the user to do so. There is no option for the administrator to go in and say, hey, you have to use MFA. So it cannot be enforced directly from an administrator or root account. But what the administrator can do if they want is they can restrict access to resources only to people that are using MFA. So you can't make the user account itself have MFA, but you can definitely restrict access to API calls and things like that. So temporary security credentials are just like pragmatic access keys, except they are temporary, and they're used in the following scenarios when you were dealing with identity federation, delegation, cross-account access, and IAM roles. And so we're going to look in more detail at identity federation and cross-account access in the upcoming slides. But let's talk about how they are different from pragmatic access keys. The first thing is that they last from minutes to an hour, so they're very short-term credentials. And they're not stored with the user, but they're generated dynamically and provided the user when requested. So with pragmatic access keys, they're strongly linked to a specific user. But in this case, we just give them these credentials when they need them. And these temporary credentials are the basis for roles and identity federation. So you've actually been using temporary security credentials this entire time, but you probably just don't know it. So anytime you use a role, an IAM role, they actually generate out an STS, which is the token that is used for temporary credentials, but you just don't notice it because AWS does it for you. But let's dig deep more into this stuff here. So we said that the use case for these temporary security credentials would be identity federation, but let's talk about what that actually is. So identity federation is the means of linking a person's electronic identity and attributes stored across multiple distinct identity management systems. So that definition is a little bit confusing. So my take on it is that identity federation allows users to exist on a different platform. So an example of this would be your users are on Facebook, but they can gain access as if they are a user in AWS. So the idea is that their identities are hosted somewhere else, whether it's Facebook, Google, Active Directory, or whatever. So with IAM, it supports 2 types of identity federation. So we have enterprise identity federation and web identity federation. So the protocols you can use for enterprise identity federation would be SAML, which is compatible with Active Directory, a very popular Microsoft Windows identity system, or custom federation brokers. This allows you to connect to other identity systems. And generally with enterprise identity federation, you're doing things with single sign-on. But for the scope of the developer associate, we don't need to really know about that. What we do need to know about is web identity federation. And you've used this before. If you've ever clicked a button where it's like connect with Facebook or connect with LinkedIn to quickly sign into a service, you are using a web identity federation system. So Amazon has one, Facebook has one, Google has one, LinkedIn, et cetera, et cetera. But generally, the protocols that they adhere to is the OpenID Connect OICD 2.0, and that's actually built off of OAuth 2. So you might have heard of OAuth. So OIDC is built on top of OAuth. So, yeah, so now we have an idea of identity federation. Let's dig a little bit deeper here. So we've been talking about these temporary security credentials, but actually, how do we get a hold of them? And that's where this service comes into play, this Security Token Service, STS. So it's a web service that enables you to request temporary limited privilege credentials for either IAM users or for federated users. And we just talked about identity federation, so users that are outside of AWS. And so this service is a global service. If you were to go into the AWS console and type in STS, nothing will come up because you can't access it through the console. You can only access it pragmatically. And there's actually an endpoint for it. So there's one that's sts.amazonaws.com. So that's where all the requests get generated. And an STS returns, so like once you use the API to get that STS, it's going to return an access key ID, a secret access key, a sessions token, an expiration. You're going to notice the first two should be very noticeable to you because it's the same thing when you do pragmatic access with a user. It's the same stuff. And in fact, you can take this, the access key ID and secret access key and put it in your AWS credentials file and make a profile. Of course, these will be temporary, so it's not great for long-term storage, but the point is that they're exactly the same. It's just that they're temporary. And if you want to actually get this token, you have to use the API actions for STS, which you could use either the SDK or the CLI to use. And so this is a list of them. The top three are the ones that are most likely in use. So we have Assume role. That's used anytime IAM role gives you an STS. Remember we talked about AWS. Every time you use IAM, it gives you an STS, but you don't see it. It uses Assume role. Same with cross-account roles, it uses Assume role. Then you have SAML, that's for the Enterprise Identity Federation. And then you have Assume role with Web Identity, which is the one we really need to know for the developer associate, and that's authenticating to Facebook, Google, et cetera, et cetera. So let's look at that in more detail and see how that works. So now let's look at actually how to get an STS from using with Assume role with Web Identity. So this action here is going to return a set of temporary credentials for the users who have been authorized in a mobile or a web application. So you have a developer, and the first thing you're going to do is you need to authenticate with whatever the web identity is. So we're going to send an OAuth call to Facebook as our example here. And they're going to send us back a JavaScript web token, a JWT. And then once we have that, what we can do is use something like the CLI. You could also use the AWS SDK, but we'll use the CLI, and we're going to call the Assume role with Web Identity, passing along that JWT. And then the STS service is going to determine whether it's going to give us a token or not. And so there it passes along the temporary credentials. So we're going to get that information. So now that we have those temporary credentials, we can use the CLI or other means to gain access to a variety of AWS services within our AWS account, and just whatever we decide that they're allowed to gain access to. So that is the process for getting an STS for at least the Assume role with Web Identity. What's really important to note is the order that this happens in, because this definitely shows up on the exam. They'll ask you, they'll give you an example of the order of when this happens, and just know that you always authenticate with the web identity first, and then you get the token second from STS. So just remember that it's always the web identity first, and you'll definitely score points on the exam. So I was saying earlier that cross-account roles are another thing that is used with STS, the Security Token Service. So let's talk about why we'd want to make cross-account roles. So the whole purpose of them is to allow you to grant access a user from another AWS account to resources within your own account. And the advantage here is that you don't have to create your own, like a user for them in your own account. So here's an example where we have account A. So I have an account in that one, and the account B wants to grant me access to specific resources. What they're going to do is create a role for me, which is a cross-account role, and this is going to grant me access. So how does this role actually do that? Well, there's a policy that's attached to it, and to that role, and it's granting me access to assume role. And so we said that STS, the Security Token Service, is what issues those temporary credentials. And we saw there was a bunch of actions, one being web identity assume role, the other one being assume role. So assume role is what is granting us access across account. This happens seamlessly, so you don't have to do anything. But yeah, that is cross account roles. Hey, this is Andrew Brown from Exam Pro, and we are going to do the IAM follow along. So let's make our way over to the IAM console. So just go up to services here and type in IAM, and we will get to learning this right away. So here I am on the IAM dashboard, and we have a couple things that AWS wants us to do. It wants us to set MFA on our root account. It also wants us to apply an IAM password policy so that our passwords stay very secure. So let's take what they're saying in consideration and go through this. Now I am logged in as the root user, so we can go ahead and set MFA. So what I want you to do is drop this down as your root user, and we'll go manage MFA. And we will get to this here. So this is just a general disclaimer here to help you get started here. I don't ever want to see this again, so I'm just going to hide it. And we're going to go to MFA here, and we're going to activate MFA. So for MFA, we have a few options available. We have a virtual MFA. This is what you're probably most likely going to use, where you can use a mobile device or computer. Then you can use U2F security key. So this is like a UBI key. And I actually have an UBI key, but we're not going to use it for this, but it's a physical device which holds the credentials, okay? So you can take this key around with you. And then there are other hardware mechanisms, okay? So, but we're going to stick with virtual MFA here, okay? So we'll hit continue. And what it's going to do is you need to install a compatible app on your mobile phone. So if we take a look here, I bet you Authenticator is one of them, okay? So if you just scroll down here, we have a few different kinds. I'm just looking for the virtual ones. Yeah, so for Android or iPhone, we have Google Authenticator or Authy two-factor authentication. So you're going to have to go install Authenticator on your phone. And then when you are ready to do so, you're going to have to show this QR code. So I'm just going to click that and show this to you here. And then you need to pull out your phone. I know you can't see me doing this, but I'm doing it right now, okay? And I'm not too worried that you're seeing this because I'm going to change this two-factor authentication out here. So if you decide that you want to also add this to your phone, you're not going to get too far. Okay, so I'm just trying to get my Authenticator out here, and I'm going to hit plus in the thing, and I can scan the barcode. Okay, and so I'm just going to put my camera over it here. Okay, great. And so it is saved the secret. All right, and so it's been added to Google Authenticator. Now, now that I have it in my application, I need to enter in two consecutive MFA codes. Okay, so this is a little bit confusing. It took me a while to figure this out the first time I was using AWS. But the idea is that you need to set the first one. So the first one I see is 089265. Okay, and so I'm just going to wait for the next one to expire. Okay, so there's a little circle that's going around. And I'm just waiting for that to complete to put in the second one, which just takes a little bit of time here. Still going here. Great, and so I have new numbers. So the new numbers are 369626, okay? So it's not the same number, but it's two consecutive numbers, and we will hit assign MFA. And now MFA has been set on my phone. So now when I go and log in, it's going to ask me to provide additional code, okay? And so now my root account is protected. So we're gonna go back to our dashboard, and we're gonna move on to password policies, okay? So let's take the recommendation down here and manage our password policy, okay? And we are going to set a password policy. So password policy allows us to enforce some rules that we want to have on our users. And so to make passwords a lot stronger, so we can say it should require at least one upper letter, one lower letter, at least one number, a non-alphanumeric character. Enable the password expiration. So after 90 days, they're going to have to change their password. You can have password expiration requires the administrator reset. So you can't just reset it. The admin will do it for you. Allow users to change their own password is something you could set as well. And then you could say prevent password reuse. So for the next 5 passwords, they can't reuse the same one. Okay. So, and I would probably put this a big high number so that there's very high chance they won't use the same one. Okay. So, yeah, there we go. We'll just hit save changes. And now we have a password policy in place. Okay. And so that's how that will be. So to make it easier for users to log into the IAM console, you can provide a customized sign-in link here. And so here it has the account ID, or I think that's the account ID, but we want something nicer here. So we can change it to whatever we want. So I can call it Deep Space Nine. Okay. And so now what we have is, if I spelt that right, I think so, yeah. So now that we have a more convenient link that we can use to log in with, okay? So I'm just gonna copy that for later because we're gonna use it to log in. I mean, obviously you can name it whatever you want. And I believe that these are just like picking like your Yahoo or your Gmail email. They have to be unique, okay? So you're not gonna be able to use Deep Space Nine as long as I have it in use, I believe. But yeah, okay, so maybe we'll move on to actually creating a user here. So here I am under the users tab in IAM, and we already have an existing user that I created for myself when I first set up this account, but we're gonna create a new user so we can learn this process. So we can fill in the name here, Harry Kim, which is the character from Star Trek Voyager. You can create multiple users in one go here, but I'm just gonna make one. Okay, I'm gonna give him pragmatic access and also access to the console so we can log in. And I'm going to have it auto-generate a password here so I don't have to worry about it. And you can see that it will require them to reset their password when they first sign in. So going on to permissions, we need to usually put our users within a group. We don't have to, but it's highly recommended. And here I have one called admin for which has administrator access. I'm going to create a new group here and I'm going to call it developers, okay? And I'm going to give them power access, okay? So it's not full access, but it gives them quite a bit of control within the system, okay? And I'm just going to create that group there. And so now I have a new group, and I'm going to add Harry to that group there, and we will proceed to the next step here. So we have tags. I'm going to ignore that. We're going to review, and we're going to create Harry Kim, the user, okay? And so what it's done here is it's also created a secret access key and a password, okay? So if Harry wants to have programmatic access, he can use these, and we can send an email with this information along to him, okay? And yeah, we'll just close that there, okay? And then we'll just poke around here in Harry Kim for a little bit. So just before we jump into Harry Kim here, you can see that he has never used his access key. The last time his password was used was today, which was set today, and there is no activity, and he does not have MFA. So if we go into Harry Kim, we can look around here and we can see that he has policies applied to him from a group. And you can also individually attach permissions to him. So we have the ability to give him permissions via group, or we can copy permissions from an existing user, or we can attach policies directly to him. So if we wanted to give him S3 full access, we could do so here, okay? And then we can just apply those permissions. So just to wrap up this section, we're just going to cover rules and policies here. So first we'll go into policies. And here we have a big list of policies here that are managed by AWS. They say they're managed over here, and you can definitely tell because they're camel case, and they also have this nice little orange box, okay? And so these are policies which you cannot edit. They're read-only, but they're a quick and fast way for you to start giving access to your users. So if we were just to take a look at one of them, like the EC2 one, or maybe just read-only access, we can click into them, and we can see kind of on to the IAM cheat sheet, so let's jump into it. So identity access management is used to manage access to users and resources. IAM is a universal system, so it's applied to all regions at the same time. IAM is also a free service. A root account is the account initially created when AWS is set up, and so it has full administrator access. New IAM accounts have no permissions by default until granted. New users get assigned an access key ID and secret when first created when you give them pragmatic access. Access keys are only used for the CLI and SDK. They cannot access the console. Access keys are only shown once when created. If lost, they must be deleted and recreated again. Always set up MFA for your root accounts. Users must enable MFA on their own. Administrators cannot turn it on for each user. IAM allows you to set password policies, to set minimum password requirements, or rotate passwords. Then you have IAM identities, such as users, groups, and roles, and we'll talk about them now. So we have users. Those are the end users who log into the console or interact with AWS resources pragmatically. Then you have groups, so that is a logical group of users that share all the same permission levels of that group. So think administrators, developers, auditors. Then you have roles, which associates permissions to a role, and then that role is then assigned to users or groups. Then you have policies, so that is a JSON document which grants permissions for specific users, groups, roles to access services. Policies are generally always attached to IAM identities. You have some variety of policies. You have managed policies, which are created by AWS. They cannot be edited. Then you have customer managed policies. Those are policies created by you that are editable. And you have inline policies, which are directly attached to the user. So there you go. That is IAM. Hey, this is Andrew Brown from ExamPro, and we are looking at CloudFront, which is a CDN, a content distribution network. It creates cached copies of your website at various edge locations around the world. So to understand what CloudFront is, we need to understand what a content delivery network is. So a CDN is a distributed network of servers which deliver web pages and content to users based on their geographical location, the origin of the web page, and a content delivery server. So over here, I have a graphical representation of a CDN specifically for CloudFront. And so the idea is that you have your content hosted somewhere. So here the origin is S3. And the idea is that the server, CloudFront, is going to distribute a copy of your website on multiple edge locations, which are just servers around the world that are nearby to the user. So when a user from Toronto tries to access our content, it's not going to go to the S3 bucket. It's going to go to CloudFront, and CloudFront is going to then route it to the nearest edge location so that this user has the lowest latency. And that's the concept behind CloudFront. So it's time to look at the core components for CloudFront, and we'll start with origin, which is where the original files are located. And generally, this is going to be an S3 bucket because the most common use case for CloudFront is static website hosting. However, you can also specify origin to be an EC2 instance, an Elastic Load Balancer, or Route 53. The next thing is the actual distribution itself. So a distribution is a collection of edge locations which define how cached content should behave. So this definition here is the thing that actually says, hey, I'm going to pull from origin and I want this to update the cache with whatever frequency, or use HTTPS, or it should be encrypted. So that is the settings for the distribution. And then there's the edge locations. And an edge location is just a server, and it is a server that is nearby to the actual user that stores that cache content. So those are the three components to CloudFront. So we need to look at the distribution component of CloudFront in a bit more detail because there's a lot of things that we can set in here. And I'm not even showing you them all, but let's just go through it so we have an idea of the kinds of things we can do with it. So again, a distribution is a collection of edge locations. And the first thing you're going to do is you're going to specify the origin. And again, that's going to be S3, EC2, ELB, or Route 53. And when you set up your distribution, what's really going to determine the cost and also how much it's going to replicate across is the price class. So here you can see if you choose all edge locations, it's going to be the best performance because your website is going to be accessible from anywhere in the world. But if you're operating just in North America and the EU, you could limit the amount of servers it replicates to. There are two types of distributions. We have web, which is for websites, and RTMP, which is for streaming media. Okay. You can actually serve up streaming video under web as well, but RTMP is a very specific protocol, so it is its own thing. When you set up behaviors, there's a lot of options we have. So we could redirect all the traffic to be HTTPS. We could restrict specific HTTP methods. So if we don't want to have puts, we can say we not include those. We can restrict the viewer access, which we'll look into a little bit more detail here. We can set the TTLs, which is time to expiry, or time to live, sorry, which says like after, we could say every 2 minutes, the content should expire and then refresh it, right? Depending on how stale we want our content to be. There is a thing called invalidations in CloudFront, which allow you to manually set, so you don't have to wait for the TTL to expire. You could just say, I want to expire these files. This is very useful when you are pushing changes to your S3 bucket, because you're going to have to go manually create that invalidation so those changes will immediately appear. You can also serve back at, error pages. So if you need a custom 404, you can do that through CloudFront. And then you can set restrictions. So if you, for whatever reason, aren't operating in specific countries and you don't want those countries to consume a lot of traffic, which might cost you money, you can just restrict them, saying, I'm blocking these countries. Or you could do the other way and say, I only whitelist these countries. These are the only countries that are allowed to view things from CloudFront. So there's one interesting feature I do want to highlight on CloudFront, which is Lambda Edge. And Lambda Edge are Lambda functions that override the behavior of requests and responses that are flowing to and from CloudFront. And so we have 4 that are available to us. We have the view request, the origin request, the origin response, and the viewer response. Okay. And so on our CloudFront distribution under probability behavior, we can associate Lambda functions, and that allows us to intercept and do things with this. What would you possibly use Lambda Edge for? A very common use case would, let's say you have protected content and you want to authenticate it against something like Cognito. So only users that are within your Cognito authentication system are allowed to access that content. That's actually something we do on Exam Pro for the video content here. So, you know, that is one method for protecting stuff, but there's a lot of creative solutions here with, you can use Lambda Edge. You could use it to serve up A to B testing websites. So you could have it so when the viewer request comes in, you have a roll of the die and it will change what it serves back. So it could be, it could set up A or set up B. And that's something we also do on the Exam Pro marketing website. So there's a lot of opportunities here with Lambda Edge. I don't know if it'll show up in the exam. I'm sure eventually it will. And it's just really interesting. So I thought it was worth talking about. So now we're talking about CloudFront protection. So CloudFront might be serving up your static website, but you might have protected content such as video content, like on Exam Pro, or other content that you don't want to be easily accessible. And so when you're setting up your CloudFront distribution, you have this option to restrict viewer access. And so that means that in order to view content, you're going to have to use signed URLs or signed cookies. Now, when you do check this on, it actually will create you an origin identity access, an OAI. And what that is, it's a virtual user identity that it will be used to give CloudFront distributions permission to fetch private objects. And so those private objects generally mean from an S3 bucket that's private, right? And as soon as that's set up and that's automatically set up for you, now you can go ahead and use signed URLs and signed cookies. So what are these things? Well, the idea behind it is a signed URL is just a URL that CloudFront will provide you that gives you temporary access to those private cached objects. Now, you might have heard of pre-signed URLs, and that is an S3 feature, and it's similar in nature, but it's very easy to get these two mixed up because signed URLs and pre-signed URLs sound very similar, but just know that pre-signed URLs are for S3 and signed URLs are for CloudFront. Then you have signed cookies, okay? And so it's similar to signed URLs. The only difference is that you're passing along a cookie with your request to allow users to access multiple files. So you don't have to every single time generate a signed cookie, you set it once, and as long as that cookie is valid and passed along, you can access as many files as you want. This is extremely useful for video streaming, and we use it on Exam Pro. We could not do video streaming protected with signed URLs because all the video streams are delivered in parts, right? So a cookie has to get set. So that is your options for protecting CloudFront. Time to get some hands-on experience with CloudFront here and create our first distribution. But before we do that, we need something to serve up to the CDN, okay? And so we had an S3 section earlier where I uploaded a bunch of images from Star Trek The Next Generation. And so for you, you can do the same, or you just need to make a bucket and have some images within that bucket so that we have something to serve up, okay? So once you have your bucket of images prepared, we're going to go make our way to the CloudFront console here. And so just type in CloudFront and then click there, and you'll get to the same place as me here. And we can go ahead and create our first distribution. So we're going to be presented with two options. We have web and RTMP. Now RTMP is for the Adobe Flash Media Server protocol. So since nobody really uses Flash anymore, we can just kind of ignore this distribution option, and we're going to go with web, okay? And then we're going to have a bunch of options, but don't get overwhelmed because it's not too tricky. So the first thing we want to do is set our origin. So where is this distribution going to get its files that it wants to serve up? It's going to be from S3. So we're going to click into here. We're going to get a drop down, and we're going to choose our S3 bucket. Then we have path. We'll leave that alone. We have origin ID. We'll leave that alone. And then we have restrict bucket access. So this is a cool option. So the thing is that let's say you only wanted people to access your bucket resources through CloudFront, because right now, if we go to S3 console, and I think we made it was data public, right? And if we were to look at this URL, okay, this is publicly accessible. But let's say we wanted to force all traffic through CloudFront because CloudFront, they can track things, so we get some rich analytics there, and we just don't want people directly accessing this ugly URL. Well, that's where this option comes in, restrict bucket access, okay, and it'll create an origin identity access for us, but we're going to leave it to no. I just want you to know about that. And then down to the actual behavior settings, we have the ability to redirect HTTP to HTTPS. That seems like a very sane setting. We can allow the HTTP methods. We're only going to be ever getting things. We're never going to be put or posting things. And then we'll scroll down. We can set our TTLs. The defaults are very good. And then down here we have restrict viewer access. So if we wanted to restrict the viewer access to require signed URLs or signed cookies to protect access to our content, we'd press yes here. But again, we just want this to be publicly available. So we're going to set it to no, okay? And then down below, we have distribution settings, and this is going to really affect our price, the cost we're going to pay here, as it says price class, okay? And so we can either distribute all copies of our files to every single edge location, or we can just say US, Canada, Europe, or just US, Canada, Europe, Asia, Middle East, Africa, or just the main three. So I want to be cost saving here. It's not really going to cost us a lot anyway, but I think that if we set it to the lowest class here, that it will take less time for the distribution to replicate here, and this tutorial will go a lot faster, okay? Then we have the ability to set an alternate domain name. This is important if we are using a CloudFront certificate and we want a custom domain name, which we would do in another follow along, but not in this one here, okay? And if this was a website, we would set the default root here to index.html. Okay, so that's pretty much all we need to know here, and we'll go ahead and create our distribution, okay? And so our distribution is going to be in progress, and we're going to wait for it to distribute those files to all those edge locations, okay? And so this will just take a little bit of time here. It usually takes, I don't know, like 3 to 5 minutes, so we'll resume the video when this is done creating. So creating that distribution took a lot longer than I was hoping for. It was more like 15 minutes, but I think the initial one always takes a very long time. And then after, whenever you update things, it still takes a bit of time, but it's not 15 minutes. It's more like 5 minutes, okay? But anyway, so our distribution is created here. We have an ID, we have a domain name, and we're just going to click in to this distribution, and we're going to see all the options we have here. So we have general, origins, behaviors, error pages, restrictions, and validations, and tags, okay? So when we were creating that distribution, we configured both the general, origins, and behaviors all in one go, Okay, and so if we wanted to override the behaviors from before, we just select edit here. We're not going to change anything here, but I just want to show you that we had these options previous, and just to see that they are broken up between these 3 tabs here. So if I go to edit, there's some information here and some information there, okay? So now that we have our distribution working, we have this domain name here, and if we had used our own SSL from the Amazon Certification Manager, we could have had a custom domain, but we didn't, so we just have the domain that is provided with us, and this is how we're going to actually access our cache file. So what I want you to do is copy that there. I'm just going to place it here in a text editor here, and the idea here is we want to then, from the Enterprise D, pull one of the images here. So if we have data, we'll just take the front of it there, okay? And we are going to just assemble a new URL. So we're going to try data first here, and data should work without issue, okay? And so now we are serving this up from CloudFront. So that is how it works. Now, but data is set to public access, okay? So that isn't much of a trick there. But for all these other ones, I just want to make sure that he has public access here. And it is set here, yeah, to public access. But let's look at someone that actually doesn't have public access, such as Keiko. She does not have public access. So the question is, will CloudFront make files that do not have public access set in here publicly accessible? That's what we're going to find out, okay? So we're just going to then assemble another URL here, but this time with Keiko, okay? And we're going to see if we can access her, all right? Okay. Oops, I copied the wrong link. I'll just copy that one more time. Okay, and there you go. So Keiko is not available, and this is because she is not publicly accessible, okay? So just because you create a CloudFront distribution doesn't necessarily mean that these files will be accessible. So if we were to go to Keiko now and then set her to public, would she be accessible now through CloudFront? Okay, so now she is, all right? So just keep that in mind, that when you create a CloudFront distribution, you're going to get these URLs, and unless you explicitly set the objects in here to be publicly accessible, they're not going to be publicly accessible, okay? But yeah, that's all there is to it. So we created our CloudFront distribution. So we need to touch on one more thing here with CloudFront, and that is invalidation. So up here we have this Keiko image, which is being served up by CloudFront, but let's say we want to replace it, okay? So in order to replace images on CloudFront, it's not as simple as just replacing them in S3. So here we have Keiko, right? And this is the current image. And so let's say we wanted to replace that. And so I have another version of Keiko here. I'm just going to upload it here, and that's going to replace the existing one. Okay. And so I'm just going to make sure that the new one is here. So I'm just going to right click, or sorry, I'm going to hit open here, make sure it's set to public. And then I'm just going to click the link here, and now it's the new one, right? So here we have the new one. And if we were to go to the CloudFront distribution and refresh, it's still the old image, okay? Because in order for these new changes to propagate, you have to invalidate the old cache, okay? And that's where invalidations come into play. So to invalidate the old cache, we can go in here to create invalidations, and we can put a wildcard to expire everything, or we could just expire Keiko. So for Keiko, she's at /enterprise D. So we would just paste that in there, and we have now created an invalidation, and this is going to take five minutes. I'm not going to wait around to show you this because I know it's going to work, but I just want you to know that if you update something, in order for it to work, you have to create invalidations, okay? So it's time to look at the CloudFront cheat sheet, and let's get to it. So CloudFront is a CDN, a content distribution network. It makes websites load fast by serving cached content that is nearby. CloudFront distributes cached copies at edge locations. Edge locations aren't just read-only. You can actually write to them, so you can do puts to them. We didn't really cover that in the core content, but it's good to know. CloudFront has a feature called TTL, which is time to live, and that defines how long until a cache expires, okay? So if you set it to expire every hour, every day, that's how fresh, or I guess you'd say how stale, your content is going to be. When you invalidate your cache, you are forcing it to immediately expire. So just understand that invalidations means you're refreshing your cache, okay? Refreshing the cache does cost money because of the transfer costs to update edge locations, right? So if you have a file and it's expired, it then has to then send that file to 10, 20, whatever amount of servers it is, and there's always that outbound transfer cost, okay? Origin is the address of where the original copies of your files reside. And again, that can be S3, EC2, ELB, Route 53. Then you have distribution, which defines a collection of edge locations and behavior on how it should handle your cache content. We have two types of distributions. We have the web distribution, or also just known as web, which is for static website content. And then you have RTMP, which is for streaming media. Again, that is a very specific protocol. You can serve up video streaming via the web distribution. Then we have Origin Identity Access, which is used to access private S3 buckets. If we want to access cache content that is protected, we need to use sign URLs or sign cookies. Again, don't get sign URLs confused with pre-sign URLs, which is an S3 feature, but it's pretty much the same in terms of giving you access to something. Then you have Lambda Edge, which allows you to pass each request through a Lambda to change the behavior of the response or the request. Okay, so there you go. That is CloudFront in a nutshell. Hey, this is Andrew Brown from Exam Pro, and we are looking at CloudTrail, which is used for logging API calls between AWS services. And the way I like to think about this service, it's when you need to know who to blame. Okay? So, as I said earlier, CloudTrail is used to monitor API calls and actions made on an AWS account. And whenever you see these keywords, governance, compliance, operational auditing, or risk auditing, it's a good indicator they're probably talking about AWS CloudTrail. Now, I have a record over here to give you an example of the kind of things that CloudTrail tracks to help you know how you can blame someone when something's gone wrong. And so we have the where, when, who, and what. So the where, so we have the account ID, like which account did it happen in, and the IP address of the person who created that request. The when, so the time it actually happened. The who, so we have the user agent, which is, you could say, it could tell you the operating system, the language, the method of making this API call. The user itself, so here we can see Wharf made this call, and what, so to what service, and it'll say what region and what service. So this service, it's using IAM here, and the action, so it's creating a user. So there you go, that is CloudTrail in a nutshell. So within your AWS account, you actually already have CloudTrail logging things by default, and it will collect things for the last 90 days under the event history here. And we get a nice little interface here, and we can filter out these events. Now, if you need logging beyond 90 days, and that is a very common use case, which you definitely want to create your own trail, you'd have to create a custom trail. The only downside when you create a custom trail is that it doesn't have a GUI like here, such as event history. So there is some manual labor involved to visualize that information. And a very common method is to use Amazon Athena. So if you see CloudTrail Amazon Athena being mentioned in unison, there's that reason for that, okay? So there's a bunch of trail options I want to highlight, and you need to know these. They're very important for CloudTrail. So the first thing you need to know is that a trail can be set to log in all regions. So we have the ability here to say yes, and now no region is missed. If you are using an organization, you'll have multiple AWS accounts, and you want to have coverage across all those. So in a single trail, you can checkbox on apply to my entire organization. You can encrypt your CloudTrail logs, which you definitely want to do using server-side encryption via Key Management Service, which abbreviated is SSE KMS. And you want to enable log file validation, because this is going to tell whether someone's actually tampered with your logs. So it's not going to prevent someone from being able to tamper from your logs, but it's going to at least let you know how much you can trust your logs. So I do want to emphasize that CloudTrail can deliver its events to CloudWatch. So there's an option after you create the trail where you can hit configure, and then it will send your events to CloudWatch logs. All right. I know CloudTrail and CloudWatch are confusing because they seem like they have overlapping of responsibilities. And there are a lot of AWS services that are like that. But, you know, just know that you can send CloudTrail events to CloudWatch logs, not the other way around. And there is that ability to connect the two. There are different types of events in CloudTrail. We have management events and data events. And generally, you're always looking at management events because that's what's turned on by default. And there's a lot of those events, so I can't really list them all out for you here, but I can give you a general idea what those events are. So here are 4 categories. So it could be configuring security. So you'd have attach role policy. You'd be registering devices. It would be configuring rules for routing data. It'd be setting up logging, okay? So 90% of events in CloudTrail are management events, and then you have data events. And data events are actually only for 2 services currently. So if you were creating your trail, you'd see tabs, and I assume it's when they have other services that can leverage data events, we'll see more tabs here. But really, it's just S3 and Lambda, and they're turned off by default for good reason because these events are high volume. They occur very frequently, okay? And so this is tracking more in detail S3 events such as get object, delete object, put object. If it's a Lambda, it'd be every time it gets invoked. So those are just higher there. And so those are turned off by default, okay? Now it's time to take a quick tour of CloudTrail and create our very own trail, which is something you definitely want to do in your account. But before we jump into doing that, let's go over to event history and see what we have here. So AWS by default will track events for the last 90 days. And this is a great safeguard if you have yet to create your own trail. And so we have some event history here. And if we were just to expand any of them, doesn't matter which one, and click view event, we get to see what the raw data looks like here for a specific event. And we do have this nice interface where we can search via time ranges and some additional information. But if you need data beyond 90 days, you're going to have to create a trail. And also just to analyze this, because we're not going to have this interface, we're going to have to use Athena to really make sense of any CloudTrail information. But now that we have learned that we do have event history available to us, let's move on to creating our own trail. Let's go ahead and create our first trail, and I'm just going to name my trail here ExamPro Trail. I do want you to notice that you can apply trail to all regions, and you definitely want to do that. Then we have management events where we can decide whether we want to have read-only or write-only events. We're going to want all of them. Then you have data events. Now these can get expensive because S3 and Lambda, the events that they're tracking are high-frequency events. So you can imagine how often someone might access something from an S3 bucket, such as a get or a put. So they definitely do not include these, and you have to check them on here to have the inclusion of them. So if you do want to track data events, we would just say for all our S3 buckets or specify them. And Lambdas are also high frequency because we would track the invocations of Lambdas, and you could be in the thousands upon millions there. So these are sanely not included by default. Now down below, we need to choose our storage location. We're going to let it create a new S3 bucket for us. That seems like a good choice. We're going to drop down advanced here because it hides some really good tidbits here. So we can turn on encryption, which is definitely something we want to do with KMS. And so I apparently have a key already here. And so I'm just going to add that. I don't know if that's the default key. I don't know if you get a default key with CloudTrail. Usually you'd have one in there, but I'm just going to select that one there. Then we have enable log file validation. So we definitely want to have this to yes. It's going to check whether someone's ever tampered with our logs and whether we should not be able to trust our logs. And then we could send a notification about log file delivery. This is kind of annoying, so I don't want to do that. And then we should be able to create our trail as soon as we name our bucket here. So we will go ahead and just name it. We'll say ExamPro Trails, assuming I don't have one in another account. Okay, and so it doesn't like that one. That's fine. So I'm just going to create a new KMS key here. KMS keys do cost $1 per, so if you want to skip the step, you can totally do so. I'm just going to create one for this here called ExamPro Trails. Okay. Great, and so now it has created that trail, and we'll just use the site here, and then maybe we'll take a peek here in that S3 bucket when we do have some data. All right. I do want to point out one more thing is that you couldn't set the CloudWatch event to track across all organizations. I didn't see that option there. It's probably because I'm in a sub account. So if I was in my, if you have an AWS organization, right, and this was the root account, I bet I could probably turn it on to work across all accounts. So we didn't have that option there, but just be aware that it is there and you can turn a trail to be across all organizations. So I just had to switch into my root organization account because I definitely wanted to show you that this option does exist here. So when you create a trail, we have applied to all regions, but we also can apply to all organizations, which means all the accounts within an organization, okay? So, you know, just be aware of that option. So now that our trail is created, I just want you to click into it and be aware that there's an additional feature that wasn't available to us when we were creating the trail, and that is the ability to send our CloudTrail events to CloudWatch logs. So if you wanted to go ahead and do that, you could configure that and create an IAM role and send it to a log or CloudWatch log group. There are additional fees applied here, and it's not that important to go through the motions of this, but just be aware that that is a capability that you can do with CloudTrail, okay? So I said earlier that this will collect beyond 90 days, but you're not going to have that nice interface that you have in event history here. So how would you go about analyzing that log? And I said you could use Amazon Athena. So luckily they have this link here that's going to save you a bunch of setup to do that. So if you were to click this here and choose the S3 bucket, which is this one here, it's going to create that table for you in Athena. We used to have to do this manually. It was quite the pain. So it's very nice that they've added this one link here, and I can just hit create table. And so what that's going to do, it's going to create that table in Athena for us, and we can jump over to Athena, okay? And yeah, it should be created here. Just give it a little refresh here. I guess we'll just click get started. I'm not sure why it's not showing up here. We're getting the splash screen. But we'll go in here and our table is there. So we get this little goofy tutorial. I don't want to go through it, but that table has now been created and we have a bunch of stuff here. There is a way of running a sample query. I think you could go here and it was preview table, and that will create us a query, and then it will just run the query, and so we can start getting data. So the cool advantage here is that if we want to query our data, just like using SQL, you can do so here in Athena. I'm not doing this on a day-to-day basis, so I can't say I'm the best at it, but you know, if we gave this a try here and tried to query something, maybe based on event type, I wonder if we could just like group by event type here. So that is definitely a option. So we say distinct. Okay, and I want to be distinct on maybe event type here. Okay. It doesn't like that. What if I just take that out there? Great. So there we go. So that was just like a way so I could see all the unique event types. I can just take the limit off there. The query will take longer. And so we do have that one there. But anyway, the point is that you have this way of using SQL to query your logs. Obviously, we don't have much in our logs, but it's just important for you to know that you can do that. And there's that one button press there to create that table and then start querying your log data. So we're onto the CloudTrail cheat sheet, and let's get to it. So CloudTrail logs calls between AWS services. When you see the keywords such as governance, compliance, operational auditing, and risk auditing, it's a high chance they're talking about CloudTrail. When you need to know who to blame, think CloudTrail. CloudTrail by default logs events data for the past 90 days via event history. To track beyond 90 days, you need to create a trail. To ensure logs have not been tampered with, you need to turn on log file validation option. CloudTrail logs can be encrypted using KMS. CloudTrail can be set to log across all AWS accounts in an organization and all regions in an account. CloudTrail logs can be streamed to CloudWatch logs. Trails are outputted to S3 buckets that you specify. CloudTrail logs come in two kinds. We have management events and data events. Management events log management operations, so attach role policy. Data events log data operations for resources, and there's only really two candidates here, S3 and Lambda. So think get object, delete object, put object. Data events are disabled by default when creating a trail. Trail logs in S3 and can be analyzed using Athena. I'm gonna have to reword that one, but yeah, that is your cheat sheet. Hey, this is Andrew Brown, and we are looking at AWS CloudFormation, which is a templating language that defines AWS resources to be provisioned or automating the creation of resources via code. And all these concepts are called infrastructure as code, which we will cover again in just a moment here. So to understand CloudFormation, we need to understand infrastructure as code because that is what CloudFormation is. So let's reiterate over what infrastructure as code is. So it's the process of managing and provisioning computer data centers. So in our case, it's AWS through machine readable definition files. And so in this case, it's CloudFormation template YAML or JSON files, rather than the physical hardware configuration or interactive configuration tools. So the idea is to stop doing things manually, right? So if you launch resources in AWS, you're used to configuring in the console all those resources, but through a scripting language, we can automate that process. So now let's think about what is the use case for CloudFormation. And so here I have an example where let's pretend that we have our own Minecraft server business and people sign up on our website and pay a monthly subscription, and we will run that server for them. So the first thing they're going to do is they're going to tell us where they want the server to run, so they have low latency, and what size of server. So the larger the server, the more performant the server will be. And so they give us those two inputs, and then we somehow send that to a Lambda function, and that Lambda function triggers to launch a new CloudFormation stack using our CloudFormation template, which defines, how to launch that server, that EC2 instance running Minecraft in a security group, in what region, and what size. And when it's finished creating, we can monitor maybe using CloudWatch events that it's done, and using the outputs from that CloudFormation stack, send the IP address of the new Minecraft server to the user so they can log in and start using their server. So that's a way of automating our infrastructure. So we're going to look at what a CloudFormation template looks like, and this is actually one we're going to use later on to show you how to launch a very simple Apache server. But CloudFormation comes in two variations. It comes in JSON and YAML. So why is there two different formats? Well, JSON just came first, and YAML is an indent-based language, which is just more concise. So it's literally the same thing, except it's indent-based, so we don't have to do all these curlies. And so you end up with something that is in length half the size. Most people prefer to write YAML files, but there are edge cases where you might want to use JSON. But just be aware of these two different formats, and it doesn't matter which one you use, just use what works best for you. So now we're looking at the anatomy of a CloudFormation template. And so these are made up of a bunch of different sections, and here are all the sections listed out here, and we'll work our way from top to bottom. And so the first one is metadata. So that allows you to provide additional information about the template. I don't have one in the example here, and I rarely ever use metadata, but it's just about additional information. Then you have the description. So that is just describing what you want this template to do, and you can write whatever you want here. And so I've described this template to launch an EC2 instance running Apache, and it's hard-coded to work for US East 1. Then you have parameters, and parameters is something you're going to use a lot, which is you defining what inputs are allowed to be passed within this template at runtime. So one thing we want to ask the user is what size of instance type do you want to use? It's defaulted to micro, but they can choose between micro and nano, okay? So we can have as many parameters as we want, which we'll use throughout our template to reference. Then you have mappings, which is like a lookup table. It maps keys to values, so you can change your values to something else. A good example of this would be, let's say you have a region, And for each region, the image ID string is different. So you'd have the region keys mapped to different image IDs based on the region. So that's a very common use for mappings. Then you have conditions. These are like your if-else statements within your template. Don't have any examples here, but that's all you need to know. Transform is very difficult to explain if you don't know what macros are. But the idea, it's like applying a mod to the actual template, and it will actually change what you're allowed to use in the template. So if I define a transform template, the rules here could be widely different based on what kind of extra functionality that transform adds. We see that with SAM, the serverless application model is a transform. So if you ever take a look at that, you'll have a better understanding of what I'm talking about there. Then you have resources, which is the main show to the whole template. These are the actual resources you are defining that will be provisioned. So think any kind of resource, IAM role, EC2 instance, Lambda, RDS, anything, right? And then you have outputs, and outputs is it's just what you want to see as the end results. So like when I create the server, we don't know what the IP address is until it spins it up. And so I'm saying down here, get me the public IP address. And then in the console, we can see that IP address so that we don't have to like look at the EC2 console and pull it out. But the other advantage of outputs is that you can pass that information onto other CloudFormation templates or create a chain of effects because we have these outputs. But the number one thing you need to remember is what makes a valid template. And there's only one thing that is required, and that is specifying at least one resource. All these other fields are optional, but resource is mandatory, and you have to have at least one resource. So if you're looking for CloudFormation templates to learn by example, AWS Quick Starts is a great place to do it because they have a variety of different categories where we have templates that are pre-built by AWS partners in the APN, and they actually usually show the architectural diagram. But the idea is you launch the template, you don't even have to run it. You could just press a button here and then actually see the raw template. And that's going to help you understand how to connect all this stuff together, because if you go through the AWS documentation, you're going to have to spend a lot of time figuring that out, where this might speed that up if this is your interest. So I just wanted to point that out for you. It's not really important for the exam. It's not going to come up as an exam question. It's just a learning resource that I want you to consider. Let's talk about stack updates. So the idea is that you have a CloudFormation template and you deploy it, and now you need to make some kind of change. And so you might think, well, all right, I have to delete the entire CloudFormation template and then re-upload and recreate the entire stack, but that's not the case, because with CloudFormation, you can just modify your existing CloudFormation template, push that stack to update, and then CloudFormation is going to intelligently change, delete, reconfigure your resources. So you're doing the least amount of work to make those changes, and you're not doing the most destructive path possible. There are two ways to perform stack updates in CloudFormation. First, we have direct update, and this is very straightforward. The idea is you're going to directly upload your template to CloudFormation. You could use the CLI for this. And then it's going to just immediately deploy. So CloudFormation is just going to go ahead and apply that directly to your existing stack. And this is super fast to do. The other method is using change sets. So the starting process is the same. You're going to upload your template to CloudFormation. But what's going to happen is that a change set is going to be generated. And all that is just a way of showing you the difference between what the current state of the stack is and what changes will be made. And the idea is that it gives you an opportunity to audit or review what gets changed. And so in order for those changes to take effect, a developer has to manually confirm saying, yes, I'm happy with these changes, go ahead and do it. Okay, so that's the two methods for stack updates. So we were saying that stack updates are intelligent, and CloudFormation figures out what should be performed, whether it should just reconfigure it or recreate that resource. So let's talk about the circumstances or the actions that CloudFormation could take during an update on a resource. And so the first one is update with no interruption. So imagine you have an EC2 instance and you just need to have something changed on it, like a security group or something. So the idea is that this update will be performed without affecting the operation of the actual service. So the availability of the service will still remain. The physical ID will not change. So for EC2, you actually have like an ID for it. And maybe here when they say physical ID, that could also mean like the Amazon resource name will not change. So, you know, it's just, this is just a configuration has taken effect. The next case is where we have updates with some interruption. So there could be cases where we don't need to destroy the server, but we need to maybe disassociate it with a load balancer and then reassociate it, or same thing with an auto scaling group. But because that happens, there is a chance for the service to experience downtime, unavailability, but the physical ID is going to remain the same. Then the third case is where replacement has to occur. So there's no way around it. The only way is to create a new instance or delete the old one and make a new one. A good example is launch configurations. Launch configurations cannot be modified. They can only be created and cloned. And so in this case, you're getting a new resource, and that new resource is going to have a new physical ID. So those are the three cases. So let's talk about preventing stack updates, because it's possible in certain circumstances you don't want there for an instance to be replaced, because let's say you had an RDS database and the action that would be taken that would replace the database, that would result in data loss. So you'd say, no, I don't want that updated. Or it could be that you have a critical application and there's certain EC2 instances that cannot be interrupted. So what you can do is create a stack policy and specifically say that, you know, you're not allowed to do an update replace on this DynamoDB table, and then all other actions are allowed. So that's a great way to just make sure that critical resources are not affected by these stack updates. So let's take a look here at CloudFormation nested stacks. And nested stacks allow you to reference CloudFormation templates inside of another CloudFormation template. And the advantage that we're going to get here is we're going to be able to create modular templates. So we're going to get reusability, and we're going to be able to assemble larger templates. So that's going to reduce complexity of managing all these templates. And so just to get like a hierarchy kind of view, you have at the top here this root stack. And then underneath, you can nest stacks into stacks. And you can see we can go down multiple levels. So it's not just one level down. But to understand like who can access what, generally we have nested stacks can access anything from their immediate children. But the root stack is accessible by everybody. So no matter where the stack is, anything that's defined up there is accessible everywhere. And just to show you like how you would use a nested stack. So here I have one where it says my stack. And then what we're going to do is define that type of CloudFormation stack. And then we're just going to have to provide access to that template. And you're going to want to store that template in S3 and serve it up from there. So there you go. So let's take a look at drift detection in CloudFormation. And to understand this, we need to first understand what is drift. So drift is when your stack's actual configuration differs, so has drifted by what CloudFormation expects it to be. So why does drift happen? Well, when developers start making ad hoc changes to the stack, a good example is they go ahead and delete something. So maybe you provisioned a bunch of stuff in CloudFormation and it created an EC2 instance that you didn't need anymore, so the developer deleted it. But when you go back to the CloudFormation console, it still says it's there, but you know that it's been deleted. And that can cause complications, or it just doesn't give you good visibility in terms of, you know, what resources you have and what state they are in. And so what that developer should have done is they should have went and updated that CloudFormation template and let the CloudFormation delete that resource. So CloudFormation has this feature called Detect Drift, and it does is what we've been talking about here, which is it determines whether something's been deleted or it has been modified. And so all you got to do in your CloudFormation stack there is just drop down, turn on Detect Drift, and then you can view the results. Now, I do want to mention about nested stacks and drift detection. So when you are detecting drift on a stack, CloudFormation does not detect drift on any nested stacks that you belong to. Instead, you can initiate a drift detection operation directly on those nested stacks. So you have to turn it on for all the individual stacks. It's not going to trickle down to every single thing in your hierarchy there. So let's just take a quick peek here at what drift detection kind of looks like. So the idea is you would turn it on and it would tell you whether your stack has drifted. And you can see when it last checked to see if it's drifted. These are the possible statuses that your resources could be in. So it could be that it's been deleted, it's been modified, it's in sync, meaning everything is good, and not checked. So there's cases where it just CloudFormation hasn't checked it. In fact, if you first launch or you turn on drift detection, you have to wait till that check has happened. So all of them will say not checked. And just to take a look at what that looks like, here I have a bunch of resources. And on the right-hand side, you can see there's some that have been deleted, there's ones that are in sync, and there are ones that are modified. So there you go. Let's just talk about rollbacks here with CloudFormation. So when you create, update, or destroy a stack, you could encounter an error. And if you encountered, and like an example of an error could be like your CloudFormation template has a syntax error, or your stack is trying to delete a resource which no longer exists. And so now it has to roll back to get it back into the previous state. That's the whole point of rollbacks. So rollbacks are turned on by default. You can ignore rollbacks by using this command flag. So you say ignore rollback. If you are triggering this via the CLI, I don't know if you can do it via the console. I don't think so. And rollbacks can fail. So sometimes you'll have to investigate and change resources or configurations to get it back to the state that you want. Or you might have to use paid AWS support to resolve that issue on a failed rollback. Now, these are the states that you will see it. So when a rollback is in progress, you'll see rollback in progress. When a rollback succeeds, you'll see update rollback complete. And when a rollback fails, you'll see update rollback failed. So, there you go. So let's take a look at pseudo-parameters in CloudFormation. So parameters that are predefined by CloudFormation, you do not declare them in your templates. Use the same way as you would a parameter. So use ref function to access them. So here is an example of us using a predefined parameter. The one here is called AWS ::region. And so, what are these? And these are what they are. So we have AWS partition, AWS region, AWS stack ID, stack name, URL suffix. So not to go through all these because it's not that important, but let's go through region because I think that is a very prominent one you'll end up using a lot. And so the idea is that let's say you need to get the current region that this CloudFormation template is running in. So what you can do is, as you were seeing there, we do AWS ::region. And if this was running in US East 1, that's what it would return. So that is pseudo parameters. So let's take a look at resource attributes for CloudFormation. These are additional behaviors you can apply to resources in your CloudFormation templates to change the relationships and just how things happen when you have stack updates or deleting operations. So the first one we want to look at is creation policy. And what this is going to do, it's going to prevent the status from reaching a create complete until CloudFormation receives a specified number of success signals or the timeout period is exceeded. So on the left or right hand side, we could see we expect either 3 successes or we have a timeout of 15 minutes. And that's just to make sure that everything has successfully created. So it's just an additional check there that you can put in there. Then you have deletion policy. And so this is going to happen when you are deleting something. So let's say you have a resource like an RDS database, and you want to make sure that anytime it's deleted, it takes a snapshot. So that's what you could do. I think in most cases, you're going to want to retain that database. You generally do not want to delete your database, but it's going to depend on the situation. So you have delete, retain, and snapshot. The next one is update policy, and this is only for ASG, Elasticache, domain, and Lambda aliases. And it's just whether the handle is going to get replaced. And so you got a Boolean, you either say yes or like true or false, and that's all there is to it. Then you have update replace policy. So this is when you are doing a stack update, and it's the question of what's going to happen when that stack update occurs. Are you going to delete the resource, retain it, or take a snapshot? So it's kind of similar to deletion policy, but it's when resources are being replaced. The last case here is depends on. And so this is when you have a resource that's dependent on another resource. So you want that resource created first. So in our scenario here, we have an RDS database, an EC2 instance, and we're saying before you make the EC2 instance, go make the RDS database first. And so, yeah, those are the resource attributes we can apply. So let's take a look here at intrinsic functions for CloudFormation. And what these do is allow you to assign values to properties that are not available until runtime. And the two most popular ones are all the way at the bottom there, and that is reference and get attribute. And these are so important that we're going to cover them shortly here in other slides, but let's just talk about them quickly here. So reference is going to return the value of a specified parameter or resource, and get attribute will return the value of an attribute from a resource in the template. That doesn't make sense right now. Don't worry, we're going to cover it here shortly. So let's go to the top of the list and just see what kind of stuff that we can do with intrinsic functions. The first one is base64. So this returns the base64 representation of the input string. There's just some cases where you need them to be base64. I can't think of anything off the top of my head. I've definitely had to use this before, but yeah, there's cases for that. Then you have CIDR. So CIDR, it returns an array of CIDR address blocks. When you're working with VPC resources, it needs to be in the CIDR format. So that's when you'll be using that function. Then you have condition functions. And so here we have n equals if, not, and or. So this is going to allow us to have a bit more logic within our CloudFormation template. So if you want to add that kind of stuff, that's what you got there. Then you have find and map. Find and map is used with the mapping section. So whenever you're doing a mappings, you're going to definitely be using find and map. And as the name implies, is trying to find a corresponding value to a key. So that's what that is for. Then you have transform. Transform is super interesting, and it's used with SAM. So the serverless application model, which we definitely cover in another section, actually right after CloudFormation, that's what we look into next here. And what it does is it performs a macro on part of the stack on CloudFormation. So what it essentially does is changes the logic of how you can actually write CloudFormation templates, giving you access or extending the ability of CloudFormation to do things that it couldn't do before. Then you have getAZs. This is going to return a list of availability zones for a specified region. Then you have import value. This is really important when you're working with nested stacks. So this returns the value of an output exported by another stack. So it's kind of a way to have stacks talk to each other. Then you have join. So if you have an array and you want to turn it into a string where they're delimited by comma, you'd use join. Then you have select. So let's say you have an array and you want to select an object out of that list by providing its index, you'd use select. Then you have split. Split is the opposite of join. So you have a string that might be delimited by commas and you want to turn that back into an array, you'd use that. And you have substitute. This is where you can substitute a variable in an input string with another value. So generally, you know, replacing a part of a string. Those are intrinsic functions. All right, so let's take a look at reference in closer detail here. So reference, short for ref, returns different things for different resources. And you'll need to look up each resource in the AWS docs to figure out what it's returning, whether it's an ARN, a resource name, or a physical ID. And so here's an example, and we have a parameter for address VPC, and then we are accessing it down below. And so this example is actually for parameter. It's not for a resource. So for this one, it's very straightforward for parameters, but resources is a totally different thing. But I want you to know that if there's something you can't get with a reference, then it's a good chance that you can get it with get attribute. So let's go take a look at get attribute now. So here we're taking a look at get attribute, and this allows you to access many different variables on a resource. And you know, sometimes there's lots, sometimes there's very few. But you'll, again, have to check the AWS docs to see what's available per resource. So here in our example, we have a security group at the top. And then down below, you can see we are referencing that resource with get attribute. And then we're getting the group ID. But yeah, that is get attribute. But let's hop over to the docs and take a look. All right, so here I am on the AWS resource and property types reference. And this is going to help us see what we can return with reference or get attribute. So let's take a look at EC2. That's always a good one to compare here. So I'll open that in a new tab, and maybe we'll look at DynamoDB. So to figure out what they return, and there's a lot of options for EC2, so we'll go EC2 instance. And for DynamoDB, we'll go DynamoDB table. But there's a lot of stuff here which tells you how to work with the EC2 instance, but we just care about reference. And the fastest way to find it is go to get attrib, because reference is right above it. And we will go over here and do the same thing. Oops, we'll type in get attrib. And so there it is. So here for EC2, when you pass the logical ID of the resource intrinsic function, so this returns the ID. So that's what it returns, okay? And then for DynamoDB, if you go over here, it's going to return the resource name. So there's a bit of difference there, but like it's confusing because sometimes with some resources, the ref will actually return the ARN, but in the case for DynamoDB, it doesn't return the ARN. You got to use get attrib to get it. And then with EC2 instance, these are the get attribs that you have with it. So that's pretty much what you have access to. And, you know, just be aware of that and just realize that there isn't consistency across the board here, and you'll have to do a bit of digging to figure it out every single time. So let's take a look at wait conditions. So wait conditions, as the name implies, waits for a condition. And there are two use cases where you're going to be using wait conditions. The first is to coordinate stack resource creation with configuration actions that are external to the stack creation. So what do I mean by that? Well, it just like matters of whether you're dependent on something outside of your stack. So maybe you have to make sure that this domain exists and it's not part of your CloudFormation template, or maybe you have to go hit an external API endpoint to make sure that something is working. So it's just something that is external and nothing about anything that you're spinning up within your stack. And the second case is to track the status of a configuration process. So maybe you know, you have a resource and you have to have that resource in a particular state. And so you're going to pull and continuously check to see whether it's in that state before proceeding forward. So those are your two use cases. And so here on the right-hand side, we actually have an example of a wait condition, and this is for an auto scaling group. This is actually pulled from the AWS docs, and it's kind of funny because AWS does not recommend, actually I think that's the next section, but wait conditions are similar to creation policies, but AWS recommends using creation policies for ASG and EC2, but here they're using ASG. But there could be a use case for using it for ASG, so we can't say that you can't use it with an auto scaling group. But if you look on the right-hand side, you see you have a wait handle, and then you have something that it depends on. So this depends on the web server group. And then you have a timeout, and you reference the web server capacity. So there's a lot of different options here. You'd have to read up the docs on it. But the takeaway is that a creation policy waits on the dependent resource, and a wait condition waits on the wait condition, and generally for something external from your stack. So hopefully that makes sense. Hey, this is Andy Brown from ExamPro, and welcome to the CloudFormation Fall Along, where we're going to learn how to write a CloudFormation template and go ahead and deploy an EC2 instance, all using the power of infrastructure as code. Now, you're going to need a Cloud9 environment to do this. You could do this locally on your computer, but it's a lot easier to do everything through here. And if you wanted how to get started with Cloud9, we show it in multiple fall alongs, but in this particular case, we were showing how to set it up in the Elastic Beanstalk fall along. So I would recommend doing that first before doing this fall along here, or just figure out how to get a Cloud9 environment set up. But once you're in here and you have a Cloud9 environment, what I'm going to do is I'm going to make a new directory to store this CloudFormation file. I'm going to call it mkdir cfn project to create that there. Then we're going to need a new file in there. So I'm just going to touch a new file. I'm going to call it template.yaml. It's important that you name it YAML instead of YML. It's just more consistent here. If you look up based on what is the best practice between the two, it just the whole community agrees to just do the full form here. So let's make our lives easier and just always do .yaml. Now that we have that file there, we can go ahead and open that up. So I'm just going to open that up. And of course, you could navigate here and click on it as well. And the first thing we need to specify is the template format version. So that is AWS template format version here. And that's going to be 2010-0909. And this line pretty much says this is the version of CloudFormation we're going to be used, and everything else, like anything that's in this template, is affected by this version. This version obviously hasn't changed in a long time since it's nearly 10 years ago. Maybe at some point they will change it. The next thing we'll want to do is add a description. And we are going to use this 2 characters to allow us to do multi-line in YAML. And I'm just going to say this as infrastructure for StudySync. We're not actually deploying the StudySync application just because it's a little bit too much work. But, you know, I figured we will just name it that anyway. I changed this to 2 spaces. You can have 4 spaces, but generally 2 spaces is a lot easier to work with. So that's what I'm going to be doing through this. YAML is indent-based, and you have to be very careful with YAML files, because if you are not using spaces, soft tabs, and you use hard tabs, you might receive errors. So we have our format version, we have our description, and the first thing we need to do is specify an actual resource. I'm going to type resources, and then we'll name our resource web server, and then it's going to be a type of AWS EC2 instance. Now I could wrap this in single quotations or double quotations, but YAML's pretty good about just turning this into a string, so I like to leave them naked, so to speak. In order to launch an EC2 instance, we're going to have to do a couple of things. But before we do that, I just want to show you how you would know what to fill in here if you had to read the docs. So I just type this here into the docs. And in CloudFormation, we have all these resources here. So if I really wanted to know EC2, I would go down to EC2, I would read it, and I'd say, okay, well, I want to launch an EC2 instance, and this would be the closest matching one. And that's how I would know how to add things to a CloudFormation template. And here they give you a full example in JSON and then in YAML. Obviously, YAML is a lot less verbose, and that's what people prefer to use. When AWS was first starting out with CloudFormation, it only had JSON, so YAML came later, and it is the preferred way of doing things. You can see all the formats. But the question is do we need to include all these attributes or properties? The answer is no, but you have to figure that out by looking at the actual properties here. It will either say required no, required yes, or required conditional. So the easiest way to find out what's required, we'll just do conditional. I don't think there's any yeses for EC2. And it says we need an image ID, and we're going to need a security group ID, which is conditional. Because I would think that if you didn't provide it, it would just automatically include the default. I think that's what it is, and that's what we'll probably do. We just won't include one at this point. So I think really we just need to include an instance ID and instance type. Actually, I don't think it says we have to include an instance type. I think that one is defaulted to something. It is defaulted to M1 small, and we're going to want a T2 micro because we want to save money. So let's make our way back over to here, and now that we've learned a little bit, what we're going to do is type in properties. And that's going to be all the properties for this resource that we're making. And so we saw instance type. I want this to be a T2 micro. Again, I could wrap this in single or double quotations. I just like to leave them naked. And the next thing we're going to need is the image ID. Now, the image ID is going to be the AMI ID. And AMI IDs vary based on region. So in order to get this, we're going to have to make our way over to the EC2 console. So type in EC2. And what we'll do is we'll pretend that we're launching a new instance. We're not going to launch an instance, but we'll just pretend as if we are. So I'll say launch instance here. And we will get the EC2 for North Virginia. Make sure you're in US East 1. This is going to be very problematic if you're not consistent about this. And this is what we want. They have 2 versions, x86 and 64-bit ARM. We want the x86 version. That's what we're used to using. ARM is very cool, but not for me today. So I'm going to copy that. And we are going to just paste that in. And that's all we need to launch an EC2 instance with CloudFormation. So in order to do this, we should probably put this in an S3 bucket. I'm just going to go quickly to the CloudFormation wizard to show you the steps that we're going to have to do and why we're going to put that in S3 in a second. So we'll go here and we have a lot of CloudFormation templates. I never created these. These were automatically created for me when we were doing other tutorials here, or I was running example applications. But go up to the top here and create a new stack, and we'll say new resources standard. And the idea is we're going to provide a template, and we can either provide one from S3 or we can upload our own template. This template is so darn small we could upload it, but I think it's good to get in the practice of putting it onto S3 because after a certain size, or like when a file gets a certain size and length, you have to store it in S3. And that's where you're going to want it to be because a lot of services expect to find your CloudFormation templates there. So what we'll do is we will use the CLI to create a new bucket and store it there. So I'm going to type in AWS S3 API create bucket. We're going to type bucket here. And then I'm going to call it study sync Andrew. I think I already used that, so I'm going to call it Andrew B. And we're going to say region US East 1. Now, be sure to customize this based on your name or some other value because these bucket names are unique across all AWS. So now that I have that there, we'll hit enter. And if this is successful, it should give us the location back, which it did, and that's all great. And now that we have our bucket, what we can do is go ahead and copy this template file to S3. So I'm going to type in AWS S3. And notice there's S3 API and then S3. I don't know why it's like that, but that's just how it is. We'll do environment, CFN project, template YAML, and then we'll specify the S3 path here. So it's going to be study sync Andrew B. And then we will do template.yaml. Oops. Look at that. YML. I'm already messing things up here. I'll just do that twice there. And I don't care about that other one. We'll let it hang around. If I can remember the delete command, and I cannot, but we'll try it anyway. Maybe I can delete that one there. Is that it? Yes, it is. There we go. My memory is doing well. So we now have copied that to CloudFormation. And so if we go back to here, we can provide the URL. Now notice it says HTTPS : and that is a different URL there. So if we go to S3 here, and we go and see our bucket, we have this one here. If we look at this item, it's going to show us this is the URL. So that's what the URL is. We'll make our way back to CloudFormation here. I'm going to paste that in there. We'll go ahead and hit click off. We could go to the viewer, the designer to check that out, but I don't really care about it. So we'll just go next. We have no parameters. I'm going to name this study sync. We'll hit next. We will leave all of these alone. These all seem good to me. Yep, these are all great. And we'll go ahead and hit next. We'll go all the way down the bottom and we will hit create stack. And it's going to have create in progress. And so now we just have to wait. We'll have to hit refresh here a bunch of times. This is going to take however long it takes to spin up an EC2 instance. If this fails, it will say rollback in progress. If we have a syntax error, it's totally possible we could have a very minute error that we had missed here because we were typing this all manually. And we'll just wait for this resource to complete. So I think it must, the template must be valid because it looks like it's spinning up an EC2 instance. So it's on its way. So we just have to wait for this to create here. So I'll see you here in a little bit. Okay, so our EC2 instance is now running here. 2 out of 2 checks have passed. There's not much we can do with this instance because it doesn't have a web server installed. It doesn't have a security group that exposes port 80. It's using the default. So there's a lot of work we need to do here. Let's make our way back to CloudFormation and just take a look at the events. So here we can see the previous events, and now it says create complete. A lot of times when you're waiting around here, you have to hit the refresh button to see these changes. Sometimes they'll give you a little blue pill telling you there are available events. So, just don't wait around and wait for things to happen. Click and see what's going on. So let's get a security group in here because that's the next thing that we're going to need. So what we'll do is we'll make our way back to Cloud9 and we're going to want to add a security group. So if we wanted a security group, it should be under EC2. Because it is a EC2 service. And if I typed in security group here, well, there it is. And so this is going to tell us all the information we need to know on setting up a security group. So let's go back here and we're going to create a new resource and I'm going to call this one security group. And then it's going to be type AWS EC2 security group. And the properties are going to be, it's going to need a VPC ID, which if we need that, we're going to have to provide our own variable for that. All right. We could just copy and paste ours in as we did with the image ID here, but I think it's time for us to start making this less brittle. We can give it a group description, which isn't a bad idea. So let's go ahead and do that. I'm going to say open port 80. We want to set an ingress rule. That means inbound traffic. So you have ingress and what is the other one? Outgress. I know ingress is inbound. So, and what we'll do is hit enter there. IP protocol. Oops. And I'm going to type in TCP. And then we'll just align with the IP there from port 80. And then we have to port 80. And then we have CIDR IP, colon. And in this case, I'll do double quotations. Just because it has like weird characters, I always think I have to do that here. It could be naked, I don't know. /0. And that says from anywhere on the internet, open up port 80, which is the common port for just plain old HTTP. I think that looks right. I'm just checking for spelling mistakes. So yeah, we're gonna have to deal with this. Also, I think while we're here, we might as well go ahead and turn this into a variable. So I'm gonna call that image ID, and we're gonna go and use some parameters. And so parameters is a great way for us to pass in variables at creation of a stack or at an update of a stack as well. So we defined one called image ID. We will default that to the value we just had there. Which I no longer have. So I'm just going to have to go to launch EC2 instance here quickly and then grab it again. So that's a great way to default an option when we know we want something to be something. All right. It's good to give these a description because then when it prompts us, it's going to tell us what they are. So I'll go ahead and do that. I'm going to say, am I to use EG? I'll just tell them what format it has to be. And this is going to be type string. Then the next one we need here is VPC ID. And we will give this a description. And we'll just say the VPC used by the SG. And just fix that spelling mistake there. We will call this type string. And we're not going to default this one. We'll pass this one in. And we're going to have to figure out what our VPC ID here in a moment. I'm just double checking this to make sure everything is A-OK. Looks good to me, but if we really want to know whether our template is good, we can use a tool called CFN lint, which is a node module. So I'm going to just go ahead and install that right now. And this is going to check to see if our application is good. -G means it's going to install it globally. And then what we'll do is I'm just going to CD into our directory, which we called CFN project here. And I'm just going to do CFN lint validate and then provide the template name there. And if it's good, it will say it's good. If it's not, it will error out. And look, it's already complained. So clearly I've done something wrong. I'm not sure what the problem is. I think it's because has an invalid type security group. Resource security group has an invalid type. So I've typed this wrong. It's supposed to have 2 colons here. I'll go ahead and save that. Now we'll validate it. I think we're getting closer. AWS EC2 security group. VPC ID is not a valid property. Okay. Oh, you know what? Lowercase here. Got to be really careful with these characters. Image ID, it's the same problem here. I capitalized the D on the end of it. If I can find it in here. Image ID, do you see it? As if you're going to tell me, right? Okay, we'll save that, and I'll just hit up here. And now the template's valid. So, I mean, it doesn't tell you exactly what the problem is. I mean, you have to hunt it down there a bit and make sense of it. And you will have to double check the names of these properties. But, you know, that's all there is to it. So what we'll do is we will go back here. And now that that's done, I guess what we'll do is we will upload this to cloud or back to S3, but let's automate that process because it's going to be tiresome to always type in the commands over and over again. So I'm going to touch a new file. I'm going to call this update.sh. So we're going to make a bash command here. We're going to chmod it, which changes it so that it can be executable. So if we didn't do that and we try to execute it, it's not actually a binary. It won't work, or whatever you want to call it. Just will not execute. Now that we have that file, I'm going to go ahead and open that up, and we are going to supply some information. We're going to tell it where to look for bash, first of all. which is always a great idea. It should already know what to do here, but this is just out of habit. I think you should always do that. And then what we're going to do is we're going to just type in our CLI or AWS CLI commands, and that's as simple as it is. So we'll type in template.yaml. We'll do s3:/ study sync, and I got 3 slashes in there. I'm sorry about that. It's a bit hard to see what I'm doing. So, and we'll type in Andrew B /template.yaml, and that looks pretty good to me. We'll go back down here, and now we'll just do /update.sh. You could do like, I think, sh or whatever, or bash, but I always just like to use the period. That's the way you execute bash files on Linux. We'll hit enter, and that should work. Yep, it gave us output. It uploaded it. So it looks like everything's great. So what we can do is we can go back to CloudFormation and update the stack. So I'm going to go ahead and do update. We're going to replace the current template, and then we're going to provide that S3 URL again. I'm going to make my way over to CloudFront or S3 because I cannot remember that URL. I'm going to paste that on in there. We'll hit next, and it's now going to ask us for that VPC ID. So what we need to do is go grab it. So I think we have our EC2 open here, but we will, an easier way to do this would be to just go back to stacks here, click into this one, and we've checked the resources. We can click into the actual instance we're using and get the exact VPC that it's using. Because it could be, if you have multiple VPCs, it could be in a different one. It should be in the default one because we didn't specify anything. So we're going to just find it, and there it is. I'm just going to hit that little copy button. We'll make our way back to CloudFormation here, paste that in. Fingers crossed, and I think this will work. Nothing new here that we need to choose. We're going to hit next. We'll go all the way down to the bottom, hit update stack. And there it goes. And so we're just going to have to wait a little while here. Hopefully it does not roll back on us. But since we've linted fine, the only thing that could mess up is we got those parameters wrong. So, oh, and I think it's already done. I think it was really, really fast because it didn't have to create a new EC2 instance. It's just adding a security group. So let's go to our resources, and now we can see we have a security group and a web server. I'm just going to close that tab there. We'll leave that open. We'll close that. And we already have this open. We'll close that. So what I want to do is just check out the security group. I just want to see if it actually set the port 80 to be open. If we go here to inbound, port 80 is open. That is what we want. Now the question is, if we check our web server, is the security group associated with it? And the answer is no, it's on the default because we actually never associated it in our Cloud9 template. So in here, yeah, we have this, we have that. We didn't put a property here for the security group. So that's what we're going to need to do next. Because we want to open up that port 80 when we install our Apache web server to view a web application. So what we're going to do is we are going to go ahead and add that property. And I'm just stalling for time as I look for the line that I have to type in. There it is. So what we need to do is add security group. Security group IDs. Wouldn't it be so nice if this all auto-completed for me? It's like if it actually auto-completed all the documentation, that'd be sweet. And what we're going to use is get ATT. We're going to type in the security group here, security group.group ID. And so this get attribs is a way of getting special properties on a resource here. And you're limited to what you can grab, but here we can grab the group ID, and that's what we need for this case. So I think that's all we need to do here right now. So let's go ahead and actually update this, our stack. And instead of going through here and click on that and do all that work, let's update our script here so that we can just automate this further. So I'm going to go here and type in AWS CloudFormation. And it's going to then be update stack. We are going to provide our region, which is a great idea. We don't want that to default to anything funny. Put a / there. We'll provide the stack name, which should be called study sync. We will provide the template URL, which will be this link here. We are going to need to provide those parameters. Oops. Parameters. And we are going to supply the parameter key. It's parameter key and then parameter value. Very verbose. They just don't want to make anything easy for us. VPC ID, we want it to be lowercase. And then we'll do parameter, it's going to be value. And that's going to have to be what our VPC ID is. So we'll go back here and we will grab it. There it is. So we'll grab it from there. And we will paste that in there. That all looks good to me. I'm just going to double check more thoroughly here. It's very easy to make a mistake when you're typing all this stuff, but I'm pretty sure that's good. And so now that our script is updated, we can just do update.sh. Fingers crossed, hopefully it works. And we have an error. Oh, geez. So the template URL or template body must be specified. So we have it right there, but we forgot that /. This / just allows us, or backslash leans to the left, / leans to the right. But this allows us to make this multi-line. We can make this all a single line, but that's really messy. So that should fix that issue. We'll hit up here. Oh boy, VPC ID must have values. I guess I named it this. Yeah, I did. And I guess I could lowercase this because we should really be consistent here. But then I'll have to go down here and do that as well. Just to make our lives a bit easier. Again, that's a little mistake on my part. And actually, before we update this, we should really be linting this. So we'll do scfn lint validate template.yaml. Everything's good. I'm going to just change this to lowercase here. Everything looks good. We'll hit up. We're still having a hard time. Security group IDs. Security group IDs. It's weird that the linter didn't pick that up. Invalid template property, resource property, security group IDs. So I'm just going to search that there. Security group IDs. Oh, you know what? It's got to be indented. My bad. And it's surprising the linter didn't pick that up. So maybe there's another tool out there that's a little bit better at checking that stuff. And there we go. We know it's created because it gave us back a stack ID. If we go back to our CloudFormation template and give it a refresh, we can see that it is updating. If we want to see that status actually in Cloud9, we can do it pragmatically by typing AWS CloudFormation describe stacks stack-name study sync. And I would probably output this as a table because it's a lot of information. It doesn't exist. Well, I typed it wrong. And so there it is. There's all our information. We could also get this back as JSON if we just took that off there. It's showing us the status of it. So it's saying update in progress. So it's kind of like a cool way of checking that up. So update complete. So it's almost done. And we can also monitor it through here. It's got to choose what you want to do. It says delete in progress. I guess it's deleting the web server. And if it's deleting the web server, that means we're going to have to wait a little bit here. So I will see you back here when this is 100% done. Okay, and so after a little wait here, everything is updated. Now it deleted the web server, and when I was building out this follow along, and I got to this stage, it didn't actually delete it. So clearly I have made a change, and maybe it's because I was fiddling with the names of the parameters there, or properties, that it forced a delete. So that's the thing with CloudFormation. It doesn't always delete resources, but in this case it did. And so I had to wait a little bit longer here. If we go over to EC2, we can see now that it's running. And let's say we wanted to actually go check out whether the security group is the correct one, and it is. But let's say we wanted to do this through Cloud9, or I should say the CLI here. And what we could do is get a list of the CloudFormation resources. So I'll do ableist CloudFormation list stack resources, stack name study sync. And here what we're getting is a list of resources, and in there we should have the security group, and that's going to give us that SG here, which is what we're going to need to check the next thing. And so we'll use AWS EC2 describe instances, instance IDs, and we will provide, actually we don't need the SG, we need the instance, because we want to see if the instance has the security group on it. That's what we're typing this out for. And I'm going to just output this as a table. You're kind of noticing a convention here: describe stacks, describe instances. That's why it's great to work with the CLI for a while. You just start to figure things out as you go. But you got to type it right if you want it to work. So we'll go back here, hit enter, and there it is. And so if we just look through this, there should be one called security groups. So we have the instance itself. Security group, where are you? There it is. And so we can see that it's attached. So there you go. So we definitely know that it's correctly attached, but if we just want to double check ourselves, we can go here and even check the inbound rule, and we see that port 80 is open. So now we have a web app with port 80 open, which is great. Now we just need to install our web server, and the way we can do that is through user data. Now, if you were launching an EC2 instance and you're just going through the steps here like I am, you get to this part, advanced details, and you provide the script into the user data, and that would initially set up whatever you want. That is one way to get that set up, and that's what we're going to do using CloudFormation. So we'll go back to our template here. I'm going to go to our template.yaml, and I'm just going to scroll on down here so I can see what I'm doing, and we're going to add another property to the web server, and we're going to call this one user data. And then we're going to add a function called base64, because this has to be base64. That's just how it is. And then we will use a sub on that because we need to substitute, well, we don't really need to substitute in the values, but in case we do, we should just do that out of habit. And this is the developer associate, so you don't need to know all these things in great detail. It's more so at the sysops and the DevOps. So that's why I'm kind of glazing over these things, because I'd rather you get more practical experience as to whether to actually know exactly how they work. And then we will do EC2 user, because it always starts you as the root user, and you got to force it to switch to EC2 user. Then we'll do sudo yum install HTTPD. That is Apache. You think they just call it Apache, but they don't. And then we'll do start, which will start the service, and then we'll do sudo service HTTP enable. So if that service is stopped for whatever reason, it will, if the server is restarted, it will continue running. I'm going to double check this to make sure this is right. User bin mvar bash looks good to me. I got that right. Yum y update, good. SSU EC2 user, great. Sudo yum install, that looks good to me. So everything is great. So that's all we need to do there. And while we're here, we might as well add some outputs. Outputs are going to make it easy for us to find values, so we don't have to click around everywhere. I'm going to make an output called public IP, because I want to get the IP of the web server, if you don't mind. And I believe that is typed correctly. I'm just going to double check here. Yeah, it looks good to me. So what we'll do now, I'm just going to scroll all the way up here. And what I'm going to do is I'm just going to CFN, or we're going to lint that. I'm just going to hit up till I find that linter. Says everything is good. But we found out earlier that's not always the case. And then we'll do our update.sh. Fingers crossed. Yep, that's great. So now that has been uploaded to S3 and it's doing a stack update. We're going to make our way back here to CloudFormation. I'm going to do refresh, and we can see this update is in progress. So we're going to have to wait on that. And what we're looking for is that output of the actual IP address. I don't know if it's going to replace the server in this case. It probably won't. If it did, that'd be great. But it says update in progress, so it's not doing a delete in progress for the web server. But anyway, we'll check back here in a moment. So we'll see you soon. So our update is done here, and notice that it didn't do a delete in progress. It just updated it. So that's interesting. If we go to output here, now we actually have that IP address, and it's going to make our lives a lot easier because now we can just place that in there. But it's not working. So that's a bit of a shame, but I actually know why it's not working. It's because it didn't replace the instance. It didn't delete it and recreate it. It just updated it in place. And the reason why I know that is the core reason why this is not working is that when you use user data, this script only runs the absolutely first time an instance has been launched. And so the only way for this to ever run again would be if you destroyed it and recreated that instance entirely. If you restarted it, it wouldn't run it again. There are ways of adding things here so that it will trigger a restart, I guess, in some cases, or like replace the actual instance, but it didn't. So what we're going to have to do here in this case is just delete our entire stack. And that's a great chance to see how deletions work. So what we'll do is go ahead and delete it, hit delete stack. And what it's going to do, Might have to go back a step here. It says delete in progress. It's better to see it on this level. We're going to see delete in progress. And deletes can actually fail and then roll back. But I don't think this one is going to. So what we'll do is we'll just wait a little while until this is done. And then we'll recreate our stack. And actually what we'll do while we're waiting here is we'll go to our update script. And we'll change this from update to create stack. And we're not going to run this until this one is done because you can't have a stack with the same name. We could just name our new stack a different name, but I want to keep this consistent. Oh, and it looks like it's done, so that was pretty darn quick. So that means I don't have to go away and we can just move on to the next step here. So we change this with create stack and we will just do an update. And that is going to create our new stack here. We'll do a refresh and there it goes. And we'll go to events. We'll just hit refresh here. And we'll have to wait a little bit because it's launching EC2 instance. So I'll see you then. Okay, and so we're back. I don't know if we're going to have the same IP address here. See, this one's 54.227.84.67. Nope, it's different. But we'll give that a go, and we'll see now if it actually works. And look at that. We got the test page up. So we fully automated something using CloudFormation. So that is pretty much the scope of what I wanted to show you here. And all we need to do now is just delete what we've created. So what we'll do is we'll do it through the CLI, because we already did it through here, so might as well learn how to do it through the CLI. And I'm going to take a guess, but I'm pretty sure it's AWS CloudFormation, delete stack, and then stack name, study sync. I tell you, the more you use the CLI, you just start guessing, and you're pretty much right. So I didn't get any output there. I'm going to go double check here, and I'm going to refresh, see what's going on. It says the delete is in progress, and there we go. So just make sure that this deletes, because sometimes deletes fail and they roll back, and you still have those resources around there. So if you don't want to be paying for something you don't need, just double check that there. But yeah, that's CloudFormation for you. So we're all done here. So we are on to the CloudFormation cheat sheet. This is a long one. It's like 3 pages long. Super important for the SysOps and developer associate, so we need to know this inside and out. So let's get into it. When being asked to automate the provisioning of resources, think CloudFormation. When infrastructure as code is mentioned, think CloudFormation. CloudFormation can be written in either JSON or YAML. When CloudFormation encounters an error, it will roll back with rollback in progress. CloudFormation templates larger than 51,200 bytes or 0.5 megabytes are too large to upload directly and must be imported into CloudFormation via an S3 bucket. Nested stacks help you break up CloudFormation templates into smaller reusable templates that could be composed into larger templates. At least one resource under resources must be defined for a CloudFormation template to be valid. I'm going to repeat that because it's so darn important in a second here. And let's talk about the template sections. And you definitely need to know these for the exam because they'll give you questions that you have to pick out which section does what. So we have metadata that is extra information about your template, the description that tells you what your template does. You have parameters. This is how you get user input into the template. Transform applies macros. This is like applying a mod, which can change the anatomy to be custom. And a good example of that is SAM, the serverless application model. I think that's what it stands for. Then you have outputs. These are values you can use to import into other stacks. You have mappings. These map keys to values, just like a lookup table. Resources, define the resources you want to provision. And here I'm going to repeat it again. At least one resource is required. Conditions are whether resources are created or properties are assigned. And those are all the properties. So again, make sure you know, or the sections, make sure you know them inside and out because it'll earn you a few points on the exam. On to the second page, stack updates. It can be performed 2 different ways. We have direct updates. And so the way those work, you directly update the stack, you submit changes, and AWS CloudFormation immediately deploys them. This is what you're going to be used to doing when you're using CloudFormation. Then the other way is executing change sets. So you can preview the change set to CloudFormation, you can preview the changes to CloudFormation will make to your stack, and that is what we call a change set. It's just telling you what's going to change. Then decide whether you want to apply those changes. So it's just like a review process. And then stack updates will change the state of your resources based on circumstances. So we have a few, we need to know them. So update with no interruption. So updates the resources without disrupting operation and without changing the resource's physical ID. Then you have updates with some interruptions. Updates the resources with resource with some interruption and retains the physical ID. Replacement recreates the resource during an update, also generates a new physical ID. You can use a stack policy to prevent stack updates on resources to prevent data loss or interruption to services. We have drift detection. This is a feature that lets CloudFormation tell you when your expected configuration has changed due to manual override. An example of this, let's say you have a CloudFormation template or a stack that creates a security group and a bunch of other resources. A developer comes in and deletes that SG. So CloudFormation would think that it's still there, even though it's not. And drift detection, if you turn that feature on, is going to tell you that something that it's no longer the case. And then on to the last page, and this is a long one. We're going to talk about rollback. So occurs when a CloudFormation encounters an error when you create an update or destroy a stack. When a rollback is in progress, you'll see rollback in progress. When a rollback succeeds, you'll see update rollback complete. When a rollback fails, you'll see update rollback failed. Then you have pseudo parameters, are defined parameters. So here we have a ref AWS region, which would return US East 1. So these are like AWS predefined parameters. Then we have resource attributes. So resource attributes, we have a lot of different policies under here. We have creation policy, prevents its status from reaching create complete until AWS CloudFormation receives a specified number of success signals or the timeout period is exceeded. Deletion policy, reserve or in some cases backup a resource when its stack is deleted, retain, or snapshot. Update policy, how to handle an update for an ASG, Elasticache domain, or Lambda alias. An update replace policy to retain or in some cases back up the existing physical instance for resource when it's replaced during a stack update operation. So we have delete, retain, or snapshot. And then we have depends on. The resource is created only after the creation of resource specified in the depends on attribute. And there's some cases where you use depends on. There's another case where you use a wait condition. So we have intrinsic functions, allow you to assign properties that are not available during runtime. Most important to know would be the ref one, returns the values of a specified parameter or resource. Get attrib, returns the value of an attribute from a resource in the template. And then just some CLI commands you should know. You should know the create stack command, because sometimes they'll have a question and they'll actually show you some CLI commands, and it's good to know what's what. Then you have the update stack one. And the last thing I want to just talk about is serverless application model is an extension of the CloudFormation, CloudFormation that lets you define serverless application. It doesn't get its own cheat sheet because there's just not enough information on it. There's a lot more stuff on CloudFormation, but like if this is for the associates, this is good enough. If you're going for the developer, the DevOps Pro, this is like a 6-page cheat sheet. So there you go. Hopefully this helps you on exam day. Hey, this is Andrew Brown from Exam Pro, and we are looking at Cloud Development Kit, also known as CDK, which is a way to write infrastructure as code using an imperative paradigm with your favorite language. So let's get into it. All right, so to understand CDK, I want to talk about transpilers here for a moment. So a transpiler turns one source code into another, and so CDK transpiles into CloudFormation templates. So, just a simple diagram. We have a CDK on the left, and then that turns into CloudFormation templates under the hood. And so this is the difference between an imperative infrastructure and a declarative infrastructure. So let's talk about these two differences. So imperative is when you have something that's implicit, you know what resources will be created in the end state, and this allows for more flexibility. You'll have less certainty because you don't know exactly what's going to be created. You don't have fully control or visibility on it, but you generally know what is going to happen. But you get to write less code. And so an example of something being imperative is saying, I want an EC2 instance, but you go and fill in all the other details. I just want to tell you that I want to have one. I don't want to have to worry about everything else. And so that is what CDK is. It's imperative. Then when we were looking at declarative, on the right-hand side here, it's explicit. We know what resources will be created in the end state. There's less flexibility. We're very, very certain of every single little thing that's going to happen, but we have to write a lot more code. And so a comparative example to imperative is, I want an EC2 instance, and I have to tell you exactly every detail of it. And that is what CloudFormation is. It's declarative by nature. So I said earlier you get to use your favorite language using CDK. And so let's talk about some of the language support it has. So CDK was first available only using TypeScript, and then they eventually started releasing for other languages. So we have Node, TypeScript, which again is just Node, Python, Java, and ASP.NET. So that's what we have so far. If you're wondering exactly what versions, that is what it supports. I'm still waiting for a Ruby version, and hopefully, when you're watching this video, a Ruby version becomes available. But generally, I think whatever language is supported by AWS generally is what we'll see. So I would not be surprised if they do a PHP one and also a Ruby one here. But I don't think you'll get one in PowerShell. I want to make a note about how up-to-date CDK is with CloudFormation. So the CDK API, they may have yet to implement specific APIs for AWS resources that are available in CloudFormation. It's just because it takes time for them to write this stuff, and they have a lot of languages to support. But it's my best guess that TypeScript would be the one that supports the most AWS resources. And then the other ones would follow behind. I would think Python would be next, and then Java, and then probably ASP.NET would be last. But just consider that in mind. So that is one of the things you have to think about with CDK, which is if you need full control of what CloudFormation offers, you might have to just use CloudFormation templates. So you do have to explore there and see what you can do. Hey, this is Andrew Brown from Exam Pro, and we are looking at Serverless Application Model, also known as SAM, and this is an extension of CloudFormation that lets you define serverless applications, and I always like to think of it as just as a CloudFormation macro where you use transforms. So let's get to it. So SAM is both a AWS CLI tool and also a CloudFormation macro, which makes it effortless to define and deploy serverless applications. And you might be looking at that word macro and thinking, what does it mean? So this is the textbook definition, which is a replacement output sequence according to a defined procedure. The mapping process that instantiates a macro use into a specific sequence is known as a macro expansion. Now that doesn't make a whole lot of sense, at least to me, so I've reworked that definition. And so I would say a macro allows you to change the rules on how code works, allowing you to embed a language within a language. Macros serve to make code more human readable or allow you to write less code. Creating a language with another language is called a DSL, a domain-specific language. And by using macros, you are creating a DSL. And so CloudFormation allows you to specify macros through the transform attribute, and this is how SAM is used. So what you do is you would use transform and then specify AWS serverless, and then you'd have access to now these new resource types. That's what this macro, SAM, is injecting into it. So you can define this function, this API and simple table, along with a bunch of other properties. So to really understand the value of SAM, it's great to put it against CloudFormation in a one-on-one comparison. So what I've done is set up an example here. So we have API Gateway calling a Lambda, and that Lambda gets data from a database such as RDS. So on the left-hand side, this is what it would look like if you wrote it in pure CloudFormation. So that's without SAM, and we're 100 lines in. And on the right-hand side, we have it with SAM. And so this is 50 lines in. So you have at least a 50% reduction in code when writing in SAM. And this is a more verbose example. I think in most cases, you could see 72 to 80% reduction in code just for when you're writing these serverless components. So you can see that SAM is going to save you a lot of time. So let's talk about the SAM CLI, because I said at the beginning of this SAM section that SAM is both a CLI and a CloudFormation macro. So the SAM CLI makes it easy to run, package, and deploy serverless applications or Lambdas. And these are its CLI commands. I don't think you need to learn them all, but it's good to go through them and get some hands-on with this kind of stuff. So starting at the top, we have SAM build, and that prepares the Lambda source and the code to be deployed by packaging it for upload. So it doesn't upload it, it just packages it into an artifact. The next one is SAM deploy, so that uploads the Lambda package code as an artifact and then deploy. If you're wondering what an artifact is, that's just a fancy word for a zip file. And then the next one here is SAM init. So if you have yet to start a project, you could run this, and it's going to give you a bunch of default folders and files, and it's going to be set up for a serverless project. I would think that this would be set up for the serverless application repository. So whatever default files you need there, I bet it would set it up for you. Then you have generate event. I think this is for testing. I've never used it, but you get different payloads for your event sources. Then you have invoke, which runs a single Lambda locally. Then you have start API that runs your serverless application locally for quick development. Then you have start Lambda, which is very similar to invoke, but looking at the two, I would probably say you'd more likely want to run start Lambda than invoke. So that is another one there. Then you have logs, which fetches I would think from CloudTrail would fetch the logs for that Lambda function, so you can see it locally without having to log into the console. And the last three really have to do with the serverless application repository, packaging a serverless application. So as package is for packaging a serverless application. So it creates a zip and uploads it. It seems like it kind of does build and deploy in one go. But again, for serverless application. Then you have publish, so that's going to publish it to the actual serverless application repository. Then you have validate, which just checks, I think, syntax errors for your SAM templates. So there you go. That's the big rundown there. Hey, this is Andrew Brown from ExamPro, and we're going to be looking at CI/CD, which is the automated methodologies that prepare, test, deliver, or deploy code onto a production server. Hey, this is Andrew Brown from ExamPro, and we are looking at the CI/CD models. And before we jump into those models, I want to just talk about a couple terminologies if you're not familiar with them, which is production and staging. Production, short for prod, is the live server where real paying users are using the platform, and staging is a private server where developers do a final manual test as a customer, which we call QA, and that is short for quality assurance. And they do this before deploying the code to production. So it's like that last check before there. So if you see staging and production and wondering what those mean, those are those terms. So this is our pipeline from code to deploy. And I'm going to show you three different models. And if you look online about CI/CD, you might see some additional steps in here. So there is a bit of flexibility in terms of like how these are defined. But this is what I'm going to show you, and it pretty much is what it is. So the first one we're going to look at is continuous integration, which is short for CI, and that's automatically reviews the developer's code. The next one is continuous delivery. That's automatically preparing developers' code for release to production. And the last one is continuous deployment, which is automatically deploying code as soon as developers push code and if all tests pass. And you're going to notice that both of these have the same initialism, which is a bit confusing, but that's just how it is. So if someone says CD to you, you got to get clarification because they could mean delivery or deployment. So let's move into these individually and learn more about them. Continuous integration is first on our list here, and so this is the practice of automating the integration of code changes from multiple contributors into a single software project. So our pipeline is going to be code, build, integrate, and test. And this, the reason we do this is it encourages small changes more frequently, and each commit triggers a build during which tests are run that help to identify if anything was broken by the changes. So it's somebody checking over the developer's code as they're coding, which is going to definitely speed up productivity with your team. So here is an example down below. So we have a developer and they push a new feature to GitHub in a new branch. And what that would normally do on GitHub is trigger a webhook to something like Circle CI. And then Circle CI would go create a new build server. That build server would pull in other developers' code, run the test suite, and then it would report back the results. And the results would give us test coverage saying how much test code has been written to cover the code. And the other part is, did any tests fail? And so that is generally what most people are familiar without of AWS. But if we're using AWS, we can just replace these things. So we can replace GitHub with code commit. We can replace that webhook with Lambda. We can replace Circle CI with code build. And the results would go into S3 and it would be called an artifact, which is a fancy word for a zip in code pipeline. So, that's continuous integration. So let's move on to the next one. So now we're going to look at continuous delivery, and this is the practice of automating the preparation of code to be released to production or staging branches. You're preparing the code base for deployment. Deployment is still a manual process. So in our pipeline, now we have code, build, integrate, test, and release with a strong focus on the last one, release. So here I have an example, and you're going to notice that half of it we've already seen in the previous example, but in this case, we're now using all AWS services. So we have code commit, the Lambda function, code build, and stuff like that. And so that was the continuous integration part. So now let's look at the continuous delivery. So we have that S3 artifact, which tells us that the test coverage is good. So in some projects, code can't be accepted unless you write a certain amount of test code. So whatever that threshold is defined per project. Could be 30%, could be 70%. And then all the tests pass. So that's great. And so we push that to a Lambda, and that Lambda is going to check and say, okay, all the tests and everything is good. So go ahead and make a pull request. It creates a pull request in code commit, and now that is left for the developers to review. So the developers are going to check over that code, and if they're happy with it, three of them are going to all vote on it. And if there's a consensus, then one person is going to decide to release that code. And so they say approved, and then that code gets merged into master. And so master is generally the production server, or it could be a production branch, but whichever, master production, usually the same thing. And so that doesn't mean it's deployed, but it's ready to be deployed. We're on our last model here, which is continuous deployment. And this is the same as continuous delivery, but it automatically deploys changes to production. And so there's our pipeline. It's blue all the way across. And here is our technical architecture. And it looks very similar to the last one, but we have a little bit on the end here. So we know continuous integration, we know continuous delivery, and now we're looking at continuous deployment. So the last thing we saw in continuous delivery was the feature branch being merged into master, so all the code was ready to be deployed. And so this is where continuous deployment comes in. So something would check to see if something changed in the source. It would be monitoring code commit or GitHub. And as soon as something was merged into it, it would then trigger code pipeline to start doing things. And in code pipeline, you would define something such as code deploy. So the source would then get checked out, maybe go to code build and run the test one final time. And if those pass, it passes on to code deploy, and then code deploy would start that process of deployment. And so that is the whole pipeline there. Hey, this is Andrew Brown from ExamPro, and we are at the end of the CI/CD section, so let's do a quick review with the CI/CD cheat sheet. So CI/CD is automated methodology that prepares, tests, delivers, or deploys code onto servers, and generally it'd be production servers, which can be abbreviated to prod, an environment which is intended to be used by paying users. It's your live server. Then you have your staging server, your staging environment, which is intended to simulate a production environment for last stage debugging. That's why they call it a staging server. Then you have continuous integration, represented as CI, and this is automating the review of developers' code, making sure their code is in good shape before we allow it to be turned into pull requests, or just to speed up our development cycle. So run tests with a build server. So in this case, we'd use code build, and that's how that would work. Then you have continuous delivery. So this is automating the preparation of the developer's code for release. So it's not being deployed, it's just one step before that. So an example here is very similar to the last one, except you'd run the test suite with a build server. If the test passed, it would automatically create a pull request or merge branch into staging, because sometimes staging is a precursor to production. So it's saying we're ready to deploy this code, but you need to check it over before doing so. Then continuous deployment takes that a step further, also abbreviated as CD. And the idea here is it's automatically deploying developers' code with which is ready for release. So it's all the steps prior. So it's going to run test suite with a build server, and here if the tests pass, then it's just going to immediately merge it into production and deploy it. So it just does everything automated end to end. And the last thing I just want to touch on continuous deployment here is that it can refer to the entire pipeline. So when you think of continuous deployment on AWS, you should be thinking of code pipeline, code commit, code build, and code deploy all combined. So there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at CodeCommit, which is a fully managed source control service that hosts secure Git-based repositories. And I like to think of it as the GitHub for AWS. So to understand CodeCommit, we need to know what a version control system is, and that is a system that records changes to a file or set of files over time so that you can recall specific versions later. A very famous story about a code base not having a version control system, I think, is either Doom or Wolfenstein. I can't remember which one, but the idea was that they had a bunch of people working on computers to program that game back in the early 90s. Since there was no version control system, or they weren't using one, they had to move code around on floppies. And, it was very difficult to manage all that code. And also, if you had one computer that had that source code, if anything happened to that computer, all your code was gone. So this is what version control systems alleviate. And so in 1990, we had CVS, which stands for, I think, Control Version System. Not a very creative name, but very clear as to what it does. Then you had Subversion. This is where I started out using SVN. And then in 2005, we had a renaissance for version control systems with Mercurial and also Git, which you might be familiar with. And Git is actually the most popular version control system, and there's good reason for it. It's a distributed version control system, and its goals, which it does definitely deliver on, is speed, data integrity, and support for distributed nonlinear workflows. So because of all those features of Git, that's why that is the primary one. And so any version control system, that is generally what it is using. So what is CodeCommit then? So CodeCommit is a service which lets you store your Git repositories in the cloud. So developers can push and pull code from the cloud repository, and it has tools to resolve conflicts. And so you just go ahead and create your repository, and then you could download your code from there, upload, and etc. And if you've ever used something such as GitHub, Bitbucket, or GitLab, this is the same thing, but this is just like AWS's solution for hosting repositories, but with some special features. So why would you want to use CodeCommit? So let's talk about the key features. And so the first one, which I think is a really strong point, is that it is in scope with a lot of compliance programs. So one compliance program is HIPAA. And so this might be an advantage it has over other competitors, or it might be more cost effective to get this compliancy, whereas like maybe with GitHub, you have to pay for enterprise support. It's very expensive. We're on AWS. It's very inexpensive. Repositories are encrypted at rest as well as in transit, so security is definitely a key feature. It can handle repositories with large numbers of files, branches, large file sizes, and lengthy revision histories, though I've never felt any kind of limitations on other platforms. So I kind of feel like they all do this, but it's great that they state that. There's no limit on the size of your repositories or the file types you can store. You keep your repositories close to your other production resources in the AWS cloud. Now that, to me, is the largest value, is that CodeCommit has a lot of synergies with a lot of AWS services. And the benefit there is going to help increase the speed and frequency of your development life cycles, and also to be able to code in some creative automation. And to control access to CodeCommit, you're going to use IAM. And that's going to say, hey, these users are allowed to have access to this repository. Hey, this is Andrew Brown from ExamPro, and we are looking at Docker, which is a third-party tool designed to make it easier to create, deploy, and run apps by using containers. To best understand containers, we should compare them against virtual machines, which is what we're used to using. So imagine we launch an EC2 instance, and anytime you launch an EC2 instance, it's likely going to launch you a virtual machine. And on that EC2 instance, there is a hypervisor installed, and that is what is used for launching VMs. So you launch your virtual machine, you choose Ubuntu, and you're going to have to go in and then set up your dependencies. So if you want to run a Django app, you're going to have to install Python and additional libraries to run that application. So you go ahead and you install that Django application. But this EC2 instance is really large, so you want to make best use of it as you can. So you say, okay, well, I'm going to put my MongoDB database on here. So you'd have to go on the server, install packages and binaries to run that, and then you say, Okay, I also want to run RabbitMQ on here. So you go into this virtual machine, install that. But the issue with installing multiple applications on a virtual machine is that some of these programs, their dependencies may not work best in a particular OS. So maybe RabbitMQ doesn't run best on Ubuntu, or maybe Django and Mongo have a similar library, but they have different conflicting versions, and that makes it hard for you to have them installed side by side. Another issue here is when they're all in the same virtual machine. Let's say RabbitMQ ends up eating up all the memory. There's nothing from stopping it from consuming all the memory and then installing the Django app, installing the MongoDB app. Or imagine if someone broke into your virtual machine. They now have access to everything. So there is an issue with all this shared space. So generally, people will not launch multiple applications on a virtual machine. They'll launch up additional EC2 instances and have an app per virtual machine, but you'll always end up with leftover space. And so that is an issue. It's because the idea is that you're always choosing a virtual machine that is never the correct size for the job at hand, or it's just, you can't make best use of that space. Now let's look at containers. So we launch an EC2 instance, and this has the Docker daemon installed, and that is what is used to launch containers. And so when you launch a container, the container has a OS, and even though you choose, this one's Alpine, but even though you're choosing this OS, not everything is actually virtualized. So all the hardware virtualization isn't part of that container, but you get to package in your custom libraries and packages and binaries, any dependencies that you need that are specific to this Django application. Now, when you want to launch MongoDB, you can just do so, and you package the libraries and the OS that is specific to MongoDB. And then you do that with RabbitMQ. Okay, and so you can see it's very easy to launch applications, and you can remove them easily as well. Whereas when you install everything on the virtual machine on the left, if you remove RabbitMQ, that doesn't mean the libraries and packages and binaries go with it. Or let's say you just want to kill MongoDB completely and reinstall it. You can't do that or you could, but it'd be a lot of labor to do so. So containers gives us a lot of flexibility to easily launch and destroy new applications. And so we think of this more as available space. So if this EC2 instance, we're not utilizing it all, it's easy for us to launch things into it. So just to reiterate, VMs do not make best use of space. Apps are not isolate, which could cause configuration conflicts, security problems, or resource hogging. Where with containers, this allows you to run multiple apps, which are virtually isolated from each other. You launch new containers and configure OS dependencies per container. So let's take a look at Docker files. And this is a file that is used to run the commands that would be required to assemble the final image, your Docker image. And so here's an example of a Docker file. And this is for setting up a Ruby on Rails application. And it has the Postgres client, so it can use Postgres database. And it's installing Node.js probably for its front-end stuff. But let's just walk through here and kind of understand how this Docker file works. So the first command we have here is called from, and this allows us to pull in another Docker image as the basis of our Docker file. The reason why you do this is because if you had to set up Ruby, there's a lot of dependencies, and this would make this file really large. So it's nice to be able to build off another Docker image. And after this Docker file is turned into a Docker image, you could then build off of that one. So that's kind of an interesting strategy. Then you have the run command, and this allows you to execute any kind of command that you normally run in Bash. So you see apt-get, so we're installing packages. And they have mkdir, that's for making a new directory. And it does this in layers. So every time a run command for whatever's in the scope of it, it turns it into a layer. And as Docker is building that image, it caches those layers. So let's say you made a change later in this Docker file. Then what it would do is it wouldn't rebuild from scratch. It would just go from the last cache layer and then on. So that makes rebuilding these a lot faster. The next thing is working directory, and this allows you to change the default folder for future commands. So it just makes it a lot less verbose when writing those future commands in this file. Then you have copy. This is going to copy files or folders from your local computer onto this image. Then we have the entry point. So this is the command that is executed when the container is first started, and you cannot override this command. So that's what it's going to be. Then you have the expose, and this allows you to listen on specified network ports at runtime. We can see the port is 3000. That is the default port for Ruby on Rails when you're running it in development mode. So it gives you an idea that this is a Ruby on Rails app that's using Postgres that is intended for development. And the last one here is the command, and it is passing the default arguments for the entry point. So we're not sure what's in the entry point.sh, but there's something in there because it is clearly a bash script that does something, and it was included into here. But what we're doing is we're passing in Rails server -b, so binding it to port 000, so that starts up the application. So hopefully that gives you a perspective of what a Docker file is and how they work. So I just want to cover some Docker commands here with you, and these are Docker commands that are very common, and I think that you should know them. There's definitely a lot more than what's in this list, but I thought we could just quickly go through it. So the first one is docker build, and this is the command you're going to use when you want to build an image from Docker. Then you have docker ps, which lists produces a list of containers. You're only going to see containers here that are actually running, so just be aware of that. Docker images is the list of images you have on your machine. So those are the Docker images you built from your Docker files, or if you pulled them from repositories. Then you have docker run, and this is going to run a command in a new container. Then you have docker push, and this is if you have an image, you want to push it to a repo. A repo here could be Docker Hub, or could be AWS's Elastic Container Registry, ECR. And then you have pull, so you could pull an image from a repo. So, those are the ones I think are important for you to get some hands-on experience with. So yeah, there you go. Hey, this is Andrew Brown from ExamPro, and we are looking at CodeBuild, which is a fully managed build pipeline to create temporary servers to build and test code projects. So, CodeBuild is a fully managed build service in the cloud. It compiles your source code, runs unit tests, and produces artifacts that are ready to deploy. It eliminates the need to provision, manage, and scale your own build servers, which, by the way, is really hard to do. I tried it, and I'll never do it again. It provides prepackaged build environments for popular programming languages and build tools such as Apache Maven, Gradle, and more. You can also customize build environments to use your own build tools, which is very useful. They're talking about using Docker and scales automatically to meet peak build requests. So now that we have a little bit of knowledge on CodeBuild, let's look at some use cases and dig in a bit deeper here. So let's look at a code build workflow. So the first thing is you're going to have to trigger code build somehow. You could do that via the AWS console, the CLI, the SDK, or the most common use case is that it's going to be part of your code pipeline. And after it pulls a source, it's going to pass that onto code build, and that's how it's going to get triggered. When you set up code build, you have to set up a build environment, and AWS has some pre-built managed images for you. So they have an Amazon Linux 2, Ubuntu, and Windows Server. If they don't have the things that you need installed on them, then you have to provide a custom image, which is a Docker image. And you would normally store this in ECR, Elastic Container Repository, where you'd upload your image, and you could reference it from that. You could reference from other Docker storage like Docker Hub, but you're probably going to use ECR. The next thing is the source code. So you need to get source code into that build project. So that you'd have to use a source provider. So that could be from CodeCommit, GitHub, Bitbucket, or etc. You probably could also just pass along the code. So see how there's like no source. So you could have no source, and as the build script triggers, it could then just use the internet and pull from there. But generally, you want to provide a source provider. And speaking of like how are we going to run our build, that comes down to that build spec YAML file, and this is generally part of your code base. So when you pull in that your code from the source provider, this file would be in that your root directory there, and it's going to talk about, or it's going to tell you all the commands that need to be run. But one thing I want to tell you that even if you have a build spec file with your project, you can override it with other build commands. which is very important for you to know for the exam, because they might bring it up saying like, hey, you have this build spec file, but you want to override it. How can you do it? So it's like, well, use the CLI for that. So hopefully that gives you kind of an idea about the code build workflow. So I just wanted to touch again on the build environment. So Docker images are managed by code build, which is AWS, so it's AWS managed. And so you want to check these images to see what comes pre-installed. So you choose that environment image. You have Amazon Linux 2, Ubuntu, Windows Server, and these are the images. So if you want to dig into them, they're in the AWS documentations, but you can see that there are 2 variants for Amazon Linux 2. There's 2 variants for Ubuntu, and these are images, so you could download them and theoretically run them in Docker and poke around and see what's in them. But I'm pretty sure they listed all in the docs there. So if your needs aren't met by these managed images, then you'll have to make a Docker image, store it on ECR, and then reference it that way. So let's look at a couple use cases for code build. The first one being generating out static pages from a Jamstack. Jam stands for JavaScript APIs and Markup. And so we have a website that was built with Gatsby. That's a Jamstack application that needs to render out static pages and deliver them to S3 static website hosting. So let's say we have our code or Gatsby code or a code commit. So we could trigger code build with the AWS console. Code build is going to pull from its source build being code commit. And then the build is going to render out those static pages. And then it's going to output that artifact into an S3 bucket. So those are ready for static website hosting. The next one is, let's say we want to run test code and report test coverage. This is probably the most common use case for code build. So developer needs to ensure their code passes all tests before being allowed to make a pull request. So, let's say you have a Ruby on Rails application and you've pushed some code to it to a feature branch. That's going to trigger a GitHub webhook that will trigger a Lambda function that uses the SDK to then tell code build to start building on the source code. And so the code build will pull down the Ruby on Rails project, and it's going to run RSpec, which will generate out test coverage and also say whether the test failed or not. And it's going to take those reports, put it in a zip, and then you could pass it on to another Lambda function, and then that information can get passed back to GitHub to determine whether that pull request should occur or not. So those are 2 use cases you could do. So let's take a look at the build spec YAML file, which is the most important thing you need to know about code build. You need to know this inside and out, and definitely get some hands-on experience with this because it's super important. So the build spec provides the build instructions. The build spec YAML needs to be at the root of your project folder. And here I have an example, and this is actually the one we use on Exam Pro. So we have a Ruby on Rails application, and so we don't use all the stages, but you generally use pretty much everything. And so let's walk through it. So the first thing we need to define is the version of the build spec. And so there's 0.1 and 0.2, and 0.2 is what is generally recommended. And if you want to know the difference, I don't think it's show up on the exam, but it's good to know. And this affects the default shell in the build environment. So 0.1 runs each build command in a separate instance, where 0.2 runs all build commands in the same instance build environment. So this is important because it tells you, what information is going to get shared into to the next command. So that changes the way you're going to write that file. So the next thing are phases. So phases are the commands that run during each phase of the build, and there is a very specific order that they go through. The first is install. So this is only for installing packages in the build environment. Then the next one is pre-build. So these are commands that run before building. Then you have build. So these are commands that you run during the build. Then you have post-build. These are commands you run after the build. So they're pretty straightforward in terms of their definitions. The only thing that's not clear is actually at what step does the source code get pulled. I think it is after the install step. So that is a step that is not very clear there, but it's not that important for the exam. But you should know these different build phases. And then the last thing there is artifacts. So we're not showing that here in this document, but you can configure the artifact to build somewhere else. So if you wanted, there's like a default place where that build artifact goes, but if you wanted to specify the S3 output, you could do so in here. And again, artifacts are just the results that are in a zip that go to S3. So there you go. All right, so we are at the end of the code build section, so let's move on to the code build cheat sheet. So code build is a fully managed build pipeline to create temporary servers to build and test code. Compile source code, run unit tests, and produce artifacts that are ready to deploy. Provides pre-packaged build environments, or you can build your own environments as Docker containers. Use a build spec YAML to provide build instructions. This file is stored in the root of your project, and we need to know the contents of this file, so let's go through it right now. So we have version 0.1 of this file, which runs each build command in a separate instance. Then you have version 0.2, which runs all build commands in a separate in the same instance. And I think it's when it says instance, it means like instance of a shell or bash shell, not necessarily another EC2 instance. That would be ridiculous. Then we have different phases. So we have, it runs these commands through different phases. So we have the install phase. So this is only for installing packages in the build environment. We have the pre-build stage, which is for commands that run before building. We have the build phase, which is commands that you run during the build. And the last one is post-build, which is for commands that run after the build. So there you go. That's code build in a nutshell, and we're ready for the exam. Hey, this is Andrew Brown from Exam Pro, and we are looking at Code Deploy, which is a fully managed deploy pipeline to deploy to staging or production environments. So looking at Code Deploy, it is a fully managed deploy service in the cloud. You can deploy to EC2, on-premise, Lambda, or Elastic Container Service. You can rapidly release new features, which is the idea behind Code Deploy. You can update Lambda function versions, so that is a method of deployment you can do there. You can avoid downtime during application deployment. This is generally with blue-green deployment because the idea is it replicates an entire environment and moves it over and then kills the old one, where in place generally takes effect on the existing server. So we have the ability to perform in place in blue-green, which we just talked about there a moment ago. It integrates with tools such as Jenkins, Code Pipeline, and other CI/CD tools, and it integrates with existing configuration management tools such as Puppet, Chef, and Ansible. All right, so the first thing we're going to look at here for core components is creating an application. This is the first thing you do in Code Deploy. And an application really is just a container for the rest of the components that make up Code Deploy. But for an application, it's as simple as going in and naming your application, and then you have to go ahead and configure a bunch of other components. The first component that you need to configure is deployment groups, and this is a set of EC2 instances or Lambda functions where your new revision is going to be deployed to. And then once you have your deployment group where you know you're going to do your deploys, you can then go ahead and create a deployment. And so you create a deployment and you choose the code that you want to upload, and then you can go ahead and configure that deployment with a lot of rules. So whether you wanted to roll back, or whether you wanted to like how you want it to fail, and a bunch of other rules in there, which we'll look at in more detail in the Code Deploy follow along. Then you're going to have your AppSpec YAML file. This is extremely important to know, and we definitely cover it in here in great detail. And this contains all the deployment actions that Code Deploy is going to use to figure out how to execute, or like how to install, restart your application on the actual server. It's just a YAML file. And then last here, we have the actual revision itself. So this is just an embodiment of all the changes that will take effect on the actual server. So that is your AppSpec YAML file, application files you'd have to install, configuration files you have to install, or any kind of executable. So there you go. That is the core components to Code Deploy. So it's very important that we know the difference between in-place deployments and blue-green deployments for Code Deploy. So we're going to start here with in-place deployments. So when you set up your deployment group, or I think it's the deployment group, you're going to get this option between in-place and blue-green. So we choose in-place, and then you choose the environment, whether you want to do EC2 in an auto-scaling group, or you could choose EC2 instances based off their tags, or you can actually choose on-premise instances. So let's understand the process of how this works. So the app on each instance in the deployment group is stopped. The latest app revision is installed and the new version of the application is started and validated. You can use a load balancer so that each instance is deregistered during its deployment and then restored to service after the deployment is complete. Generally, when you're doing in place, you want to use a load balancer. It's a great idea. And then last, only deployments that use EC2 on-premise compute platform can use in-place deployments. So notice that you cannot do a Lambda function here, and we do not have ECS clusters. So just be aware of that. And now we'll move on to blue-green deployment. All right, so let's take a look here at blue-green deployments for Code Deploy. So in here, you choose the blue-green option, and then you have choosing between the automatically copy EC2 autoscaling group or manually provision instances. You're definitely going to want to choose the first case, and this is what would generally show up on the exam if they do talk about this. And the idea here is if you already have an environment and it's using an autoscaling group, you specify it here. It's going to copy that one over, and a new EC2 instance is going to spin up. Code Deploy is going to then apply the latest code version and install it using the app-spec YAML file. And then what it's going to do is shut down the old environment, it will shift over the traffic from old to new and then destroy the old infrastructure. So let's go through that just again here. So instances are provisioned for the replacement environment. So that could be the auto-scaling group being cloned. The latest application revision is installed on the replacement instances. So if you're using code pipeline, it could be passing the artifact from the source to Code Deploy, and then it will install into the correct location. We'll see that in the app-spec YAML file, and then it will install from there. An optional wait time occurs for activities such as application testing and system verification. Instances in the replacement environment are registered with an ELB, causing traffic to be rerouted to them. So that's the shift of traffic. And instances in the original environment are deregistered and can be terminated or kept running for other uses. So people don't always terminate their old environments right away because sometimes you need to debug them or you need to fall back to them in the case of a disaster. So it's up to you on that case. So we're going to take a look at the app-spec YAML file, which is responsible for saying where the code should be installed and how to get the new piece of code running. And this example here is actually from the ExamPro's Ruby on Rails application. It's an older version, but it makes still for a very great example of a real-world use of this app-spec YAML. So we'll just walk through this, and there is some variation on this file here, but this file is a very good example. So the first thing is we choose our OS. This could be Linux or Windows. Then for files, we are saying where the code should be downloaded to. So / is after that zip is, because you provide the code in the form of a zip. So wherever that zip resides, take it and put it in home EC2 user app, because I want it to be an app. Then we can apply permissions to anywhere. So I just want to make sure that EC2 user is the owner of that app directory. And then we have our hooks. So you have an application stop. So this command should be responsible for doing the stop. If you notice, we're providing a location to a bash file. So the way app-spec YAML works is you write bash scripts for all of them, and then you specify them with part of the zip that is provided to Code Deploy. So the app-spec YAML will be in a zip, and then all these files, so this one, this one, this one, this one, this one, they'll all be in that zip there. Then you have a timeout, so you can set a timeout. I think there's one by default, but if you know generally how long these are going to run, you should set them, because this will just speed up the process if one of these hang for whatever reason. Then you can set what it should run as. So I would always say EC2 user, especially with Amazon Linux 1 and Amazon Linux 2. And let's look at some of the other hooks. So we have before install. So that's before it's downloaded the code to your server. After install, things that you'd want it to happen afterwards. And then commands to restart the application up. And I want to point out that the lifecycle event hooks are going to be different based on whether you're using EC2, ECS, and Lambda. So you have to look up the documentation to what's available to you, but this is for an EC2 instance, and so this is the most common use case. So when you do perform a deploy in Code Deploy, you're going to get to be able to visually see all the lifecycle event hooks that are available to you. As they perform, you'll see these go from pending to successful, or if they fail, they'll show you additional information. You can see that we get the durations of it. So it's a really good way to get that overview of it. In the case of a failure, it will look like this. So you can see that this script got through here and then it failed at this point, and then you click into that. And then once you click into it, you'll get a little bit more information. It's not always clear as what has gone wrong. So here you can see that it's saying start_puma.sh has failed. So that script in particular that I wrote had an issue. And then inside we might get some information actually as to what failed exactly. And this one is totally not clear. So there's a lot of cases where you have to log into the EC2 instance to debug Code Deploy. Generally what you want to do is stream your Code Deploy logs to CloudWatch logs, which I don't show you in this section, but it's something you definitely want to do if you're running Code Deploy in production, because it's such a pain to log into an EC2 instance and debug this stuff. So, but there you go. So I just wanted to hop over to the documentation here quickly to show you what hooks are actually available to you. And what's going to affect hook availability is the deployment methodology. You can notice for in-place deployment, we have all hooks available to us. And then for blue-green, based on the case, it's going to change. So it's interesting here because when you do blue-green deployment, you will see all these hooks in the Code Deploy. You'll see all of them, but it's just trying to separate them out to say these are the original ones that are going to happen on that side, the replacement ones on this side. So just be aware of that. And then these are just for rollbacks. So for rollbacks, you can see the scope is quite fewer there. Do you need to remember any of these for the exam? No, but it's just good to know because it could save you time debugging if you're doing this for real in a practical use case. So to get Code Deploy working with your computing powers, you're going to need two things. You're going to need the Code Deploy agent. I always think this is pre-installed on Amazon Analytics 1 and 2, but it's not. So what this is, it's just a service. It's like a binary that you, it's actually written in Ruby, but you have to install Ruby on your server and then download the script, install it. And then what that will do is it will have the Code Deploy agent continuously running, and it's going to report back to Code Deploy the progress of when you run the lifecycle hooks and installs all the steps. The other component to it is you need to create a Code Deploy service role. This is pretty easy through the IAM console. If you just go to, if you choose Code Deploy, they have some preset ones for you. And what this does is it gives access to things like autoscaling groups, CLB, and things like that. I say you may need to create it because I think in some cases you might not need it. But this allows Code Deploy to create an additional autoscaling group and like shift traffic between Elastic Load Balancers. So these are the two things you'll need to set up, which is not very clear when you're using Code Deploy. Hey, this is Andy Brown from ExamPro, and we are going to be doing the Code Deploy follow along. So we're going to learn how to set up automated deployment using Code Deploy. And the first thing we're going to need to do is get an EC2 instance set up with a basic web page that we're going to turn to an AMI, which we'll use for Code Deploy. So let's make our way over to EC2. And what we're going to do here is we're going to go to instances on the left-hand side. We're going to launch a new instance. And I want you to choose Amazon Analytics 2, the top one there, hit select. We're going to go with the T2 Micro because we want to save money. And what I want you to do is just drop down here, and you should have this SSM EC2 service role. If you don't, let's just go through the process of creating that right now. But we have created it in other follow-alongs here, but just in case you don't have it, I'm just going to delete this role here and make a new one. And this allows us to gain access to Sessions Manager if we need to log into this instance. So I'm going to go EC2. Next, we are going to let this load here. I'm going to type SSM. Next, SSM EC2 service role. That's what I like to call it. We'll go ahead and create that there. And then what you'll do is go back here, refresh, and then this role should now appear. So that's very important that you set that because it's going to save us a lot of trouble. Now down below, we have the ability to put in a user data script. This is what we came here to do. So let's set up a basic web application. So what I'm going to do is go over to Cloud9, and you should have a Cloud9 environment. If you don't, watch the Elastic Beanstalk follow along or some of the other ones where I show you how to set up Cloud9. It's very easy to get environment set up. And what we're going to do is we're going to make a new folder here on the left-hand side. I'm going to call this Code Deploy Project. And I'm just going to make a new file in here called userdata.sh. And what we're going to do is set up a script that's going to set up Apache in a basic web page. So the first thing we need to do is specify our shebang. Our shebang is going to tell this script what it should use to execute it, which will be bash. We're going to want to switch to the sudo, the EC2 user when we log in. We're going to want to install HTTP, which is what Apache is. Then we will want to change the ownership of the directory for the var ww. This just makes it a lot easier to work with it. So we're going to change that to the EC2 user. The next thing we want to do is we're going to make a basic web page. So we're going to place an index file in var www.html and have index.html. That's where Apache looks by default. And we're going to use a nice here doc here to do a multi-line here in bash, which is very useful to know. And so I'm just going to make a very, very basic website, the ugliest website I can think of. So we'll just get an HTML in there, then we'll get a head, and we'll get a body in there. And we'll need a title. My code deploy app. And we will do the same thing here in the body, except instead of having a title, we're going to make that an H1. And then there's just a couple things we need to do down below. We need to start up Apache using systemctl. You could use the alternative syntax, which is sudo service http start, but I noticed that if you do that, the enable doesn't work. So this is why I'm using the more long form format here. So that's for anyone that is very familiar with this. For whatever reason, it's not working in the other format. And so that should be everything. So switch to EC2 user, install Apache, change ownership, create that initial file, and that looks all good to me. So I'm going to copy this here, go over here. As you can see, you could input a file, but I'm just going to use text here, nice and plain. And assuming I got that all right, we'll be in great shape. If we don't, that's okay. We'll make our way in there using Sessions Manager. So we just need to set up a security group here. So I'm going to go next, next, next. I like naming. Actually, I'm going to go to tags. This is always a good idea. We're just going to put a name. I'm going to say my code deploy app. So if we do that, it will name it. And I usually do that afterwards. And we're going to make a new security group here just so we can see what we're doing. My code deploy SG. And we're going to open up port 80. We do not need port 22 because we will not SSH into this. We can get into it using Sessions Manager. We'll hit launch. I want you to drop down, proceed without a key pair, which is super more safe. And we will go to, we'll click on that instance there. And now all we have to do is wait for it to launch. So I'll see you here in a moment. Okay, so we have a running state. Both the status checks have not passed, but that's okay because generally we can check the website, but we should usually wait for those two checks. I'm just grabbing the IP address here and refreshing, and there's my application. Now, what's really important to check whenever you set up an app here is to restart the server, because we absolutely want to be sure that if we stop and start this again, it reboots. So what we're going to do here is we're going to go stop. And we're just going to let this shut down here. It shouldn't take too long. Just keep on refreshing here. And then once that's stopped, we're going to start it back up. So that is just a pro tip for you because there's a high chance that the service might not start up because something's wrong with their script. And to find that out later is such a pain. You have to rebake the AMI. I do not want to do that. So I'm going to go ahead and start this up again. And we'll just give that a refresh. I guess I'll see you back here in a moment when it's active again. Welcome back. I didn't wait for my status checks again, but it is running. And if we copy that IP address, we can see that the application is there. So we're all in great shape. If you did want to connect to this instance, you could go to Sessions Manager. But another way is just go click Connect here and go to Sessions Manager. We don't need to do anything here. I'm just showing you around. And so what you normally do is do sudo su-ec2 user, because it always logs you in as root. It'd be really nice if it logged you in as ec2 user. You could select that. If you're listening to AWS, please make that change. If we go to var www html and do ls-la, there's our file. All right. So just getting you a little bit comfortable with EC2, and we'll pop out there. And so the next thing we need to do is make an AMI of this image. So I'm going to go here and create a new image. I'm going to call this my code deploy app 000. It's great to version them this way. Always give it 3 zeros so you have a little bit of room to breathe. And what we'll do is we'll go ahead and create that image. And so if we go here, we'll just have to wait for that image to go pending. And once that is done, then we will, actually we can just leave our current server running. That is totally fine. But what we need to do next is set up a code commit repo. So we'll go to code commit. And the next thing here, I don't know if we need code commit right now. We'll need it for later. But yeah, you know, we'll come back to code commit later. I was thinking later when we add it to the code pipeline. But that's something we can definitely do later. So what I'd rather do instead is to get code deploy set up. And for that, we're going to need a deploy file, which they call appspec.yaml. So I'm just going to make a new file here called appspec.yaml. And let's make our way over to code deploy. We might get stuck through this process if we don't actually have a way of deploying, but we will do the best we can here. So what I want you to do is on the left-hand side, go to applications, and we're going to create a new application. And I can see that I have a test one here. I'm going to go ahead and delete that. You're not going to have this. Oops. Anyway, we'll go back to applications here, create a new one. And I'm going to call this my code deploy app. And we'll hit, we'll choose EC2. We'll create the application. And so now that we have an application, we have to set up a deployment group. And we'll call this my deployment group, or my code deployment group, which is a bit silly. Enter a service role, a code deploy permissions that grants AWS code deploy to access your target instances. So we don't have one of those. So that's something we're going to have to go get. We probably can just go edit our existing EC2 role. So maybe that's what we'll end up doing. Okay, so I just pulled up the documentation quickly here, and I believe we need to make this service role. So what we'll do is we'll make our way over to IAM. So I already have it here on the left-hand side. You might have to type in IAM. We'll go over to roles. We're going to create a new role. We are going to choose probably code deploy. What do we have to choose here? Choose a service with the role, choose code deploy. All right. We'll go back to IAM here. We'll choose code deploy. And then down below, we already have those presets. So we're going to choose code deploy, which is for auto scaling. Yeah, it looks fine to me. We'll go next. We will see what we get there. So it's already predefined. We will hit next. I love it when they have those predefined ones for you. It saves you so much time. And we're just going to name it as suggested. So we'll go up to here. I'm just going to call it that. We'll create that role. Then we'll go back here. And let's see if it auto-completes. Enter a service role ARN. Well, there you go. I guess that's what we'll do. So we'll go into here. I'm just going to copy that ARN and paste it on in. Hopefully that works. We have in place in blue-green. I'm going to try to keep it simple and do in place. The environment configuration, select what you want to deploy. So we'll choose EC2 instance. And you can add up to 3 tags. So I guess I have to tag my EC2 instances. Oh boy. So what we'll do is we'll make our way over to EC2. We'll go to instances. There's our app. And what we'll do is we'll just add a tag. So we'll go edit tags. I'm going to call this app CD. And we'll save that. We'll go back over here and I'll say app cd. Add tag. Oops. I guess we only really need one there. So that should do it. We're going to do all at once. Sounds great to me. We're going to turn off load balancer. We don't need that. We're going to disable rollbacks. We're going to go ahead and create that deployment group. So now that we have this deployment group, it should know how to deploy. So if we want to go ahead and do a create deploy, and we scroll down here, what we need to do is supply the revision. So it's interesting you can't supply, like you have GitHub, but you can't do code commit. So, which is totally fine, I guess. So I guess what we're going to have to do is we need to supply a change to our server, a revision to our server. So what we'll have to do is make our way over to Cloud9, and we will make a revision. And then what we'll do is place it in an S3 bucket. So let's go over to Cloud9 here. I'm going to make a new file here. I'm going to call it index.html. I'm going to grab our code from over here. I'm going to copy this. I'm going to paste this. And I'm just going to call this v2. v2. Now I think we're going to need to have an appspec.yaml file in this, because that's what it uses to figure out the deploy. So yeah, I think that's what we'll need. So just give me a second to pull up the documentation for that. Okay, so I just pulled up the documentation for the appspec YAML.file. But actually, you know what I think what we should do is we should go set up that code commit, because this is going to make things a little bit more organized. And we'll just get this out of the way. So I'm going to go create here. I'm going to say my code deploy app. And what we'll do is we'll hit create. And we're going to have this clone URL. So grab the HTTPS one, it copies to your clipboard, make your way back to your Cloud9 environment. And what I want you to do is get into this folder here. So just go to tilde. Tilde takes it to the home, code deploy project. And then we'll do git clone there. And that will put a folder inside of a folder, a little bit messy, but it works. And what I want you to do is drag this index.html into there. And then we'll drag this app.yaml into there as well. So that's a little bit more organized. And then let's open up our appspec.yaml. So the first thing we need to do is define our version. It's going to be version 0.0. I don't think there's any other version at this point. This is the only version there is for appspec. Then we'll do OS, and we'll choose Linux because we're not using Windows. And we could set some other things like files and permissions. And that's where it's going to place the file. So I'm trying to decide where this should go. I guess I'm going to just place it. So we'll say source, which is the root of the revision we'll upload. And then I'm going to just supply the destination. I'm going to do home, EC2 user. Oops. No. We're going to put var www.html. So that's going to place it where we want it to be. And we're just going to make sure the permissions are as what we need them to be. So I'm going to do object, and we're going to say var ww. We've already done this already, but I'm going to just force it anyway. And it's also a nice way to see how we can use permissions to change permissions. EC2 user. We're going to do group EC2 user as well. And the next thing we'll do is we'll put in some hooks. So for hooks, there's the application stop. That's something we definitely want to do. And we will just name this. So we'll say location. And we'll say stop app.sh. We'll give it a timeout. It's always good to provide timeouts so that it doesn't take forever. Stopping the app is super, super fast. So we'll give it, 10 seconds, which is, maybe we don't even need 10 seconds. I think it takes like 6 seconds. And we'll run this as EC2 user. And so that should be the premise of that one. We're going to need that stop app there. So I'm going to go here and make a new file. Say stop app.sh. Whoops. We will rename that because if it's named wrong, we're going to have a lot of trouble on our hands. So I'm going to just double click that there. We're going to go to user data and we're going to grab this line here And what we're going to do is paste that in there. Generally, when you run commands, you want to give it the absolute path. So we need to know where the absolute path of HTTPD is. So what I'm going to do is connect to the instance here. We're going to use Sessions Manager. I'm going to hit connect. And we're going to get here sudo su-ec2 user. And then what we're going to do here is type in where is HTTPD, and that's going to give us the full path. So this, I believe, is the full path. I really hope that's the case. I guess I could just run it. Yep, that's it. And what we'll do is we'll go back here, and I'm just going to paste this in fully here because I do not want to have any problems. And I think it's this. Here we go. So that's our stop. And we don't necessarily have to stop it. We could just restart it, I suppose. Maybe that's a little bit cleaner to do. I think that's what I'm going to do, actually. So I'm going to rename this to Restart App. And that's going to avoid us a bunch of problems. And so instead of doing this in the application stop, I'm going to do this in the application start, which is one of the last things that it does. So for application stop, we're not going to do much here. There's the before install that we can put in here. There's nothing really to do there, but we're definitely going to need an after install. So after install, that means like after the code has been downloaded to the source directory. I'm still wondering if this is a smart idea to place it here. Maybe I'll just put it in a folder called revision. That's actually what I think I would prefer to do. And then what we can do here is we will just copy this here. And we are going to make a, we'll rename this to restart, and we'll rename this to update app. And what we'll do here is make that new file over here. I'm going to call that updateapp.sh. And we will open that one up there. And what I need to do is I need to make a command that's going to copy that revision. So I'm just going to double check, make sure I put a / in there. Yeah. So the revision should be stored here. So the first thing I would do is remove the old file. So I'd say remove var www.html index.html. And then I'd say copy revision to var and this one up here. I'm not going to read the whole thing out there. And so this should do it. Okay. And so, yeah, this should be our code spec. Now, what I'm going to go ahead here and do is commit all this stuff to our repo for a later step. Actually, we'll leave it alone for the time being. We don't have to do that. But I do need to zip the contents of the stuff that is here. So let me think about that. We'll go back to code deploy. I'm pretty sure it expects it to be a zip. Copy and paste the Amazon S3 bucket where your revision is stored. And here you can see we have folder object.zip targ or tgz. So what I'm going to do is I'm just going to figure out what the zip command is, and I'll be back here in a moment because I never can remember that off the top of my head. Okay, I am back. And I think I know what the command is. It's zip, and then you supply the name, and we'll do this in that actual folder there. So we'll go into there. I'm going to type in zip, and then whatever we want to call this, we'll say this is revision 000 or 0.1 maybe, zip. And then we need to say what files we want. So we want the app spec YAML, we want the index.html, we want the restart app, we want the update sh. Maybe we should match the version. So if it says version 2, let's just call it version 2. It'll be less confusing. And so I think we have everything. Update, restart. Yep, we have all the files we need. What we'll do is we'll hit enter. And that all looks good to me. So now we just need to get this revision file onto S3, and we're going to need a new S3 bucket. So using the CLI, it's going to be AWS S3 API create bucket, and we're going to give it a bucket name, of course, and the name is going to be my code deploy app. If that doesn't work, you might have to choose a more unique name because S3 names are unique like domain names. And we're going to specify the region. Always specify the region. It makes our life a lot easier. Always US East 1. And I did not use the command correctly. AWS S3. API S3. Hold on here. AWS S3 API. Help. Yep, there's a create bucket command. And so we'll do create bucket. Just scroll down here for a second. I'm just looking for an example. Okay, so it's just : bucket. I called it bucket name. So that's not the command that I was supposed to do there. So I'm just going to hit up there, and we're going to make our way over here and just take out the hyphen name part. And there we go, it created the bucket. So now what we need to do is copy this revision to there. So I'm going to do AWS S3 CP. Why it's not S3 API, why there's two different ones, I have no idea why, but that's just how they have it. And so we'll specify that file, which is revision 2. And then we need to specify the bucket. So S3 : then we'll put the name of the bucket here. And we'll just maybe put in a new folder called revisions. And yeah, maybe we'll call it version 2. And we'll hit upload there. And so now it's uploaded. So if we make our way back over to here, it's now expecting that bucket path. And we are just going to go back to our Cloud9 environment, and we have it right here. So I'm going to just grab it. Okay, and paste that there. The revision type is a zip. That is correct. And there's that application stop lifecycle. I don't remember this option being here before. Don't fail to deploy to an instance if this lifecycle event on instance fails. No, that's a cool option here. So we don't have to do anything with that. We don't need to override anything there. We don't have to do anything like that. Normally, you have to add a code deploy agent to the EC2 instance for this to work. So I'm just wondering if I need to give permissions for that there. Maybe we should do that before we proceed forward, because I feel like that's going to give us trouble if we don't do that. So what we'll do is go back to our EC2 instance, and it's already running, and we have this SSM EC2 role that's here. And so what I want you to do is I want you to go to IAM. And we're going to just create ourselves a new unique role for this app. So I'm just going to go EC2, next, and I'm going to add some policies. So I want the SSM one definitely, and then I want the code deploy agent. Yeah, and we'll hit next, and I'm going to call this my code deploy app role, and we will create that role. What we'll do is we'll make our way back to the EC2 console. Not sure where that is. We'll just type that in again. We'll go to instances on the left-hand side. We'll look up this instance, and I'm pretty sure we can just replace the role through here. Where are you? Attach replace IAM role. So we will swap it out for my code deploy role, and we'll hit apply, and we will close that. I don't know if we'll have to restart the app. I don't think so. And the IAM role is not part of the actual AMI. We attach it when it launches, so that's another thing we don't have to worry about. So what we'll do is we will go back to code deploy, and I think we're all in good shape here. Deployment description, add a brief description, deploy version 2. That's what we want to happen. Now, whether that will work, I guess we'll find out here in a moment. And we'll hit create deploy. And I'm so used to code deploy deploys failing, so if this fails, I'm totally okay with that. Now this is an in-place deploy. Yeah, so I was thinking I needed the code deploy agent because code deploy might have to start up another autoscaling group or something, but I just realized it's an in-place deployment. That means it's not creating a new server. It's just going to take the server out of service and then apply the updates in place. And we will see, we can click view events here and see how that goes. Generally, this is super fast, so I'm not sure why it's taking its time. But I guess what I'll do here, I'm just going to click back. So if it's in place, it should be super fast. What I'm going to do is I'm just going to wait until we have the results here. If it fails, it fails, or if it times out, I guess we'll find out here shortly. All right, so this failed, but that's okay. I figured out what the problem was. I hopped onto AWS support because I was really stuck, and I realized I didn't install the code deploy agent. I guess I just thought it was pre-installed on Amazon Linux 2, but I guess it's not, which is a bit frustrating, and they don't have a run command for that either, so I guess we'll have to manually install that. Not a big deal because we were smart enough to set up SSM just in case we had to go into our server. So let's go ahead and hit connect, go to Sessions Manager, connect, and then we'll go ahead and install code deploy. So